Microsoft Azure platform is constantly evolving and expanding, numerous industries are utilizing Azure development, and the demand for Azure professionals is soaring high. Around 80% of businesses are expected to move their workloads to the cloud in the next few years. Due to this, there is a rapid growth potential in the career of Azure professionals with the advancement in the career. Hello everyone and welcome to this session. You are currently watching an Edureka Microsoft Azure Full Course video. By the end of this video, you will have a thorough understanding of Microsoft Azure all the way from theory to practical applications that are required to master. Now, if you love watching videos like these, then subscribe to Edureka's YouTube channel and click the bell button to never miss out any updates from us. Also, if you want to learn more about Azure after watching this session and wish to obtain Edureka's Microsoft Azure certification course, then please see the link in the description below. Now, let's begin with our agenda where we'll have a brief overview of what we will cover in this Microsoft Azure full course video. We will start with the introduction to Azure, where we'll learn what Azure is and why should we learn it. Then, we will learn how to create a free Azure account. Now, it's time to deep dive into the different services of Azure. We'll start with Azure Compute Services, followed by Azure Identity and Access Management. After this, we will learn some Azure Networking and Storage Services. Once this is done, we will then understand Azure Web Services and Azure Database Services. We will also see Azure Analytics and Azure Machine Learning. At last, we will see the Azure IoT and Azure Integration. Well, we truly hope that this session assists you in getting jobs in the industry. In order to accomplish this, we will look at how to start a career in Microsoft Azure, where we will see the certifications in Azure, followed by some essential Microsoft Azure interview questions with answers. So stick till the end. Now let's get started with our first topic, that is Introduction to Microsoft Azure.
Let's kick things off by talking about why businesses, and everybody for that matter, need cloud computing. Here's an example. Meet John, who's an entrepreneur who has a brilliant idea for an app which solves a problem and has a great user experience. So what does John need? John will need developers to build his app, but other than that, in terms of infrastructure, he will need servers, then he will need storage devices, a dedicated network, security systems, and of course, he will need a dedicated IT operations team to monitor the whole infrastructure and make sure everything is working properly. John figured that there would be 4 major problems with this setup. And what are those? Let's take a look. So the first problem is that owning his own infrastructure would require a huge amount of money. And because of a huge investment in setup of the infrastructure, this would also greatly increase the risk if the app fails. Second problem is that he noticed that the infrastructure would take too long to set up, as he would have to buy all the components required for his infrastructure, then hire IT technicians to install all the components and connect everything up so that everything is talking to each other and working nicely. So that means more money and more time. Next, he realized that even after the expensive setup of the infrastructure, he will have to hire a team of IT operations to work around the clock for the upkeep of the infrastructure. This would include things like resolving issues with the hardware or software, replacing broken pieces of the infrastructure, so he would need to have spare parts on hand, switching to backup servers if the server goes down, preventative maintenance, and so on. Means more money and more headaches when the issues crop up. Another problem has to deal with the inability of the infrastructure to scale. So what if the traffic on the servers increases or decreases abruptly? Well, if the traffic increases, he will have to scale the infrastructure to meet that demand, which means expanding the infrastructure, so buying more components, probably renting more office spaces, hiring more IT staff to monitor the expanded infrastructure, and so on. But what if there's a sudden drop in the demand? All of this extra infrastructure and resources will sit idle. What about the extra people he hired? He will have to let them go? Well, it's terrible, but he may have to. Well, now let me tell you, John was smart. He did not opt for this setup. He opted for cloud computing because he was studying up on cloud computing, and he found that all big and small companies that are at the top in their domains are using cloud computing. And this research into cloud computing was a real eye opener as he found that all these issues that he would face with the infrastructure that we just talked about could be solved by using the cloud. So obviously he opted for cloud. This is because there was almost no initial setup cost required, and it could be done in a few minutes or hours by using a single computer. And he wouldn't need a dedicated team to take care of the physical machines because that is taken care of by the cloud provider. And finally, to John's relief, infrastructure in the cloud scales automatically as the demand changes. Isn't that freaking amazing? So, why don't we find out more about cloud computing in this next section? What is cloud computing? Cloud computing is the delivery of the computing services like servers, storage, databases, networking, software, analytics, intelligence, and so on over the internet, which we call colloquially the cloud. Okay, so let's understand that. John takes a computer that is connected to the internet, then he accesses the resources on cloud platform. So these resources that John needs are running on physical machines in the data center that are owned by cloud providers. So like I said before, all John needs is a computer that is connected to the internet, and the remainder of the infrastructure is actually provided by the cloud provider, and he can access the resources that he needs from the data center using the cloud platform. So how does this work? Well, first, John goes to the cloud provider, whichever one he likes the most. Amazon Web Services, Microsoft Azure, Google Cloud, these are the top cloud providers. So after going to the cloud provider's website, he signs up for an account and then he signs up for the services as per his requirements and configures the resources that he will need for the app to run on. And the amazing thing is that he only pays for the services that he uses and for the amount of time that those services were up for. Isn't that amazing? Of course it is. So let's now talk about what is Azure. Azure is a cloud platform that is provided by the company Microsoft from which you can rent your resources and services. So you can grab a computer that is connected to internet, then go to Azure Portal on your web browser and then access the resources that you need by signing up with Microsoft Azure. So now it's time to find out which cloud platform did John choose. It's kind of a no-brainer, but here's what John says. The developers of my app and we all use Windows OS and other Microsoft products. So we wanted a cloud service that is best compatible with them. Can you guess which one this is? Of course, it is Microsoft Azure because it is most compatible with the Microsoft products. So before we talk about the services, why don't we find out some of the interesting things about Azure? Just like every other cloud platform, Azure provides 5 distinct type of services: infrastructure as a service, platform as a service, software as a service, container as a service, and functions as a service. Apart from that, Azure has 22 main categories of products, which we will take a look at later on. Next, Azure is operating globally in 60 plus regions and provides its services to 140 countries and counting. So just like the major cloud platforms, Azure provides pay-as-you-go plans and free plan. So there are actually no upfront fees for signing up with Azure, and you can pay as you go and only pay for the time your services are running. And just like every other cloud platform, Azure provides free basic plan, which is surprisingly good, and it is valid for 12 months. So you can tinker around and see if you like it. Okay, so what about the languages that are supported on Microsoft Azure? They are C Sharp, F Sharp, Java, TypeScript, and Python. Now let's move on to the next section where we discuss the services offered on Azure. So in the previous section, you probably remember that I mentioned that Azure has 22 categories of products. But what I did not mention is that it has over 600 services. So obviously, we are not going to be able to have enough time to discuss all 600 services. So here's your homework. Go to Azure's website and check out each of these categories and read up on them. If you have any questions, come back to this video and comment down in the section, and we will be more than happy to answer any of those for you. So I hope that you got a picture of all the categories of services provided by Microsoft Azure. So let's now go back to John. John needed 3 services. They were compute, networking, and storage. So let's take a look at each one of these in a little bit of a detail and then move on.
So the first product that he's going to need to build his infrastructure in the cloud is compute. He can use this to deploy and manage virtual machines, containers, and batch jobs, as well as support remote application access. Compute resources created within the cloud can be configured with either public IP addresses or private IP addresses, depending on whether the resource needs to be accessible to the outside world. So some of the services that are offered within compute product are virtual machine, containers, Kubernetes service, cloud services, mobile apps. Let's move on to talk about the next, which is networking. So after setting up the virtual machines using the compute product, he will require networking in order to connect those virtual machines up so they can talk to each other and form a network. So this product gives you the ability to set up virtual networks, dedicated connections, and gateways. And it also gives you services for traffic management and diagnosis, load balancing, DNS hosting, and network protection against some of the attacks like DDoS. Next one that John needs is storage, obviously, for his virtual machines so that they can store customer data and use backup storage for all of the infrastructure. So there are various services that are offered within storage, like Azure Disk Storage, Blob Storage, Azure Backup, Queue Storage, and many more. This category of services provides scalable cloud storage for structured and unstructured data. It also supports big data projects, persistent storage, and archival storage. Similarly, there are 19 more categories that provide services that can cater to all needs of any organization or company. Which brings us to our next section, which is companies using Azure. Let's see which companies use Azure. So hundreds of big companies use Azure, but these are the ones that I picked for you guys because each one of these use Azure for a different purpose. So let's check that out. eBay has been using Azure for app development and hosting since 2010, which is the same year Microsoft announced Azure to the world. Boeing mainly uses Azure for its data analytics services for things like crew planning, maintenance optimization, fuel optimization, and crew training by building predictive models on the platform. BMW uses Azure's Internet of Things to make manufacturing process within their factories more efficient by connecting all different machines, sensors, and other devices. On the other hand, Samsung has used Azure for its smart TV infrastructure. The entire smart TV infrastructure is actually on the Azure platform. By choosing Azure, Samsung was able to achieve a significant reduction in costs and increased capacity in order to meet its rapidly growing customer base. With that, we have come to the end of this video. I hope this video piqued your curiosity, and if it did, and you would like to learn more about Azure, then I'm going to leave the links to Edureka's YouTube playlist on Azure and Edureka's blog series on Azure. And you'll find these links in the description along with a link to Azure Architect certification. If you want to be certified in Azure, then this is going to be very helpful.
Okay, let me show you the user interface for Azure now. So guys, this is how the user interface for Azure looks like. You have all the services listed here on the left side, right? And this is the dashboard. This is called the dashboard. Whatever services you launch, you can pin it here for basically getting access quickly. It is just like a desktop on your computer, which has all the shortcuts and everything. And this is what the dashboard is actually used for. All right. Having said that, let's see how we can launch the app service in Azure. So first you will click on app services. As you can see from here, you can click on app services, and moving ahead, once you have clicked on app services, you will reach this page. Click on create app services, and then you'll click on web app, and that is it. Let me show you how you'll do that. So you'll click on app services, click on create app services, you'll go down, click on web app, and over here, as you can see, after this you will reach the screen wherein you will see that you have four options. You can either code your website in .NET, PHP, Node.js, or Python. So if it is either of these four languages, you don't have to do anything. You just have to upload your code in this web app that you'll be creating, and your app will be deployed automatically without installing any software, without doing any configuration, just this. All right. Okay, so once you have reached this page, you will click on create. So let's click on create, and then you will reach the screen. So now you have to give your application some name. So let us give us this name as Edureka-01. So it says everything is fine. So this subscription is pay as you go. Resource group is something which you can create or you can use as existing. So resource group is something, it's a group of all the resources, right? So we'll be creating a storage account, we'll be creating database account, we are creating an app service, right? So all of this will come under one group. It can be clubbed in one group and it will be called as resource group. So any changes that you want to put across the group, you can do to the resource group. All right, we'll be discussing in detail what a resource group is in the further modules, but for now, all you should understand is that a group of resources is called a resource group. So if you have an application and it's utilizing, say, 3 or 4 resources, it's better to put those resources under one group. All right, so this is about that. Then you have the app service plan. So app service plan is something as in what kind of computers you use and everything. So let's create a new plan for you, so that you understand it better. Under the pricing tier, this is the main part that you have to select, guys. You can select the app service plan. You can give it some name. Let's give it as app service -1. All right. And this is my app service plan. You can select what kind of plan you need. Let me select the basic plan as of now and click on select. All right. And then click on OK. So this was about app service plan. You can click on application insights, which basically gives you the monitoring tools. For now, let's not discuss it. Let's not go into it. We'll be discussing it later. And now let's click on create. So I am ticking the pin to dashboard, which will basically create a shortcut on my dashboard to this application. Comes in handy, and that's it, guys. You will click on create. All right. So now my application is being created. Okay. So all right, why my web app is deploying, let me go back to my slide and let's jump on to our next service, which is blob storage. So like I said, blob storage is just like a file system. You need a file system to store your files, right? So that is what the blob storage is all about. Let's see how we can create a blob storage instance in Azure. So you will reach, this is the dashboard, you reach the screen and you will click on storage accounts. Once you have clicked on storage accounts, you'll click on add, and that is it, guys. Nothing much required. Let's go ahead and do this. I'll go here, I'll click on storage accounts. I will reach the screen and click on add, and I will start entering the value. So let's give it the name called Edureka-01. So this is taken. Let's give it name as Azure Edu, right? This name is available. Alright, so the performance should be standard because this is a demo. Replication is not required, so I'll say locally redundant storage. Storage service encryption is not required. Secure transfer is not required. And subscription is pay as you go. Okay, resource group. Let's select Edureka-01 because this is the resource group that I selected earlier, right? And let's pin it to dashboard. So we'll click on create. Alright, so my web app has been deployed already and my storage account is also being deployed. Alright, so this was about it. Let's go on. Let's see for our MySQL now. So for MySQL, let's see what all we have to do. So we will click on new, we will click on databases, and then we'll click on Azure database for MySQL. Alright, and that is about it. Let's go back and do that. So we'll click on new. We'll search for Azure database for MySQL. Alright, here it is. So I'll click on this and I'll click on create. So here it is. I have to enter the server name. Let's enter the server name as Edureka-01. It is available. It's good. The resource group should be the same. So let's select Edureka-01. Server admin login name, let's give it as Edureka. Password, let's give it Edureka1234. Confirm the password, Edureka1234. And It is asking me some special character, so let me add the special character as well. Okay, so basically you cannot have the login name in your password. So let me change the password to edu1234 exclamation. Same in the confirmation. Alright, so this is available now. The location is South Central US. Version is 5.7. Pricing tier, let me see if there is something more or less. Alright, I'll take this. I click on OK. Pin it to dashboard and click on create. It's pretty simple, guys. You would know when you will do the hands-on on yourself. So the pricing tier can be the minimum if you are using it for demo, or if you're creating an application which is for global scale application, you can choose the pricing tier according to that. All right, while it is deploying, let's move ahead. So let's come on to the auto scaling part now. So basically we have to configure our web app to auto scale as and when required. So let's see how we can do that. So let's understand the types of auto scaling first. So basically there are two types of scaling. One is called horizontal scaling and one is called vertical scaling. So horizontal scaling is when you are increasing the number of servers that you require. Say you have an i7 server, for example. All right, now the usage goes up, so you take two i7 servers, and if it again goes up, you take three i7 servers, right? So this is what horizontal scaling is all about, right? Let's come on to vertical scaling now. So vertical scaling is when you are increasing the capacity or the configuration of your system. Say you were using an i3 system before, right? The traffic increases, so now you're using an i5 system. The traffic increasing, now you're using the i7 system. So you are having only one machine, but you're increasing the configuration of your system, right? So these are the two types of scaling which exists in auto scaling. Also, the other way is manual scaling. So you can also manually scale up the number of instances or the configuration of your system, right? So the way to do that is to manually go into the service, change the pricing tier, and you are set. This is how you manually scale. Auto scaling, I'm going to tell you in a couple of few slides. Also, guys, when you are auto scaling, like I said, load balancing is automatically attached to it. All right, so when you will be auto scaling in a web app, you don't have to configure the load balancer. The load balancer is configured automatically and set automatically for you to be used. All right, because it doesn't make sense to use auto scaling and not use load balancer. And that is the reason Azure has automated the process of attaching a load balancer when you're using auto scaling. All right, moving ahead, guys, let's see how we can launch this instance. So guys, first you will click on App Services. You will go to your particular instance that you have launched. You will go to Scale Out and you will click on Enable Auto Scale. All right, so let's do that. We will go to App Services, which is here. So this is my instance that I've launched. I'll click on Edureka-01. I'll go down, and as you can see, I have two options. I have Scale Up and I have Scale Out. When I click on Scale Up, you will see the pricing tier, so I can increase the configuration of my system, right? But this is not what I want. I want to scale out, which is I want to increase the number of instances running right now, right? So it says auto scale is not supported for basic tier of web apps. Okay, so let me change my configuration. All right, so if I go to scale out now, you can see that I have the option to enable auto scale. So I will click on enable auto scale, and then let's give it a name. Let's give it a name as Edureka Auto. All right, so my auto scaling property name is Edureka Auto. The resource group is Edureka-01. Right, so now you have an option to scale based on a metric, which is based on some statistics like the CPU usage or the memory usage or anything, right? And the other one is scale to a specific instance count. So for example, whenever the traffic increases, say you were one instance, now like increase to 5 instances. All right, so these are the two options. We'll go with scale based on a metric, and scale out and scale in your instances based on metric. All right, so let's add a rule. Let's add the rule as in what do we want, what kind of metric do we want to monitor and scale according to, right? So as you can see, the time aggregation is not something we should be worried about? Okay guys, so these are all the metrics that you can actually monitor and scale according to. You can scale according to the memory percentage, you can scale according to disk queue, HTTP queue, data in and data out, right? So let's for now keep it simple and scale according to CPU percentage, right? The time is not something you should be worried about. And the operator, all right, so what should be the condition? So should it be greater than, or should it be greater than or equal to? Let's keep it at greater than or equal to. So whenever the threshold is greater than, or whenever the CPU usage will go greater than or equal to 70 for 10 minutes. So you can set this as say 2 minutes, all right? Okay, so it says that it should be between 5 and 720. Okay, so let's keep it at 5. And increase count by. So let's see what all options we have here. So you can increase by percentage, you can increase by count. 2, as in if you were 1, you can increase it to 10, right? And you can decrease the count, or you can decrease the person by as well. Alright, so when you are auto scaling, guys, you have to set 2 rules. One is the rule to increase, and obviously one rule is there to decrease. So whenever the traffic goes down, you have to decrease your instances as well. So for now we are setting the increase rule. So let's set the increase count by option. So how many instances should it increase? I think 1 is a fair number. And cooldown is something that is actually there when you are, say you auto scale right now, right? And then say you auto scaled 1 minute back, and again the CPU usage goes up. So rather than going on and scaling up again, what you can do is you can wait for 5 minutes and watch the metrics, right? Because it doesn't happen in a second that your CPU usage will go down, because there are a lot of services which are actually running, right? So you can wait. Once your new server has been deployed, you can wait for the traffic to be transferred to that server as well, and then you can see the metrics go down. All right, for that we keep something called cooldown minutes, right? So we have the default is for 5. Let's keep it at 5 only, and now this is it, guys. There's nothing else to configure. Let's click on add. All right, so as you can see, this rule has been set. Let's add one more rule to decrease. So the CPU percentage is fine. The operator should be less than or less than, right? So whenever the threshold is less than 50%, decrease count by 1 instance, and let the cooldown be this much. All right, so again the cooldown logic goes here as well. Say you decrease an instance, and again your CPU is still low, because it takes time for your traffic to get transferred to the server number it has decreased down to, right? So let's keep the cooldown minutes. So we'll click on add now. All right, so we have added the auto scaling rule, guys. This is it. There's nothing much to configure. Actually, if you think about it, it's a very complex process, but Azure has given you the simplicity to do it very simplistic or a very English manner, because you just say, like I said, if the CPU usage is above 70%, increase the number of servers by 1, right? So if you go here and if you don't know about auto scaling, you can actually figure out what is happening, right? And same is the case with scale-in. So whenever your CPU is less than 50%, decrease the count by 1, right? So as you can see, you can actually read it here that this is what we have configured. All right, so let's save this now. Alright guys, so this is how you auto scale your web app instance. Now since we are doing a demo, guys, we don't require the auto scale module for my application, so I'll just discard it for now because I can't even demonstrate this to you, right? So I just showed you how you can auto scale. Now let's go back and see what all is left. Alright, so now we are going to do the demonstration. So we have launched each and every service. We have launched the app service, we have launched the blob storage, and we have launched the MySQL for Azure. Right? Now let's go back and check and deploy our website. So let me show you how the website looks like in my local host. So my local host is this. Alright. Okay, so this is showing me an error because as of now my code is not connected to my Azure instances. Alright, so let's first configure our instances. So let us go to the dashboard and let's first configure our database. Alright, now for configuring your database, the first thing that you have to do is connect to it, right? Now the way you can connect to it is using the command prompt. For that, you have to click on connection security. Now you cannot connect to your database just like that. You have to configure your IP address in the set of rules that are there for the firewall of the database. And when your IP address is listed there, then you can connect to the database. Let me show you how. Let me show you that you cannot connect as of now. So I will launch the command prompt. I will go to my MySQL installation. All right. Alright, so this is my MySQL installation, guys. So I will type in the command mysql-h space and then the server name, which is this. I'll paste it here. Alright. Then I will give the port number. So the port number is -P, guys. Don't forget it's capital P. It's different than small p. Right? Small p is for password, capital P is for the port number. And then I'll give the username. So the username is this. I'll paste it here. Right, and then I will type in the password. I'll hit enter the password, which is edu1234 exclamation. Hit enter. See, as you can see, client with IP address is not allowed to access the server. Alright, so now what I'll do is I'll go to connection security. I will add my IP and I'll click on save. So it says successfully updated connection security. Let's go back to our command prompt. Execute the same command again, type in our password, and now as you can see I have successfully connected to my database. Now I can create a database here called Edureka. Let me create a database. Let me clear the screen. Oh guys, I forgot I'm working on Windows. So in Windows you cannot clear your MySQL screen. Alright, so if you were using Linux you could have just typed in Control L and it would have been fine. Alright guys, so as I was saying, let's create a database called Edureka. So create database Edureka, and that is it. Then I'll type in use Edureka. I'll create a table. Let's create a table called image, right? And title name as this. 1 second. My column name is name. Alright, so I've created a table. So if I type in show tables, it will show me the table name, which is image. Alright guys, so this is done now. I have created a table. At first I created a database called Edureka in my MySQL, which is hosted on Azure. And then I created a table called image in it, and the table has one column called name. Alright, so this is it. This was my MySQL. So my MySQL has been configured now. Alright, so my MySQL has been configured now. Let me go back to the overview. Alright, so my MySQL has been configured. As you can see in the databases, it will show that there's a database called Edureka which I just created. Alright, let's go back. You might have to add the web apps IP address as well. We'll do that later. Let's go to our web app now. Awesome. So we'll go to our web app. And guys, this is your web app. This is the URL for your website. We'll click on this URL and you will see a welcome page. This is your welcome page. So now what you have to do is you have to upload your code over here. Alright, so the way you can do this is using GitHub, or you can do it using FTP as well. Now I know most of you are from non-technical background, so you might not be knowing what GitHub is. So for now what I'll be doing is I will be using a FTP software called FileZilla for transferring my files. From the next session onwards I'll be using GitHub, and for that I have actually there is a video in your LMS which is a short tutorial on GitHub, how to use GitHub, which is enough for a demonstration. So you can go through that video before coming to the next session, and then we will be using GitHub. Alright, for now let's use the FTP software which is called FileZilla. All right. So the way you can connect here is like this. So you have to create a deployment credential. All right. So my deployment credentials is HR1. Let's give it a password, and the password could be, okay, let me give as Hemant199. All right. And over here also Hemant199. All right. Let's click on save. Or maybe this username is not available, so let me give it HR12. Click on save. Okay, let's try this again. HR12. Alright, maybe I'm connected here, maybe that's why. Let me exit it. It's Hemant1994. Let's click on save. Alright, so I get the error out of here. Alright, so we have successfully reset the deployment credentials now. Alright, so what we can do is I will go back to my web app. Alright, so now I can get connected to my web app. I'll have to enter the FTP hostname, so it'll go here. 1 second. Alright, the hostname will go here. The username is HR12. Password is this. Right, and what else? All right, the username is this. I'm sorry, the username will be this. All right, let's click on quick connect. All right, so as you can see, we have successfully logged into our FTP channel. So over here you'll go on a site. All right, you'll go on www.root, and then you can copy all your website files over here. So let us do that. My files are somewhere here. All right, so let's copy the files now. I can just drag and drop it over here, and the process will start. Now it might take a while, so let us configure some other files while my website is being copied. Okay, so now what we can do is we will go to our dashboard and we can configure our storage. Mind you guys, I might have to upload my code which in my web app, because there are some things that I have to change in the code, because the addresses and all, I'm creating new services, right? So I'll have to change the services address in my code. So I'll do that, and then I will update the particular file that I'll be changing in my web app. So let me just give me a minute. Okay, so now what I'll do is I will create a blob. Over here I'll create a container, and the container name shall be hello, and the access type be container. Alright, I click on OK. So I have successfully created a container called blob. If you go in properties, you will see that this is the URL for it. Right, so let me show you the code for my website, guys. So this is the code for my website. Alright, now I'll have to change the URL at places, so let me do that. So it will get changed here. Alright, then my container name is hello, so that is okay. And now one more thing, guys. So whenever you are basically going to connect to your storage account, your blob storage, you have to go here. I'll show you. You will have to go to access keys. So here is your key, right? So this is the connection string that you have to include in your code. I've copied it. I'll go here and I will include it in the connection string code. All right, so I'll control V, and over here you have to remove the endpoint suffix. All right, so this is not required. If you put this, it will not work. Okay, I don't think anything else is required. Oh yes, I have to change the database credentials as well. So let's do that as well. So your storage account is set. You don't have to change anything else. Let's go to the MySQL part. All right, here it is. So the server name has to be changed. Let's copy the server name and give it here. So the host name is this. Alright, and let's see. So our login name is this. Let's put the login name here. Password is edu1234 exclamation, which is right. DB name, database name is Edureka, which is right. Username, user table is image, which is right, and the field name is name. Alright, everything seems fine. One more place I have to change it, so let's do that as well. So let's copy this, paste it here, copy our username, paste it here, and everything seems fine now. So now when I try to run the code, it will run on my local host, but it will not run on my web app. Why? Because I'll tell you. So I was getting these warnings, right? So let me refresh. Wait, let me save it. So let me refresh it now. Okay, 1 second. Okay, so say successfully updated. Let's go back and check whether it's working. Alright, so basically you have to disable the enforce SSL connection in your MySQL, and that would be it. I forgot to do this. Alright, so now I will choosing a file and I'll be uploading this particular file, which is desert. I'll click on upload image and it will take some time to upload the image, and it says well done, blob update complete. And as you can see, my image is loading. Let's check whether we have it in our dashboard, as in our storage account. We'll go to Azure Edu, we'll click on blobs, we'll go to hello container, and you can refresh it. And as you can see, there will be a file here which says 1496742468. Alright, so let me connect to my MySQL now again. Alright, just give me a second. I will type in MySQL-H and then the username. So this is my hostname, guys. So I'll copy this hostname, paste it here, and then my port number, which is 3306, my username, which is this, I'll paste it here, and then the password, which is as of now this edu1234 exclamation. I've connected to my database. I'll use the database that I've created. Select table and I'll show you the record. Now let's compare it with what is there. It's 1496742468 and it's 1496742468. So guys, as you can see, the same file has been uploaded here and it has been mentioned here. So what my website is now doing is, it is basically fetching the file from my database and then accessing that file over here in my file system, and hence displaying it in its background. So as of now, since there is only one image, it is not showing the slideshow. Let me choose one more file. Let's upload the koala image and click on upload image. So now when you will see, that's the image which is being loaded. And if I go here and I refresh it, I can see that there are two images now here, right? And in my database as well, if I refresh it, I can see two images. Alright guys, so this website seems to work fine. It is connecting with my storage account. It is connecting with my database on Azure. Now let's check if my files have been uploaded. So it says, okay, this might take some time, guys. So let's wait, because we are all set here. We are done with everything. We are just waiting for our files to be transferred here, and then I'll show you how it works over there. Alright, so let's wait. Alright guys, so my transfers have finished. So now let's check whether my web app is working or not. Right, so I'll go to the dashboard. I'll go to my web app, and this is the link. I'll click on this link. Now guys, like I said, you have to add the IP address of the web app in the MySQL as well. So when I go here, you'll see an error, right? And now, like I said, we have to send the index file again. So I delete the index file from the server from here. All right, copy the index file again because it's been updated. All right, and now I will refresh this. So as you can see, it says the IP address is not allowed to access the server. So what we'll do is we'll copy the IP address. We'll go to our database, go to connection security. All right, so here we are. We'll select the web app, give the start IP and the NIP. All right. So let's get rid of the spaces, and this is it. Now we'll click on save. Now, why are we doing this? We are doing this because here we got an error that this IP address is not validated with the MySQL. So we have added this IP address over here. It says successfully updated security settings. Let's refresh it and check. Okay, awesome guys. So now my website is working. So I have successfully updated my website in the web app. All right, and I didn't have to configure anything. I didn't go to the UI. I just transferred my files and my website is up and ready. This is the address which is being used to get to the website. All right, so guys, this was the demo. Let me get back to my slide. So let me recap what I did. I configured my app service with the code. I configured my MySQL with the IP addresses of my own computer to configure it and the IP address of my app service so that the app service can communicate with the MySQL. I configured my blob storage and I configured its address in my code, my PHP code, and I configured the host name and the password for the created MySQL service in my PHP code as well.
What is Azure certification? Azure certification is a level of Microsoft cloud expertise that an individual obtains by passing one or more certification exams. Microsoft Azure certification validates an individual cloud expertise and skills. Now let us move on to our next topic and see some of the benefits of Azure certification. With an Azure certification, you validate your cloud skills in your selected domain. You will earn the credibility, and your present or your future employee will know for sure that you have worked on Azure and have the skill as you mentioned. The next advantage is you will have higher salary packages. Business Wire has estimated that Azure course certification have raised their wages by 20 to 40%. Payscale.com also announced that based on the position and job description, those credited by Microsoft Azure could get a salary of $128,000 per annum. With the Azure certification, you can pursue a wide range of career options. You can become a cloud architect, a developer, a solution architect, or even AI engineer. There are many options. And in addition to this, the certification enables you to work with different industry at different locations. The next advantage would be it provides a proof of commitment. To get an Azure certification, you should be able to commit yourself to it. You would have to sign up for a course, study, and then only pass the exam. That would imply that you can commit your time and resources towards achieving your goal, and that you're dedicated to improving your career objectives in the long term. These were some of the benefits of Azure certification. Now let us move on to our next topic and see what are the types of Azure certification. First, we'll take a look at different Azure certification based on job roles. So first, we have developer certification who designs, builds, and tests cloud solutions. Second, the system administrator who implements, monitors, and maintains Microsoft solution. Third, a solution architect who expertise in compute, network, storage, and security. Fourth, we have the data engineer who designs and implements the management, monitoring, security, and privacy of data using the full stack of data services. Fifth is data scientist who applies machine learning techniques to train, evaluate, and deploy models that solve business problems. And then sixth, we have the AI engineer who use cognitive services machine learning, and knowledge mining to architect and implement Microsoft AI solutions. On 7th, we have DevOps engineer who combines people, process, and technologies to continuously deliver valuable products and services to its company. 8th is a security engineer who implements security control and threat protection. He also manages identity and access and protects data, application, and networks. And last, we have the functional consultant who leverages Microsoft Dynamics 365 and Microsoft Power Platform to anticipate and plan for customer needs. Microsoft Azure certification have 4 levels of certification. First is the fundamental level, second is the associate level, third is expert, and we have specialty. Now, specialty certification is a certification based on a particular domain. Now, let us move on to our next topic and see some of the major job role based certification. Now, before we get into any major role based certification, I would like to talk about a fundamental certification, which is Microsoft Certified Azure Fundamentals or AZ900. Now, this certification is intended for candidates who are just beginning to work with cloud-based solutions and services or who are new to Azure platform. This certification will provide an opportunity to prove your knowledge of cloud concepts, Azure Services, Azure workloads, security and privacy in Azure, as well as Azure pricing and support. Candidates who take this certification should be familiar with general technology concepts, including concepts of networking, storage, compute, application support, and application development. The AZ900 certification is the fundamental certification which can be used to prepare for any other Azure role-based or specialty certification, but it is not a prerequisite for any of them. Now let us see some of the major role-based Azure certification. We have the Azure Administrator Associate or AZ104. Candidates for the Azure Administrator Associate certification should have subject matter expertise in implementing, managing, and monitoring an organization's Microsoft Azure environment. The responsibility include implementing, managing, and monitoring the identity, governance, storage, compute, and virtual network in a cloud environment. They also have to monitor and adjust resources wherever and whenever needed. They often serve as a part of larger team dedicated to implementing an organization's cloud infrastructure. For this certification, a candidate should have at least 6 months of hands-on experience administrating Azure. Along with that, they should also have strong understanding of core Azure services, Azure workloads, security, and governance. The next certification is Azure Developer Associate or AZ204. Candidates for the Azure Developer Associate certification should have subject matter expertise in designing, building, testing, and maintaining cloud application and services on Microsoft Azure. The responsibilities include participating in all phases of cloud development, from requirements definition and design to development, deployment, and maintenance to performance tuning and monitoring. Azure developers should participate with Cloud Solution Architect, Cloud Administrator, and clients to implement solutions. A candidate appearing for this certification should have at least 1 or 2 years professional development experience and experience with Microsoft Azure. Next, we have an expert level certification, which is Azure Solutions Architect Expert or AZ303 or 304. Candidates for the Azure Solution Architect Expert certification should have subject matter expertise in designing and implementing solutions that run on Microsoft Azure, which would include aspects like compute, network, storage, and security. The responsibilities include advising stakeholders and also translating business requirements into secure, scalable, and reliable cloud solutions. They should partner with cloud administrator, cloud DBAs, and clients to implement solutions. A candidate appearing for this certification should have advanced experience and knowledge of IT operation and also know how decision in each area affects an overall solution. These were some of the major role-based certification. Now let us move on to our next topic and see an overview of the exam guide. First, we have the exam format or question types. Microsoft continuously introduces innovative testing technologies and question types. Your exam might contain questions like multiple choices, repeated answer choices, short answers, mock review, drag and drop, labs, and so on. The time limit for different examination is, for associate and expert job role exams, you have 130 minutes to complete it. For job role fundamental exams, you have 60 minutes to complete it. For associate and expert job role exam that contains lab, you have 150 minutes to complete it. Now talking about the cost for the exam, for the fundamental exam, it would cost you $99. For the associate and the expert level exams, the cost is $165. and you can write the certification exams in either English, Chinese, Korean, or Japanese. Now, the fundamental certification can also be written in Spanish, German, or French. Now, let us move on to a last and important topic, which is how can you prepare for the certification? First, start with the basics. So, if you're not 100% sure which certification to start with, I would recommend you to start small by taking the AZ900 Azure Fundamental Certification exam. This will help you understand how Microsoft exams work by not being too deep into technologies. And after you have experience taking the Microsoft exam, this will help you understand how Microsoft exams work while not being too deep into the technology. Having experience taking the Microsoft exam, it will also help you focus on the actual topic and not on the testing process. The next step is to understand the exam content. The first thing to do after you decide which exam you're going to write is to see what you're asked during the exam. Every Microsoft exam page has the skill measured in the exam. This list is very accurate and helps you focus and study the right content. The page will also have some training and courses to prepare for the exam. You should also understand the different question types asked in the exam, which will help you in the certification. The next step is to take hands-on learning courses on Microsoft Learn for free. Microsoft Learn is a free learning platform for a lot of different Microsoft technologies. It provides you with various learning paths depending on your job roles or the skills you're looking for. Most of the learning paths gives you a hands-on learning opportunity so that you can develop practical skills through interactive training. The next and the most important step is hands-on experience. The best way to learn and pass the Microsoft Azure exams is by having real hands-on experience working with the technology. While Microsoft Learn gives you some free hands-on learning modules, there is also Azure Free Account. The Azure Free Account will provide you with 12 months of free Azure services so you can work on various Azure services for free. Now, the next step which will help you prepare for the certification is reading the Microsoft documentation. It will help you understand the topic better which might appear in the exam. As I've mentioned before, read the skills measured on the exam page. Look up for the specific Microsoft documentation pages and read through them, and then try them out in the tutorials. You can also refer some books from Microsoft Press. You can find Microsoft Azure documentation and Microsoft Press in Microsoft Azure Certification official page. After the step, you can also take up a practice exam. Some of the Azure certification have practice examination along with it, which is very similar to the actual certification examination.
Now let us understand what you will get after you sign up for Azure free account. So basically you get many things for 1 year, which includes $200 credits for first 30 days, popular services free for 12 months, more than 40 other services which are free all the time, and 750 hours of virtual machines which includes Windows and Linux, and you can create up to 250 GB SQL database. Apart from this, you can get other services like free dev test labs, free load balancers, free batch jobs, free SQL Server, etc. Now we'll see how to create an Azure free account. For this, you require a phone number, a credit card, a GitHub or a Microsoft account to create your Azure free account. The best way is you can create a Hotmail or an Outlook email ID, then you can use the same email ID and password to sign up for the Azure free account. So firstly, you need to sign in through the Microsoft account using your Outlook, Hotmail or any ID. And after that, you need to follow the couple of steps. That is, you need to first fill out about you, and then you will go through a verification by phone, and then you go through the verification by card, and finally you sign up. In the first step, that is about you, here you fill up your basic details, that is first name, last name, email ID and phone number. Then followed by next step, that is identity verification by phone. So here you give your phone number and you will receive an OTP, and you need to just type your one-time password and just verify your phone number. So once you're verified, you move on to the next step, that is identity verification by card. Here you fill up your all credit card details followed by card hold number, then credit card number, its expiry and CVV and your address. Once all it is done, Then they charge you around 2 rupees just for your verification. They charge you 2 rupees and it is deducted. Once it is deducted, you move to the next step, that is like accepting the agreements. So you need to just tick mark all the agreements and finally you sign up. So once all this process is done, then you are ready to start with Azure. So this is how you create your Azure free account. It's very simple and super easy. So now let us know how to create an Azure free account without a credit card. So can we do this? So the answer is yes. Yes, you can. You can create an Azure free account without a credit card. But for this, you need to have a school account or a required school email ID. So you basically log in as a student. In this case, if you log in through a student account, so you will receive only 100 credit points, and you also get various other services like 750 hours Windows virtual machine, and you can create up to 250 GB SQL database, and you also get machine learning free workspaces, SQL Server Developer Edition, that is also for free, and lots of AI and machine learning features. This is how you create your Azure free account without a credit card. Now, let's move on to the next topic, that is, can we delete a credit card? So many of us had a doubt that can we actually delete our credit card? So here in this picture you could see that I have a payment method and here the delete option is disabled. So why is this so? In this case, you cannot delete a credit card as there is only one payment method option. If you really want to delete a credit card detail, then you need to add one more payment method. So you can click onto this add icon and you can add your new payment method. Once the payment method is added, then your delete option gets enabled. Then after that, you get the access to delete any one of your credit card details. So this is how you delete a credit card detail. Next, how to cancel subscription. So it is very easy to cancel the Azure subscription. So for this, you just need to go to cost management section. There you get go to subscription option. Once you click on to the go to subscription, you get all the details of your current subscription. So, and you can also find the cancel subscription option there. So once you click on to the cancel subscription, they will ask you the type of subscription name and you need to provide a reason why are you canceling the subscription. So you just give the reason, prescribed reason of your own, and then just click on cancel subscription. So once you click on to the cancel subscription, they will ask you the type of subscription and the reason why you want to cancel the subscription. So you can give your details accordingly and click on cancel subscription. So this is how you can cancel your Azure subscription.
How easy it is to actually go ahead and carry out your business processes or computing processes on Microsoft Azure. So what makes it this easy for you to actually go ahead and use all these services on this particular platform? Well, one of the major reason is its portal. Azure Portal actually helps you do a lot of things that basically simplifies your work of cloud computing. So let us just go ahead and take a look at what this Azure Portal does. Before I start about Azure Portal, I would like to inform you that we would be opening Azure's portal and then we would be understanding what this portal is, what are the services it helps you with, and how it actually relates or combines all the stuff that cloud has to offer to you. So to do that, let me just quickly switch into the console part and we can just get started with the remaining part as well. So guys, what I've done is I've gone ahead and I've switched into Microsoft Azure Portal. So for people again who are completely new to cloud computing, they might ask as in what is this Azure Portal and how do I get to this portal? So this is what the link is. It is portal.azure.com. If you are a completely new person to this particular page or this website, you would be required to sign in and create an account. Now, as you can see, I already have an account here. It is a fresh account. The reason I've chosen a fresh account is I wanted this dashboard to be clean so that we could go through certain pointers. However, there are certain applications that are running which would help us to understand certain pointers which otherwise you wouldn't have. So this is a perfect account for me. Apart from that, if you need to have this account, as I've already mentioned, you would have to go ahead and create a particular account. How do you do that? You visit this link, that is portal.azure.com. Once you do that, it would ask you to sign in and put in certain details. So when you do sign in or sign up, you'd have to enter certain details like your email ID, contact details, and why do you want to use this account. One pointer you need to consider is Microsoft Azure would ask you to enter your credit or debit card details. Now, do not worry, they do not charge you unnecessarily. What happens is this is a free tier account where Microsoft Azure would give you certain credit limit, maybe 12,000, 15,000, something like that. I do not remember the exact number, but it is somewhere around 10 to 15,000 in that range. 10 to 15,000 Indian rupees, because I am based in India right now, so I'm talking about Indian rupees. When you talk about it in dollars, I think it is somewhere around $200. So based on where your account exists, in that local currency, you would be given certain amount, which you can spend for 1 month and use all these services for free. So yes, you have sufficient time to explore all the resources. What Microsoft Azure does is it asks you to enter your credit card or debit card details. That is, once you exceed these limits, you might be charged, because all these services have a certain cap on that. Don't mistake it for the fact that you'd be charged, because these limits are fairly high and probably you won't be charged in any way, but still you would be wanting to get through the documentation as in how much would you be charged. But before that, I would suggest that you actually go ahead and enter in all these details, create an account, and once you have an account, probably you can go through the pricing models as well to avoid getting billed in case if you actually go ahead and exceed these limits, which is very less likely to happen. So that being said, we have an account. If you do create an account and sign in, this is what your interface would look like. And this is something we call it as the Microsoft Azure Portal. So let us try to understand what does this portal has to offer. What are the components that are there? Now, as you can see on the screen on your left-hand side, you have all the services that are listed. Now, these are the most commonly used services. When I say services, most of them are domains, as in these domains have more services under them. So domains and the services that you can see here on this part, there is an option called as create a resource, using which you can actually create these resources as well. Then you have this dashboard. It is blue in color for now. Let me see whether the color changes. Yep, as you can see, the color has changed. So if you double click on this dashboard, the color would change. So you can probably customize it to meet the needs. For now, let me just stick to the standard version, which is this. So you have the freedom of changing the color, and all the stuff that happens, the applications you launch, you can actually go ahead and have a picture of these things on your dashboard. How do you do that? Probably you can choose first of all which dashboard do you want to use. If you have multiple dashboards, you can do that. As you can see, this is one dashboard which has certain things pinned here. You can unpin those things and you can pin in all your applications to this dashboard. You can click on those applications and you have an option of pinning them to the dashboard. Next thing that you can do here is when you actually launch an application, there is this notification panel where you would be notified as in what has happened. If you've launched an instance maybe and you want your virtual machine or your application that is running on top of it to be on your dashboard, here you'd be given an option. Do you want to pin it to the dashboard? And you can say yes, and immediately it gets pinned on the dashboard. Now, what benefit does this particular thing serve? I mean, what would I get if I actually go ahead and pin it here? The thing is, based on your business model, I mean, this is a fairly simple demo, so we do not have too many applications that we are talking about. But as your business grows, probably you might be dealing with a number of servers, a number of applications. So you might want particular information which is readily accessible to you. So you can probably pin those things on your dashboard. You get stats on those dashboards. If there are certain insights, you can actually have a plugin for analytics, which gives you reports and all those things. It readily integrates with Power BI, which is a very powerful data visualization tool using which you can actually have all the insights that you need. So yes, this is what the dashboard is. You have all the options here. You can create a new dashboard. You can upload files, download files. You can edit it, share the stuff that is there on your dashboard. You can probably maximize the screen size as well, clone certain dashboards and delete it here and here. So when you talk about dashboards, you have all the features. Now this is your Cloud Shell, guys. So what does a Cloud Shell do basically? So when I say a Cloud Shell, as I've already mentioned, you have your portal using which you can launch applications and you can do all the stuff right away. But at times you might be required to use command prompt. You might be required to hard code certain things. And how do you do that? You click on Cloud Shell, where you can use it through the command prompt medium as well. Cloud Shell is the command prompt which is provided by Microsoft Azure. Apart from that, you have settings where you can actually go ahead and modify the settings. As you can see, this is the theme. You can change the theme here as well if you want. some other features which you'd want to explore. You can just go ahead and explore all the settings, delete certain settings, private dashboards as well. That boils down to your requirement. If you are unable to figure certain things on yourself or on your own, you'd want to actually go ahead and check in what the support has to offer to you as well. Feedback, you can submit feedback whether you're happy or not. And this is your account. If you click on this link, whether changing your passwords and stuff like that, all those things would be taken care of here. So guys, yeah, this is pretty much the dashboard. I mean, you can click on these services and you can just explore those services. If you have a particular requirement, you can type it here. Say if I type Azure bot service, if there is something or any service that is related to this, any documents as well, that would be popping up here, and you can actually go ahead and direct or redirect yourself to those services from this mode as well. So yep, this is pretty much the interface, guys, the portal which I wanted you people to see. But let's not keep it this basic for now. What I'm going to do is I'm going to go ahead and create something. So if I click on this create option, it gives me an option of the stuff. I mean, I can choose, say for example, for now it says Windows Server VM, which means that it would launch a virtual machine, guys, which is Windows Server 2016 VM. Now, let me tell you what a VM is for people who are completely new. This might be basic for people who have some experience of cloud computing, and they might wonder as in why am I talking about these small little things, but probably we have people around who are completely new. So for them, I might get into the details of certain basic topics as well. So when you talk about a virtual machine, what we do is suppose I am running a particular application and it is supported by a particular operating system, say Windows in this case. So I want my architecture to support that particular operating system, right? But when you talk about larger applications, you might not always work on a particular environment. Your environment might change. So what cloud computing does is it readily lets you launch these virtual machines that can deal with different environments. And yet all these virtual machines can be under one network, and they can stay connected under one VPC or one virtual network, basically. So yes, you can run multiple environments. You can have multiple applications running on different platforms and stuff like that. So this is one service that lets you do that. That is virtual machines offered by Microsoft Azure. And you have something called as web app, which lets you launch web applications. It is more platform as a service kind of an application. So what is a platform as a service application? Here, a complete platform is provided to you by a vendor. You just enter in certain details and it does everything for you. It launches virtual machines. I talked about having different environments, right? So when you click on a virtual machine and create one using Microsoft Azure, you have to specify details like the security group, IAM users, what network it lies under, and then you have to go ahead and manually install softwares, run your applications on top of it. But when you use something as platform as a service, what it does is it launches all this platform already. So your VM basically, which I talked about, is your infrastructure as a service where just the infrastructure is given to you, and on top of it, you do everything. But in PaaS, your vendor does everything for you. They launch this instance in the background, all the services that I mentioned, as in assigning security groups, security, IAM users, assigning it a network. All these things are taken care by a vendor. Even the platform that you choose, that is set up by your vendor. All you do is you just put in your data there. So this is platform as a service. So when you talk about Microsoft Azure, your web apps, basically when you create a web app, it is a PaaS service. All you have to do is just go ahead and enter a name, say sample app for me. You have to select the subscription. For now, it is the company's account that I'm using. It would create a resource group on its own, as you can see. And then all I have to say is create. So it has selected an operating system. Whether it wants to use a code or a Docker image, it is up to it, right? So it would take care of everything that is happening here, guys. My application would be launched right away. As you can see, I have been notified already that the deployment is in progress. It might take maybe half a minute or a minute and a half maybe for this deployment to complete. I mean, all the processes that I talked about, those are happening in the background right now. And once those processes complete, I can actually go ahead and launch my application. So this would be a very basic application, guys. And as I've already mentioned, when you have a dashboard, it would ask you, do you want to pin your application to the dashboard? And if I say yes, it would pin it there directly. Let's hope that it happens quicker. See, it says pin to the dashboard. I would say yes. And there you go. It has been pinned to the dashboard. I can delete it, unpin it, and do whatever I want to. I can click on it and the application would open for me. So this is what the interface does. It gives me certain options, guys. I can check in the activity log, what all has happened in this application. If I click on this icon, It would give me the information. The operations, see, this is the operation name, that is right sites. So it has written a site. Access controls, who gets to control this application in particular. If you need a quick start guide, you can come here. Deployment slots, you can take a look at that as well. Application settings, you can click on this and you'd be getting all the settings. If you want to make a change to that, you can do that as well. The version, what application are you using and stuff like that. Configuration preview, click on this, certain other details would be given. So what framework are you using and stuff like that. Authentication process, guys, if you click on this icon, it would give me details about that as well. So if I scroll down, I come here, I have quite a few other things which I can actually look at. So if you are interested in these things, you can just come here and explore as in what is happening here. So this is pretty much it. I mean, the application has been launched. So if you take a look at it, it would give you details. What is the resource group that you're using? What is the URL? Where is it located? It is located in central US, guys. So see, I'm based in India right now and I've launched an application at a data center based in USA. So that is what you can do. And if you click on this link, it would tell you that your application is up and ready. So yes, a simple application has been created. So this interface, that is Microsoft Azure's portal, is fairly easy to use, fairly nice to use, and there are quite a few things which you can do. I've talked about certain basic things only. There are quite a few things that you can explore. I would suggest that you do go ahead and explore all these resources. As you can see that this has been done. If you want to take a look at some of the services here, you can actually go ahead and say all services, and it would give you details about all the services, all the resources. Yes, you click here and you have all the resources that are available to you. You can actually go ahead and modify your search as well. You can decide which resource group you want to view your data into. For now, I have these many resource groups that are there, which are running because this is an account that belongs to someone else. So this is my resource group. I can actually go ahead and select which resource groups I want to use to shortlist this data. Here's the information about all the resources. You can modify them, delete them, work on those, and do all the stuff that is required. If you go back to the dashboard, you would be taken here. If you open, you have all the other information again, diagnosis, application insights. You can install certain plugins that give you all these insights as well. For now, one more thing that you need to know is if there are certain applications that might charge you on the longer run, you'd want to get rid of those resources once your usage is done. You can just go ahead and delete those resources as well. Type the name of the app. It says it is sample app for me, if I'm not wrong. There you go. You can just go ahead and delete this application and it will delete that application for you guys. It's fairly simple, guys. The application has been deleted as well. So yes, you're free to actually go ahead and explore this particular portal. And I hope that you'd be having a lot of things to do. As far as this particular session goes, this was what my aim was, to introduce you to these basic things, and which I feel I've done. In case if you feel that I might have missed out on certain things, you might put those in the comment section, and probably next time when we do have a session on this, we can have a discussion on that as well.
Why one needs Azure virtual machine? So first thing is of course the cost saving, the pricing criteria. So we can like shut down and stop the virtual machines if not in use. Stopped virtual machine will not incur any charge. Restarting the virtual machine will maintain its state based on persistent disks. Second, the boosted scalability. So we can like scale up and down or in and out the virtual machines. Auto scale features is also there to support based on some metrics. For example, scale out to 5 instances when CPU utilization is greater than 70% for more than 5 minutes. Third is alerts. So like we can trigger actions and alerts based on metrics of computing resources consumed by a virtual machine. Fourth is we can have a better control or say more amount of control. So with Azure Virtual Machines, developer have more control over the development environment, which is very helpful in case of building a highly secure architecture for a complex solution. Developers can choose operating system, networking, storage connections, etc. to build a sandbox solution. Lastly, easy diagnostics means Azure Virtual Machine provides the facility to troubleshoot issues with options like remote debugging, event logs, IIS logs, application logs, etc. Moving ahead, let's understand in brief what is Azure Virtual Machine. So for that, we are going to first understand what is a virtual machine. So a virtual machine is a computer file typically called as an image which behaves like an actual computer. It is one of the files which contains everything. It runs in Windows, Linux, etc. This gives you a flexibility that you can run multiple machines in a physical computer. Each system can have a different operating system Each of these virtual machines provide its own virtual hardware, which includes CPUs, memory, hard drives, network interfaces, and other such devices. Now let's understand what is Azure Virtual Machine. So Azure Virtual Machine is one of the services provided by Azure to create your own instances. So it can be used for various ways like development and test applications in the cloud and also for extended data center. It is to remember that when you are running Azure Virtual Machine, you must pay for the compute time on a per minute basis. The pricing of this is based on the size, operating system, and any licensed software that has been installed in it. In order to avoid corresponding charges when you are not using it, it is to be saying that you change its state to stopped, that is deallocated. Now let's understand some of the key features of Azure Virtual Machine. So first is isolation. So each of these network work independently. When creating a virtual network, you can divide them into segments. You can configure the virtual network to use your own DNS servers. Second is virtual network connectivity. So it can be connected to each other, enabling resources in any virtual network to communicate with resources in any other virtual network. Third is internet communication. So by default, when you are launching any instances in the Azure virtual machine, it can access the internet. As and when you need, you can enable inbound access to specific resources. Fourth is on-premises connectivity. So a virtual network can be connected to an on-premises network, enabling resources to communicate between each other. Then there is Azure resource communication. So resources which falls under Azure Virtual Network can communicate with each other using private IP addresses, irrespective of the resources are from different subnets. They provide default routing between subnets. On-premise networks operating system, you don't have to configure and manage routes. So the next one is routing. So Azure's routing can be optionally overridden by default through configuring with your own routes or by propagating BGP routes through network gateway. And the last one is traffic filtering. So network traffic can be filtered from resources in a virtual network by source IP addresses and port. So now let's understand the Azure virtual machine architecture. Azure was initially named as the Project Red Dog by Microsoft. The brain behind the Project Red Dog is Mr. David Cutler. In initial days, it was a custom version of Windows, and the goal was to boot from a virtual hard disk. So for that, let's first try to understand the main components of Azure Virtual Machine. So first is Fabric Controller. So one of the most important components in Azure Virtual Machine architecture is this is one of the pillars based on which the architecture works. Fabric Controller basically owns all the resources. The placement of the nodes, load balancing, scalability as per requirement, update, patch management, everything is owned by this segment. As the user creates their own instance of virtual machine, all the tasks like provisioning or the deprovisioning along with the supervision of all the nodes is taken care by the Fabric Controller. In brief, we can say that this is the backbone of the Azure Virtual Machine system. So next is the patch management. So patch management workflow is a major advantage of the Azure system, as this module makes Azure easy to manage and stay updated across all the nodes. In Azure system, hosts are image based, therefore there is no need to update all the nodes one by one like a legacy system. Here, Azure basically delivers updated VHD at one place and the entire system of nodes gets updated. A typical update takes place every 4 to 6 weeks, which ensures security and system stabilization. Microsoft here ensures that the updates are tested and verified before it gets rolled out to the nodes. Third is partition. So Azure Fabric Controller has a couple of partition types, and they are update domains, fault domains. These partitions help Azure Virtual Machine to maintain its availability and resilience. The partitioning helps maintain zero downtime, minimum failures, and constant availability. So the first is update domains in partition. That is, it is the strategy that ensures the upgradation of the servers without taking it down. Then Microsoft Azure system distributes instances into a few update domains. Here, every update domains work as a logical unit. One update domain gets upgraded at a time. The upgrade process gets completed when all the update domains are processed. Azure makes sure that the upgrade is completed with the minimum impact on the running services. Then there is fault domains. Fault domain is nothing but a single failure point. Fabric Controller ensures that isolated hardware failure does not happen by distributing the instances to multiple fault domains. This will prevent the malfunctioning of the system due to any single component malfunction. Then there is Azure Compute Stamps. So Azure divide things into multiple stamps, and each stamp has its individual fabric controller. Azure has two kinds of stamps: compute stamps and storage stamps. The fabric controller is also distributed in multiple branches. Azure generally has 5 replicas of fabric controller, and they are all in synchronization to replicate the state. In these 5 instances, one is primary and the information is passed to primary by the control panel. Now, primary instances make sure that same instruction has been passed to the secondary instances. Now, the last one are like some other virtual machine components. So, apart from these, there are 3 other important components of Azure Virtual Machine. They are computer, storage, and networking. So Microsoft Azure also has the capability to monitor the health of the virtual machines in place, and if any issue is found, there is an option to auto recovery. This service is known as service healing. As the Fabric controller has the capability to detect the failure, therefore this task is carried out by the Fabric controller to detect failure and trigger auto recovery. So this was all about the components of like the main components of Azure Virtual Machine. Now let's understand the architecture of how to run a Windows virtual machine on Azure. So provisioning a virtual machine in Azure requires some additional components beside the virtual machine itself, including networking and storage resources, as we recently talked about the other virtual machine components. So let's understand this step by step. The first is the resource group. Resource group is a logic container that holds related Azure resources. In general, group resources based on their lifetime and who will manage them. Then there is a virtual machine. So you can provision a virtual machine from a list of published images or from a custom managed image or virtual hard disk, like what we say as VHD file, uploaded to Azure Blob Storage. So Azure offers many different virtual machine sizes. If you are moving an existing workload to Azure, start with the virtual machine size that's the closest match to your on-premises server. Then measure the performance of your actual workload in terms of CPU memory and disk or input or output operations per second, and adjust the size as needed. So generally choose an Azure region that is the closest to your internal users or customers. Not all virtual machine sizes are available in all regions, so keep that in mind. Then there are disks. So for best disk input output performance, we recommend like premium storage for that. Go with premium storage, which stores data on solid state drives, means SSDs. So cost is based on the capacity of the provisioned disk. IOPS and throughput also depend on disk size. So when you provision disk, consider all the factors like capacity, IOPS, and throughput. We also recommend using managed disks. So managed disks simplify disk management by handling the storage for you. Managed disks do not require a storage account. You simply specify the size and type of disk, and it is deployed as a highly available resource. The operating system disk is a virtual hard drive stored in Azure storage, so it persists even when the host machine is down. We also recommend creating one or more data disks which are persistent. So virtual hard disks used for application data. When possible, install applications on a data disk, not the operating system disk. So some legacy applications might need to install components on the C drive. In that case, you can like resize the operating system disk using PowerShell. The virtual machine is also created with a temporary disk. This disk is stored on a physical drive on the host machine. It is not saved in Azure storage and may be deleted during reboots and other virtual machine lifecycle events. Use this disk only for temporary data such as page or swap files. Then there is a network. So the networking components includes the following resources like virtual network. So every virtual machine is deployed into a virtual network that can be segmented into multiple subnets. Then there is network interface. In short, we say it as NIC. The NIC enables the virtual machine to communicate with the virtual network. So if you need multiple NICs for your VM, be aware that maximum number of NICs is defined for each virtual machine size. Then there's public IP address. A public IP address is needed to communicate with the virtual machine. For example, via remote desktop means RDP. So the public IP address can be dynamic or static. The default is dynamic. Then there is a network security group, where we say at NSG, which are used to allow or deny network traffic to virtual machines. NSGs can be associated either with subnets or with individual virtual machine instances. Then there are certain operations, so that includes diagnostics. So enable monitoring and diagnostics, including basic health metrics, diagnostics, infrastructure logs, and boot diagnostics. So boot diagnostics can help you diagnose boot failure if your virtual machine gets into a non-bootable state. Create an Azure storage account to store the logs. A standard locally redundant storage account is sufficient for diagnostic logs. Then there's availability. So your virtual machine can be maybe affected by planned maintenance or unplanned downtime. You can use virtual machine reboot logs to determine whether a virtual machine reboot was caused by planned maintenance. For higher availability, deploy multiple virtual machines in an availability set. Then there are backups to protect against accidental data loss. So use the Azure Backup service to back up your virtual machines to geo-redundant storage. Azure Backup provides like application consistent backups. Then there is a stopping a virtual machine. So Azure makes a distinction between stopped and deallocated states. You are charged when the virtual machine status is stopped, but not when the virtual machine is deallocated. In the Azure portal, the stop button deallocates the virtual machine. If you shut down through the operating system while logged in, the virtual machine is stopped but not deallocated. So you will still be charged. Then there is deleting a virtual machine. So if you delete a virtual machine, the virtual hard drives are not deleted. That means you can safely delete the virtual machine without losing data. However, you will be charged for storage. To delete the virtual hard drive, delete the file from blob storage to prevent accidental deletion as a resource log to log the entire resource group or like log individual resources such as virtual machine. So this is all about the major components and how they work in synchronization with each other to form a virtual machine. So this is how the architecture looks like and how it works of Azure Virtual Machine. Now that we have a theoretical as well as an architectural understanding of Azure Virtual Machine, let's try our hands on it on how to create a virtual machine and how to connect it. So you can just go to the Azure portal. Here you see all the services which you have recently used, and you can just directly go search for virtual machines from here. Go to the virtual machines. Here you see there's no virtual machine being created till now, so you can just go to create. So subscription Azure Labs we have, and then resource group we have to give. If you already have a resource group, just give or create a new one from here. Resource. You can give a name as well. I'm going to give VM demo 01. Area is Central India, so yeah, region I'm choosing Central India, which is nearest to me, and also my consumers are nearest to me. That's the region I'm selecting. So always keep in mind while you select the region, select the region which is near to you and also to your consumers. Then in availability options, requirements, security type standard, Windows 2009 data center generation 2, right? Azure, no, not required. Size, then we have to choose. Yeah, I can go with B1, or you can like select any other size. You can see for all the sizes, so you can select any one of them. Like right now I'm using B1. I can use B2s as well, so I will just select B2s. That has 2 virtual CPUs and 4 GB of memory. Then I will be creating a username. So Azure admin is good for me, and I will give a username as well. It should be alphanumeric along with special character with 1 capital letters as well. So keep that in mind while creating the password. Password meshed. So let's go to the next step. Public and one not selected. Allow selected report. So RDP 3389 you have to select if it's not selected. So yeah, now let's go to the disk. No thanks, not required. Then select whichever is viable for you, like SSD or HDD standard one. It also like the price was also dependent on which option you are going with. So I'm going with standard SSD right now. Next, networking. Nothing is required. If you want to change anything as per your requirement, you can change that to management. Auto shutdown, if you require enable, like if you enable auto shutdown, it will auto shutdown. That's depend on you. Right now I don't require that. So go to the next one. Extensions and everything is there. So I'm selecting an extension here for myself. You can also like select which one is required for you. I require Microsoft entire malware. Go next. So then I just have to create that. So I created next text. If you want to add any text, you can. It's up to you. And then you can just go to review and create. So here you will actually get the price. Right now I'm not getting because I have a different kind of an company based account. But if you have any personal account, then you will be getting the total price of your virtual machine you're going to host, right? So you can recheck all the information you've selected for, all the services you have been selected, sub services, and then you can create it. So the virtual machine is getting deployed. So here you can see deployment to resource group is in progress. So now you can see the deployment is complete. So you can just go to your resource from here. Let's see what all is created. We can see a virtual machine is created, public IP address is there, a network security group is created for security purposes, then there's network interface being created, then a storage disk is being created, and as well as the virtual network. As we have understood, all these things are required on virtual machine architecture. You've understood, right? So that's all been created. So we can go to a virtual machine. Now you can see here status, it is running right now. Location, the region location, you can see it's showing Central India, and you can see the public IP address as well here. So all this is here. You can actually like copy the public IP address and directly connect it through your remote desktop connection by pasting it here and connecting it, or you can just go to connect and go to RDP, and here you can like download the RDP file, the personal RDP file. Just for that, one thing, remember, you have to go back to that. You have to copy the IP for that. So you can see the IP is copied. So let's open the RDP. Yeah, go to connect. Yeah, so for that same IP, the RDP has been downloaded. So we don't require IP to paste. So you can just give the username and ID that we have given while creating the virtual machine. So that was regular. And then the password credentials. Yes. So we have created the virtual machine and now we have connected it as well. So here is your service manager which has been opened, and here how your virtual machine has been created. So virtual computer has been created. Here you can see the dashboard, all the things like add roles and features, whatever you want to add, and get from here, or you can create a local server given all the requirements. You can create a local server as well and come to this PC, and here you can see all like this is the storage. You have got temporary storage and main program storage. So this is how we can connect the virtual machine. I hope you have understood it. So stop this session. Yeah. So I've closed the virtual machine and I can even stop it from here. If I go here and stop, so that it stops, like the charging cycle gets stopped. You won't be charged for running the virtual machine. Here, so through this we can like save our cost. It is under process. It is getting stopped. Takes a little while. See, you can see the status as deallocating. Deallocating means it's getting stopped. So you can see it's successfully stopped, and after that you can even delete the virtual machine. So the virtual machine is getting deleted, and through this billing cycle was still going on for because we had a virtual machine with us, so it got deleted. So virtual machine is, you can see, is deleted. Still other things are still there. If you want to delete the resource group as well, you can completely delete the resource group. You just have to type the resource group name. So delete. So all the services which are being under this will be deleted along with the resource group. So you can see and just come to home, and now you can see there is no. Okay, let me go to the VM resource. The resource not found because it got deleted. Okay, let me refresh it once again. So yeah, there's no resource group anymore. So this is all about the virtual machine and how to create it as well as how to delete it and all the concepts behind it. So next is the pricing options. So for pricing option, you can just simply go for Azure Virtual Machine pricing. Let's see the pricing structure, how the pricing works for Azure Virtual Machine. You can see like you can select whatever the operating system you want to choose. You can choose that from here. Just a sec. Yeah, everything is there. You can choose as per your requirement. Like right now, going with I'm going with Windows OS only, and category I can choose like whichever I want to. Right now, I'm choosing general purpose only. Pricing is getting updated here. You can see BS series, AV2 and standard, D2 AS standard. All standards are there. On the basis of that, pricing differs. And now, if I choose the VM, just a second, Windows OS, choose the category that is general purpose. Then I have to choose the VM series. It is suppose I'm gonna choose BS series, and then the region. Suppose I choose mine Central India. Currency, no in rupees or dollars. It's up to you. Like suppose I'm going with dollar only right now. I'm displaying prices by hour or by month. You can see, and then you can come to see the prices, right? For B1s, because we have choose the B1s, right? BS series. So B1s, that is the price dollar wise. Similarly, if you could go with a different series, like suppose we say this V5, then you can see the prices got changed. This is how it gets changed. So this is how you can look for the prices and go as per your requirement.
What Azure Kubernetes service is. Now, I'm not going to get into the details of this service right away, but just to give you an introduction, Azure Kubernetes service is a fully managed container management service. It is provided by Microsoft Azure, obviously, which is a very popular cloud service provider. And recent stats also state that it is one of the leading public cloud service providers in the market. So when you talk about Azure Kubernetes, it is basically managed by Microsoft Azure. What it does is it offers serverless continuous integration and deployment experience. Now, what does that mean? What we can do with it? We'll discuss all those things as we get into the details of Azure Kubernetes service. For now, we need to understand quite a few other concepts before we get to that point. But to summarize a few of its benefits, what Azure Kubernetes service does is, what it offers is end-to-end deployment, scalability, and availability. Now, how do these things work? We'll discuss that. But before that, let's try and understand what evolution of software development and deployment is and how it has evolved with time, right? So we all know how applications were built and how they've progressed with time, right? So if you talk about the popular ways in which software development and deployment has evolved, we all think of waterfall model, agile model, and DevOps, which is the current way in which we basically go ahead and deploy applications, right? Or basically not only develop, but also maintain, monitor, and deploy applications, right? So let's try and understand all of these one by one. Let's see how they evolve with time. So when you talk about waterfall model, agile model, or DevOps, they all have these three things, which basically sets them apart, right? The application architecture, be it their deployment or packaging, and finally, the application infrastructure that we can think of. Now, when you talk about the application architecture, the first one, that is your waterfall model, is known for its monolithic architectures, right? Something that we came away from. If you talk about current generation, we are more into the microservices model that is handled by a DevOps, right? So when you talk about waterfall, we had monolithic applications. That means everything was inside a single application. Your servers, right? Your applications, be it your management tools and stuff like that, everything was inside a single application. And these kind of architectures were called as monolithic architectures. Now, with time, we had agile model where we had multi-tier applications where some of your applications or some of the functionalities of your applications were handed over to some other domain or to some other tier, right? And hence we had multiple tiers. Say, for example, you would have your application tier in one place and you'd have your basically your database tier in other place, right? Something like that. And when you talk about DevOps, they took this functionality to a further classified, I would say, architecture where we had microservices or granular parts of your application that could function independently. Now, why do we need these kind of changes, right? Why did we not opt for monolithic applications? Now, when you talk about monolithic applications, these were bulky and these were very rigid, not easy to basically go ahead and modify. If you had to change the entire thing. When you talk about Agile, it gave you more flexibility. How? We had multi-tiers, right? So if one of the tiers is not functioning, right? So we could actually go ahead and work on that tier and it would not affect the remaining functionality. But when you talk about DevOps or when you talk about microservices in particular, it basically breaks down your application into granular chunks where each of these applications performs as a whole, but you can think of them as an individual part, which you can basically go ahead and function or operate on individually, and also ensure that you can basically make changes to these individual parts individually without affecting the functioning of the entire application. Now, when we talk about deployment and packaging, we have different ways in which these applications are hosted, right? Or in which these different ways of software development and deployment work, right? So when you talk about deployment packaging, your waterfall model supported or supports your physical servers, right? You have a physical server. Similarly, when you talk about your DevOps, or rather we have Agile first. So when you talk about Agile, you had your virtual servers. Now, if you talk about cloud computing, yes, to some extent, it supports virtualization, but back in those days, virtual servers were a little different. So if you talk about Agile model, it basically lies on a deployment model which is based on virtual servers. When you talk about Microservices, on the other hand, they are more based on containers kind of an deployment is what I would say. Similarly, if you go ahead and discuss their application infrastructure, now for your waterfall models, we had data centers that basically had all these applications being hosted, right? Your monolithic applications. Similarly, when you talk about Agile, we mostly move to the hosted platforms, right? And when you talk about current microservices or your container infrastructure, we talk about cloud hosting. And that is why we've come up with this session where we'd be understanding how containers work on top of cloud. That is your Kubernetes orchestration tool. In this case, would be working on our Microsoft Azure cloud platform. So I believe the evolution of development and deployment is clear to you all. Let us now go ahead and understand or discuss some of the other bits that are there on our plate. Now, before we actually go ahead and understand how Kubernetes works, right? And why are we talking about containers and stuff? We need to understand how containers are different from virtual machines, because virtual machines are something that people have been using and many of them have migrated to containers. Why? Because both of them, they have their benefits and reasons for these benefits. So let us try and understand how a container is different from a virtual machine. More than a comparison, it is just understanding how they're different from each other. Now, this image should give you an understanding as to how these two things are different. The one on the left-hand side, you have your container, and on the right-hand side, you have your virtual machine. Now, when you talk about virtual machine, what a virtual machine does is, on top of your server, it lets you host your guest operating systems. To give you an example, when you talk about a service, right, or if you talk about a cloud platform like Microsoft Azure, where you have Azure virtual machines, which again lets you spawn instances or virtual machines. Now, these virtual machines or instances can have different guest OSs. Say, for example, if you launch a virtual machine that basically has a guest OS of Linux, and there's another virtual machine that has a guest OS of your Windows, right? So we are talking about two different virtual machines or entities which function on the same server, but they have different operating systems. That means if I want an application to run in Windows, I can do that using my VM, that is Windows in nature. And similarly, if I want something to run on top of Linux, I can use the virtual machine that is Linux in nature, right? So that is what virtual machines offer you. Okay. But there's a catch here. When you talk about a virtual machine, you're talking about a server, right? On top of that server, you'd be having your host operating system on which you'd be running a hypervisor. Now, this is more of a middleware, okay? Or a service that supports all the applications that are there on top of it, including the operating system, the guest operating system that we are talking about. Now, here, the problem is, as you can see, the virtual machines that you see on the left-hand side, right? They'll have separate guest OSs, they'll have their bins, and then on top of that, they'll be having the applications that are running. Now, what is the disadvantage here? Here, what happens is, each time you have a virtual machine that is operating, we need to ensure that there's a guest OS there. So there's a dependency on this. And what this does is, it makes it difficult for you to basically break this virtual machine from the existing infrastructure or architecture and make it run somewhere else, right? Because this is a complicated process. But when you talk about your containers, this is where the difference lies. Say, for example, I'll be having a Docker engine in this case, right? It can be anything. I mean, when you talk about Docker engine, it is a type of tool that provides you containers, okay? So supports container spawning for you in simple words. There are other container tools as well. We are not here to discuss Docker, but Docker is one of the most popular container tools. That is why you see Docker here. So think of it as your container image, what you see there in the left-hand side. So you can see that there's a server host, you have your hypervisor, you have your guest OS. So guest OS here is common, right? So when you have a guest OS here, what that means is all the containers that would be running on top of it would be running on the same guest OS. So you do not have a dependency where basically you have to ensure that all the guest OS requirements are also there in your container. So your container is more independent of the operating system, right? The only concern here though is, in case of containers, you have to ensure that if you have one hypervisor or one Docker engine that is running for you, right? in that Docker engine where there's a single guest OS, in that case, you'll be running all your containers that are supported by that guest OS, right? Now, if my guest OS is Windows, I cannot expect myself to run Linux containers there. I'm just giving you an example, okay? So there's a drawback there. But the benefit here is, right, since your applications, your bins and your library files are independent, you can package them in a container and move them across easily. So you can run it on other Docker engines as well to support your claim. What that does is, since you have this freedom here where you're not dependent on your guest OS, right, or you do not have a guest OS inside your container, you get certain benefits. It makes your containers faster, okay, makes them reliable, and at the same time makes them efficient. So that is what basically containers are, and that is how they're different from virtual machines. So I hope by now the point here is clear to you all, as in how do these things function. Okay, let us now go ahead and understand the other bits. So now let us try and understand what Kubernetes is, right? Because many of us know that it is a container orchestration tool. We always try to compare it with Docker, which may not be the rightest things to do, or the best things to do rather. Why is that? Let's try and understand that, as in what is Kubernetes, why do we need it, and is it same as Docker or not? Okay. Now, here are few things that would tell us why do we need Kubernetes, and how it is different from Docker is something that I would discuss in this bit itself. Now, when you talk about Kubernetes, it is used for container communication. Now, this is where it is different from Docker. When you talk about Docker, it is something that lets you basically set up containers and work with containers. Okay. When you talk about Kubernetes, it is something that lets you manage these containers, be it your Docker containers or be it other kind of containers as well. So that is what Kubernetes does for you. Now, let us try and understand why do we need something like Kubernetes to manage these containers, be it a Docker container or be it any other container. Now, when you talk about containers, they cannot communicate with each other. They need help to do that. This is where a tool like Kubernetes comes into picture. Apart from that, if you go ahead, what containers do is they basically can be deployed as applications, right? As individual applications. But since it is easier to deploy these applications thanks to containers, you cannot just go ahead and deploy applications the way it suits you. You cannot just go ahead and deploy your containers the way it suits you, right? There has to be a process behind it. You need to understand what containers to spawn, what to schedule, what to release, right? I mean, what to deploy rather. So to do that, this is where Kubernetes again comes into picture. Third bit here is careful container management. Now, what do you mean by careful container management? It again is similar to what we discussed, right? As we talked about how deployment works, similarly, we also need to understand how container management works, right? When you talk about containers, there are quite a few pointers that come into picture. Now, at the start, when I talked about Azure Kubernetes Service, you realize that there were certain pointers that talked about, I mean, there were some highlights or features there on the first slide that showed you it helps you in better deployment, right? And quite a few other things. So when you talk about those pointers, right, what services like Kubernetes do is they ensure that your deployment is happening properly. You are able to deploy multiple applications, right? And you are also able to track whether these applications are up and functioning, whether one of these applications is dead. Do you need to work on it, right? So you get this kind of management when you talk about Kubernetes. Enable auto scaling. To give you an example, let's assume that you have an application that basically deals with 3 servers. Now, let's assume that that application does very well, right? In this case, you might need to scale that application. Is it easier just to go ahead and scale these applications? No, right? Because there could be a possibility that now you have to manage not just 3 servers, but you're required to manage like 100 servers. In that case, using a tool or using an orchestration tool rather like Kubernetes would help you ensure that all your containers running in different 100 servers on top of these different 100 servers are functioning properly. So this is where auto scaling comes into picture. What Kubernetes does is it gives you an ability to auto scale your applications in situations where manual intervention is not needed. And that is what Kubernetes does for you. So these are some of the reasons why Kubernetes came into picture. So yes, we had containers, but these were some of the drawbacks that containers had, and this is what something like Kubernetes lets you do. Okay, let us now go ahead and understand what is Kubernetes, right? So I've already explained what Kubernetes is. There's not a lot of different pointers that have left to be explained. So if you talk about Kubernetes, right, it is an open source container management tool which automates container deployment, container descaling, and container load balancing. So all the activities that we discussed, right, be it managing multiple servers, ensuring that all the containers are working together, right, they're able to communicate with each other. So basically all the container management, it happens, all the orchestration, it happens using your Kubernetes, and that is what it does. Okay. What is one of the benefits it offers? It works brilliantly with all cloud vendors, be it your public, hybrid, or on-premise. Okay. And one of those popular cloud platforms, as I've mentioned, is Microsoft Azure, which we'll be discussing as we move further. So what do you need to know more about Kubernetes? Now, these are some of the facts, right? I mean, some of the things that might intrigue you. I'm not very sure about that. But if you talk about Kubernetes, it was developed by Google. Okay. So Google, as we know, brings in a big customer base, a big audience, right? A big community to discuss. And that is why this in itself is a big thing. Why? Because when you talk about something like Kubernetes, it is going to have a huge community. And that would mean that there's huge support, huge documentation for you to work with. It was developed using a programming language called as Golang, and it entirely was built using it. Apart from that, to summarize what Kubernetes is, you can think of it as a number of containers that can be put into one logical unit so that you can simplify the process of managing these containers and how they work. Okay, so this is what Kubernetes is in a nutshell. Let's try and understand how the architecture of Kubernetes works and what are the components that you should know about Kubernetes. So this is what the basic architecture of Kubernetes looks like. Okay, so you have your APIs, you have your Kubernetes master, you have your image registry, then you have your nodes, which basically are nothing but your applications. So let's try and understand these one by one, as in how do these function. Okay, so when you talk about the APIs, the CLI, and the UI, right, the first thing that you need to do is you need to set up a Kubernetes cluster, right? So when you talk about a Kubernetes cluster, a cluster would be nothing but your central management point using which you'll be managing all your applications or your different containers that host your applications, right? So first what you do is you create this cluster, something that you can do by using your CLI, right? And then you can interact, or others can also interact with your cluster by using an API server. Okay, so your API server is nothing but that basically ensures the authentication and the identification of the people or the resources interacting with your Kubernetes master or with your Kubernetes cluster. Okay, now if you talk about Kubernetes cluster to start with, your Kubernetes cluster, here what you can see is you have your Kubernetes master, right? Kubernetes master is something that basically manages your containers. And what you see on the left hand side, the nodes and stuff, right? This is nothing but your worker nodes. Now this is where you will be having your applications that are actually running. So your worker nodes would be implementing or running your applications. Your Kubernetes master, on the other hand, would basically be managing these applications and telling you how to basically run these applications on top of it. To understand this better, let's go ahead and take a look at this diagram that you have. Okay, so what you see here is you see a Kubernetes master, right? And inside this Kubernetes master, there are quite a few other things as well. We'll discuss those. But what you see on the screen are some key components that you need to know. Okay, so inside your Kubernetes master, you'd be having two important pointers, that is your replication controller and your service. Okay, so when you talk about a replication controller, it is nothing but a resource that is owned by your master, that is your Kubernetes master, right? What it does is it ensures that the requested number of pods are running on nodes always. Okay, so your replication controller is something that controls the functioning, not controls, it basically tells your worker nodes that keep the nodes or the pods running. Now, what are the pods and what do they do? We'll discuss that. Do not worry about that. It's not very complicated, but that is what your replication controller does. Apart from that, you have your service, which is nothing but, again, an object on your master node, right? Or your Kubernetes master rather, that provides load balancing across replicated groups of pods. Now, let me try and make sense for these two terms by first explaining what are your nodes, what are your pods, right? So when you talk about your nodes, these are nothing but your worker nodes, which would be holding your application. Now, in this case, your node can hold more than one application. What we do is we basically classify our worker nodes into pods. Now, pods are sub-entities, right? These are logical collections of the containers which need to interact with each other for the applications to keep running, okay? And inside these pods, you basically have your containers. So that is what the infrastructure looks like. You'll be having pods and which would be holding a logical set of containers that probably result in a particular kind of application, right? And you can have multiple such pods. What you see here is you see Docker. So what it tells you is the worker node is nothing but a container, right? So it can be other container tool as well, need not be Docker. But again, as I've mentioned, Docker is a popular tool, so you see it here. So what you see here is basically a Docker container, right? Which has multiple pods, and these multiple pods are basically responsible for running your application. And who controls all these applications? Your Kubernetes master. So assume a situation where you need to scale up a particular virtual machine, not a virtual machine, in this case, a particular node. So how do you do that? To do that, you basically have something like a load balancer, which helps you balance your load, right? Either distributed or in case if you need scaling, it helps you scale your applications as well, right? And then you have your replication controller that basically ensures, right, your application is running. So what your replication controller does is it tells your node that this application has to run, okay? And who makes it run? There's something called as kubelet. Now inside every node, there would be another entity called as kubelet. That kubelet is responsible for running your application. So this is how your Kubernetes architecture looks like, and this is how it functions. Now, we've understood what Kubernetes is, how it works, right? Let us now go ahead and understand Azure Kubernetes Service. Now, to give you a brief about Azure Kubernetes Service, as I've already mentioned, it is a Kubernetes service that is hosted on the Azure cloud platform. Okay, so let me just go back to the slide one and explain that again so that we can go ahead and understand how working of Azure Kubernetes happens. So we've already seen this slide, right? What is Azure Kubernetes Service, but now it would make a lot more sense for you. Okay, so what can happen or what Azure Kubernetes Service offers to you. Now, if you talk about Azure to start with, it is a popular cloud service provider. What that means is with Azure Kubernetes or with Microsoft Azure, you can basically have various services that help you in software development, planning, management, right? Be it your administrative practices, development practices, or architectural practices related to a software. All these things can be hosted on a public server in this case, which again can be your Microsoft Azure cloud. Now, what it does is it basically gives you all the services that are needed to carry out all the actions that I just mentioned, where you can rent these resources or follow a pay-as-you-go model and use these services to benefit your requirement. Okay. Now, when you talk about a platform like Microsoft Azure, which again is a cloud platform, as I've just mentioned, the possibility of dealing with applications are plenty, or the possibilities rather are plenty. So you can do so many things. So what that does is that gives developers or application owners options to work with these applications in numerous ways. Okay, it simplifies their complications, right? Since if you're talking about a platform like Microsoft Azure, it helps you basically orchestrate quite a lot of activities, be it managing your servers, infrastructure, right? Be it basically load balancing, be it auto scaling. All these things can be controlled by using the cloud platform. So what that does is that gives developers this added benefit, okay, or the application owners this added benefit. And that is why what these cloud platforms are doing these days is they are encroaching or basically covering different domains, be it your big data, DevOps, analytics, right? All these things are or can be implemented using these cloud platforms, because when you talk about these cloud platforms, they're already owning various markets of software development and application hosting. Okay. So that is why having something like Kubernetes work on top of Azure is a benefit. Why? Because some of the complications that you'd find difficult to implement using Kubernetes can be controlled by using Microsoft Azure. And that is why you have these added benefits, be it your end-to-end deployment, be it your availability or scalability. If you talk about some of the benefits that it actually offers, what it does is you pay only for the nodes that you use. That means last time I checked, Microsoft Azure did not charge you for your master node. You only get charged for your worker nodes that you use. Okay. Your cluster upgrades are easier, so you do not have to worry about the patching part and stuff like that. Integration with various Azure and other tools and services becomes easier. Not just that, what you can also do is you can actually go ahead and enforce various rules that are under Azure policy across multiple clusters to have uniformity if you need to, right? What you can also do is you can scale Kubernetes and other nodes using autoscaler that Microsoft Azure supports. And you can even expand your scale even greater by scheduling your containers on Azure containers. So that is what Microsoft Azure Kubernetes service provides you with. Okay. Let us now move further in this Azure Kubernetes service tutorial video, and let's try and understand some of the other important pointers, like how does the architecture of Azure Kubernetes services works. Okay, to understand the working of AKS or Azure Kubernetes service, right? You can see this diagram on the screen. It's a fairly simple diagram and it tells you what Azure Kubernetes service does. Okay, so we've already seen how Azure Kubernetes architecture works, right? I mean, we know what all components it has and stuff like that. This is a more detailed view. So what you'll have is you'll have again a Kubernetes master node or cluster is what you can call it. Okay, so in this master node, the functionality would be same. It would be controlling how the deployment and how the management of your containers work. So basically, Azure will manage your master node. It will basically help you control quite a few activities that are there. As a customer, you'd be managing the applications only. There too, you would have support from Microsoft Azure. How we would understand that? Now, if you talk about the control plane, what you have here is you have your API server. Now, when you talk about your API server, what it does is it basically tells you how the underlying Kubernetes APIs are exposed. Okay. What this component basically does is it provides the interaction for your management tools, be it your Kubectl or the Kubernetes dashboard. Similarly, you have your etcd. Now, etcd basically what it does is it maintains the state of your Kubernetes. When I say the state of Kubernetes, I'm talking about the Kubernetes cluster, and basically it helps you control all the configuration that is there. This thing is highly available and it is key value based in nature. Okay. What you also have here is basically you have a scheduler. What your scheduler does is it lets you create and scale your applications to basically determine which nodes can run on what workload and stuff like that. Okay. And finally, you have your controller manager. Now, this is an important bit again. What it does is it controls or oversees a number of smaller controllers, whether they're performing their actions or not. And what it also helps you in doing is replicating the pods that you have and handling your nodal operations as well. So this is what your control plane does, and it is basically managed by your Azure. Now, what is the benefit of having Azure manage it, right? Since Azure is managing it, you do not have to worry about the configuration part, setting up part, right? Your cluster node is basically set up by Microsoft Azure, and that is what it simplifies. Then the other bit is your customer managed bit, be it your kubelet, right? Kube proxy, your container and container runtime. To understand this better, I think this diagram should draw a clearer or a better picture for you. Okay. So basically, when you talk about your customer part, now there are quite a few things that you need to know. I've mentioned kubelet, which basically lets you run your pods, right? Your pods are run by your kubelet. That is what your kubelet does. Okay. There are other things as well that you need to know here. You have your Azure Virtual Network Interface. Now, it is something that takes care of all the interface requirements that you might otherwise have. Okay. And Similarly, you have your kube proxy, right? Kube proxy again works together with your virtual network interface, right? Or basically your Azure virtual network and tells you what needs to be done. Okay. Now, all these things, they reside on a virtual machine again. So we've discussed all the differences and benefits of it. So what Azure does is it basically launches a virtual machine for you on top of which your containers would reside. Okay. So when you talk about these containers again, these are nothing but your applications that are running for you. Okay. And these are the services that would help you actually implement or control all these applications that are there. You can actually go ahead and scale up your virtual machines to meet the requirements of your application in different ways. So this is how the working of AKS is. I mean, this is how the master node works, and this is how your basically customer node or your worker nodes work when you talk about AKS. We'll see these as we get into the demo part. But before that, let's go ahead and understand a use case or see a use case as to how vehicle safety with AKS is supported. Now, when we say vehicle safety, we are talking about a use case that was set forth by Bosch. Okay, Bosch, as we all know, is a very popular company which has numerous thousands of employees working across the globe for meeting different technological needs of the world. Okay, in this particular use case, what they thought of was the amount of accidents that happen due to wrong way driving. Okay, and what they thought was, could we find a solution that could basically help us overcome this bit of problem? Okay, so what were the problems that they were facing, right? When you talk about wrong way driving problems, right? What are the issues that we face? Okay, because of wrong way driving, there could be a lot of accidents, unplanned casualties, and stuff like that. But if I am to avoid wrong way driving using technology, it's a very tedious task. The reason for that is what I can try and do here is I can basically set up an application that notifies me of wrong way driving, right? But then for that to happen, I have to have a lot of data that is in real time. And when I'm driving, my only way of fetching data is by using cell phones and GPS, right? But then again, there are problems with these things. When you talk about cell phones, they basically function very well in a radius of 5 meters distance when you talk about their operational radius rather, or there are limitations when you talk about range on exchanging this data. Okay. So you can transfer data to a larger audiences. We see that through WhatsApp and stuff. But if you talk about GPS kind of data, we are talking about multiple points or multiple data that we are dealing with. And to deal with them parallelly can be a difficult task. So because of that, Bosch felt was that this was an impossible task to deal with. Why? In order to get the last piece of information out of the noisy sensor data can be a problem. And in order to develop a highly scalable and ultra flexible service to process this data in real time can also be a tedious task. What they also figured out was to solve this problem, they needed this data in real time and in very short duration. If we could do that, we could actually go ahead and save accidents and we could save these wrong way driving incidents. And that is why they decided to work with Microsoft Azure, which was their already supporting partner. What they also did was they ensured that they did go ahead and accommodate Azure Kubernetes service in their infrastructure. What this did was it ensured that Bosch would get repeatable, manageable clusters of containers. And since they work in such shorter durations, do not have latencies in minutes, but rather in seconds, they offered a simple form of services for them to work with. And what that ensured was they had the average time to calculate whether a driver is going the wrong way or not in milliseconds. So around 60 milliseconds they could figure out. That is around a second where they could figure out whether a driver was in the wrong way or not. And that is what basically your Azure Kubernetes service enabled them to do. Their major problem, that is they had the time constraint. That is something it helped them solve. And because of that, they could come up with this wrong way driving problem solution where they basically use Microsoft Azure to host their data and basically Azure Kubernetes service to basically help them in simple provisioning, scaling of applications, and ensuring that the real-time data is made available to the drivers within a span of 60 milliseconds, which again is a big achievement. So that is what AKS or Azure Kubernetes service had to offer. If you go to Microsoft Azure's website, there's so many good use cases that talk about AKS. So you might want to go ahead and take a look at that as well. as far as the session goes, we would go ahead and take a look at the demo and understand how we can actually go ahead and set up an Azure Kubernetes cluster and a lot more. Okay, so guys, let's go ahead and get into the demo part now. This is how the Azure portal looks like. Okay, I've signed into the Azure portal. Now for people who are new to Microsoft Azure, what Microsoft Azure does is it gives you an Azure portal where you can implement all the cloud related activities that concern Microsoft Azure. Okay, so if you want to practice from scratch, it also offers a free tier account where you have a number of services available free of cost. Okay, or rather, in case of Azure, it works differently. For AWS, you have those free services. With Azure, you have this $200 of credit that it gives you. So you can spend those $200 on creating resources for 11 months duration. Post that, those will expire. So if you do not have an account, you can just go ahead and create a free tier account, fill in the details, right? And you should have this free Azure portal for your usage. Okay. In my case, this is a paid account. This is the company's account. So it's called as pay as you go in my case. In your case, it would be a free tier account. But the functionality would be similar for you as well. The only thing is with the paid account, you have more services available to you. And even the larger instances is something that you can actually go ahead and spawn and use because you're paying for those, right? Under free tier, you don't have to worry about paying for them, right? So there are certain restrictions and limits there. So do go ahead and register to Microsoft Azure's portal. Okay. Now coming back to the demo part, what we are going to do now is we are going to create a Kubernetes cluster. And on top of that, we are going to deploy an application. And the application would be a basic pre-built app by Microsoft Azure. We are not going to create a new app. I'll be sharing the code for the application. So do not worry about that. So we are just going to go ahead and use that pre-built code, and we are going to deploy that code on top of Kubernetes cluster that we have. Okay. So the main thing to note here is we have to see how easily the cluster is created. We are not concerned about the orchestration process at all here. Everything is taken care by your Microsoft Azure, and that is what we are going to look into. So let's not waste any time. Just quickly go ahead and get an instance in place, rather a cluster in place. Okay. So to do that, we are going to click on this icon and say create a resource. Okay. Here you can see all the service domains that are there for offering. So I'm going to click on the containers one and click on Kubernetes service. Once you do that, you see you'll be brought to this page and you'll get all the details, right? AKS manages your hosted Kubernetes environment, making it quick and easy for you to manage containerized applications. The main point is without having to container orchestrate or have any expertise in that. Okay. It eliminates the burden of ongoing operations and maintaining, provisioning, upgrading, scaling your resources rather, which happens on demand here. So you don't have to worry about those things. So let's just go ahead and create a resource group. So for people who do not know what resource groups are, resource group is nothing but you can think of it as a small container or a folder where you put forth all the necessary things that are important for your resource to work. Now, in this case, our resource is Kubernetes. So quite a few other nitty-gritties related to it would be in the resource group. Okay. So let's just go ahead and create one. So I'm going to click on create new. Let's just say we have RG for demo. I'm going to give a simple name so that I can remember that. Okay. So I'm going to say, okay, I'm going to create a cluster. I'm going to call it cube cluster. Okay. This is enough. So cube, let's call it cube cluster. Okay. And this is in place. Where do I want it? If you're using a pay-as-you-go model, there won't be any restrictions here. If you're using free tier, there might be some. Okay. So just select any region that you want to do. I'm going to randomly select a region now. What region it should be? My region would be, okay, let's pick this one. And it would ask me how many nodes do you want to create? Let's create one. Since it's a very simple demo, we do not need more nodes. Okay. We've discussed what nodes are, right? So that is what we are doing. We are creating a node here where our application would run basically. So I'm going to say review, or let's just go ahead and see if we have all the settings. Node pools. Authentication, you have two options, whether you want your server or rather your cloud platform to manage your identity pools and basically create resources accordingly. You can do that, or you can select a service principal, which is an older way to do it, where you use an Azure Active Directory to do that. So there's no rule here. You can go for this one as well. I'm just going to do this just because I've thought of showing it to you. I selected that. It does not hold a lot of impact on our demo. Okay. Just gonna say create and review. Okay. So for creating this thing, now it will review all the requirements. If the requirements are in place, what it will do is it will just go ahead and create your cluster and put everything in place. Okay, so it says, do you want to create it now? I'll say yes, create. Okay, let's just refresh and see whether our application is done. It's still deploying. Let's wait for this deployment to get in place, and once it's done, we'll just go ahead and get these things in place. After this, the process is very simple. Okay, we are gonna just go ahead and put in certain set of commands and our job would be done. So you don't have to wait for too long post that. Okay, let's just refresh it again and see whether it's in place. Normally it takes a couple of minutes, so could take longer, right? But it's a very easy deployment process. So let me give you an idea as in what happens when you say that the deployment is happening. So first your Kubernetes will actually go ahead and launch a Linux instance to start. Okay. So once the Linux instance is in place, that is when we'll actually go ahead and put forth all our resources on top of it. In that Linux instance, we'll set up a cluster, right? All the nitty-gritties that we need, and on top of that cluster, our application would start working. Here in this case, it would probably set up a cache. Could be a Redis as well. We'll have to go ahead and look into it, whether it's that one. Okay. And then accordingly, we can go ahead and implement everything on top of that. But we don't have to get into the complications of things. It's a fairly simple process for us. Okay. Okay, let's just go ahead and refresh it once more. Okay, it's done. Your deployment has been complete is what it says. That means we are good to go ahead and use our resource. You can do other things as well on top of it. It is suggesting what all you can do. Okay. So we are going to do one of these things. Do not worry. So just go to the resource in our case. Okay. And in this resource, you can see there's all the information that you need. Okay. You'll get to know where it is hosted and stuff like that, what kind of instance it is, where it is located, everything. One node pool is what you have, right? So you have all the information to actually go ahead and connect to it. So in your case, I'm hopeful that it would happen faster than what you see in my case, or on my screen rather. You see, Cloud Shell is up and running. So let's just go ahead now and basically get credentials, right? Here, let's get the credentials or merge our cluster, okay, so that we can start using it. So how do we do that? We use this command. We say AKS, okay. And in this case, what we are going to do is we are going to say get credentials. Okay. Now the next thing is, what do we need? Resource group details. So I'm going to say resource dash group. And I'm going to give the resource group name, which I am certain that we should see if we just scroll up. Okay. So the resource name is RG for demo that we used. Okay. RG for demo. And what we also need is we need the name of the cluster. And in that case, it is kube cluster. So you can do it vice versa as well. You don't have to go this order. You can start by giving in the details for your cluster and then the detail for your resource group. I'm just going to hit the enter button now. Merge kube cluster as a current context in this path is what it says. Okay. Now let's just go ahead and get the details for the node. In this case, we know there's only one node, but you could be working on multiple nodes, right? So in that case, you have to use this command. You say kubectl. Now it is basically a client-side interactive tool for interacting with your Kubernetes. Okay, so that is what kubectl is all about. Okay, and you say get nodes. If there are multiple nodes, it will give you multiple nodes. If there's only one node, it will give you only one node. So there you go. You can see that there's one node that we have with us. Okay, we have all the details. It's been running for 5 minutes, it says, right? Because that is when we started the node. Okay, now the next thing is we are gonna go ahead and select the YAML file where we've actually put forth the details for our application, right? So how do we do that? For that, we are going to go ahead and use this command. Okay, nano, okay, space Azure. The name of the application is, or the application rather, is related to voting. So that is why I'm going to use this name, and I'm going to say .yaml. Okay. Okay, so guys, I've already pasted a piece of code here because I tried implementing this demo before. So you'll see that there's code here. Okay, so in this case, what we are going to do is we are going to remove this code just to be safe. I'm going to just paste the code again. So basically, this is where you'll have all the details. What is the API that is being used? What is the container port, right? What is the memory that you are using? What call are you making, right? All those details are here. Do not worry, I'll share the link to this piece of code in the description. If not, you can just look for Azure demos or getting started with Azure on your browser and you'll find this piece of code. It's available everywhere. You'll get this code on GitHub as well. I do not own this code, so I will not take any right in saying that this is something that I've created. It is a code that has been used and it is somebody else's work. Okay. So you may check out online the details. I'll also pass in the details in the description. Okay. So everything is removed now. I'm just going to go ahead and paste my piece of code here. Okay. I'm going to say paste and all the same code is again here with us. Okay. Now, how do I go ahead with it? In this case, I'm going to say justify, cut, uncut. Do I want to replace? I'm just going to say exit for now. So it's Control X in my case. And I'm going to say no, we'll discard the changes. So we'll say yes. So Y. That means it will save my code. Okay. I'm going to hit enter now. So it will take me back to my cluster. Okay. The next step is now what we are going to do is we are going to go ahead and call out this YAML file. Okay. So once we do that, this is how we are going to do it. We're going to say kubectl again. Okay. And apply /f Azure. What was the name again? /vote dot YAML. I'm going to hit the enter button. And there you go. What it has done is it has created a vote back application. Its front is created, its back is created, right? So we need to see how it looks like, right? So we are going to find out all the details, as in if we want to watch this app working, we need the details for it. So we are just going to go ahead and use a command called as get service. Okay, so get service is in place. And in this case, again, my app name, Azure vote, but this time I want the front. Okay, so I'm going to say front and I'm going to say watch and hit the enter button. I basically made a blunder here, and that blunder is we have to call this command through kubectl, right? So in this case, again, we'll have to type the remaining command again. So I'm just going to do it quickly. Okay, get service Azure vote dash front watch. And there you go. You have your external IP here. So guys, at times what you see here, your external IP, if your system is very slow, which is in my case, but I don't know how it happened. Its age is only 85 seconds is what it says. So normally it takes time for you to see this external IP. Okay. But luckily we can see it. So I'm going to just copy it here. Okay. And I'm going to paste it here. And this way we should be able to see the application that we've created. Okay. So you can see you can vote here. One, let me vote for dogs, twice, thrice, and I can just go ahead and reset it as well. Okay. So guys, this is how you actually go ahead and create a cluster. Okay. A suggestion here would be you delete all the resources that is there. Delete this one, delete the resource group, and also the Azure Active Directory so that you do not get charged. If you want to see what all we did here, right, and how the performance went on, Azure lets you track all the working as well, right? If you want to take a look at the insights and stuff, if you click here, you'll have all those details as well. So there you go. If I just refresh it, you should have all the details, right? How long did we use the cluster? This is where the usage started. Okay, so you'll get all these details that you want. So you can do that. So that's it. I believe this demo was clear to you people and you got to know what things we've worked on, how we've used these things, and how basically your Kubernetes cluster works. Okay, so we've created a simple Kubernetes cluster and explored it. Ensure when you go back, you just delete. Just go to the resources and delete the resource group, the cluster, and the Active Directory if any.
What are ARM templates? So as you can see in the definition, ARM template is a block of code that defines the infrastructure and the configuration of your project. So here it means that it is a way of deploying infrastructure as a code to the Azure environment. So here you create a project in that you define the objects you want, and you also specify their properties, names and their types, and you convert it into a JSON file. And once you upload this file into the Azure, what does ARM API do? It understands the whole code, which is in the JSON file. So here, the JSON file is then checked into the source control and managed like any other code file. So here, what ARM templates are like, they give you the ability to roll out within the Azure environment. So it can contain the contents of the entire resource group, like they can manage the whole resource group, or it can also contain one or more resources which is assigned under that particular resource group. So when a template is deployed, you have the option of either using complete or the incremental code, like part by part codes. So if you go with the complete mode, it deletes any object that are not visible or that does not appear within the template. Okay. So if you have a template and in that, if you are not able to see any objects, so you can delete. You can delete from those resource group which you're deploying. So in this scenario, whatever you're deploying into the resource group, like you will see that many amount of objects into that particular resource group. In the incremental deployment, it uses basically the template to the additional resources to an existing resource group. So the benefit of this is that you don't lose any infrastructure that is missing from the template, but the downside is that you will have to clear up old resources from the other way. So it's like whatever new resources you are adding into the existing resource group, that won't delete, you are able to see those. But once you are adding new, then you need to filter out the previous resources as well. In this case, the ideal deployment is complete, but it does mean that you need to have a good automated deployment pipeline with at least one test environment where you can validate that template and it doesn't rip the heart of your production. Like it should not ruin your management. Now that we've come to know what are ARM templates, now let us see why choose ARM templates. So how are they useful to us? What makes it so special? So there are a few advantages which validates that how ARM templates are useful to use in Azure environment. So we'll look onto them one by one. So our first is declarative syntax. So what does it means is that the RM template allows you to create and deploy the entire Azure infrastructure declaratively. So it means here that if you're using the RM template, you can create it while declaring all your by declaring all the codes in the JSON file. You declare your needs, your properties, and everything. It is very declarative. You declare, then it allows you to deploy it in that way itself. Okay. For example, you can not only deploy virtual machines, but also network infrastructure, storage systems, and any other resources that you need within that Azure environment. You don't have to go one by one, like first you create virtual machine and then you can go to storage account. You can create it at once. Next is repeatable results. So here you can repeatedly deploy your infrastructure throughout the development lifecycle and you have the confidence that your resources are deployed in a consistent manner. It is not key you can only deploy once, you can deploy it more than one time. So and you get the consistent results out of it. Like whenever you deploy, you will get that much appropriate results consistently. So here the templates are idempotent, which means that you can deploy the same template many times and the same resource types in the same state. So if you have created a template, you can deploy it more than one time. So whenever you deploy, the resources under it will give you the same results. You can develop one template that represents the desired state rather than developing lots of separate templates to represent updates. Next is orchestration. So, what do I mean here is that you don't have to worry about the complexities of ordering operations. So, the resource manager orchestrates the development of interdependent resources, so they are created in the correct order. So here you don't have to worry that in which order, like you don't have to think that which one should be deployed first, which one should be deployed second. So ARM template manages, it reads the code and it manages itself and it makes it in order, which has to be deployed first, which has to be deployed last. So it is done by the ARM itself. You don't have to do it manually. When possible, Resource Manager deploys resource in parallel so your deployment finish faster than serial deployment. It can also manage your time by just deploying the resources parallelly. So it can do the multitasking work, like it can deploy two resources at once so that you get the faster results. And you don't need so many commands to it. You can just deploy the template through one command rather than through multiple imperative commands. So here you just need to like hit a command to run this particular template and it all your other tasks are done simultaneously. Next is modular files. So here you can break your templates into smaller reusable components and link them together at the deployment time. You can also nest the one template inside the another template. So you can break down these templates into one or more parts and then you can link them. You can also just create a nested loop out of, like you can create a proper chain how your deployment should process. Next is you can create any Azure resources. So as we said, you can immediately use new Azure resources and features into the templates. As soon as a resource provider introduces new resource, you can deploy those resources through these templates. So you don't have to like wait for the tools or modules to be updated before using the new services. If you want that particular service to be included in your template, it automatically grasps that particular service and it makes it ready to deploy. Next is testing. So when we talk here about testing, you can make sure that your template follows recommended guidelines by testing it with the ARM template toolkit. So what does it do? It helps you like to test whether your whole process or your whole project is running smoothly and based on the requirements or not. So the test kit is a PowerShell script that you can just download from GitHub or any portal. So the main benefit of this toolkit is that it makes it easier for you to develop expertise using the template language itself. Everything is within the ARM itself. You don't have to have a separate testing toolkit for it. All right. Okay, so one of our folks named Rohan has asked, is there any other toolkit available? So as I said, Rohan, the testing process is within the ARM manager. So ARM itself has its own toolkit. So when you're deploying a particular template into that ARM API, so once it is in the process of deployment, it checks once it is deployed, it will automatically go under the testing process and it will test the whole template over there. So you don't need an extra toolkit for it because ARM is one whole soul thing. It is managing your services, it is managing your resources, whatever you're deploying into the Azure. Lastly, once it is deployed, it is also testing it whether that particular resource is working smoothly or not. I hope you got clear with this. Moving ahead, we have deployment blueprints. So before we see what is the advantage of these blueprints, let us understand what are basically blueprints. So just as blueprints allow a particular engineer or an architecture to sketch a project's design or the parameters. So Azure Blueprints is also one kind of them that enables the cloud architects or the central information technology groups to define a repeatable set of Azure resources that implements and adheres to an organization's standard patterns and requirements. So basically, the blueprint makes it possible for the development team to rapidly build and start new environments with same trust that they are building within the organizational compliances with a set of built-in components such as networking, speeding up of development and the delivery. So basically it is a declarative way to orchestrate the deployment of various resource templates and other artifacts such as role assignments, policy assignment, ARM templates itself, resource groups. So what is the advantage of deploying blueprints is like you can meet the regularity and the compliance standard. So these blueprints include pre-built templates for various architectures, which will help you organize your work as well as fasten your deployment rate. Next is track deployments. So in Azure Portal, you can review the deployment history and get information about the template deployment. And you can also see the template that was deployed, the parameters value passed in, and any output values. Other infrastructure as a code service aren't tracked through the portal. So here, whatever your deployment history, you can track down the deployment history. You can also get to know which template has been deployed and what were the parameters under that particular template and what output did you get out of those templates. So you can have keep a track of each and every deployments. Next is exportable code. So here you can get a template for an existing resource group by either exporting the current state of the resource group or viewing the template used for that particular deployment. So viewing these exported template is a helpful way to learn about the template syntax. Lastly, policy as a code. So, Azure policy, as we know, Azure policy is a policy as a code framework to automate the governance. So, if you're using the Azure policies, policy remediation is done on the non compliant resources when deployed to the template. So, these are some of the key benefits of the advantages of ARM templates, which makes it more useful within the Azure environment. Now, let us understand what are templates. So basically, the template is a JavaScript object notation or a JSON file that defines the infrastructure and configuration of your project. As we had discussed before, to create a particular object or if you want to run a particular resource, you need to specify what services you want to use and what are the parameters, its properties and its name and all the information into a JSON file and then you upload it. So it becomes a template. The JSON file is nothing but a template that is run inside the ARM, that is nothing but Azure Resource Manager. So the template uses a declarative syntax which lets you state what you intend to deploy without having to write the sequence of programming commands to create it. So in the template, you specify the resources to deploy and the properties for those resources. That is nothing but in the JSON file, you specify each and everything. What are the properties, whatever resources you want to deploy. And it becomes a template form and it gets deployed in the ARM. Now that we have understood what are templates, now let us understand the template design. So, defining the templates and the resource group is entirely up to you and how you want to manage your solution. For example, you can deploy your 3-tier application through a single template. So, as you can see in this diagram, so this is a 3-tier template. All right. So, in this template, you can run 3 types of application, that is virtual machine, app services, and SQL database. And it can be done within the one resource group itself. So here you don't have to define your entire infrastructure in a single template. Often it makes sense to divide your deployment requirements into a set of targeted purpose specific templates. But you can easily reuse these templates for a different solutions. So now if you see in this another diagram, you can also deploy a 3-tier solution through a parent class or in the nested form. So as you can see here, this is a parent template. Under this, we have created sub templates. That is, one template is for virtual machine, the second template is for app services, and the third one is for the SQL database. So here you can create it in the nested form as well. So it depends upon you how you need to design your own templates. And you can create different resource groups also, or you can add them into a single resource group. Now let us understand how do ARM templates work. So as you can see in this diagram, the ARM templates actually work on the hierarchical scope level. So as we know, there are different ways to create our resources like Azure Portal, Azure PowerShell, and Azure CLI. And apart from the Azure environment, we also have the third party clients, those are REST clients. So these are the different ways through which you can create your own resources and your resource groups as well. Once you start creating the resources in the Azure environment, so whenever you're creating a resource group or you're opting for a new service, so what happens that in the backend there creates a JSON file that is nothing but an ARM template. So as we discussed that ARM template is all about the JSON format. It has the JSON syntax. So whatever resources we would be creating or whatever services we would be opting within the Azure environment, that would be converted in the backend as the JSON file. And that JSON file then goes to our API, that is nothing but Azure Resource Manager API. So what does the Azure Resource Manager API do is that extract that file and then understands what are the requirements in that particular template. And for that, like now, if you're opting for a resource for any services from Azure, you always need a subscription. So it will check whether you are subscribed to Azure portal or not. Then based on your subscriptions, it allows the particular resources to get deployed. So once your subscription is authenticated, then you have a resource provider. So in the ARM template, we specify what are the different services we want to opt for or what and all resources we require within the Azure environment. So it goes automatically into a resource provider, and within that, we can run multiple objects that are nothing but our services. For example, virtual machines, app services, storage account, and SQL. So this is how ARM templates or the whole Azure Resource Manager work. So in a just if I call it as is like whatever resource you are trying to create in the Azure portal or through PowerShell or through CLI or from any third party application. So it does have a template and in the backend, which is then extracted by the RM, that is a Azure Resource Manager API. Then it processes the particular template for the deployment based on your subscriptions. Now we know that how templates usually work. It uses the JavaScript object notation syntax that also includes the advanced capabilities. So in this particular syntax, we have the different components. So the first component is the parameters. So what are actually parameters? So here the parameters allow you to pass the different values to the ARM template for use during the deployment. Some common examples like you can include the names of the resources or which Azure region to host them. So what do they do is it enables your templates to be more dynamic and used across the different environments. So parameters require a name and a type. So here you can include strings, array, objects, integers, boolean, or any secure string like password. Optionally, parameters also contain the description of how to use these particular parameters. So you can include default values to your parameters so that you do not need to provide one at runtime and you can configure it with a set number of values. So this configuration is helpful when you want to limit what SKUs or location a person can deploy the resources. The next component is functions. So in ARM template, functions allow you to create complicated expressions that you don't want to repeat throughout the template. So here what functions actually do is there are a lot of functions in other programming language. Like when we code, you add on different kinds of functions, like more than one function you can add. So you have a list of functions into it. But here you can tell them when you need to run them and you can pass informations to them and expect the return value from there. For example, say you need to create a unique name of a resource. So instead of copying and pasting the same code to generate the unique name, you can create a function that makes the unique name. For example, if a function called as unique name with a parameter named prefix returns a unique name using the resource group ID. So here, note this namespace value. So this value can be anything you want. So here the functions require a different namespace value to avoid a naming conflict with the regular template function. Next is variables. So variables are not much different in ARM templates that you find it another programming languages too. Here, the variables contains the values that are used repeatedly throughout the template. Like functions, you can use variables to create complicated expression. Like functions, you can also use variables to create complicated expression so that you don't have to repeat them into the same template. And like parameters, variables have the same data types such as strings, objects, and integers. So you can define variables using colon as a signed operator. For example, instead of passing the Azure region as a parameter, you can define it as a variable. So you can just type down location and whichever required location you need, you can specify there. Next are resources. So what are resources basically? So the resources defines the Azure resources to deploy within the particular template. So the resources can be anything as small as a network security group, all the way to, like it can be virtual machine, storage account, or functions, or any other services which are within the Azure environment. So when you specify a resource, so you have to give a couple of explanation in each part. Like you need to specify the name of the resource, and then you also need to give the type of the resource you need to deploy. Whether you need to like refer to the high level family of the resource to deploy. For example, like Microsoft.compute, Microsoft.storage, or .network. So this will help you out to map out these resources to deploy more precisely. Next, you need to also specify the API version, that is like to check the configuration of that particular resource. So you also specify the dependencies. So here dependencies determine the order of Azure, how Azure should deploy these particular resources. So for example, if an ARM template is deploying a virtual machine and then a virtual network, so the virtual machine will exist first before creating a virtual network. And then you start giving up the properties. So here the properties contain the configuration information for the deployment. And last is the output. So the output section will define the values and information returned from the deployment. It is helpful for the data that Azure dynamically generates through the public IP address. So these are the key components that are used in ARM templates and which will help you to work with these Azure Resource Manager. Now that we have an overview on the ARM templates, and all the key concepts related to ARM templates, now let's have a quick demo and let's see how do they actually work. So for that, let's quickly move on to our Azure portal. So we need to first log into our Azure. So let's quickly sign in. So this is our Azure portal. Now, as we had discussed that there are different ways, like you can use the portal itself to create your services. As you can see here, there are different services you can opt for, like create a resource group or service bus, virtual machines, application gateways, etc. And you also have your CLI, that is your cloud shell. So you can even run your commands, and you can create your resource group. So let's see how are these templates created while we create a resource group or any resource through Azure portal. So let's quickly create a resource group first. So as you can see, we don't have any resource group yet. So let's quickly create a resource group. So we'll give any random name to it. So as it is ARM, let's give it a name as ARM demo 123. And you can choose any of your region as it's up to you, like of your choice based on your requirements. So I'll take West US because that region is more free. So let's review and create. And your validation is passed. Let's create. So when you see over here, your resource group has been created now. And now you can also see your ARM demo has been automatically created. I will just go inside. So now that we have created a resource group, now if I just go into their properties, like we just click onto this resource group and we'll just go to their export template. So here you can see the template has been created. So this is a snippet code where it shows whatever object you have created. So under that, what are the parameters and what are the variables you need to add. This happens in the backend once you create any resource or any resource group. So one of our folks have a doubt. Tejashwini has a doubt that how does these template create? So Tejashwini, as we had discussed before, that whenever you create anything in the Azure, no matter if it is a resource group or if you're using any services, so whatever resource you're creating, either it is through Azure Portal or PowerShell or CLIs. So in the backend, it automatically creates a JSON file. In the backend, it automatically creates a JSON file, which then becomes a template. It is formed in the backend process so that it goes to the ARM, that is our ARM API, Azure Resource Manager API, then it can process the rest of the resources accordingly. All right. So it is formed automatically. So whenever you create any resources or any services you're applying to or you're utilizing any resources and you create any resource, so it will create a template, and that template will then go to the our ARM, and from there the whole process of the deployment starts. I hope you got an answer to your question. So as we have seen that we created a resource group, and as we go under their overview, you just come into these export template and here you find out your template, that is the JSON file, and you can even download it or you can send it to deploy as well. So now what we'll do, we'll create a resource within this resource group. So you can take any resources. So I'll just take up the storage account. Let's create a storage account at first. And our resource group is ARM demo 123. And now let's name our storage account as well. And we'll change our location. All right. And our performance would be standard because as our subscription is free and it is only for the demo purpose, so we'll be keeping everything as it is, and we'll just review and create. All right. So here, as you see, they are initializing the template deployment to the resource group. So as I said, whatever resource you're creating, it automatically creates a template of that particular resource within that particular resource group. So now once it gets deployed, we'll see. So here you see the overview, the input and outputs and your template. So we'll just get into this and you see. This is the ARM template of our storage account. This is how your ARM templates are created.
What an Azure Active Directory exactly is. Let us start by taking a look at the definition first. Now, if I talk about the definition, this is what we have. It is Microsoft's multi-tenant, cloud-based directory and identity management service that combines core directory services, application access management, and identity protection into a single solution. Now, there's so many terms in it and so many things to understand. Let me simplify this definition so that you understand it in a much better way. To do that, I would be giving you an example. Think of it in this way. Suppose I am a cloud vendor, or not a cloud vendor, I am a service vendor and I reside on a cloud. That means I have a particular application that runs on cloud. Now, this service is used by quite a few customers. Plus, there are quite a few organizations that I have to interact with. Now, in this case, all these medias or customers and organizations, they have to communicate with me. So how do they do it? Well, what they would do is they would go ahead and create an account or maybe have some user IDs through which they can actually communicate with me. Now, this is okay if the number is countable or manageable. Suppose there was a situation where we had n number of people and the number of people was constantly increasing. Suppose I have somewhere around 1,000, 2,000 people. Now, these many logins and these many credentials, managing all these can be a huge problem. Let me give you an example. How does this happen exactly, or what problems do you face normally? Suppose I have 10 organizations. Now, to log into all these or give access to all these 10 organizations can be a huge problem. Why? All these organizations might have different kind of accesses. Based on that, I have to set in different security protocols as well. If certain organizations have an easier protocol, what if they get an access to other organizations as well, or to the data that other organizations have to correspond to? In that case, it can be a huge problem. Apart from that, I might have n number of customers, and keeping track of so many customers can again be a problem when you talk about creating credentials. So all this is a huge problem. So what happened was Microsoft Azure, it went ahead and created something called as Azure Active Directory. It is nothing but something that acts as a middleware. It takes care of all the sign-ins and all these things. How? Now the users will have a single sign-on process. That means they would sign in only once. Plus, they can have access to the applications that are there, which I provide them. Now, this intermediary, that is your Active Directory, what it does is it federates all the responsibilities of taking care of access and all those things. That is, the way I set all the rules, it just incorporates those rules and accordingly it gives access to all the users, thus simplifying all the complexities that I would face otherwise. So this is what an Active Directory exactly is. It basically goes ahead and simplifies all the signing in and user authentication processes, or identification processes rather. Now, as we move further, we would be discussing quite a few other terms and you'd be having a clearer picture as to what I'm saying exactly. But meanwhile, you just bear with me and let's move further and try to understand what are the other points that we need to talk about. Okay, yes, I did miss out on this point. What Microsoft Azure does is it also gives you something called as a better platform where developers can develop their applications with a lot more ease. Again, as we move further, we'd be understanding this point as well. So what is the exact difference between Windows AD and Azure AD? Let's try to understand that as well. Now, when you talk about Windows AD, that is Active Directory, these are the layers it has to take care of. You have something called as your domain services, you have your lightweight directories, you have your federation services, certificate services, and rights management services as well. Now, these are so many things to take care of. When you talk about your Active Directory with Microsoft Azure, it combines all these layers into two. Firstly, you have your Windows Azure Active Directory. Now, it is something that takes care of all the services that surround or revolve around identity problems. That is, when you talk about identification management, this is the part that takes care of it. That is your WAAD. And then we have the other part where you have to actually go ahead and communicate with other organizations. I gave you an example of 10 different organizations needing 10 different things. That is federating all these organizations. Your Windows Azure Access Control Services, it takes care of all those things. So both these so-called Active Directories, they more or less serve similar purposes, but the approach in which they do is completely different. Your Active Directory has more layered approach where every service is given a different layer or different way of handling it. But when you talk about your Microsoft Azure Active Directory, it simplifies things. Your first layer takes care of most of the things, and the remaining things are something that is taken care by your Windows Azure Access Control Service. Also, when you talk about Active Directory, it uses something called as LDAP for various other communications. But when you talk about your Azure Active Directory, here you use something called as your REST APIs. Again, the approach is completely different. So what are the audiences that are catered by this directory? Well, first and foremost, we have IT admins. Now, when I talk about IT admins, what Microsoft Azure Active Directory does is it provides in single sign-on for various applications. Now, there are quite a few SaaS applications, that is software as a service applications, and various on-premise applications to which you have a single sign-on. You do not have to log in every now and then. Now, I've worked on quite a few applications and places where you have to log in every now and then. You have a lot of trouble because you have to remember so many passwords and so many logins, and these different credentials can be a problem. Now, this is something your Microsoft Azure takes care of. Single sign-on is very convenient. Apart from that, it ensures strong identification, and there are quite a few processes that ensure this. Now, I won't be discussing those points in detail, but yes, when you talk about identification, Microsoft Azure ensures that it happens in a very good manner. Plus, it automates quite a few processes, again easing up this process. Apart from that, it also caters quite a few developers as well. Now, I'm talking about quite a few organizations, and since sign-on becomes easier here, your application developers can focus on building applications. And since they have access to so many organizations and so many resources, application development definitely becomes easier. Online customers. Now, people who have been working for quite a while, they might know that we have things like Office 365, or you have your CRM services as well. Now, you had an access to all these things by using your Windows Active Directory, but your Microsoft Azure Active Directory also gives you access to all these services. That means if you're using or have account on any one of these things, you can have access to all these services or have access to all the Active Directory services that Azure has to provide to you. So what this does is it caters the needs of various online customers as well. So let us try to understand the next point, that is Azure Active Directory additions. for that, what I'm going to do is I'm going to go ahead and switch into the Microsoft's web page basically, or I'm going to switch into my browser and move to their website and talk about all these points. So instead, what I would do is I would first discuss the last point. And before we do go ahead and take a look at the demo, then we would just go ahead and talk about these points as well so that we can directly switch into the demo part. So let's move further and try to understand the next point and then come back to this point. So what are tenants basically? Now, when you talk about a tenant, it is nothing but an organization. I just mentioned that we have tens of organizations that a particular application might cater. Now, all these organizations are treated as tenants. All these tenants can have access to a particular Active Directory or more than one Active Directory. As we move into the demo part, I would be talking about how to create multiple directories as well. Yes, we can have more than one Active Directory. We'll discuss that as we move into the demo part. But before that, you just understand these points as in what I'm trying to say exactly. Yes, what happens here exactly is when you talk about a tenant, first and foremost, it is nothing but an organization and it is a dedicated instance of your Azure Active Directory service. Plus, these are isolated instances. That means, as I've mentioned, we have 10 organizations or 5 organizations. You'd be having isolated instances for each of these organizations, ensuring that they stay aloof and their services and their protocols are maintained differently. This is where your Azure Active Directory steps in. It takes care of all these things. It ensures that nothing is ambiguous or nothing is intermixed. Everything stays separate. Plus, each and every platform or organization gets serviced equally well. As we move further, we would be creating users, and then I would give you the differences as in what a tenant is, how do you go ahead and create all the domains and all those things. So again, into the demo part, you'd be understanding these topics with little more clarity or more understanding rather. This is the demo part, but before that, as I've already mentioned, let me quickly switch to the website of Microsoft Azure and I would be discussing the editions that you can choose from, and then we can directly jump into the demo part. Okay guys, so this is a Microsoft doc basically which talks about choosing an edition. So these are the options you have. We would be finishing this quickly and then we would be switching into the demo part. So let's understand this. Now, what Microsoft Azure does is it gives you various options. First and foremost, you have 3 options to pick from. And out of these 3 options, the first one is your basic option, that is your Active Directory basic. Then you have your premium, which is P1. And then you have one more premium, which is P2. All these things provide you with different options that you have. First and foremost, your main job is to have your access, that is your identity management, your security, and your single sign-on and all those things. Now, these are some of the services that come with your basic account as well, and also with your free account. What Microsoft Azure does is, for people who are completely new to this session and Microsoft Azure, let me tell you that you have a free sign into Microsoft account. That means you can go ahead and create your account there and avail these services for a certain duration, which are available to you for free. So yes, you do not have to pay anything. There you have a free account. In that, you'll be having access to some of these services. But if you need advanced services, then you have to pay for it. And for those things, you have 3 options. That is your basic, premium P1 and premium P2. Let's try to understand these one by one, as in what are these and what do they have to offer to you. Now, if you scroll down and if you take a look at this thing, you have your Azure Active Directory basic now. This basic is nothing but it is designed for people who are task workers or who are focused on a particular application on cloud. Now it takes care of everything, your single sign-ons, your SLAs, and it ensures that the security is 99.9%. And it provides you with all these features which you can see here, that is your self-service password resets and all those things. You also have access to quite a few things like your proxies and all those things. I won't be getting into the details of what proxies are and all those things. But yeah, for people who are admins and who have worked on these topics or in these domains, they would understand what do these things mean. So yep, you have access to all these things which fall under your basic option. Apart from that, you have something called as your premium P1. Now, this is for people who want to scale up. So when you try to scale up, you'd be dealing with quite a few things, and terms like your IAM and all those things would come into picture. Now, IAM is nothing but your identity and access management basically, which is a very important point when you talk about Active Directories. So yes, it provides you with these things as well, or these facilities as well, like identity protection, your security in the cloud and all those things. Everything is taken care of for this particular model. Now, when you talk about premium P2, if I scroll down, this is what you have. It is designed for more advanced protection. That means you'd be getting all the services that were provided in basic and P1. Apart from that, you'd be having some additional services which ensure more security. That means it focuses more on privileged identity management. Now, again, this is something that you can read and understand. It is very easy, but to give you a basic difference, your first thing provides you with your basic services. That is, your basic access gives you basic Active Directory service access. Then you have your premium version, which is focused for scaling up. And when you talk about P2, it focuses more on advanced security. So these are the three different editions that you can choose from. Now, if you're somebody who is belonging to a particular organization and wants to go ahead and use these services, he can actually go ahead and read all these things and then go ahead and take a decision accordingly. Now, what I'm going to do is I'm quickly going to go ahead and switch into the demo part. For that, I need to go ahead and open my Microsoft Azure account. So let's do that. Well, my internet is kind of slow today, so it might take a little longer while than normal. I can click here on portal and there you go. It would ask me to sign in. I would be using a dummy account today for this so-called demo. I wanted to give you an access to or view to quite a few directories and all those things. So that is why I did go ahead and create an account and or certain Active Directories created or basically certain accounts created. Now, this is how the Azure portal looks like for people who are completely new. Again, you have your dashboard here. Apart from that, you can actually go ahead and create quite a few things. That is your virtual machines, your data factories and all those things. For people who want to know all those things, they can actually go ahead and refer the other videos that are there in this series, and you'd know quite a few other things as well. But as far as this session goes, we are here to talk about Active Directory. So let's head into it and try to understand how do you go ahead and create Active Directories and all those things. Now, how do you navigate to a particular Active Directory? Now, if you scroll down here, you'd be seeing an Active Directory here. For people who have an account on Microsoft Azure and have access to all these things, they would have an Active Directory by default. So you just have to come here and click on it, and a particular dashboard would open up for you people as well. Now, this is how it looks like. You have all these things, an overview, getting started. You have users, groups, which you can manage and monitor. You have devices you can connect to, your various app registrations. As I've told you, you can manage multiple applications as well. Now, in that case, what happens is, as I've mentioned, you might be dealing with multiple applications. So a particular user, what applications should he have access to? What domains does he have access to? What are the devices that are configured? All these things can be controlled or managed from here basically. So this is what your so-called Active Directory does. Now let's move further and try to create some users. Now, how do we do that? Well, I can click on this icon here and it would give you the list of users that are already there. As you can see, there are quite a few users here. This was a demo account, so we did go ahead and create so-called users so that you can have a look at them. This is something that I created yesterday, that is Chris Pratt. Now, how do you go ahead and create an account? I would be talking about all these things. To give you a start, you have to click on this thing, new users, and this window opens up. Now again, I'll have to go back and show you something else. How do we deal with all these things? Well, first and foremost, you need to give in a pseudonym or a name of the person for which you want to create a user. Apart from that, you need a particular domain name or yes, a domain name for a particular domain service. Now, how do we get that? Now, these domain services have to be registered with your so-called Azure Active Directory. So I have these accounts here, right? So I can use one of these accounts to just go ahead and create a particular user. Suppose I want that user to be assigned or maybe associated with this ID. So I can select this domain service extension basically. Again, click on new user. So what name should I give to this particular user? Now, I am a huge cricket fan and recently I watched England's match. So let's pick name of one of the players that belongs to England team. Say Sam Billings, and again, this is where I would be creating the user. Say I say Sam Bill as a pseudonym, and I give in this domain details, that is at edureka.tk. Now this is something that is configured already. That is why I can use it and I can have an account. If I used an ID that was not registered with this Azure account, I wouldn't have been able to create this user because it would have given me a particular error. As we move further, we would be taking a look at that as well. But for now, let's go ahead and create a legitimate user, that is this one. Now it verifies whether the name is proper or not. Name is something you can use in any which way you want to, but your username has to be legit and valid. So I have these details which I've entered. Configuration not required, properties can be default, and if I have to assign him a role, I can click here. You can see the name is verified here as well. Let's make him a global admin maybe. And again, you'd be given a password here. If you say show, it would show you the password, and I would suggest that you note it down because you would be required to go ahead and log in, and in that case you might be needing this password. So a suggestion that you note it down. I say OK here and I create the user. Now it might take a while because at times there are certain things that take a while, but in this case it has happened pretty quickly. So as you can see, we've gone ahead and created a user. His name was Sam Billing if I'm not wrong. So yes, there you have this account, which is Sam Bill. And if you click on it and open it, you can have access to that account where you can enter in other details, what applications that are there under this user and what applications do you want to assign, which devices do you want to configure and all those things. If you scroll down, you have some other options as well, sign-ins and audit logs. Now I won't get into the details of these things, but you can assign all these things to this particular user as well. So yeah, this is what the user looks like, and you can actually go ahead and log into this Azure account through this user profile as well. We can do that. What I'm going to do is I'm going to go ahead and create or open an incognito window where I'm going to go ahead and log in as this user. Let's just say incognito. And now if I try to log in, I would have to enter in the details. I've actually gone ahead and tried logging in, but I've forgotten the credential details. So let me just quickly switch to this window, copy this email ID and again switch here. So this is the email ID which we have, Sam Bill, next. And my password was, I hope it is right. Yes, so when you log in for the first time, it would ask you to enter the current password. And then you can enter the new password, let's say. And then you re-enter the password. There you go, and you sign in. So what happens is you enter into this portal as a fresh user. See, I'm a completely new user and it says, do you want to start at Tor? But I don't want to do that, so I would just say maybe later. There you go. You have your fresh dashboard. There is nothing pinned here and everything is completely new. So yep, you've entered in as a completely new user. And this is the Active Directory where I'm assigned to. That is my previous Active Directory. As you can see, this is what we have here to offer. So yes, as a user, I have certain privileges and I can have access to this so-called portal. So this is something I wanted you all to see. There are quite a few other things which we are going to go ahead and take a look at it. But for now, let me just log out and close this tab. I'm back here. The other things I want you to understand, and those things are, if I come here, what you can say is we have certain users here, right? There you go. Now, if you take a look at certain email IDs, you can see these email IDs. Now, these are quite huge email IDs, right? What happens is when you do go ahead and register your domain service, you register that domain service with Microsoft Azure account. And when you do go ahead and create users, you would not want to have such use names. That is, say, for example, Vishal at Microsoft something, 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 something. That can be long, right? And that is complicated to handle or manage. So instead, what you can do is you can provide them with pseudo identities or pseudo IDs as well, so that the process becomes easier or simpler to handle. Let's try to do that and see how can we do that. Can we just go ahead and assign a particular domain name or a domain service when we just go ahead and create a new user or all those things? So in order to add a particular domain, what you have to do is you have to go ahead and again, where is my Active Directory? Here it is. And I just kind of scroll down. You can see custom domain names, where you can actually go ahead and add domain names, but there are certain catches to it. Let's try to understand those. Now it would ask me to enter a custom domain name and I say demo domain maybe. Yeah. And let me give it some extension. Now, again, let me tell you that this is a demo practice and it won't take in this particular domain name. I'll tell you why. But first, let's just try to add this domain. Yeah, the domain name is added. But as you can see, to use demo domain.add with Azure AD, create a new text record with your domain name registrar using the info below. So if I say text, I need to copy this part and I have to actually go ahead and add this to my particular domain name. Now, I won't be going ahead and doing that because that is something that we are not discussing here, because for that, we would be needing some other domain name, which I do not have right now with me. So if you do go ahead and try to add a particular domain name, you need to have that particular domain. That is, suppose I'm using a particular website or I have a particular organization which has a particular website or a domain name that is xyz at xyz.com or something like that. So I need to make sure that I go ahead and register or have access to that particular domain. And then I need to go ahead and attach this particular text to it or authorize this text with it so that I can actually go ahead and confirm with Microsoft Azure that yes, I have an access to that particular domain. And only then can I go ahead and use this particular domain with my Microsoft Azure. Now, if I click here on verify, it would give me an error that I'm very sure of. See, could not find the DNS record for this domain. DNS changes may take up to 72 hours to propagate. That means I have 72 hours to go ahead and add this particular text message to that domain, and so that I can verify that yes, this domain is legal. But in this case, it isn't. I just took something for the demo purpose or for the reference sake, and this is the domain that I might have or which I can actually go ahead and use. So yeah, this is how you actually go ahead and add a particular domain, and you can actually go ahead and create a user as well. What you have to do is when you do go ahead and register this particular domain, you can just go ahead and follow the processes like creating a user, which we did in the previous case, because that was the registered domain. When I used that so-called edureka.tk, it was registered with my so-called Azure account, and I could actually go ahead and register that particular user. But in this case, I cannot. But yes, if you do go ahead and create a particular domain, or you want to go ahead and create a particular domain or register a particular domain, make sure that it is valid and it is under use, and you can actually go ahead and register that particular domain by using this particular process. So yeah, this is how you actually go ahead and do all these things. Now, when you have this particular domain, which is not registered, and if you do go ahead and create a particular user on it, what happens is your Microsoft Azure would let you create that user, but the credentials or the access that user has is as a guest user, because your Microsoft isn't sure that this domain which you just created is actually registered or something that you can actually go ahead and use. So that is one point which you need to consider. Now let me just quickly go back to my Active Directory and see if there are anything or any points that I need to discuss with you or something that we have missed upon. So what I'm going to do is I'm going to talk about something else called as creating an Active Directory. Or can we create multiple Active Directories? That is a question. If you ask me, I would say yes, definitely you can create multiple directories. Now, as you see here, if I go to a particular directory, I would be having an option called as switch directories. Now, if I click here, I have certain options from which I can pick a default directory. Now, in my case, I have quite a few directories which I can actually go ahead and choose from. But I want to give you all a demo as in how do you go ahead and create one, because these are something that we have created for the practice purpose or certain usage purpose. So let's go ahead and create a fresh one. So how do we do that? Can we just go ahead and create one? Well, yes, definitely we can create one. If you just scroll down, you have certain options here. We had an option of creating a new directory. Let me just go ahead and see where that option is. See, here's this option, create a directory. So let's start by giving it certain names, say Edureka 1, 2, 3, 4. Not 1, 2, 3, 4. Let's call it say Edureka, maybe. Is it there? Yep. And what should be the domain name? Edureka 121. Edureka 121. State, well, since I'm from India, let's stick to India. And I say create. Now it might take a couple of minutes when you just go ahead and create this so-called directory. So yep, meanwhile you bear with me. And there you go, you have your directory here. You can just click on this thing to manage your directories. As you can see, it's a completely new directory which is fresh and new to use. That means, as you can see, it's Edureka. And if you click on any one of these things, you won't be having anything else. Now, in my previous Active Directory, I had so many users. Now, if you come here, you'd see there's just one user, main admin. I do not have anything else or no other user whatsoever. That means this is a fresh directory. Like as you can see, if you just go back to the Edureka option, you'd be having an option of resetting your so-called directory, and you can do that as well. But I do not want to do that for now. I can just click on this and I go back. See, here's the option. You can click on it and you can switch the user. So yeah, you can use multiple directories and you can have multiple users for these directories as well. Now I can just go ahead and create users for this directory as well, but I won't be doing that. Now, since I do not need this directory, I'm just going to go ahead and delete it. So I click on this icon. I do not have permissions probably, so I click on it and I ensure that permission is granted. I say yes and I save changes. It might take half a minute to update these properties, or if the internet is slow, it might take longer as well. There you see, the changes have been updated. Now if I refresh this thing, the access is given to me. I can just, I don't want to delete the dashboard. I just want to go ahead and delete my so-called Active Directory. Okay, so I do not have an access to my domain services, because of which I'm not able to delete this account. But yeah, you normally have an option where you can actually go ahead and delete this directory. So yep, you can go ahead and do that as well. So yeah, this was the demo about Active Directory, as in how do you go ahead and create a user, how do you create a particular domain space or domain service basically, how do you go ahead and create multiple Active Directories.
What is Azure Load Balancer? Azure Load Balancer can be defined as a cloud-based system that allows a set of machines to perform as one single machine to serve the request of a user. It allows you to distribute traffic to your backend virtual machines and also provide high availability for your application. At whole, the Azure Load Balancer is a fully managed service itself. So to be more precise, an Azure Load Balancer is a four-layer load balancer that provides high availability by distributing incoming traffic among the healthy VMs, that is virtual machines. So now that we have come to know what is Azure Load Balancer, so let's get to know why do we use load balancers. So with Azure Load Balancer, you can scale your application and create highly available services. It supports both inbound and outbound scenarios and scales up to millions of flows for all TCP and UDP application. So there are many key scenarios of load balancer that help you accomplish your tasks. So we'll quickly have a look on them. Load balancer load balance internal and external traffic to Azure virtual machine. It also increases availability by distributing resources within and across the zones. If we talk about the configuration, then Azure Load Balancer configure outbound connectivity for Azure virtual machines and load balances service on multiple ports, multiple IP addresses, or both. Let's look on to few more scenarios. So Azure Load Balancer has the capability to move internal and external load balancer resources across the Azure origin. It also balances TCP and UDP flow on all ports simultaneously using the HA ports. Load Balancer uses health probes to monitor load balanced resources and enables support for load balancing for IPv6 versions. So these were some of the key scenarios which makes Azure Load Balancer useful and demanding. Now let's look on to some of the Azure Load Balancer types. So there are three types of load balancer. So first is Azure Load Balancer. As we discussed before, Azure Load Balancer is a layer 4 load balancer, which means it operates at layer 4 of the operating system's interconnection model. It's a single point of contact for clients and it distributes inbound flows that arrives at the load balancer's front end to back end pool instances. These flows are according to the configured load balancing rules and health props. The backend pool instances can be Azure virtual machines or the instances in the virtual machine scale set. Next is Application Gateway. An Azure Application Gateway is a web traffic load balancer that enables you to manage traffic to your web application. It is a traditional load balancer that operates at the transport layer and route traffic based on source to destination IP address and port. Application Gateway can make routing decisions based on the additional attributes of an HTTP request. So, for example, if you have an image file that is in the incoming URL, then you can route the traffic to a specific set of servers which are configured for images. If you have a video file in the incoming URL, then that traffic can be routed to the another pool that is optimized for the videos. This type of routing is known as application layer load balancing. And third type of load balancer is Traffic Manager. Azure Traffic Manager is a DNS-based traffic load balancer. It allows you to distribute traffic to your public-facing application across the global Azure regions. It also provides your public endpoints with high availability and quick responsiveness. Traffic Manager uses DNS to direct the client request to the appropriate service endpoint based on the traffic routing method. It also provides health monitoring for every endpoint. So these endpoints can be any internet facing services hosted inside or outside the Azure. So what does Traffic Manager do? It provides a range of traffic routing methods and endpoints monitoring option to suit different application needs and automatic failure models. It is very much resilient to failures, including the failure of the entire Azure region. Now that we have talked about each type of load balancer, let's quickly compare each one of them. So as you can see, there are different parameters based on which all three types of load balancers are compared. So in terms of service, Azure Load Balancer is the network load balancer. Talking about application gateway, it is mostly related to web application. So it is mostly known for web traffic load balancer. And traffic manager is a DNS based load balancer. If we talk about network protocols, then Azure Load Balancer is a layer 4, which includes TCP or UDP. Application Gateway is the layer 7 load balancer, which includes HTTP and HTTPS. And Traffic Manager is also layer 7, which includes DNS. If we talk about their types, so Azure Load Balancer has internal and public. Application Gateway has standard and WAF, but there are no types in Traffic Manager. Going ahead with routing, then Azure Load Balancer is hash-based source IP affinity. Application Gateway is path-based, and Traffic Manager looks into performance, weighted, priority, geographic, and multi-value subnet. The recommended traffic in Azure Load Balancer is for non-HTTPs. In Application Gateway, it is for HTTPs. And in Traffic Manager, it is for non-HTTPs. Talking about the endpoints, then in Azure Load Balancer, we have NIC IP address. In Application Gateway, IP address, FKDUN, virtual machine, VMSS, app services. And in Traffic Manager, we have cloud service, app service, logs, public IP addresses. If we talk about the global services, so in Azure Load Balancer and Traffic Manager provides global services where application gateway is only bounded to regional. At last, if we talk about the redundancy, then Azure Load Balancer is zone redundant and zonal. Application Gateway is also zone redundant, whereas Traffic Manager is resilient to the regional failures. So these were the important parameters which compare all the three types of load balancers. So now let's quickly move on to our hands-on part. For this, we need to first log into our Azure portal. So this is our sign-in page. So let's quickly sign in. They ask for stay signed in, so it is up to you. If you want to stay signed in for a long time, you can. So just click yes. So yeah, here we enter to our main dashboard. So this is how the Azure dashboard looks like. So here you can see many of the services provided by Azure, and there are resources. So currently I have no such resources. So first and the foremost thing we need to do is to create a resource. So let's quickly create a resource. We'll come and click over here. And as you can see, there are different options. So they ask you whether what kind of resource do you want to create. So there are popular Azure services. So based on that, you can create resources. So here you can see different servers like Windows Server, Ubuntu, and Windows 10 Pro. So there are many options over here. For us, we'll be going to virtual machine. So let's just move on to our virtual machine. So here only you can see virtual machine is given. So let's create one of the virtual machines. Now that we have to deploy a virtual machine, so we need to first fill on to the basic details. So as you can see, the first and foremost thing they ask for the resource group. So what do you mean by a resource group? It is basically a group of resources that you are going to deploy into the server. So let's quickly create a new resource group as we haven't created any yet. So let's name it as Azure demo and click OK. So this is a resource group name. And now they ask for the virtual machine name too. So let's name that as well. Azure VM
1. That sounds good. And they also ask for the region. So default they have put the Central India. So let's keep it as it is. Now they ask for the OS, type of OS. So there are different options you can choose, like Ubuntu, Windows, then Oracle. So there are many operating system options. So I'll just go with the Ubuntu server itself. And the size, next comes the size. So there are different sizes depending upon the prices as well. So it depends upon which type of size do you want to. So I will keep this as a default as well. Now they ask for the authentication type. So there are two options, that you need an public key or you need to set a password. So let's quickly set a password to it. So let's give a username. Let's name it as Edureka demo. That sounds good. And now let's give a password. Alright, so the value must be within 12 to 72 characters. So let's do it accordingly. Alright, so this sounds good. Now they ask for the inbound ports. So as they have showed here, SSH22. So that means that they will be using the 22 port for the as a firewall. So let's keep it as it is. Now let's move on to next. So here they ask you about the OS disk type. So there are different type of, like, you have different types of SSDs, like premium SSD, standard SSD, HDD. So depending upon your requirement, you can choose any one of them. So I'll be choosing the standard SSD, and rest all let's keep it as it is, and let's move on to next. So here you can see they ask for a virtual network. So it has like automatically set up a virtual network for me. Same as they have also created a default subnet as well. So we won't be making any changes over here. So let's quickly move ahead. Now here they ask for any type of monitoring we need to provide. So here we are not interested in having any monitoring. So let's just disable the monitoring and move on to the next options. So let's skip all these two as well and just review and create. So here basically you need to review everything, whatever information you have given in the options. So once you're done with that, once you review it, just click on create. So here you can see it is getting ready for the deployment. Alright, so your virtual machine has been created. Now it is just, here you can see the status, like it is showing deployment is in progress. So let's just wait for it. So you can get all the status. Alright, so here you can see your deployment is complete. So let's quickly check whether it has been created successfully or no. Let's go to our virtual machines. So yeah, here you can see your Azure VM1, that is a virtual machine one, has been created successfully. So here you get your subscription resource group, under which resource group it has been created, location, and operating systems and the sizes. So now let's also check on to our resource group as well. So let's quickly move on to our resource group and let's find out. So here you can see Azure demo, which we have created currently. So just click onto it, and here you can see different types of resources which have been created. So this is the virtual machine which we launched and deployed. So let's quickly create one more virtual machine. Let's quickly move on to virtual machines and let's create Azure virtual machines. Now here we'll take the US resource group. So let's click on it and let's name it as Azure VM 1 US, as it is from a different server, and the region would be West US. And let's keep all the other details as it is. Now let's change the authentication type. Let's give it a password. Edureka demo. Alright. And then we'll move on to next. Here we'll be selecting the standard SSD, and rest others would be same as it is. So here again, I said you before, the virtual network and the subnets are created automatically. So let's quickly move on to next. Here we'll be disabling the monitoring and just skip the rest and review and create. Alright, so let's just create it. So as you can see, the deployment is in progress. So it takes a couple of minutes. So here you can see the status of your virtual machines. Alright, so here you can see your deployment is complete. So let's quickly move on to a resource group and let's check whether it shows there itself or no. So just go to Azure Demo US. So now that we have created one virtual machine in US as well, let's create again one in Azure Demo. So let's quickly create one in Azure Demo. So virtual machine. Okay, so here we'll be selecting Azure Demo and let's name it as Azure VM 2 and list others, change the authentication type and just move on ahead. Next, we'll change the disk type to standard SSD and next, we'll just disable the monitoring and review and create. Alright, so here you can see the deployment is in progress. Let's go to our Indian server. So let's go to resource group and this is our Azure demo. So let's come over here. So as we come over here, so let's try to configure the first server. So the first server is Azure Virtual Machine. So as you can see over here, this is the Azure Virtual Machines 2 overview. So here you can find out the IP address of this virtual machine. So we'll just click on copy and now we need to open our terminal. So in Windows, we'll be using an app. So as I'm working on Windows, so there's an application named as Putty. So we'll just open that. Guys who are using Ubuntu can directly open their terminal as well. So here I'll just open Putty. Let's open Putty. Alright. So here what do you need to do is just paste your IP address and your port is 22. So let's keep it as it is and let's just open it. Right, they ask for some acceptance. So let's just accept and let's log in. So we had just Edureka demo. Let's give the password. Alright, so as you can see, we are logged in now. So now that you are connected to your first server, first Indian server, let's just get connected with our another server as well, which we had created. So let's quickly move on to our Azure Portal and we'll go back to Azure Demo and we'll select the second one. We'll do the same thing. We'll copy the IP address and we'll just go to Putty again. Let's open and we'll again type the IP address and open it. accept. And now they again ask for the authentication. So let's just give the password. So yeah, you're logged into both the servers. As you can see, this is our server 2 and this is our server 1. So now that we have logged into both the servers, now we need to configure it. So in this, we need to install a software that is Apache 2. Before that, let's quickly update our servers. That is by sudo apt. So now that both the servers are updated now, so let us just install the software that is Apache 2 by sudo apt get install Apache 2. Alright, so it has been installed in this. It is the server 2. Let's just do the same thing in the server 1 as well. Sudo apt get install Apache 2. So now that we have installed the Apache 2 in both the servers, let's just try to check one of them and see whether it's working or no. So we'll go back to our Azure portal. So we'll just open a new tab and put the IP address over there. So as you can see, the site can't be reached. This is because we haven't given the access to port 80. So basically what happens whenever we enter the IP address, the browser interacts with the port 80. But in Azure, we had given the access to port 22. So what do we need to do is go back to our Azure portal, and in this we'll go to networking, and here we will go to add inbound ports. So here we need to give the access to port 80. So here is the destination port. Let's just put it 80 and allow it and just add it. So it's creating in the server. So it has been created successfully. Now let's just come here and reload this. It may take some time because as I have just given the access to port 80, so it may take some time to load as well. Alright, it isn't happening. Okay, so as you can see over here, you can see your Apache 2 default page. Now what do we need to do is replace the file. So here, as you can see, replace this file located at var.ww.html. So we'll just copy this path and we'll go to our virtual machine 1 and just cd path. So we have come into that path. Now what do we need to do? We need to remove the index.html and we'll create a new index.html. So sudo rm index.html. Now sudo nano index.html. So here nano is just like a notepad in our Windows. So in Ubuntu it is known as nano. So what we'll do over here is just write a few code, HTML code. So let's quickly type some code, HTML. Let's give it a heading. Welcome to Indian Server 1, just as an example. And let's close the body and the HTML tag. Alright, now we'll just save it and we'll just go back and just exit. Alright, so let's quickly move on to our website. So let's just reload it. So as you can see over here, it is written welcome to Indian server. Same I had done with the server 2 as well. So now we have to create the application gateway. So let's quickly go to our application gateway. And as you can see, we don't have any. So let's create one new. So as usual, we need to give our resource group. So we'll be selecting the resource group of India. So let's name this resource group Central India. We'll give it a region, and let's name this as AG Server IN. Now we'll go ahead. So now we need to give the virtual network as well. So we'll use Azure DevOps. Within that, we'll be selecting Azure Demo VNet. So here you could see this error, subnet must only have application gateway. So let's just create a new subnet. So we'll click on manage subnet configuration. So here we have already been given with the default IP range. So let's create a new subnet where we get some of the range. So here we can change the address range, but I guess there is some error. So what do we need to do is go to this address space and let's see what is the limit. So here you can see it is 10.0.0.0 and your range is up to 10.0.255.255. So let's go back to the same subnet and let's add a subnet and let's name it AG Server IN and let's save it. So here you can see you have your new subnet has been created. Let's go back to our application gateway and let's see if we get that option or no. Alright, so here we have got the option. We'll just click on it and we'll move on to next. So now here we come to the front end. So here we need to provide the IP address. So here we'll create a new IP address. So let's name it as AG Server IN and let's next and we'll go to backend. So here we don't find any backend pool. So we need to add a new backend. So let's add up a backend pool as well. So let's name it as AG pool IN and let's pick up the virtual machines which we had created. So here you can see you have both the virtual machines. So let's add both of them and click on add. And now we go ahead with the configuration. So here we have the front ends, we have the backend pools. Now we need to add the routing rules. So let's add up the routing rule. So here we need to name the rule. So let's name it as first rule IN and let's set the priority. So here the priority range is 1 to 20,000. So I'll keep it 1 and then they ask for the listener name. So let's name this as well. Then we need to select the front end IP. So that is public and rest other will be as default. Now we should go to the backend target. Here we will choose the backend target that is AG pool in and then we need to create the backend settings. So we'll go here. So let's call it as HTTP India and then rest others would be same. Now we'll just click on add and yeah, your route has been created. So let's move on to next and click on review. Alright, we'll just click on create. So as you can see, my application gateway for India has been deployed. It's still it is in progress. So it may take a while to deploy. So as you can see that your application gateway has been deployed successfully. Now let's go to this application gateway. Let's quickly move on to application gateways and let's see whether it has been created or no. So we'll just click on to this and we'll just copy this. So what do we need to do? We need to copy the IP address and we will just paste it over here and we'll just try to reload it. So as you can see, welcome to Indian server 2. So if we just refresh it quite a couple of times. So it also shows you welcome to Indian Server 1. So this is how application gateway runs and balances the load between the two servers. Now we'll quickly move on to our next one, that is Traffic Manager. So for this, we need to open the Traffic Manager profile. So once we come over here, so let's create a new Traffic Manager. So here we need to specify the Traffic Manager's name. So let's give it a good name to it, like Global Traffic Manager. Okay, that sounds good. And now we'll just choose the resource group. So we'll be using the Indian server and let that be Central India as well. And we'll just hit create. So as you can see, the global traffic manager has been successfully created. Now we just look on to the configuration part. So let's quickly check onto it. It looks pretty good. Now we need to add the endpoints. So let's quickly add the endpoints. For this, we need to click on add and let's name it, as we are using the Indian server. So let's name it as AG India and we'll choose the resource type as public IP address and then we'll click to AG Server India. So here it shows that no DNS name is configured. So let's quickly resolve this error as well. For this, we need to go to the public IP addresses. So let's quickly go to the public IP addresses. And here you can see this AG server in. We'll just click on to this. And now what do you need to do is go to configuration and we need to set the DNS name. So let's name it as AG India. Its suffix would be the Central India Cloud App.azure.com. So let's quickly save it. So it has been saved successfully. Let's just close this and redo it again. So we'll do add, then we'll write AG India. We'll select public IP address and we'll select AG server in. So we'll just click on to this and we can also give the geographical location for which region you want to see the traffic manager. So let's quickly give a region. So I'll choose Asia and India. So once that is done, we'll just quickly add. So as you can see, AG India, it has been enabled. So we'll go to Global Traffic Manager, we'll go to the overview and we'll just copy this link and we'll try to open it. So as you can see, it has been running successfully. Now let's refresh it once again. So yeah, so both the servers are running in this Traffic Manager successfully. So this is how we use Traffic Manager for the load balancing between the two servers. What is an Azure Firewall? According to the definition, Azure Firewall is a cloud native and intelligent network firewall security service that provides the best of breed threat protection for your cloud workloads running in Azure. That means Azure Firewall is a managed cloud based network security service that protects your Azure virtual network resources. It is fully stateful firewall as a service with built in high availability and unrestricted cloud scalability. So you can centrally create, enforce, and log application and network connectivity policies across the subscription and virtual networks. This service is fully integrated with Azure Monitor for logging and analytics. Now you must be thinking, why do we need Azure Firewall? Now you must be thinking, do we actually need a firewall in a cloud? So the answer is yes, you do need a firewall when you're using cloud computing. Cloud security does offer you better securities, but it is not sufficient for modern day to day business needs. If you're constantly accessing the internet for any kind of work, firewall cloud security is much needed. And as we discussed, that Azure Firewall is a cloud native security solution for Azure environment. It provides traffic inspection, filtering, and monitoring in order to protect from DDoS attacks, basic traffic monitoring, access control list, or any intrusions. So, in short, it is highly recommended to use Azure Firewall. And if you upgrade to Azure Firewall Premium, which we'll discuss in further, this will provide you additional features to your organization with greater cloud security needs. Now we got to know what is Azure and why do we need it. Let us see what are the key characteristics in Azure Firewall. So the key characteristics of Azure Firewall is that it is fully managed cloud-based firewall service which provides platform as a service as well as firewall as a service. It is built in high availability. That means no additional load balancers are required and there is nothing you need to configure. Whereas it is highly scalable because here Azure Firewall can scale up as much as you need to accommodate changing network traffic flows. So you don't need to budget your traffic peaks. It supports FQDN tags, that is nothing but fully qualified domain name, to make it easy for you to allow well known Azure Service network traffic through your firewall. For example, say you want to allow Windows Update network traffic through your firewall. You can create an application rule and include the Windows Update tag. Next is it has inbound and outbound traffic filtering rules. So in inbound, it has DNAT support. That means inbound network traffic to your firewall public address is translated and filtered to private IP addresses on your virtual networks. If we talk about outbound, through SNAT support, all outbound virtual network IP addresses are translated to Azure Firewall Public IP. Here, you can identify and allow originating from your virtual network to remote internet destinations. And last but not the least, the Azure Firewall is fully integrated with Azure Monitor for logging and analytics, which means all events are integrated with Azure Monitor, allowing you to archive logs to the storage account, stream events to your event hub, or send them to log analytics. So these were the key characteristics of Azure Firewall. Now let us see what are the different type of firewall rules. So there are three different rules in Azure Firewall, that is NAT rule, network rule, and application rule. So we'll understand each one of them accordingly. So let us start with the NAT rule. A NAT rule, also known as Network Address Translation Firewall, operates on a router to protect a private network. It works by only allowing internet traffic to pass through if a device on the private network requested it. So, a NAT rule, also known as Network Address Translation, is the process of mapping an Internet Protocol address to another by changing the header of the IP packet while in transit via router. This helps to improve security and decrease the number of IP addresses an organization needs. So, what does it do basically is that a NAT firewall operates on a router to protect these private networks. It works by only allowing internet traffic to pass through a device on the private network requested it. By doing this, it protects the identity of a network and doesn't allow internal IP addresses to the internet. A network rule dictates which network feature can connect or associate in utility network. These rules are imposed at the class level for specific asset groups and asset types. So it is basically responsible to allow or deny inbound, outbound, or east west traffic based on the network layer or the transport layer. So you can use a network rule when you want to filter traffic based on IP addresses or any ports or any protocols. Lastly, we have application rule. Application rules allow or deny inbound and outbound or any east west traffic based on the application layer. So you can use application rule when you want to filter traffic based on fully qualified domains and HTTP or HTTPS protocols. So these were the three Azure firewall rules which helps you specify which traffic is allowed or denied in your network. Now let us understand how does Azure firewall actually work. Azure Firewall offers enough feature to provide optimized control
over in and out network traffic. It eliminates the need of load balancer configuration because of its high availability. Moreover, it allows restrictions on outbound traffic by specifying the FQDN service. You can create your own defined rules using Azure Firewall to filter network based on service IP, destination IP, port, or any protocol. These rules further show the status as allow or deny status. It also enables threat intelligence feature that can identify malicious IP addresses or irrelevant traffic. Now that we have understood what is firewall and how does it actually work, now let us have a quick demo on Azure Firewall. So before we start, let us know what are we going to do in this particular demo. So first, we'll be creating a resource group, then we'll create the virtual network. And once our virtual network is created, we'll add some virtual machine to it. Once our setup is done, then we'll create a firewall and add some root tables. And lastly, we'll use some rules on the firewall and let's see how does actually the firewall works. So let us quickly move on to our Azure portal. So as I said, we need to first create a resource group. So let's quickly create a resource group. So in this resource group, we'll be creating a new resource group. So let's go to create. And now they ask for our basic details. So as we know, our subscription is there. As we're creating a new resource group, let's give it a name to it. So let's name it Firewall Demo. And now review and create. All right. As you can see, our resource group has been created successfully. Now, in this resource group, we're going to create some virtual networks and we'll try to add some subnets as well. So let's quickly move back to our home page and then we'll select the virtual network. All right. So we'll go to virtual networks. So now we'll create a new virtual network. So let's go create. Now we'll select our resource group, that is Firewall Demo, and let's give it a name, Firewall VNet. And we will change the regions. It is up to you. You can choose any of the regions as per your requirement. Now we'll go to our IP addresses. So here we'll change the IP address range. So let's quickly change the IP address range. Now it's 16. All right. Now we have changed the IP address range. Now let's quickly add some subnets. So let's add a new subnet. So we'll give it a name, server 1 subnet. And here also we'll provide specific range. Alright, so we are subnet name and IP address range is done. Rest others will leave it as default and let's quickly add. So our one subnet is created. Now let's quickly create one more and let's name it as server 2 subnet. And now we'll provide the subnet address range. So now that we have changed the IP address range and we have created the subnets, let's see our security. So here we'll keep everything as default. We don't have to make any changes over here. Same as with the tags. And now let's quickly review and create. Alright, so our validation is passed. Now let's create. Alright, as you can see, the virtual network deployment is in progress. So let's wait for it. It will take a couple of minutes and then it will get created. Alright, so as you can see, our virtual network has been created. So we'll just go to resource and let's have an overview on it. If you look onto the topology, so as you can see, we had created a firewall. Under that, we created two subnets, that is server 1 and server 2. Now let's quickly create a virtual machine.
So let's search virtual machine. And now let's quickly create one. So we'll select our resource group over here, and you can name your virtual machine based on your requirement. So I will just keep it a simple name as virtual FW demo. I hope that looks great. And we'll select West US. And as I said, you can choose as per your requirement, the way, how much ever you want. And now we'll change the image. So here we can use our server. So I'll be using Windows Server 2022. And here are subscriptions. As you can see, there are a different number of subscriptions that are standard. So based on your size and based on your requirement, you will search you can choose your size. So I'll just select the best one out of it. And now we'll have to create a username. So let's name it as Edureka 1, 2, 3. And let's set a password to it. Alright, so it must be between 12 to 123 character long. Alright, so let's do it accordingly. Alright, now I guess this looks great. Now, here they ask about the public inbound ports, so we won't be allowing it to anyone because whenever it is set in default, whenever you're creating a virtual machine, as you can see here, their inbound port is RDP. So as we are creating our own rules and creating our own firewall, we won't be allowing them. So let's just make it none. And next, here, I guess everything looks great. We don't have to make any changes. In networking, here will be, as you can see, our virtual network is given, and here they're chosen server 1. So we'll keep it as default. And here, public IP address, they've created one, so we'll just keep it none. And rest other looks perfect. Now let's just go next. And here also we won't require any changes, so we'll just quickly skip these parts and let's review and create. Alright, it shows the validation failed, required information is missing or failed. Let's go to basic and let's see what is okay. Alright, so okay. Now let's quickly review and create. So here as it shows, the deployment is in progress. So once it gets deployed, we'll change the IP address of the virtual machine. So as in default, it is set as dynamic. We'll just change it to static. So, alright, as you can see, our deployment is complete. Now let's go to resource. So as you can see, there is no public IP address, and we do have our private IP address. So now what do we need to do is go to our networking, and here we'll select our network interface, that is VM demo. And here we'll go to IP configuration and just select your IP config, and let's switch it to static. So while we'll be using the firewall, the IP address won't be changing dynamically. It will stay static. Means it will remain constant. We won't have to capture new IP addresses every time. And let's save it now. Alright, it has been saved successfully. Now our next step is to create a firewall. So let's quickly create a firewall. So we'll choose our existing resource group, that is firewall demo, and let's name it as firewall demo 001. I hope that looks fine. And I'll keep the region same as it is. So there's no change in the region. Now let's change the firewall tier and let's make it standard, and we'll choose our virtual network, that is firewall vnet. Alright. Okay, so it must have a subnet named as Azure Firewall Subnet. So let's quickly move back to our home and let's go to our virtual network, that is firewall.vnet, and here we go to our subnets and let's go to this and let's just, alright, so we need to just delete one subnet. So we'll just delete this. We will delete the second one, that is the server 2, and let's create a new subnet named as Azure Firewall Subnet. So let's add a subnet, Azure Firewall Subnet, and let's keep it the range as 2 and just save it. I hope that's great. Alright, now let's quickly move back to home and go to our firewalls. Let's check whether it is done correctly or not. So we'll follow the same resource group and we'll give a name, firewall 001 demo, West US standard. We'll use the same existing and let's see. Alright, fine. Now the error has gone. Now here they ask for the public IP address. So we'll be creating a new public IP address. So let's go add new firewall public IP. Okay. So let's just do okay. Now we'll go next and we'll just review and create. By the time the firewall is being created, but if we go to our virtual machine, that is VMFW demo, so here we can see it has not been connected to, so as you can see, it hasn't been connected to anyone. If you try to even open it, it won't be able to open because there's no connection between the firewall and the virtual machine. So what you'll do is once our firewall gets created, we'll add a rule so that our virtual machine is connected. So let's see whether our firewall has been created. Okay, so here our firewall has been created. So let us go over here. Now here we'll go to the rules. So we'll be adding the first, that is the NAT rule. So let's quickly add one NAT rule. So let's give it a name, NAT rule 1. And what is a rule? So let's give a name to our rule, that is RDP rule, as we need to give the access to that. And our protocol would be TCP. Our source type is IP address itself, and our source would be any IP address. So let's give it a star. So here our destination address would be our firewall public IP address. So as we go check in our overview. Alright, so we need to first copy the public IP address. So let's quickly go to our firewall, and so here you can see the firewall public IP. So let's quickly click here and let's see what is our IP. So we'll just copy this IP address. Now we'll go back to our rules and let's add a new rule. So NAT rule 1. You can give any name to your rule. It's nothing so specific about it. And let's give it a priority. So I'll give it up to 1000. And now our rules. So as we need to allow the RDP. So let's name it as RDP, and we'll be selecting the TCP protocol over here. Our source type would be IP address itself, and our source, let's keep it a default for now. And our destination address, as I said, our firewall's public IP address. So we'll just paste it over here. And our destination port is 3389, and our translated address is 192.168.2.4. And then lastly, it comes the translated port, that is same 3389. Now everything is set. Now let's add it. Alright. So once it gets updated, then we might get an access to our virtual machine and we will be able to open the virtual machines. So as you can see, our NAT rule has been created. So let's quickly move on to our remote desktop. And let's paste the IP address. Let's try to connect. So as you can see, they are asking the username and password. So let's give the username. Alright. So as you can see, we have entered into the virtual machine. So this is our server, which is ready. And now we will go to our local server. Let's see our Internet Explorer, and we'll just keep this off. And now here we'll open our Internet Explorer, and here we'll try to open any of the web page. So let's try to open google.com. So as you can see, our google.com has been opened successfully. If you want, you can try any other websites. So let's search any other thing like bbc.com. Let's see whether it opens or no. So as you can see, our BBC homepage, it has opened. So through NAT rolling, we were able to access the virtual machine and even browse some of the websites. Now let's do one more thing, that is adding the root table. So we'll just quickly minimize this and search for root tables. And now we'll create a root table over here. Now let's quickly give the resource group, and the region is West US. Let's name it as root table FW and just go next and just review and create. So as you can see, our root table is in progress. So once the deployment is done, we'll be configuring it. Alright, so our deployment is complete. So we shall go to the resource, and now here we'll go to the roots and we'll add some roots. Let's name it as my root table, and so we won't be adding any, so our prefix would be IP address. So here we'll block the address prefix destination, and our next host type would be the virtual appliance, and our next host address is the firewall address, that is 192.168.1, and we'll just quickly add. So as you can see, our root has been created. Now we'll go to subnets and we'll just associate. We'll select the virtual network, and in this we'll select the server 1 and click on OK. Now let's go back to our virtual machine and go to our Internet Explorer. Here we'll retype the google.com. So let's hit enter. So as you can see, the permission has been denied to open the google.com. So now let's even see for the BBC's homepage. So let's type down bbc.com. Let's see whether it opens or no. So here also you can see it has been denied. We can't actually see the whole homepage and even as well as the Google. So what do we need to do is go back to our firewall. Now we'll go to our firewalls. Now we'll go to the rules. And now we had added the NAT rule. Now we need to add the application rule. So we'll give a name to our application rule. So app rule 1 and priority would be 1000. Action would be allow. Now our target FQDNS is allow Google. Source would be star and protocol ports would be HTTP, HTTPS, and our target FQDNs would be star.bbc.com and star.google.com. Now I'll just add this. Now let us wait for it to get updated. Alright, as you can see, our rule has been updated successfully. Now let's go back to our virtual machine. Just try to refresh it and see whether it is working or no. So as you can see, your google.com has been opened successfully. Now let us try for BBC as well. c.com and let's see whether it opens or no. So here our BBC homepage has also been opened successfully. So this is how Firewall works. So here we created the resource group, then we created the virtual networks, and under that we also created the subnets. Then we also had seen how we create the virtual machines, and once our setup was ready, we created a firewall and we saw by adding root tables and some of the rules in firewall, and we saw how actually firewall works by adding the root tables and the rules.
Why do we actually need storage? All right, so for this, let's take an example first. Let's take a use case and see and understand what is the need of storage in today's era. All right, so for example, we have an image processing application. All right, so for this image processing application, we have given the user interface as a website. So around say 1 million people can access my website and put in their request to process their image. All right, so we don't want the processing of the image to happen on the server which is hosting my website. I want it to be happening on some other server. All right, I want the processing to happen on a backend server. So for that, we have some backend servers. Now my request for the processing will come in from website servers. So I need a place wherein I'll be storing all the jobs, right, which can be accessed by the backend server as well. So for that, I need an entity wherein I can dump in all the jobs which are there, which are to be done by the backend servers. Now, obviously, all the jobs cannot be done simultaneously by the backend servers, right? So say, like I said, there are like 1 million people who are accessing your website at once, and they put in 1 million requests, right? And your backend servers cannot process all the requests at once. So they will do it one by one, right? And they can do that with the help of this entity. They will pick up a job, do that job, and then go again back to the entity, pick up another job, go back to the entity, and so on. All right. So now when you have all the jobs in this entity, these jobs have to be distributed equally to the backend servers, right? Once that is done, once your backend servers process all the images which are there, or process an image which had some operations to be done on it, then the image has to be stored somewhere, right? Because you have to store the end result somewhere. So you will store all the properties like the name, the location of the image, everything on the database. But here comes the change. You cannot store an image on a database. I mean, you can actually do that, but when you look at the data that an image contained, it is all randomized. There is no structure in the data that an image has, or for that matter, any video file has, or any kind of file has, right? So that is the reason we need an entity to actually store this kind of data, so that the processing that is required to query this kind of data, which would have been there in the case when you would have stored your image in a database, right? In that case, a lot of processing is required if you try to query them. So we wanted the processing part to become less, the processing burden to become less, and hence we wanted an entity which can actually store any kind of file, let it be images, let it be video files, etc. Came in storage. So let's discuss the first case wherein we had to store the jobs, right? So when storage came in, now we can actually put in, say, 10,000 jobs per second inside this storage service without any overburden on any of the servers, be it backend servers or be it website servers, right? So the processing time has drastically reduced, and the jobs are now listed in the queue. So a queue is actually a service which is offered by storage, right? So now what backend servers will do is it will take up the job from there and execute it, and once they have executed, the job will be deleted and the next job will be queued. Next, when we talk about this section wherein we had to store images, so now any kind of file can be stored on the storage service which is offered by cloud. It's not only limited to the cloud. If you think about it, in your computer, in your own local computer, or in your mobile, you store some pictures, or you store some video files, right? And you store it inside a file system. It is not a database, it is a file system, and it can contain all the objects that you want to store. You do not store your objects inside a database. All right, so this is why storage is needed. Let's go ahead and understand what is the difference between storage and a database. So a storage is basically needed whenever you have objects, like I said. So when you have music files, whenever you have video files, whenever you have images, right? So in all these kind of cases, you use a storage kind of service. But when you have say something related to the metadata of a file, for example, when you store the file in the storage, you need to have the location of that particular file. You need to have the properties of that particular file. So all these things, all the properties, all the any location column that you want to add, all these are structured, right? They are not randomized, and hence they can be added inside a database. Be it SQL or no SQL, it can be added. Right, so this is the main difference. This is how you'll differentiate between using a storage and a database. Moving along, guys, so now we have understood what a database is, what a storage service is, when do we use the storage service, when do we use the database service. Let's move on to the topic of the day, which is Azure storage. So what is Azure storage? So Azure storage is a service from Azure. So you use it whenever you want to store something on the cloud, and since we are using the cloud provider as Azure, we'll be using the storage service from Azure, and that storage service is called the Azure storage service. Now, when you begin to use the Azure storage service, first of all, you should have a storage account, which you can create in the Azure management portal. So let me show you how you can do that. So let me quickly jump on to my browser so that I can show you my Azure dashboard. So guys, this is how my dashboard actually looks like, right? So as you can see on my dashboard, I have all these services listed. So what I'm interested in today is the storage account. So I'll click on storage accounts. So I have some deployed already over here. I'll click on add to add a new storage account. And then I'll have this page. Now, you will enter the name of the storage account here. So that name has to be unique. So let me enter a name, say live demo 23236. All right, so that seems to be available. Then comes the option of account kind. All right, so how do you want that account to be? What would it be, a blob storage or would it be a general purpose? So we don't want to restrict our account to only blob storage. We want a general purpose account, right? So we'll choose that. And then comes the replication part. How do you want your data to be replicated? Now there are quite a few what should I say, there are quite a few good options that we have here. One is called the locally redundant storage. So when we have the locally redundant storage, what this basically means is, so understand it like this, that there are regions, and inside a region there are zones. So for example, we have the US, and inside US we have cities like Chicago, New York, right? Now say New York and Chicago are two zones and the region is US. All right. So when I say locally redundant storage, what that basically means is that inside a zone, that is in say New York, you have a data center for Azure. In that data center, your storage account has been created. So when you select the option of locally redundant storage, what basically it does is it'll replicate your data inside the data warehouse. It'll replicate the data inside the data center in which you have actually deployed your storage account, so that if one server crashes, you have your storage account in other server in that same particular premise, right? But when we choose zone redundant storage, what that basically means is, so our zone was Chicago or New York, right? So in Chicago, if you have a data center, and in New York, if you have a data center, so whatever is there in the New York data center will be replicated to the Chicago data center as well. So that if one zone goes down, so if the data center in New York goes down, Chicago would be up, and hence your storage account can still be used. All right, so that is what the meaning of zone redundant storage is. When we talk about geo redundant storage, what we basically mean is you have different regions. So for example, we have the US region and we have the India region. So inside India region, we have different zones, right? So if you select the geo redundant option, we will have the read-write access to both these regions, that is in the US region and the India region as well. So whatever you have deployed in the US region, in the Chicago zone, will be replicated across India region as well, whatever zones you have deployed in India regions also. All right, so this is what is the meaning of geo redundant storage. And then we have the read access geo redundant storage, which is a very interesting option, wherein you only get the read access of the redundancy. For example, your main server is in New York, right? So it's a zone inside the US region. So if you select read access geo redundant storage, if in India, your data will be replicated to India as well, but when a failover happens, that is when your New York server is down and when you are redirected to the India region, in that case you can only read the data, you cannot write on it. All right, so it is useful for those applications which only fetch data and there is nothing to write. So in that case, geo redundant storage would actually be pretty costly for you. But if you select the read access geo redundant storage, it is a little less cheaper than the geo redundant option, since you are not writing on it. You don't want your data to be replicated whenever you write a thing, right? And that so this is the reason that read access geo redundant storage is kind of cheap. But since ours is a demo today, so I'll select locally redundant storage, and then the subscription you can choose pay as you go or free tier in your option if you have created a new Azure account. And then comes the resource group. So resource group is nothing but a group of resources. So it is basically created to manage your resources more efficiently. In the case when you have a large use case wherein you're deploying a host of different services, if you include them inside one group, it becomes easier to manage, because if you want to delete all the resources, you just have to delete the group and all the resources and the dependencies will be deleted automatically, right? So this is how the resource group is helpful. So we'll create a new resource group today. Let it be live-demo1, right? And we'll pin it to dashboard and we'll click on create. So when we pin it to dashboard, it basically has a shortcut on the desktop. for Azure. So let me, so while this is being created, let me show you how that dashboard actually looks like. So that dashboard basically gives you all the shortcuts that you want. So this is the dashboard, guys. So you get all the shortcuts that you want to your services, right? So my my storage account is now being created. It is called live demo 2336. So I can quickly access it from here rather than to go to my particular storage account over here and then accessing it. All right, so while this is being created, guys, this was about Azure storage. This is how you create a storage account. Let me come back to my slide. So this is what an Azure storage is. Let's move on to discuss the components of Azure storage. So right till now we have discussed how you can create a storage account, but inside a storage account you have a host of different services which you can make use according to your use case. All right, so the first service is called the blob service. So what a blob service? So blob service is nothing but a file system service wherein you can upload any kind of file, right? So for those of you who know about AWS, so AWS has a service called S3, right? So it is exactly like S3, right? There is nothing changed into it, just the name of the service is called blob. Now inside blob you can upload any kind of file, and then that file can be accessed by depending on the permissions that you have given, it can be accessed by anyone on the planet. For example, you have created a website and it's showing some images. So those images, rather being on the website's server, it could be there on blob and can be accessed directly through the link of any object that you actually upload in the blob. All right, having said that, guys, let me quickly show you how you can create a blob storage. So let me go back to my dashboard. So as you can see, my storage account has now been created. So if I go into my storage account, I'll get the screen wherein I have to choose a service. All right, so let me click on blobs. So because that is what I want to create, I'll click on blobs. I'll open it in a okay, I'll open it in the same tab, and then it will show me a screen where it will show me that there has nothing been added, right? So there are no containers yet. So what are containers? Containers are nothing but folders that you have inside the blob. All right, so you cannot store anything in the root directory. That is, you cannot upload any file over here. You have to have a folder inside which you will be uploading your files. All right, so folders are nothing but containers. Don't get confused with the nomenclature. Right, so inside this I will create a container called live-demo. Right, so it's done. The access type is blob. So what that basically means is if it's private, it cannot be accessed by anyone. If it's blob, inside this particular container all the files can be accessed. And if it's container, this basically means that if it inside this container you have created one more folder, that also can be accessed. But when we select blob, only the files can be accessed. So we'll select blob and we'll click on OK, and it'll hardly take a second to create a container in the blob service. All right, so we have a container now, which is the live demo, and if you go inside this container, there is nothing in it as of now. Right, so now I have actually created a website which can interact with the blob service. So let me show you how that website actually looks like. Or before that, let me show you the queue service. Let us cover the queue service first, and then we'll come back and discuss the blob. All right, so let me come back to my slide. So blobs, like I said, you have created a blob. You can upload any kind of file inside a blob using a website, or you can read the files as well from a website. All right, let's move on and discuss queues. So what are queues? Queues are basically it's exactly like a data structure wherein you whatever information goes first is the first to come out as well. All right, so you use queues to basically list jobs. So in our use case, we discussed that we have an image processing application which has millions of users accessing it, and since millions of jobs cannot be executed at once, they are listed inside the queue so that the server at its own pace can fetch the jobs and execute it. All right, so this is what a queue is all about, as simple as that. Now, the way you can create queues in the Azure dashboard is something like this, that you have your storage account, right? So let me go to my storage account. So my storage account is now being opening. All right, so inside my storage account with the blob service as well, I had queues option, right? So I'll go to that queues option and create a new queue. So my my storage account was live demo 2336, right? And now I'll choose queues. I'll go inside queues, and as you can see, as of now, there are no queues that have been created. So I'll create a new queue, and let me call it hello123. All right, so I'll create the queue now. So my queue has now been created. Now, if I go to my website, which is there for queue, this is how my website will look like if I want to upload some data into queue. So this is a sample website, guys, that I have created. Now this website has to know how to interact with your queue service. For that, you have a thing called uh, your connection string. So every storage account that you create will have a unique connection string that you have to include in your code. Now, if I click on access keys here, you'll go to your storage account, and then you'll have this pane. In that, you have to go to access keys. Once you go to access keys, you will have a connection string and a key. So you have to have the connection string in your code included so that your code can interact with the particular service. All right, so I'll go to my queues code. So my queue code is this. And if you can see, this is the connection string that I have to specify. I'll copy paste this connection string over here, and this endpoint has to be removed because it is not required in the connection string. Once you do that, you will save it, and my bucket name, my container, my queue name is hello123. So it has been already specified here, right? Now I'll go back. I will go to my website, which is this, right? So I've already specified to it for it to send messages to my queue, right? So if I send a message saying hello world, right, and I click on send a message, it'll actually send that message to my queue, which can be seen here. So if I go to my queue, you can see that a message has been added which says hello world. All right, so this is what I just entered. Now, if I go on and process this queue, which is I want to receive message now, so I'll have to change this in the PHP as well. So I'll go to my process PHP for my queue. I'll change my connection string so that it can interact with the queue and fetch the messages from over there, right? I'll change it here. I'll change the endpoint as well. And now my code will be able to interact with my queue that I've just created. All right, so if I go to process.php, it'll basically fetch the message from that queue and display it here. All right, so as you can see, the message received is hello world. If I enter any other message, say Edureka is the best, right? I enter this message, I send it to the queue. All right, and now when I'll process it, I'll get the same message back. And if you will see over here, guys, I'll just refresh it. Now, as you can see, the message has been processed and it has been deleted from the queue. So as and when the message is processed, it is automatically deleted from the queue. All right. So this is how my queues work. Let me quickly show you how the blobs work. All right. So let me go to my blobs website. So this is where I'll be uploading a file onto blobs. And again, I have to change the connection string again. Right, so I'll go to my blob code and change the connection string, which is here. All right, I'll change the connection string to my current storage account. And my container name, I've already specified it to be live demo. Right, I created a live demo container. Now, if I'll save this code, and if now I choose a file and say I upload the desert file. All right, so what it does is it basically renames the name of that file automatically according to system time, so that there's no clash when 2 or 3 files are updated with the same name. All right, so I'll upload this file now. So as of now, as you can see, if we go into our blob, there are no files. Right, if I go inside my blob, which is here, there's no file in it, right? But the moment I upload the file from this particular website, my file will be listed here. So as you can see, my file has been successfully added over here. And now if I go to the particular link of this file, I'll be able to download the file. Right, so my file is now being downloaded, and once it is downloaded, and if I try to open it, it'll be the same file that I just uploaded. Right, so if I open it now, you can see this is the file that we uploaded in the blob, and it is now accessible on this particular link by everyone in the world. All right, so this is how cool blob is. Now I'll be using blob and queues together. Let me show you how. So what I'll basically do now is this image that I've just uploaded has also been added to the queue that I created. So let me show you the queue. So if you see the queue, it will list the message that or the file name that we have just uploaded. We'll go into queues. This is my queue, and as you can see, this image has been added to the queue. Now I'll process this image, and the way I'll do it is like this, that the image will be fetched from the queue, and then the link of that image will be gone to, and that image will go into the background of the website. All right, so for that, first I have to change the code, obviously. So I'll go to my blob process website, right, and I will change the connection string to the one that we are using right now. 1 second. Right, so this is my connection string. I'll change it to what we are using right now. Right, and then also I have to change the link that will be accessing the file. Right, so this is the link that it is accessing. So the link has changed now because the storage account has changed. Right, so let me select the link for it. So I'll go inside blobs, and I'll go inside the container. So this link is going to, so from this point onwards till this point, that is till the container name, the link will be same, right? So let me copy the link and paste it in my code, and I'll show you what I mean. So if I paste the link here, so the link till live demo will be same, and just the file name has to be fetched, right? So this is this file name I'm fetching from the queue, and what it'll do now is it will fetch the file name from the queue and will change the background of the particular website, right? So if I process the page now, that is process.php, what will happen is it will fetch the file from the queue and it will change the background. All right, so I updated the desert file, right? So it is showing the desert background now. Now I'll show you how exactly queues are basically used. So say I upload, say 3-4 files, right? I upload this flower image, and mind you, the file, the message that we just received would have been deleted from the queue. All right, and I'll just show you whether that is working or not. So I'll upload this flower file. It might take some time because the files are kind of large. All right, so the file will be uploaded. Okay, it gave me an error. Let me upload it again. So I'll choose a file. So sometimes when the size the size of the file is more, it throws you an error, right? You can't do anything about it. So let me upload the file again. So once it is uploaded, guys, I'll be able to see it here, right? So I have like 3 files right now. So it says well done blob date complete, and if I refresh it, I'll be able to see 3 files now. Cool. So if I go to process.php now, it will not list me the previous file that I uploaded, but the recent file that I just uploaded. So let me go to process, and now it will show me the image that I've just uploaded. All right, it will fetch it from the queue, the file name, and then it will show me in the background. All right, the net is a little slow, bear with me. All right, so as you can see, the file has been there. I'm getting some weird error over here just because the net is not working, but forget this error, guys. You can see you get the image in the background, right? So similar is the case. Now let me go to my storage accounts. So we have discussed queues and blobs now, right? So let me go to my slides. So we've discussed what blobs are, we have discussed what queues are. Let me go to my file system, which is the best thing that I've figured out in Azure. So with file system, it is exactly like blobs. You can upload any kind of file, but with file system, you can actually mount it as a drive on your computer. All right, you can use it as if it was an extended drive in your own computer, right? And also you get an authentication protocol with it, which is called the SMB 3.0 protocol, which is used by servers whenever there is a file transaction. So that authentication you will also get when you're using the file system. And how you can mount it, let me show you how. So first of all, this mounting process is not available in Windows 7. It is only available in Windows 10 and above. So what I've done is I've deployed a virtual machine in Azure. Let me show you the virtual machine. Right, so this is my virtual machine. So I've deployed Windows 2012 server on this. Now what we'll be doing is we'll be mapping the file that we'll be creating in our storage account in this particular system. All right, so I'll connect to it, and now it'll ask me the username and the password. So I'll specify the password and I'll click on OK. Yes, and then I'll be connected to my system. So I'm in. So this is my system, guys. So if I go to my computer right now, as you can see, there is no drive that is listed, right? So we'll be creating a network drive over here on which we can upload any kind of file. Now, the way to do that is to first go to your Azure dashboard and create a file over there. Create a file system directory over there, right? So we'll go to our storage accounts. So it is in live demo 2336. And then we'll be going to files. Right, so as of now, as you can see, there is no directory which has been listed here. So I'll create a file share service, and let me name it something as my drive, right? And the quota is basically how many GBs of drive do you want, right? It can go to terabytes, but since I'm doing a demo, let me create a 100 GB drive right now, right? So I'll create a 100 GB drive and I'll click on OK. All right, so my drive has been successfully created. Right, so I'll go to this drive, I'll click on connect, and then I will get this command to connect to it. All right, I'll copy this command and I'll paste it in the notepad. So I'll use this in my server that I've just deployed. Now, how will I use this? Now, if you look at this command, guys, this is the address of your server. All right, so this is the address of your storage account, and this is the file share that you have just created, which is called my drive, right? The username to access this would be Azure /live demo 2336. All right, and the password for this would be the key, which has been specified here. Now I have to specify everything in that I've just mentioned in this server that I've created. All right, so the way you'll map the network drive is like this. You'll go to PC, you will right click it, and you will click on map network drive. All right, now it'll ask us the drive name that we want to allocate it. So for example, we want to allocate the K drive to it. All right, and in this particular thing, you will be putting in your address of the server, right? So let me copy the address of the server, which is this. All right, I'll copy the address and I'll save it over here. All right, so it has saved it, and now I'll click on finish. So if everything goes well, guys, it'll ask you for the username and the password. Now the username would be this, that is Azure /live demo 2336, right? So I'll go to my server, paste the username here, and then it'll ask me the password. So like I said, the password would be this, your key. So I'll copy the password, I'll paste it here, that is in this particular field, and I'll click on remember my credentials and click on OK. So now if everything is authenticated, it will go inside my drive. So as you can see, I'm inside my drive right now, and if I go to this PC, that is my computer, I can see that drive has been added over here. Now this drive, in this drive, as you can see, the total size is 100 GB and the space free is 100 GB. So this is the quota that we assigned in file share while creating it. Right now, if I want to copy any file over here, I can easily do that. I'll just copy this particular file and paste it here. Right, so it'll easily copy it and say I want a shortcut to be copied here. I can copy the shortcut as well, because I don't have any files on this particular server that I can show that I can copy here. So as you can see, the files have been copied here and these actually have been uploaded to the Azure account as well. Right, so let me show you on the dashboard if these files are visible. So I'll go to the Azure dashboard and this is my drive. If I refresh it right now, refresh, so it'll list me all the files that I've just uploaded. All right, so it is taking some time. And so basically, when you create a network drive in your own computer, it is as if you're using your own driver on your local computer if your internet network is good. Right, so as you can see, we have added these two files in our directory in the server, and you can view it here as well. And you can download it from here. You can click on it, you can download it, and anyone can download it if they have the link. All right, so we are done with file system. Let us come back to our slide and discuss our last component of today, which is tables. Now, tables is again an amazing service from Azure. So it is just like NoSQL, but it is basically, you can say, a child of NoSQL. You cannot do complex queries on it. Now, the way or the advantage of using tables is that say you have a data in which the structure is changing dynamically. What I mean by that is, say you are you have a form, you have created a website in which it accepts three things. It accepts your name, it accepts your mobile number, and it accepts your location. All right, so once it does that, it'll upload it in the database, right? Normal as usual. But what if tomorrow a use case comes in wherein I want to add one more field which maybe is asking for your credit card number, right? So if it is asking that, if you were using traditional systems, you would have to go to your database and add one more column and then go on to change your user interface and your PHP or whatever scripting language you're using. But with tables, the thing is that you don't have to change anything in the backend. As in, you don't have to change anything in your database. It'll automatically adjust according to your data and create one more field, which is basically which is basically you're trying to ingest. For example, in our case, we are trying to ingest the credit card number as well, so it'll do that automatically. So let me show you how you can use the table service. So we'll come back to our dashboard and go to storage accounts, right? And again, in your storage account, you'll have all the services listed. So we will select tables. We'll go inside tables, right? And once we are inside tables, we'll have to create a new table. So let's name this table as, say, new table, right? And we'll click on OK. So my table has now been created. All right, now the way you can upload your data to this table is the same. You just copy the connection string, you call the API, and you can upload your data. But to view the data in the table, you will need your Visual Studio. All right, so this is one table that I created earlier. So for adding it, I'll show you how to add it. But first, let me add some values inside this particular table. That is my new table, right? So there is nothing inside it because I just created it. So what I'll be doing is I'll be showing you the website through which I'll be uploading the data into the table. So it is this. So this is my website using which I'll be updating the table. Right, now the way I'll be doing it is I'll be first changing the connection string. So the connection string can be found here, right? I'll have to change this. This is my connection code for table. So I'll have to change the default connection string. So let us quickly change it. This is my connection string. I'll come back to my code, paste it here, right? And remove the endpoint. Cool. So my connection string has been given. Now I have to change the table name as well. So my table name is new table, right? And all right, so nothing else has to be changed. Cool. So our code is done. Now I'll come back to my slide and refresh it. All right. So now there are two things that you have to understand that are there in a table. One is called the partition key and one is called the row key. All right. What is partition key? What is row key? Let me explain you. So whatever files that you're trying to store in your table are stored in different nodes. When I say nodes, there are basically different servers. All right. Now each server will have a partition key which can identify it. So say there is server 1, server 2, server 3 and server 4. All right. So I want to store my data in server 1. All right. So my particular type of data that I want to store in server 1. So for that the partition key would be 1. All right. Now inside my server, every row has to be identified by a unique identifier, and therein comes in the row key. So this row key should be unique to each and every record that you will be putting inside a partition key table that is inside that particular server. If you change the server, again the row key can be same as that of the previous server, but when you are creating records inside one particular partition key, the rows key value has to be different. All right. Having said that, guys, so we have this website and we have created our new table over here. All right. Now what I'll be doing is I will be mapping this new table in my Visual Studio. Now the way to do that is open your Visual Studio, go to Server Explorer, and once you have you'll be listed your Azure service over here. All right. Now I'll have to map my particular storage account on this Visual Studio as well. So the way to do that is in the storage section, right click it and click on attach external storage. All right. So once that is done, it will ask me the account name and the account key. Now the way to attach it is like this, that you will go to the table service, your storage account, you will copy the name, paste in the account name, and then your connection string, your key. Right. So in this case, you'll be copying the key and you have to paste the key here. Remember the account key so that you don't have to enter it again and again, and click on OK. So this will add your storage account over here, right? So this is my storage account, live demo 2336. Right. So my storage account has now been added, and inside it I have created a table called the new table. All right. So if I click on the new table, as you can see, there is nothing that has been added as of now. So what I'll do is from my website, now I'll add a new value. So I've already specified the partition key as default. It is called task Seattle, right? All I'll be doing is I'll be entering the name over here, entering the row key over here, which will be unique. All right. So as of now, there are no records. So I'll enter 1 as my row key, and now I'll enter the columns that I want. So this particular row is the columns, and this is the values that I want for that particular column. So for that, for example, I want the name column to be there. Right. Inside the name column, I want the name Hemant. All right. I'll specify that, and say I want my mobile number to be there. I'll specify mobile NO. Right, and I'll specify the mobile number here, that is 1 2 3 4 5 6 7 8 9, say, and now I'll click on upload data. So this will upload the data to the table that I've just created. So if I go here, go back to my Visual Studio and I refresh it, I'll be able to see that a new record has been entered in which the row key is 1, right? The name is Hemant and the mobile number is this. Now say I want to add one more field which is asking for my credit card number. All right, so as I said, the row key would be different. Now I'll enter the name. So whatever column you have already specified, it will go inside the same column. So I have already specified name, right? So if I enter the value Hemant here, it will not create a new column and enter the value Hemant over there. It will just create the column which is new to the data. All right, so the mobile number is again say 5678, and now it will ask me for my credit card number. Right, so the credit card number could be this. All right, so now if I upload the data, and I'll show you how it looks now.
So as you can see now, the credit card number field has been added. So for the first record, there is nothing there in the credit card number field, but in the second record, I have added that I want this data. All right. Also, guys, you can specify in any order. There is no specific order that you have to specify. Right. So I can enter the name first. Right. And then I can enter the credit card number. So this is the credit card number that I want to add. Right. And say I'm entering the mobile here. Right. If I upload the data now, so this is required, 3 upload data. The data will be updated, and if I refresh it now, you can see that okay, so M capital and M small, you have to be careful of the indentation of the your syntax as well. So whatever column names you're specifying, it is case sensitive. So like you can see, I made a mistake here by specifying a small c, and it created one more column. All right, but as you can see, the name is in the same column now. All right, so what in whatever in whatever sequence you can add your record, that record will be added automatically in its respective column. All right, so this is how tables can be used.
What is Azure Import Export? Azure Import Export provides a way for organizations to export data from Azure storage to an on-premises location. The service offers a secure, reliable, and cost-effective method to export large amounts of data. You can also use Azure Import Export to import data to Azure storage from an on-premises location. However, I recommend that you use an Azure Data Box device when you are in a region where the Azure Data Box family is supported. Importing data by using one of the products in the Azure Data Box family is easier than using Azure Import Export. When you are moving large amounts of data between locations, speed and reliability are fundamental requirements. Even the fastest networks have bandwidth limitations. If you need to transfer tens of terabytes of data between remote sites, the operation could take several days. Additionally, if the transfer fails at some point, you don't want to have to start the whole process again from the beginning, right? So the Azure Import Export service is designed to address these kind of issues only. Now let's understand the components of Azure Import Export. So the first one is the Azure Import Export service. Import Export is an Azure service that's used to migrate large quantities of data between an on-premises location and an Azure storage account. By using the service, you send and receive physical disks that contain your data between your on-premises location and an Azure data center. You ship data that's stored on your own disk drives. These disk drives can be serial ATA, means SATA, or hard drives, HDDs, or solid state drives, means SSDs. The Azure Import or Export service is ideally suited to situations where you must upload or download large amounts of data, but your network backbone doesn't have sufficient capacity or reliability to support large-scale transfers. You typically use this service to migrate large amounts of data from on-premise to Azure as a one-time task. Also, you can use it for backing up your data on-premises in Azure storage. Or you can also use it for recover large amounts of data that you previously stored in Azure storage. And you can use it for distributing data from Azure storage to customer sites. Now the second component is WA Import Export tool. If you are importing data into Azure storage, your data must be returned to disk in a specific format. Use the WA Import Export drive preparation tool to do this. This tool checks a drive and prepares a journal file that's then used by an import job when data is being imported into Azure. The WA Import Export tool is a command line tool that performs the following tasks, such as prepare disk drives to be shipped to the Azure data center. WA Import Export formats the drive and checks it for errors before data is copied to the disk. It also encrypts the data on the drive. It quickly scans the data and determines how many physical drives are required to hold the data being transferred. It creates the journal files that are used for import and export operations. A journal file contains information about the drive serial number, encryption key, and storage account. Each drive you prepare with the Azure Import or Export tool has a single journal file. So there are two versions of this tool. Version 1 supports import or export of data to or from Azure Blob Storage. Version 2 supports import of data into Azure files. So you can download the appropriate version of WA Import Export from the Microsoft Download Center. Remember that WA Import Export tool is compatible only with 64-bit Windows operating systems. So the third component is disk drive. So you can ship solid state drives or hard disk drive to the Azure Data Center. When creating an import job, you ship disk drives containing your data. When creating an export job, you ship empty drives to the Azure Data Center. So what else you can do is you can request for a data disk from Azure Portal. So what happens is it will then send you a data bus disk directly, which will be encrypted, and there will be a encrypting key also that will also be sent to you on your address, and from where you can like store the data and send back to the Azure Data Center. So now that you have understood what Azure Import Export is and also its components, now let's understand how does Azure Import Export work. So Azure Import Export service is used to securely import large amounts of data to Azure Blob Storage and Azure Files by shipping disk drives to an Azure data center. This service can also be used to transfer data from Azure Blob Storage to disk drives and shipped to your on-premises sites. Data from one or more disk drives can be imported either to Azure Blob Storage or Azure Files. So supply your own disk drives and transfer data with the Azure Import Export service. You can also use Data Box disk drives supplied by Microsoft. So first let's understand Azure Data Box Disk. If you want to transfer data using disk drive supplied by Microsoft, you can use the Azure Data Box Disk to import data into Azure. Microsoft ships up to 5 encrypted solid state disk drives, means SSDs, with a 40 TB total capacity per order, means 40 terabyte total capacity per order, to your data center through a regional courier. You can quickly configure disk drives, copy data to disk drives over a USB 3.0 connection, and ship the disk drives back to Azure. So you can see here this flowchart how it works. So first you have to order a Azure Data Box disk from Azure Portal, and you will then receive it. You have to fill the data in it, and then you have to return to the Azure Data Center. From there, the process goes on the Azure Data Center. The process will move forward, and all the data from the disk will be provided on cloud storage. So that's how it get copied, and you can see it from your Azure Portal. You can access all your data from Azure Portal through the cloud. Now let's have a look at Azure Storage. So the Azure Storage Platform is Microsoft's cloud storage solution for modern data storage scenarios. Core storage services offer a massively scalable object store for data objects, a file system services for the cloud, a messaging store for reliable messaging, and a NoSQL store. The Azure Storage Platform includes the following data services. So the first one is the Azure Queue service, which is used to store and retrieve messages. Queue messages can be up to 64 KB in size, and a queue can contain millions of messages. Queues are generally used to store lists of messages to be processed asynchronously. Then there is Azure Table Storage, which is a service that stores non-relational structured data, also known as structured NoSQL data in the cloud, providing a key store with a schemaless design. Schemaless design. So then there is the blob storage and file storage, which we use it for the purpose of import and export. So Azure Blob Storage is Microsoft's objects storage solution for the cloud. Blob storage is optimized for storing massive amounts of unstructured data. Unstructured data is data that doesn't adhere to a particular data model or definition, such as text or binary data. Then we have Azure Files, means file storage. So Azure Files enables you to set up highly available network file shares that can be accessed by using the standard server message block, means SMB protocol. That means the multiple virtual machines can share the same files with both read and write access. You can also read the files using the REST interface or the storage client libraries. One thing that distinguishes Azure Files from files on a corporate file share is that you can access the files from anywhere in the world using a URL that points to the file and includes a shared access signature, that is SAS token. So you can generate SAS tokens. They allow specific access to a private asset for a specific amount of time. Now let's have an architectural understanding of Azure Import Export. To use Azure Import Export, you create a job that specifies the data that you want to import or export. You then prepare the data by yourself or prefer to request a disk from Azure Data Center to use to transfer the data. For an import job, you write your data to these tasks and ship them to an Azure Data Center. Microsoft uploads the data for you. For an export job, you prepare a set of blank disks and ship them to an Azure Data Center. or you can request a disk from the Azure Data Center. Means the disk is the same which I have explained to you before, the Azure Data Box disk. So Microsoft then copies the data to these disks and ship them back to you. In this scenario, you have decided that using the Azure Import Export service will meet your requirements. Let's understand how to import data to Azure. So before you import data to Azure storage, you must have the following items like an active Azure subscription, minimum of one Azure storage account, a system running a supported version of Windows, and a BitLocker enabled on the Windows system. Then the correct version of the WA import export tool, install version 1 to import data to Azure Blob Storage, or version 2 to import to Azure files. Okay, remember these things, these two distinctions. So download this tool from the Microsoft Download Center, and also I will show it to you in a further when we move on to the further process. I will show you it in a demo also how you can download the WA import export tool. Also, an active shipping career account also you should have, like FedEx or DHL, for shipping drives to an Azure data center. So you can see this diagram which summarizes the steps involved to import data. So you have to complete the following steps, like determine data to be imported, number of drives you need, also the destination blob location for your data in Azure storage. Then second step is to request Azure Data Box disk from Azure Data Center. Use the WA import export tool to copy data to disk drives. Encrypt the disk drives with the BitLocker, or you can prepare disk by yourself. Like that can be prepared by, you can connect each disk to your Windows system and create a single NTFS volume on each disk. Each disk must use a SATA connector. Enable BitLocker on the NTFS volume and then copy the data to the encrypted disk by using a tool like Robocopy. Open a command prompt window, go to the folder where you installed the WA import export tool, run the following command to retrieve the BitLocker key for the drive. These are the commands you can see. So the first command is manage BD protectors get drive letter. So drive letter is nothing like you have seen your local disk, like local disk C, local disk D, local disk F. So these C, D, F, these are drive letters. So this is the first command you have to give. Then prepare the disk by running the WA import export command. This command can take a significant amount of time to complete depending on the amount of data. So you can see the second command here, which is quite a major one. So you have to follow all the things in it. Like it is showing like this is the default one, WA import export.exe, prepare import. This is default. What will change is in the bracket thing, like you can see journal file name that will be generated when you use the WA import export tool. And also there will be a session number that will be generated, ID session number. So that also you have to put. And then there will be the same drive letter there, like which drive you want to view it on cloud. So that drive you are going to upload, right? So for that, the drive letter you have to give, just like I've explained you, like there's a drive letter for local disk C, then D, then F, all these things, C, D, F are drive letter. Then you have to give the BitLocker key that will also be generated through WA import export tool. And then again, the source directory drive letter you have to give, and destination directory container name you have to give, that will also be there. So then you have to select the blob type, whether it is a blob or page blob. Okay. Then the default code, that is skip write and enable content MD5. That is the default thing. Okay, that you don't have to change it. So that's how it has been done. So next step is to create the job. So create an import job by using the Azure Portal of the REST API. Provide the following information like name for the job, or create a storage account in which to import the data, shipping address of the Azure Data Center for the storage account, also like a return address where Microsoft should send the drive back to, also a list of drives that contain the data for the job, also BitLocker key used to encrypt the data for each drive. Then use a supported carrier like DHL or FedEx to ship the drives to the Azure Data Center. The carrier provides a tracking number. You add this tracking number to the import job. Then you have to check the job status from Azure Data Center. Like there will be certain tasks will be going on in Azure Data Center, and they will be updating you with the job status. So first is they will receive the disk at the Azure Data Center. So Microsoft updates the import job to indicate that the disks have arrived. You can track the job status from your import job page in the Azure portal. Then there will be transfer data. So Microsoft copies the data from the disk into the specified storage account. This can take some time depending on the volume of the data and number of disks. There is no SLA for this process, but it should be complete in 7 to 10 days after receipt of the disk. Microsoft updates the status of the job to indicate that the data is being transferred. When the transfer is complete, Microsoft changes the status of the job to indicate that the data is now available in Azure storage. Also, if you would have chosen to send your own disk, then after the data has been uploaded to Azure storage, Microsoft repackages your disk. This job status is updated. Then Microsoft sends the disk back to you using your selected carrier. The job status has changed to indicate that the job is now completed. Now your task is left, that is you have to receive your encrypted disk from the Azure data center. Then last thing is view data in Azure storage. So verify that the data has been copied to your storage account. Now you need to understand how to create an export job. So you can use the import export service to export data from Azure blob storage only. Remember this. Okay. And you can't export data that's stored in Azure files. So you must have the following items to support the export process, like an active Azure subscription and an Azure storage account holding your data in Azure blob storage. Okay. Second thing is system running a supported version of Windows. Okay. Then a BitLocker enabled on the Windows system and a WA import export version 1 downloaded and installed from the Microsoft Download Center. An active account with a shipping carrier like FedEx or DHL for shipping drives to an Azure data center. Also, a set of disks that you can send to an Azure data center on which to copy the data from Azure storage. Also, the second option, as I've told you, other than sending a disk, that is to request a data box disk from Azure data center if it is available in your region. Okay. Now you can see the following diagram, which summarizes the export process. To export data, you complete the following steps. So the first one is determine the data to be exported, number of drives you need, and source blobs or container paths for your data in blob storage. Second thing is request an Azure data box disk from the Azure data center, or you can send a disk by yourself to the Azure data center in your nearby region, and provide the return address and carrier account number for shipping the drives back to you. The third one is create job. So create an export job by using the Azure Portal or the REST API. Provide the following information like name for the job, a storage account that holds the blobs to export, and blobs in the account that contains the data to export, also the shipping carrier and return shipping information for the disk. Then send your disk to the Azure data center identified by the export job. The data center is assigned based on the location of your storage account. You can check the number of disks required for the export job by using the preview export argument of the WA import export command. You provide the details of your export job as parameters in this command. Then you have to check the job status, means whatever the process is going on in Azure data center task. So that will be updated in your job status. The first thing is received disk. So when the data center receives the disk, Microsoft updates the status of the job to indicate that the disks have arrived. This process is almost like same as import data also. Now the second thing is transfer data. So Microsoft copies the data from Azure blob storage to your disk. So the status of the job is changed to show that data is in the process of being transferred. When the transfer is complete, the job status is updated again. It can take several days to transfer the data to your disk, depending on the size of the export job. Then package disk. So Microsoft prepares the disk for shipping. The drives are encrypted through BitLocker. Fourth is ship. So Microsoft sends the disk back to the return address specified in the export job and updates the status of the job again. Then on your end, you can like receive and unload disk. When you receive the disk, you can mount them and use them locally. The data is encrypted. You can find the BitLocker keys for the each drive with the export job details in the Azure portal. This is how the import data with Azure import export and export data with Azure import export looks like. This is the architectural understanding of it. I hope you have understood it. Let's see the region availability for it. So the Azure import export service supports copying data to and from all Azure storage accounts. You can ship disk drives to one of the listed locations. These are all the supported shipping locations. If your storage account is in Azure location that is not specified here, an alternate shipping location is provided when you create the job. Now that you have understood how the Azure import export service works, let's understand when to use Azure import export. So the Azure import and export service is one of the several options for transferring data in and out of Azure storage. Here now we will explore in greater detail the question of when you should use the Azure import or export service and when other tools might be more suitable. So the first one in this is offline transfer of massive data. The Azure import export service is an offline solution. It's designed to handle more data than would be feasible to transmit over a network connection. Using the import export service, you take responsibility for preparing and shipping the necessary hardware. Microsoft provides an alternate solution in the form of the Azure Data Box family. The Data Box family uses Microsoft supplied devices to transfer data from your on-premises location into Azure storage. A Data Box device is an proprietary tamper-proof network appliance. You connect to the device to your own internal network to move data to the device. You ship the device back to Microsoft, which then uploads data from the device into Azure storage. The Azure Data Box family is the recommended solution for handling very large import or export jobs when the organization is located in a region where Data Box is supported. it's an easier process than using the import or export service. And the second scenario is online transfer of massive data. So the import or export service doesn't provide an online option. If you need an online method to transfer massive amounts of data, you can use Azure Stack Edge or Azure Data Box Gateway. Azure Stack Edge is a physical network appliance that you install on premises. The device connects to your storage account in the cloud. Databox Gateway is a virtual network appliance. Both of these products support data transfer from an on-premises location to Azure. Then the third scenario is online transfer of smaller data volumes. If you are looking to import or export more moderate volumes of data to and from Azure Blob Storage, consider using other tools like AZ Copy or Azure Storage Explorer. AZ Copy just means Azure Copy. So Azure Copy is a simple but powerful command line tool that lets you copy files to an Azure storage accounts. With AZ Copy, you can like upload, download, and copy files to Azure Blob Storage, or you can also upload, download, and copy files to Azure Files. Or you can copy files between storage accounts, and you can also like copy files between storage accounts from different regions. You can use AZ Copy to transfer data online across a network. To access AZ Copy, you must provide the appropriate Azure credentials to access the storage account or use an SAS, means shared access signature. AZ Copy is the ideal tool for copying small to moderate amounts of data as quickly as possible and with the least cost and effort. For large datasets, network bandwidth may limit to the speed at which you can upload or download data to and from Azure storage. You can create scripts that use AZ Copy. Then there is Azure Storage Explorer, which is a free tool that you can use to connect to Azure Storage and view data through a graphical user interface. You can upload and download data held in blobs, files, and tables. You can also examine queues and manipulate queued messages. Storage Explorer is an interactive tool. It isn't suitable for moving more than the smallest amounts of data, and it can't be easily scripted. A version of Azure Storage Explorer is provided in the Azure Portal. You can also use Azure PowerShell and the Azure CLI to upload command line interface to upload and download data. These interfaces are programmatic, enabling you to produce complex scripted solutions that can incorporate transformations, mergers, and filtering as the data is transferred. Then the next we have is security considerations for Azure Import Export. The data on the drive is encrypted using AES 256-bit BitLocker drive encryption. This encryption protects your data while it is in transit. For import jobs, drives are encrypted in two ways. First, specify the option when using the dataset file while running the WA import export tool during live preparation. Then second, enable BitLocker encryption manually on the drive. Specify the encryption key in the drive set when running the WA import export tool command line during drive preparation. The BitLocker encryption key can be further protected by using an external key protector, also known as the Microsoft Managed Key or a customer managed key. For export jobs, after your data is copied to the drives, the service encrypts the drive using BitLocker before shipping it back to you. The encryption key is provided to you via the Azure portal. The drive needs to be unlocked using the WA import export tool using the key. Then the next is pricing segments. So there are four pricing segments. First one is a drive handling fee. So there is a drive handling fee for each drive processed as part of your import or export job. So you can see the pricing options for drive handling fee. As it is shown here, $80 flat fee per storage device handled. So this is how it looks like, and return shipping fee of devices also that we will talk about the next one. So the next one is shipping cost. When you ship drives to Azure, you pay the shipping cost to the shipping carrier. When Microsoft returns the drives to you, the shipping cost is charged to the carrier account which you provided at the time of the job creation. And the third one is transaction cost. So standard storage transactions charges apply during import as well as export of data. So standard egress charges are also applicable along with storage transaction charges when data is exported from Azure storage. So you can see here I've chosen the currency US dollar. So these are the pricing options for it for data transfer. Then for inter-region, there are different charges, and for intercontinental data transfer also there are different charges. Then we have for internet egress routed via Microsoft Premium Global Network and internet egress routed via routing preferences transit ISP network. There are different prices with different plans of certain specific amount of data per month. Okay, so you can see the different prices here. Then we have the prices for data box disk cost. As I've explained you, it is very important. Like we prefer to request it from Azure data centers. So Azure cost, there is certain price for it. So which we have to pay when we request it from Azure data center. So these are the prices you can see. Like for East US region, because there are certain different prices for different regions. So East US, and dollar currency you can see like service fee is $250 and extra day fee is $15. So different kinds of prices are there. I hope you have understood this. So this is just for data box. Then there are different prices for data box disk also, data box heavy also, and data box gateway also. Now that you have a theoretical and architectural understanding of Azure Import Export service, let's now see a practical implementation of it by trying our hands on Azure Portal. So you can simply go to Azure Portal. This is how the Azure Portal looks like. So first step is let's request for a data box. As I have told you that you have to request a data box. If you are not going to send your own disk, you can request a data box from Microsoft and it will send you to your address, whichever address you provide. Okay. So this is how the Microsoft Azure Portal looks like. If you don't have your account on Microsoft Azure, create one. It's a very good platform to have your account on. It's a 12-month free trial. You'll get through it, and also there will be a 14,500 INR credit if you are in India. So of course in INR, there might be different plans in US or different other countries. Okay, so do make your account. Okay. First, let's understand how to request Azure Databox disk, because as I have explained you, if you are not going to send your own disk something, so you can actually request an Azure Databox from the nearby region of yours. Okay, so let's go to Azure Databox. Just type Databox. Yeah, so you can create from here. Then import to a transfer type, import to Azure. Choose import to Azure. Then subscription, free trial, resource group. Like I have Edureka demo. If you don't have one, create one resource group. Then select region. I can choose India. Destination Azure region, West India. Remember, I have told you the availability regions. So these are the availability regions of Databox also. Okay. So you can just apply from here. But as I have a free trial account, after this step you cannot actually move forward if you have a free trial account. You need to purchase and certain rights for it. That's why it is showing like 40 TB, 100 TB, 1000 TB, 1 TB, 1. This is like the sending your own disk. That's a different thing. But here you can see different plans are there. I have a free trial. That's why it's a limited access. So I cannot order it from here. So that's how you can just request for Azure Data Box. Let's start with import export service. So you can just go to export jobs. You create the job from here. It will show if there is already a job. So there's no job yet. So you can create from here. What you have to do it from here is resource group, free trial. You choose the resource group, like mine is a Edureka demo. Name we can give import demo, right? So import to Azure, choose import or export, whichever you want to do. Right now we are going with import, so we are choosing the import one. So next, job details. So remember, I have explained there's this WA import export tool that will generate the general file if you select the disk. So you can go it from here. Yeah. So here service devices shop. Yeah. So here it is. You can download it from here. It will get downloaded and you can extract and run the application in your system and download it. So let's assume we have downloaded the journal file. Okay. Now let's select the destination Azure region. So what we can do is, yeah, our region is West India, right? West India we can choose. Storage account we can choose. Like I don't have any storage account right now. So what I can do is I can create a storage account. Go to portal again. Storage accounts we can choose from here. So create a storage account. Yeah, so you can choose the resource group from here and then you can give a name to a storage account. So let's give import export store, and then region we can select. I'll choose India. There is given West India, right? So performance, everything is okay, not a problem. Next, advanced, just review and create after this. That's it. Create. So it is getting deployed. So yeah, it's been created. You can go to Edureka demo source. Will be showing here. What's the name of it? Import export. Or you can refresh it. If it's not showing, you can refresh it once. It will show them. Import export storage accounts. There again, refresh. Yeah, now it is there. Storage account. Import export store, right? Open it from here. This is how everything information is given. But that's it. You just have to create that. There's no other use of it. So you can just give the name here now. Import export store. We can refresh it once. It's not showing right now. You can again choose the Edureka demo now. Import demo we can give. Import into Azure. Next, job details. Then as I explained you for this, upload journal files and everything. Okay, like download this from W import export tool, and then create a journal file by selecting the disk you want to get it uploaded into. You want to import into the Azure cloud, right? So now we choose the Azure region. So we can choose the region West India. Storage account, import export store. It is there, right? So next shipping. Okay, then we can go to shipping, and you can give the address also, and also the your address also. Like if you're going to send your disk. So if you select that from Azure Data Box, now if you select the option of sending your disk, then they will provide you an address where you can send to the Microsoft. That address will be given, and you have to give your address also so that they can return back the disk. And also, if you have chosen the Data Box option, then you just have to give like your address. They will send you the a disk by themselves, and then you have to like return it back to them online. Okay, that's it. Then text, then review create, and just create it. Right now we haven't created a journal file, so it will not move forward. So these are the steps. You can see, like I have noted it here. Like you have to, first step is to determine the data, then number of drives required, and blob location. That is the first thing you will do. And the second is to download the W import export tool and create a journal file. Then you have to create import export job, as it is shown here. Then you have to ship drives to the provided address. Okay, whatever address is provided, you have to ship them if you are sending your own disk. Otherwise, it's a different step. So then fifth one is to drives are processed at Azure Data Center. It will be processed there, and it will be like whatever process is going on, it will be updated in the same import export job you are creating here, right? The import job you are creating here. Then drives are shipped back to you again if you have sent your own drive. Now, what's different in export job? The only thing different in the export job is you don't have to use the import export tool to encrypt or the BitLocker, right? For encrypting the data and everything. What about the W import export tool is used? So you can just go to basics again. Instead of this, we can choose export from Azure. We can give it export demo. Everything is same. Next job details. Then what you have to do is, right now I haven't chosen anyone, so I can just choose export all. If you want to choose a specific something, you can choose by yourself. Okay. Then next shipping, same, everything shipping and everything is given. Then you can just give all this information, and this all the steps are same. Then you can just go to text and review create and just complete. That's it. I hope you have understood this. It's not that difficult. It's actually quite an easy process. Now let's understand some of the use cases for Azure Import Export Service. So consider using Azure Import or Export service when uploading or downloading data over the network is too slow, or getting additional network bandwidth is cost prohibitive. Use this service in the following scenarios. Like first use case is data migration to the cloud. So move large amounts of data to Azure quickly and cost effectively. That's very simple in that. And second thing it provides is cloud backup. So take backups of your on-premises data to store in the Azure storage. And last one is data recovery. So you can recover large amounts of data stored in storage and have it delivered to your on-premises location.
What is Azure App Service? The Azure App Service is an HTTP based service for hosting, web application, REST APIs, and mobile backends. It is a platform as a service where you can develop in your favorite language, be it .NET, .NET Core, Java, Ruby, Node.js, PHP, or Python. With Azure App Service, you pay for the Azure compute resources you use. The compute resources you use are determined by the app service plan that you can run on your apps. So, in simple words, if we say Azure App Service is a web based service that hosts web application, REST APIs, and mobile backends. Now, let's see why do we use Azure App Services. Azure App Service is a fully managed platform as a service offering for developers. So, here are some key features of Azure App Service. Firstly, multiple language and frameworks. So here the app service has a first class support for ASP.NET, ASP.NET Core, Java, Ruby, Node.js, PHP, or Python. You can also run PowerShell and other scripts or executables as background services. Looking forward, manage production environment. Here, the app service automatically patches and maintains the OS and language frameworks for you. You can spend time writing great apps and let Azure worry about the platform. Next is containerization and Docker. You can Dockerize your app and host custom Windows or Linux container in the app services. You can also run multi-container apps with Docker Compose and migrate your Docker skills directly to the app service. Next is DevOps optimization. So here you can set up continuous integration and deployment with Azure DevOps, GitHub, Bitbucket, Docker Hub, or Azure Container Registry. You can also promote updates through test and staging environments and manage your apps in the app service by using Azure PowerShell or cross platforms like command line interface. Next is global scale with high availability. Here you can scale up or scale out manually or automatically. You can also host your apps anywhere in Microsoft's global data center infrastructure, and the app service CLA promises high availability. Moving ahead, serverless code. So here you can run code snippet or script on demand without having explicitly provisions or manage infrastructure and pay only for the compute time your code actually uses. Next is application templates. So here you can choose from an extensive list of application templates in the Azure marketplace such as WordPress, Joomla, and Drupal. Last but not the least, security and compliances. So here, app service is ISO, SOC, and PCI compliant. You can authenticate user with Azure Active Directory, Google, Facebook, Twitter, or Microsoft account. You can also create an IP address restrictions and manage the service identities. At last, connections to SaaS platform and on-premises data. So here you can choose from more than 50 connectors for enterprises systems such as SaaS services and internet services, and access to on-premises data using hybrid connections and Azure virtual networks. So these were the key features which makes Azure App Service more demanding. Let's quickly have a look on some of the app service application types. So there are four app service application types, that is web app, API app, logic app, and mobile app. So let's quickly look on to each one of them. So first is web app. Azure web apps are used for hosting websites and web applications. It lets us quickly build, deploy, and scale enterprise grade webs, mobile, and API apps running on any platform. It helps us to meet rigorous performance, scalability, security, and compliance requirement while using a fully managed platform to perform an infrastructure maintenance. Next is API app. It is used for hosting RESTful APIs. The API app features make it easy to develop, host, and consume APIs in the cloud or on premises. The advantage of hosting APIs in Azure API app is that we will get enterprises grade security and simple access control, automatic SDK generation, and seamless integration with logic apps. Next is logic app. Logic apps are used for business process automation, system integration, and sharing data across clouds. And last, mobile app. Mobile apps are used for hosting mobile app backends where we can deploy our mobile backend services on Azure using Azure mobile app. By implementing our mobile backend service on Azure, our mobile backend will be able to communicate with different Azure services. We can able to take the advantage of various features that are provided by Azure mobile apps. So these were the four app service application types. So let's quickly move on to our next topic, that is app service plan. So to create an app service, you need an app service plan. Without an app service plan, you cannot create an app service. The app service plan consists of many components. So it means the app service is a baseline for the actual compute resources. Here, the app service plan can have multiple app services, and in these each app services, we have different deployment slots. So what is deployment slots? Deployment slot allow your function apps to run different instances called slots. Slots are different environments exposed via publicly available endpoints. One app instance is always mapped to the production slot, and you can swap instances assigned to the slot on demand. When you create an app service plan in a certain region, a set of compute resource is created for that plan in that region. So whatever apps you put into this app service plan runs on these compute resources as defined by your app service plan. So each app service plan defines the operating system. Maybe it is Windows or Linux. Next is region. So it can be any region, whichever region of your choice you choose, whether it can be West US, East US, Central India, etc. And the size of the VM instances. So you can choose small, medium, large. And for sure, pricing tiers. So there are different type of pricing tiers such as free, shared, basic, standard, premium, premium version 2, premium version 3, isolated, isolated version 2, etc. So we'll look on to these pricing tiers in further. So let's quickly have a small demo on Azure App Services. So for this, we need to move on to our Visual Studio Code. So let's quickly go on to our Visual Studio Code. And the first thing we need to do is to create a folder. So I have already created a folder. Let's open that. That is Azure App Services. So I'll select this folder. And as you can see here, the folder is here. So within this folder, we'll be creating a .NET program. So let's open our terminal. Yeah, let's create our .NET program. .NET new MVC. So here you can see your web application is being created, and you can see all your folders are available over here. So as you can see, your program has been built successfully. Now let's run this program. So we'll just hit the command .NET run. Alright, so here you can see it is building. So let's wait for a few seconds. Yeah, so here you find your local host where your program has been created and it has run successfully. So just click on this link. This is the local host where our program is run. Alright, so here you can see in your local host, your program has been run successfully. Now, what do you need to do? You need to deploy it into the app services. So how do you do that? Let's go back to our Visual Studio Code. Now, for this, you need to have an extension that is Azure extension. So how do you do that? You just go to this extensions tab, and here you can just select Azure account and Azure app service. You need to install these two extensions to avail all the services. So as I have already installed these two accounts and Azure App Service, so it's already feeded inside. So let's quickly move on to our Azure. And here, as you can see in our resources, our Azure Labs, this is our account where we can utilize all the services. So as you can see here, there are many services. Now what do we need to do? Just click on the create resource and we'll select create app service web app. So we'll just click on this and we'll just give a unique name to our web app. So let's give it a new name, Azure Web App Demo 3. Alright, so let's hit enter. So here they will be asking what type of language it is. So it is .NET 6 that has been recently used, and they ask about the subscriptions, that is our pricing tier. So let's take it free, and here our web application gets created. So as you can see, your web app has been created successfully, and here you can see our Azure Web App Demo 13 web application. So here now what do we need to do is to deploy. So let's just right click and deploy to web app. So we'll just click over here and we'll just browse. So as you can see here, you can see our folder itself. So I don't have to go into the folders and find my Azure app service demo. So I'll just quickly click on this, and they ask permission for configuration. So just add configuration, and then they ask whether are you sure you need to deploy the Azure Web App Demo 13 or no. So just hit deploy. And as you can see, it's feeding, all the programs are being feeded in your Azure application. So here you can see all your packages and all your programs are being stored into the Azure portal, Azure App Service. So let's wait till it gets completed. Alright, so our deployment is successful. So now we'll just browse the website just to check whether it has come into our Azure or no. Okay, so this is the link. We'll just follow this link and let's see. Yeah. So here you can see it is Azure Web App Demo 13 website.net. So it has been deployed successfully. So this is how you deploy into the Azure App Services. Now let's quickly move on to our Azure portal and let's check whether we can see it over there as well or no. So this is our Azure portal. So let's go to all services. So here you can see it. We have the web application Azure Web App Demo 13. So let's just go into it. Let's have an overview. All right. So as you can see over here, all your details are given over here. You can see all your metrics based on whatever files are there. And let's quickly move down and see our scale ups and scale down. That is our app service plan. So as we had chosen the free option, so here you can see this is our shared compute. So you can upgrade your tiers based on your requirements. So as you can see here, different pricing tiers are there. So here you have the recommended pricing tiers. Based on that, you get your features. So the higher the tier, the more upgraded features you can avail in your Azure App Services. So you can change it anytime whenever you need it. So for currently, like we have it for free. So we have no other features in it. So let's also check to our Azure service plan. Over here, you can get app service plans. So here you can see our app service plan and just view. So you get all your details over here. So here you can see your pricing tier is free and your operating system is Windows and your one application is running. So there's one application feeded in your Azure App Services. All right. So if you wish to see here, scale ups, same thing. So here also you can see anywhere you can just upgrade your tiles based on whatever requirements you need to have. So this is how you work with Azure App Services, and it's quite pretty easy. So you can do it or through Azure Portal as well, or you can do it with our Visual Studio Code. Like how did we do it? So this is how you work with Azure App Services. You can just feed in any of your desired programs or your web applications and you can just directly put into your app services. So it's quite pretty easy. Like through Visual Studio Code, you just need to hit some commands and you can directly like deploy your applications into the Azure portal. So this was all about the demo. And lastly, we come to our pricing tiers. The pricing tier of an app service plan determines what app service features you get and how much you pay for the plan. So the pricing tiers are available to your app service plan depending on the operating system selected at the creation time. So there are few categories of pricing tiers, that is shared compute, dedicated compute and isolated. In shared compute, we have free and shared two base tiers that runs an app on the same Azure VM as other app services, including apps of other customers. These tiers allocate CPU quotas to each app and that runs on these shared resources, and these resources cannot be scaled out. Next is dedicated compute. In dedicated compute, we have basic, standard, premium, premium version 2, and premium version 3 tiers that runs app on dedicated Azure VMs. Only apps in the same app service plan share the same compute resources. The higher the tier, the more VM instances are available to you for scale-outs. And lastly, we have isolated. In this, we have two types of pricing tiers, that is isolated and isolated version 2. So these two tiers run on dedicated Azure virtual networks. It provides network isolation on top of the compute isolation to your apps and also provides some maximum scale out capabilities.
Now let's have an introduction of a database. First, let's understand why do we need a database. So the various reasons a database is important are, first of all, it manages large amounts of data. A database stores and manages a large amount of data on a daily basis. This would not only be possible using any other tool such as a spreadsheet, as they would simply not work. Second is its accuracy. So a database is pretty accurate as it has all sorts of built-in constraints, checks, etc. This means that the information available in database is guaranteed to be correct in most cases. It's easy to update data in a database. So in a database, it is easy to update data using various data manipulation languages available. One of these languages, SQL. For the security of data, so databases have various methods to ensure security of data. There are user logins required before accessing a database and various access specifiers. These allow only authorized users to access the database. So fifth is data integrity. This is ensured in databases by using various constraints for data. Data integrity in databases makes sure that the data is accurate and consistent in a database. The last is easy to research data. It is very easy to access and research data in a database. This is done using data query language, which allow searching of any data in the database and performing computations on it. Now that you have understood the need of a database, let's briefly understand what actually it is. So a database is an organized collection of structured information or data typically stored electronically in a computer system. A database is usually controlled by a database management system. Together, the data in the database management system, along with the applications that are associated with them, are referred to as a database system, often shortened to just a database. So data within the most common types of database in operation today is typically modeled in rows and columns in a series of tables to make processing and data querying efficient. The data can then be easily accessed, managed, modified, updated, controlled, and organized. Most databases are a structured query language for writing and querying data. Databases are used to support internal operations of organizations and to underpin online interactions with customers and suppliers. Databases are used to hold administrative information and more specialized data such as engineering data or economic models. Example includes computerized library system, flight reservation system, computerized past inventory system, and many content management systems that store websites as collection of web pages in a database. Now that you have an understanding of Microsoft Azure as well as of a database, let's now take a look at different types of databases in Azure. First is relational database. A relational database is a type of database that stores and provides access to data points that are related to one another. Relational databases are based on the relational model, an intuitive, straightforward way of representing data in tables. In a relational database, each row in the table is a record with a unique ID called the key. The columns of the table hold attributes of the data, and each record usually has a value for each attribute, making it easy to establish the relationships among data points. In a relational database, all data is stored and accessed via relations. So relations that store data are called base relations, and in implementations are called tables. Other relations do not store data but are computed by applying relational operations to those relations. These relations are sometimes called derived relations. In implementations, these are called views or queries. Derived relations are convenient in that they act as a single relation, even though they may grab information from several relations. Each relation or table has a primary key. This being a consequence of a relation being a set, a primary key uniquely specifies a tuple within a table, while natural attributes are sometimes good primaries. So this is all about relational database. Then second we have is non-relational database, also known as NoSQL databases. So NoSQL database or non-relational database provides a mechanism for storage and retrieval of data that is modeled in means other than the tabular relations used in relational databases. So non-relational databases are increasingly used in big data and real-time web applications. And non-relational databases are also like sometimes called not only SQL to emphasize that they may support SQL like query languages or sit alongside SQL databases. So the prominent non-relational databases provided by Azure is Cosmos database that I will explain you further in this video. And third is in-memory database. So an in-memory database, also like in the short form we say it as IMDB, also like a main memory database system, or MMDB, or memory resident database. These are all the names of it. So an in-memory database is a database management system that primarily relies on main memory for computer data storage. It is contrasted with database management systems that employ a disk storage mechanism. In-memory databases are like faster than disk optimized databases because disk access is slower than memory access. The internal optimization algorithms are simpler and execute fewer CPU instructions. Accessing data in memory eliminates seek time when querying the data, which provides faster and more predictable performance than disk. A potential technical hurdle with in-memory data storage is the volatility of RAM, specifically in the event of a power loss, intentional or otherwise. Data stored in volatile RAM is lost. With the introduction of non-volatile random access memory technology, in-memory databases will be able to run at full speed and maintain data in the event of power failure. Let's now understand the architecture of database services provided by Azure. So you can see it looks like a complex architecture, but I will explain you quite easily. So the basic fundamental building block that is available in Azure is the SQL database. So Microsoft offers this SQL Server and SQL database on Azure in many ways. We can deploy a single database, or we can deploy multiple databases as part of a shared elastic pool. You can see the elastic pools and single database. Okay. Microsoft introduced a managed instance that is targeted towards on-premises customers. So if we have some SQL databases within our on-premises data center and we want to migrate the database into Azure without any complex configuration or ambiguity, then we can use a managed instance. Because this is mainly targeted towards on-premises customers who want to lift and share their on-premises database into Azure with the least effort and optimized cost. We can also take advantage of licensing we have within our on-premises data center. Microsoft will be responsible for maintenance, patching, and related services. But in case if we want to go for the infrastructure as a service for the SQL Server, then we can deploy SQL Server on the Azure virtual machine. If the data has a dependency on the underlying platform and we want to log into the SQL Server, in that case, we can use the SQL Server on a virtual machine. We can deploy a SQL data warehouse on the cloud. Azure offers many other database services for different types of databases such as MySQL, MariaDB, and also PostgreSQL. Once we deploy a database into Azure, we need to migrate the data into it or replicate the data into it. Okay. Then we have is Azure Database Services for data migration. So services that are available in Azure, which we can use to migrate the data from our on-premises SQL Server into Azure. So in that, the first one is Azure Data Migration Service. So it is used to migrate the data from our existing SQL Server and database within the on-premises data center into the Azure. Then we have is Azure SQL Data Synchronization. If we want to replicate the data from our on-premises database into Azure, then we can use Azure SQL Data Sync. Then we have a SQL Stretch Database. So it is used to migrate cold data into Azure. SQL Stretch Database is a bit different from other database offerings. It works as a hybrid database because it divides the data into different types, like hot and cold. So hot data will be kept in the on-premises data center and cold data in the Azure. Then we have is Data Factory. So Azure Data Factory is used for ETL, means transformation, extraction, and loading. So using the Data Factory, we can even extract the data from our on-premises data center. We can do some conversion and load into the Azure SQL database. Data Factory is an ETL tool that is offered on the cloud, which we can use to connect to different databases and like extract the data or transform it and load into a destination. Then there's Azure Security Center. So all the databases that exist in Azure need to be secured, and also we need to accept connections from known origins. For this purpose, all these database services comes with firewall rules where we can configure from which particular IP address we want to allow connection. We can define those firewall rules to limit the number of connections and also reduce the service attack area. So now let's talk about the Cosmos DB. So Cosmos DB is nothing but a SQL data store that is available in Azure, and it is designed to be globally scalable and also very highly available with extremely low latency. Microsoft guarantees latency in terms of reading and writes with Cosmos DB. For example, if we have any applications such as IoT or gaming, where we get a lot of data from different users spread across globally, then we will go for Cosmos DB because Cosmos DB is designed to be globally scalable and highly available, due to which users will experience low latency. Finally, there are two things, and one is we need to secure all the services. For that purpose, we can integrate all these services with Azure Active Directory and manage the users from Azure Active Directory also. To monitor all these services, we can use the Security Center. So there is an individual monitoring tool too, but Azure Security Center will keep on monitoring all these services and provide recommendations if something is wrong. I hope the architecture of Azure Database Services is now clear to you. Now let's move forward to briefly understand the database services provided by Azure. So the first is the Azure SQL Database. So SQL Database is the flagship product for Microsoft in the database area. It is a general purpose relational database that supports structures like relation data, JSON, spatial, and XML. The Azure platform fully manages every Azure SQL database and guarantees no data loss and a high percentage of data availability. Azure automatically handles patching, backups, replication, failure detection, underlying potential hardware, software, or network failure, deploying bug fixes, failovers, and database upgrades and other maintenance tasks. So there are three ways we can implement our SQL database. So first is managed instance. This is primarily targeted towards on-premises customers. In case if we really have a SQL Server instance in our on-premises data center and you want to migrate that into Azure with minimum changes to our application and the maximum compatibility, then we will go for managed instance. Second is single database. So we can deploy a single database on Azure, its own set of resources managed via a logical server. Okay. Then we have is Elastic Pool. We can deploy a pool of databases with a shared set of resources managed via a logical server. We can deploy the SQL database as an infrastructure as a service. That means we want to use the SQL Server on Azure virtual machine. But in the case we are responsible for managing the SQL Server on that. But in that case, we are responsible for managing the SQL Server on that particular Azure virtual machine. So then we have the purchasing model. So there are two ways we can purchase the SQL Server on Azure. So first is vCore purchasing model, also known as virtual core purchasing model. So the vCore purchasing model enables us to independently scale compute and storage resources, match on-premises performance, and optimize price. It also allows us to choose a generation hardware. It also allows us to use Azure hybrid benefit for SQL Server to gain cost savings. Best for the customers who value flexibility, control, and transparency. So second is the DDU model. It is based on a bundled measure or compute storage and input-output resources. So sizes of the compute are expressed in terms of database transaction units, means DTUs, for single databases and elastic database transaction units for elastic pools. This model is best for customers who want simple pre-configured resource options. In the second database service is Azure Cosmos Database. So Azure Cosmos Database is a NoSQL data store. It is different from the traditional relational database where we have a table and the table will have a fixed number of columns and each row in the table should adhere to the scheme of the table. In the NoSQL database, you don't define any schema at all for the table. And each item or row within the table can have different values or different schema itself. So now let's understand the Cosmos database structure. First one in the structure is a database. So we can create one or more Azure Cosmos database under our account. A database is analogous to a namespace and it is the unit of management for a set of Azure Cosmos containers. So the second is Cosmos account. So the Azure Cosmos account is the basic unit of global distribution and high availability. For globally distributing our data and throughput across multiple Azure regions, we can add or remove Azure regions from our Azure Cosmos at any time. I mean Azure Cosmos account at any time. So the third is a container. So an Azure Cosmos container is the unit of scalability for both provision, throughput, and storage of items. A container is horizontally partitioned and then replicated across multiple regions. Then let's understand the types of consistency under Cosmos DB. So Azure Cosmos Database approaches the data consistency as a spectrum of choices instead of two extremes. So strong compatibility and eventual consistency are at the ends, but these are many consistency choices along the spectrum. So the consistency levels are region agnostic. The consistency level of our Azure Cosmos account is guaranteed for all read operations regardless of the region from which the reads and writes are served. The number of areas associated with the Azure Cosmos account or whether our account is configured with a single or multiple write regions. Then there's request units. So we pay for the throughput we provision and the storage we consume on an hourly basis with Azure Cosmos DB. Remember this DB means database. So then there are request units in Cosmos DB means Cosmos database. So we pay for the throughput we provision and the storage we consume on an hourly basis with Azure Cosmos DB. The cost of all the database operations is normalized by Azure Cosmos DB and is expressed in terms of request units. The price to read a 1 KB item is one request unit. All other database operations are similarly assigned with a cost in terms of research units. The number of research units consumed will depend on the type of operations, item size, data consistency, query patterns, etc. For the management and planning of capacity, Azure Cosmos database ensures that the number of research units for a given database operations over a given dataset is deterministic. And the third database service is Azure Data Factory. So Azure Data Factory is a data integration service based on the cloud that allows us to create data-driven workflows in the cloud for orchestrating and automating data movement and data transformation. Data Factory is a perfect ETL tool on cloud. Data Factory is designed to deliver extraction, transformation, and loading process within the cloud. The ETL process generally involves 4 steps. So the first one is collect and collect. We can use the copy activity in a data pipeline to move data from both on-premises and cloud secure data stores. So the second is transform. So once the data is present in a centralized data store in the cloud, process or transform the collected data by using compute services such as HD inside Hadoop, Spark, Data Lake Analytics, and machine learning. Third is publish. So after the raw data is refined into a business ready consumable form, it loads the data into an Azure data warehouse, Azure SQL database, and Azure Cosmos database, etc. So fourth is monitor. So Azure Data Factory has built-in support for pipeline monitoring via Azure Monitor, API, PowerShell, log analytics, and health panels on the Azure portal. So then there are components of Data Factory. So Data Factory is composed of 6 key elements. All these components work together to provide a data form on which you can form a data-driven workflow with the structure to move and transform the data. So first one is pipeline. A Data Factory can have one or more pipelines. It is a logical grouping of activities that perform a unit of work. The activities in a pipeline perform the task altogether. For example, a pipeline can contain a group of activities that ingest data from an Azure blob and then runs a Hive query and an HD Insight cluster to partition the data. So second is activity. It represents a processing step in a pipeline. For example, we might use a copy activity to copy data from one data store to another data store. Then we have is datasets. So it represents data structure within the data stores, which point to or reference the data or we want to use in our activities as input or output. Then there are link services. So it is like connection strings, which define the connection information needed for Data Factory to connect to external resources. A linked service can be a data store and compute resources. Linked service can be a link to a data store or a compute resource also. Then we have as triggers. So it represents the unit of processing that determines when a pipeline execution needs to be disabled. We can also schedule these activities to be performed at some point in time, and we can use the trigger to disable an activity. Then the last one is control flow. So it is an orchestration of pipeline activities that include chaining activities in a sequence, branching, defining parameters for the pipeline label, and passing arguments while invoking the pipeline on demand or from a trigger. We can use a control flow to sequence certain activities and also define what parameters need to be passed for each of these activities. I hope you have now understood the major services of Azure databases. So now let's have a look at some of the use cases for Azure database services. First, let's see the use cases for SQL database. So the first one is developer or test environment. An important use case for replicating or migrating data to SQL hosted on Azure is for developer or test environments. Before deploying to the production environment, it is pertinent that the data is tested against developer and test environments. So Azure SQL database can act as a target for such environments. The live production environment can be replicated to the developer or test environment using a database copy. So the second is business continuity. One of the most important use cases for SQL on Azure is using it as a DR target to maintain business continuity. Azure SQL databases can provide an SLA of up to 99.99% by maintaining several copies of the data. This provides business continuity as it allows you to restore geo-redundant copies of the data or use active geo-redundant copies as failover points in use of outages at data centers or in regions. Besides SQL databases, you can also use availability groups to fulfill business continuity demands. Not only can you use availability groups in Azure SQL virtual machines, but also use Azure SQL virtual machine instances as a target for high availability and disaster recovery. And the third one is scaling out read-only workloads. Apart from providing PC or DR capabilities, active geo replication can also be used to offload read-only workloads such as reporting jobs to secondary copies. You can also extend on-premises SQL Server instance using readable always-on replicas. And the fourth one is backup and restore. So Azure SQL database are backed up automatically on a regular basis, and there are no storage costs for up to 200% of the maximum provisioned database storage. You can restore backups to any point in time going back to a pretended period, which is determined by the Azure SQL Service tier in use. On-premises SQL Server databases and transaction logs can also be backed up directly to Azure using the backup to URL feature and stored in Azure storage. So Azure SQL databases can also be stored on local storage by exporting them to backpack files, means backup and restore files. So fifth one is advanced analytics. So another important reason for hosting SQL in Azure is to make use of Azure's advanced analytics platforms such as Azure Storage Blob and Azure Data Lake Store. A common scenario with advanced analytics is when users reference data from various data sources, use Azure Data Lake Store as the staging area, or perform transformation activities using Hive or Spark, and finally load the data into Azure Data Warehouse for BI and reporting. BI means business intelligence. Now let's see the use cases for Cosmos database. First of all, they are used in IoT and telematics. So IoT use cases commonly share some patterns in how they ingest, process, and store data. First, these systems need to ingest bursts of data from device sensors of various locales. Next, these systems process and analyze streaming data to derive real-time insights. The data is then archived to cold storage for batch analytics. Microsoft Azure offers rich services that can be applied for IoT use cases, including Azure Cosmos Database, Azure Event Hubs, Azure Stream Analytics, Azure Notification Hub, Azure Machine Learning, Azure HD Insight, and Power BI. Bursts of data can be ingested by Azure Event Hubs as it offers high throughput data ingestion with low latency. Data ingested that needs to be processed for real-time insight can be funneled to Azure Stream Analytics for real-time analytics. Data can be loaded into Azure Cosmos Database for an ad hoc query. Once the data is loaded into Azure Cosmos Database, the data is ready to be queried. In addition, new data and changes to existing data can be read on changed feed. So change feed is a persistent append-only log that stores changes to Cosmos containers in sequential order. Then all data or just changes to data in Azure Cosmos database can be used as reference data as part of a real-time analytics. In addition, data can further be refined and processed by connecting Azure Cosmos database data to HD Insight for Pig, Hive, or MapReduce jobs. Refined data is then for a sample of IoT solution using Azure Cosmos Database, Event Hubs, and Storm. See the HD Insight Storm examples repository on GitHub. Okay. Then we have is retail and marketing. So Azure Cosmos Database is used extensively in Microsoft's own e-commerce platform that runs the Windows Store and Xbox Live. It is also used in the retail industry for storing catalog data and for event sourcing in order to process pipelines. So catalog data storage scenarios involve storage and querying a set of attributes for entities such as people, places, and products. Some examples of catalog data are user accounts, product catalogs, IoT devices, registries, and bill of material systems. Attributes for this data may vary and can change over time to fit application requirements. Consider an example of a product catalog of an automotive part supplier. Every part may have its own attributes in addition to the common attributes that all parts share. Furthermore, attributes for a specific part can change the following year when a new model is released. Azure Cosmos Database supports flexible schemas and hierarchical data, and thus it is well suited for storing product catalog data. Azure Cosmos Database is often used for event sourcing to power event-driven architectures using its change feed functionality. The change feed provides downstream microservices the ability to reliability and incrementally read inserts and updates made to an Azure Cosmos database. This functionality can be leveraged to provide persistent event store as a message broker for state-changing events and drive order processing workflow between any microservices. In addition, data stored in Azure Cosmos database can be integrated with HD Insight for big data analytics via Apache Spark jobs. So the third one is gaming. The database tier is a crucial component of gaming applications. Modern gaming apps perform graphical processing on mobile or console clients, but rely on the cloud to deliver customized and personalized content like in-game stats, social media integration, and high-score leaderboards. Games often require single millisecond latencies for reads and writes to provide an engaging in-game experience. A game database needs to be fast and be able to handle massive spikes in request rates during new game launches and feature updates. So Azure Cosmos Database is used by games like The Walking Dead, No Man's Land by Next Games, and Halo 5 Guardians. So Azure Cosmos Database provides the number of benefits to game developers. Like Azure Cosmos DB allows performance to be scaled up or down elastically. This allows games to handle updating profiles and stats from dozens or millions of simultaneous gamers by making a single API call. Then Azure Cosmos DB supports millisecond reads and writes to help avoid any lags during the gameplay. Then Azure Cosmos Database automatic indexing allows for filtering against multiple different properties in real time. For example, locating players by the internal player IDs or their game center Facebook, Google IDs, or querying based on player membership in a guild. This is possible without building complex indexing or sharding infrastructure. Social features including in-game that messages player guild membership challenges, completed high score leaderboards, and social graphs are easier to implement with a flexible schema. So Azure Cosmos Database as a managed platform as a service required minimal setup and management work to allow for rapid iteration and reduce time to market. The last one is web and mobile applications. So Azure Cosmos Database is commonly used within mobile and web applications and is well suited for modeling social interactions, iterating with third-party services, and for building rich personalized experiences. The Cosmos Database SDKs can be used to build rich iOS and Android applications using the popular Xamarin framework. So under web applications, first we have the social applications and then we have personalization. So in social applications, a common use for Azure Cosmos Database is store and query user generated content, means UGC. So for web, mobile, and social media applications, some examples of a user generated content are chat sessions, tweets, blogs, posts, rating, and comments. Often the UGC in social media applications is a blend of free form text, properties, text, and relationships that are not bounded by rigid structure. Content such as chats, comments, and posts can be stored in Cosmos DB without requiring transformations or complex object to relational mapping layers. Data properties can be added or modified easily to match requirements as developers iterate over the application's code, thus promoting rapid development. Applications that integrate with third-party social network must respond to changing schemas from these networks as data is automatically indexed by default in Cosmos database. Data is ready to be queried at any time. Hence, these applications have the flexibility to retrieve projections as their respective needs. So the second thing in web and mobile applications is personalization. So nowadays, modern applications comes with complex views and experiences. These are typically dynamic, catering to user preferences or moods and branding needs. Hence, applications need to be able to retrieve personalization settings effectively to render UI elements and experiences quickly. JSON, a format supported by the Cosmos DB, is an effective format to represent UI layout data as it is not only lightweight but also can be easily interpreted by JavaScript. Cosmos DB offers turnable consistency levels that allows fast reads with low latency writes. Hence, storing UI layout data, including personalized settings as JSON documents in Cosmos DB, is an effective means to get this data across the wire. So these were the use cases for Cosmos DB. Now that you have a theoretical understanding of Azure Database Services, let's now see a simple deployment of a database service on Microsoft Azure. Just simply type Microsoft Azure on Google. What you can do is you can create a free account on Microsoft Azure. You get 12 months of free services and around 40,000 rupees of free credits also for using the services. We can just directly open the console from here. I'll just sign in. So for deploying a simple database service, so what we are going to deploy today, we can like deploy Cosmos database, like I've explained to you what is Cosmos database or NoSQL database it is. So we can just go to console, to the portal I mean. You can go to the portal. You can create a resource from here. You can search for Cosmos. Comes like Azure Cosmos, yes. You can see here like free credits. I have a free trial account, so it is showing that I have 14,500 free credits. So this is the like credit amount you get for in a free trial. Okay, so you can create a Azure Cosmos DB from here. Which one you want to create? Like you can create core SQL one. So resource group, you can give a new one, or we have an existing. We have a Cosmos one, resource Cosmos. So if you want to choose the existing one, or if you want to choose the new one, okay. So you can choose the existing one from here. Or if you want to create a new one, then create new one. Source one Cosmos. I hope that works out. Yeah. Then give any unique name for this. Like I will give demo underscore Cosmos 123. Okay, it cannot contain underscore. Remember these things. Okay, it just cannot contain this. So 1, 2, 3, 4. I will. Okay, it's not available. So I will give 5 also. Yeah, it's available now. And like choose your location, whichever location you are located in. You can use nearby location. So mine is Asia Pacific Central India. So I've chosen this. So free trial account is already there. I applied for it. Then you can just review and create. Before getting deployed, it will show you the review for it. So remember that on the basis of the location we have selected, the creation time will differ. Okay. So you can review it, all the information what you have inserted. So now you can create. So deployment is in progress. It will take a few minutes. You can see like how the resource has been created. Deployment is in progress. Will soon be created. You can check details for it from here. Let's go to portal again. Like it is already pinned here, or you can search from here. Okay, for Azure Data Cosmos DB. So you can just click here. So it is showing that it is getting created. This is the one I have created before only. This one is creating. It is still in progress. Let's refresh one again. You can see the processing going on here. Yeah. So your deployment is complete. It's showing. You can go to resource from here also. Or you can just refresh it from here. So yeah, this is how it's been created. You can open the resource from here, and you can go to activity log or data explorer. You can create a database, anything, or you can see the consistency of it, like default consistency and everything. So that's how Cosmos database is being deployed. So I hope you have understood this deployment. Why one needs an Azure SQL database extensively. So Azure SQL Database as the pivot platform for the transition to the cloud, there are at least 5 key reasons driving widespread adoption of the Azure cloud model. So the first one is cost savings. Well, if you see, the most efficient advantage of transitioning to Azure SQL Database is that you no longer need to invest heavily in high-priced on-site hardware. Instead, the costing for Azure Database can be treated as ongoing operating expense. This helps in budgeting as well as cash flow. Also, you don't need to be concerned about replacement, depreciation, and other financial worries surrounding capital assets and expenditures. The second key reason is boosted scalability and performance. So Azure SQL Database is a highly scalable and flexible model by design. Far from on-site hardware, you can rapidly spin up additional instances to harbor traffic spikes, seasonal flows, etc. Microsoft especially designed SQL Azure for cloud applications, giving it a performance edge over other database as a service solutions in many factors. Also, Azure now fully supports both PostgreSQL and MySQL. Hence, if there are pre-existing applications running on MySQL or PostgreSQL and one wants to seamlessly preserve functionality in the cloud, then Azure can fully support the transition. Third is high security. So the Azure SQL Database service, boosted by a network firewall and other safeguards, is widely considered extremely secure for development environments as well as many production environments. Fourth reason is time is on your side. So traditionally, to host a SQL server, you require a lot of resources. For example, you need to buy and set up a physical server with required hardware capacity. Once the server is set up, you need to ensure the required software is installed. Further, you also need to set up networking, handle failovers, capacity planning, etc. So with Azure SQL, you just need to deploy the service and everything is managed by Azure. Hence, you save not only monetary resources but also the time invested in setting up and readying a solution for Azure SQL in a couple of minutes. The fifth and the last reason is business continuity and disaster recovery. For those who would prefer to take incremental steps towards cloud acquisition before moving their entire database to the cloud, Azure has two outstanding tools, ASR and Azure Backup, that supports the Azure cloud to fully protect your on-site execution from downtime and data loss. Now that you know why we need Azure SQL Service, let's briefly understand what it actually is. So Azure SQL is a family of managed, secure, and intelligent products that use the SQL Server database engine in the Azure cloud. So these products are Azure SQL Database, which support modern cloud applications on an intelligent managed database service that includes serverless compute. Second is Azure SQL Managed Instance. You can modernize your existing SQL Server applications at scale with an intelligent fully managed instance as a service with almost 100% feature parity with the SQL Server database engine, best for most migrations to the cloud. Third is SQL Server on Azure Virtual Machine. You can lift and shift your SQL Server workloads with ease and maintain 100% SQL Server compatibility on operating system level access using SQL Server on Azure virtual machines. Azure SQL is built upon the familiar SQL Server engine, so you can migrate applications with ease and continue to use the tools, languages, and resources you are familiar with. Your skills and experience transfers to the cloud, so you can do even more with what you already have. Now that you have understood why we need Azure SQL and what actually it is, let's have a brief understanding of its architecture. So there are 4 layers in Azure SQL architecture. So we'll briefly understand each one of them. First is a client layer. So to be able to access SQL database, the client layer acts as an interface for applications. It includes SQL Server tools, open database connectivity, ADO.NET, and hypertext preprocessor. Tabular data stream transfers data between applications in SQL databases and also communicates with applications. Hence, ADO.NET and ODBC can connect to SQL without any additional demands. So the next layer in the architecture is the service layer, which is in between the platform and the client layers, that acts as a doorway between the two. As you can see in the diagram, provisioning, billing, and routing connections come under this layer. It validates Microsoft Azure SQL database requests and authenticates a user. Also, it establishes a connection between the client and the server and routes packets through this connection. Third is platform layer. So the layer has systems that host the actual Azure SQL Server in the data center. Each SQL database is stored in one of the nodes and is replicated twice across 2 different physical servers. Azure SQL makes sure that multiple copies of servers are kept within the Azure cloud. It also ensures that the copies are synchronized when clients manipulate the data on them. The fourth and the last layer is infrastructure layer. This is the first layer from the bottom of the architecture and is responsible for the administration of the operating system and the physical hardware. So these were the layers in the architecture of Azure SQL. So now let's understand different models and service tiers in Azure SQL. So in this, the first is deployment models. So Azure SQL provides the following deployment options for a database. So the first one is managed instance. This is primarily targeted towards on-premises customers. In case if you already have a SQL Server instance in our on-premises data center and you want to migrate that into Azure with minimum changes to our application and the maximum compatibility, then you will go forward for the managed instance. Second is single database, which represents a fully managed isolated database. You might use the option if you have modern cloud applications and microservices that need a single reliable data source. A single database is similar to a contained database in the SQL Server database engine. The third deployment model is Elastic Pool, which is a collection of single databases with a shared set of resources such as CPU or memory. Single databases can be moved into and out of an Elastic Pool. The next kind of models are purchasing models. So SQL Database offers 3 types of purchasing models. The first one is the vCode based purchasing model, which is new and it offers a totally different approach to sizing your database. It is easier to translate local workloads to a vCode based model because the components are what we are used to. The vCode based model lets you choose the number of vCores, the amount of memory, and the amount and speed of storage. The vCode based purchasing model also allows you to use Azure Hybrid Benefit for SQL Server to gain cost savings. The second one is the DTU based purchasing model, which offers a blend of compute, memory, and input output resources in 3 service tiers to support light to heavy database workloads. Compute sizes within each tier provide a different mix of these resources to which you can add additional storage resources. As you can see from the following diagram, the DTU model offers a pre-configured and predefined amount of compute resources. vCode is all about independent scalability where you can look into a specific area such as the CPU core count and memory resources, something that you cannot control at the same granular level when using the DTU based model. The third purchasing model is the serverless model, which automatically scales compute based on workload demand and bills for the amount of compute used per second. The serverless compute tier also automatically pauses database during inactive periods when only storage is built and automatically resumes databases when activity returns. Now let's see the service tiers for Azure SQL database. So the first one is general purpose or standard model. It is based on a separation of computing and storage service. The architectural model depends on the high availability and reliability of Azure Premium Storage that transparently copies database files and guarantees for zero data loss if underlying infrastructure failure happens. Second is business critical or premium service tier model. It is based on a cluster of database engine processes. Both the SQL database engine process and underlying MDF or LDF files are placed on the same node with locally attached SSD storage, providing low latency to a workload. High availability is implemented using technology similar to SQL Server always on availability group. Third is hyperscale service tier model. It is the newest service tier in the vCore based purchasing model. This tier is a highly scalable storage and computes performance tier that leverages the Azure architecture to scale out the storage Azure SQL database beyond the limits available for the general purpose and business critical service tiers. So now that you have understanding of Azure SQL, let's understand one of its major products, Azure SQL Database. So Azure SQL Database is a fully managed platform as a service database engine that handles most of the database management functions such as upgrading, patching, backups, and monitoring without user involvement. Azure SQL Database is always running on the latest stable version of the SQL Server database engine and patched OS with 99.99% availability. Platform as a service capabilities that are built into the Azure SQL database enable you to focus on the domain specific database administration and optimization activities that are critical for your business. With Azure SQL database, you can create highly available and high performance data storage layer for the applications and solutions in Azure SQL database can be the right choice of modern cloud applications because it enables you to process both relational data and non-relational structures such as graphs, JSON, spatial, and XML. Now let's understand the key features of Azure SQL Database. So first of all, Azure SQL Database has extensive monitoring and alerting capabilities. So Azure SQL Database provides advanced monitoring and troubleshooting features that help you get deeper insights into workload characteristics. These features and tools include the built-in monitoring capabilities provided by the latest version of the SQL database engine. They enable you to find real-time performance insights, and the second one is platform as a service monitoring capabilities provided by the Azure that enable you to monitor and troubleshoot a large number of database instances. Second feature is availability capabilities. So Azure SQL Database enables your business to continue operating during disruptions. In a traditional SQL Server environment, you generally have at least two machines locally set up. These machines have exact synchronously maintained copies of the data to protect against a failure of a single machine or component. This environment provides high availability, but it doesn't protect against a natural disaster destroying your data center. Third is built-in intelligence. So with Azure SQL Database, you get built-in intelligence that helps you dramatically reduce the cost of running and managing databases, and that maximizes both performance and security of your application. Running millions of customer workloads around the clock, SQL Database collects and processes a massive amount of telemetry data while also fully respecting customer privacy. Various algorithms continuously evaluate the telemetry data so that the service can learn and adapt with your application. The fourth feature is advanced security and compliance. So SQL Database provides a range of built-in security and compliance features to help your application meet various security and compliance requirements, which are advanced threat protection and like auditing for compliance and security, data encryption, as well as data discovery and classification, and also Azure Active Directory integration and multi-factor authentication. The fifth feature is easy to use tools. So SQL Database makes building and maintaining applications easier and more productive. SQL Database allows you to focus on what you do best, building great apps. You can manage and develop an SQL database by using tools and skills you already have. SQL Database supports building applications with Python, Java, Node.js, PHP, Ruby, and .NET on Mac OS, Linux, and Windows as well. So SQL Database supports the same connection libraries as SQL Server. Now let's understand the server in Azure SQL Database. So in Azure SQL Database, a server is a logical construct that acts as a central administrative point for a collection of databases. At the server level, you can administer logins, firewall rules, auditing rules, threat detection policies, and auto failover groups. A server can be in a different region than its resource group. A server must exist before you can create a database in Azure SQL Database or a data warehouse database in Azure Synapse Analytics. All databases managed by a single server are created within the same region as the server. Remember that Azure SQL Database Server is distinct from the SQL Server instance, or we can say which is like the SQL Server virtual machine, which we will discuss later in this video. Now the next thing we have to understand is single database in Azure SQL. So the single database resource type creates a database in Azure SQL Database with its own set of resources and is managed via a server, which we have talked about recently. Okay. So with a single database, each database is isolated and portable. Each has its own service tier with the DTU-based purchasing model or vCore-based purchasing model and a guaranteed compute size. So some of its features are dynamic scalability. So you can build your first app on a small single database at low cost in the serverless compute tier or a small compute size in the provisioned compute tier. You change the compute service tier manually or programmatically at any time to meet the needs of your solution. So second is monitoring and alerting. You use the built-in performance monitoring and alerting tools combined with the performance ratings. Using these tools, you can quickly assess the impact of scaling up or down based on your current or project performance needs. Additionally, SQL database can emit metrics and resource logs for easier monitoring. The third is security. SQL database provides a range of built-in security and compliance features to help your application meet various security and compliance requirements. So Azure SQL database has been certified against a number of compliance standards as well. Now the next is Azure SQL Database Elastic Pool. So Elastic Pool helps you manage and scale multiple databases in Azure SQL database. So Azure SQL Database Elastic Pools are simple, cost-effective solution for managing and scaling multiple databases that have varying and unpredictable usage demands. The databases in an Elastic Pool are on a single server and share a set number of resources at a set price. Elastic Pools and Azure SQL Database enables software as a service developers to optimize the price performance for a group of databases within a prescribed budget while delivering performance elasticity for each database. So software service developers build applications on top of large-scale data tiers consisting of multiple databases. A common application pattern is to provision a single database for each customer, but different customers often have varying and unpredictable usage patterns, and it's difficult to predict the resources requirement of each individual database user. Traditionally, you had two options: over-provision resources based on peak usage and overpay, or under-provision to save cost at the expense of performance and customer satisfaction during peaks. So Elastic Pool solves this problem by ensuring that databases get the performance resources they need when they need it. They provide a simple resource allocation mechanism within a predictable budget. So now we need to understand when we should go for an Elastic Pool. So pools are well suited for a large number of databases with specific utilization patterns. For a given database, this pattern is characterized by low average utilization with relatively infrequent utilization spikes. Conversely, multiple databases with persistent medium high utilization should not be placed in the same elastic pool. The more databases you can add to a pool, the greater your savings become. Depending on your application utilization pattern, it's possible to see savings with a few S2, S3 databases. So we will be assessing database utilization patterns. So in this figure, you can see this is an example of a database that spends much time idle, but also periodically spikes with activity. This is a utilization pattern that is suited for a pool. So this chart illustrates DTU usage over a 1 hour time period from 12 to 1, where each data point has 1 minute granularity. At 12:10, you can see DB1 means database 1 peaks up to 90 DTUs, but its overall range usage is less than 5 DTUs. An S3 compute size is required to run this workload in a single database, but this leaves most of the resources unused during the period of low activity. So a pool allows these unused DTUs to be shared across multiple databases and so reduces the DTUs needed and overall cost. So building on the previous example, suppose there are additional databases with similar utilization patterns as DB1. In these two figures, the utilization of 20 databases are layered on to illustrate the non-overlapping nature of their utilization over time using the DTU-based purchasing model. The aggregate DTU utilization across all 20 databases is illustrated by the black line in the preceding figure. This allows that the aggregate DTU utilization never exceeds 100 DTUs and indicates that the 20 databases can share 100 eDTUs over this time period. This results in a 20 times reduction in DTUs and a 13 times price reduction compared to placing each of the databases in S3 compute sizes for single databases. So this was the concept of Elastic Pool. So overall, now we have a conceptual understanding of Azure SQL database. So let's practically try our hands on it. So you can directly go to Microsoft Azure Portal. This is the portal. So first, let's create the database, SQL database. Go to create. You can create the resource group first. Like you can see, there's no resource group. So you can create a resource group. Give it as Azure SQL demo. So you can give the database name, like you can give SQL database, and you can like select a server. So for that you can create a server, like I have explained you now, SQL server, how we need an SQL server for SQL database. So that's what we are creating here. You can give a server name and give SQL, and then enter server admin login. So you can give a admin login as well. So Azure admin, then password. Okay. So password, and then we have to confirm password. The rate. Just a second. At the rate 453. Stay. So I will then choose my location. So that will be Asia Pacific, Central India. Now, if you want to go for Elastic Pool, you can choose that, or if you want to go for a single database only, you can choose it no. So you can create an Elastic Pool from here if you want to go for an Elastic Pool. So you can like create new. So yeah, being created. Now you can configure the Elastic Pool. So here you can see like so you can see here the different purchasing models as well as the service tiers in it. So you can see like VCO based purchasing model, DTU based purchasing model, and it has like general purpose and business critical service tiers, and like DTU has the basic, standard, and premium one. So you can go for general purpose, or we can go with basic one as well. So that will be enough. 50 DTUs is enough. 4.88 GB is enough. So yeah, we can apply for it. In this manner we can do, or we can. This is how you can configure a Elastic Pool. And if you want to go with a single database, you can just create no. So right now I have chosen. So let's go with Elastic Pool, and yeah, that's it. So rest everything is okay. You can just go to review and create, and you can like create it. So it's validating right now. It takes a little time. So you can check in the resource group as well and go for resource groups. Here, remember we have created a resource group. Remove this part. Cut. That will get validated first. Now that you have a theoretical understanding of Azure SQL database, let's try our hands on Azure Portal for deploying the Azure SQL database, and let's see how it works. So you can directly go to Azure Portal, then you can go to SQL database and create the SQL database. Create a resource group. You create a new one. So, the resource is created. Now I will give the database name. Now we have to create a server. So we create a new server. Okay, so server name I have given. Then I have to give a admin login. So I will just give Azure database admin, Azure DB admin, give a password. It's done. Then you have to select the region. So my region is Asia Pacific, Central India. Now a server will be created. So now if you want to use a Elastic Pool, you can use it. If you go over a single database, you can go for no, and you can like configure it from here, like how many cores you want, what's the storage you want. So everything is given here. So you can like select the model whichever you want to choose. So I can choose like the basic one. I can go with this one only. So I will just apply it from here. Or if I want to go with Elastic Pool, so I can create an Elastic Pool here. So I will just give maybe. So it's been created. Now I can configure it from here in a similar manner. Like B-Core based purchasing model is given, DTU based purchase modeling is given, service tiers are given. So for this one also I can go for basic. That will be enough. So you can see the price here. It's costing. You just apply, and it's been done. Everything is okay. Then I can just review and create. I can review the price again, and I can now just create. So the deployment is in progress. It takes 1 or 2 minutes max. So I can go to resource group from here, the resource which I have created. Deployment is still in progress. So here you can see the resource, which we are given the name it as Azure Resource SQL, right? Azure SQL Resource. It is here. Right now nothing has been created in this resource because the deployment is still in progress. Let's wait for it a while. Yeah. So completed now, right? Let's check it. Yeah. So the server is being created. So server is being created. Now we can just open the server, and here first we have to change the firewall settings. So we can just go to show firewall settings. So here it is given while we have to end at the client IP, and there it is given like on 158. So we can give it from 0 to 255 complete. We will give, and we will just save it. And we can go to the overview, and if you go back to the resource, it is you can see like if you refresh till now the deployment might have been completed, and you can see the database as well. Like it is showing here, your deployment is complete. So yeah, come back to here. So you can see in like, yeah, so database is being created, elastic pool is also being created. So you can just go to database, and firewall we have already set. Like this, you can see on the left side pretty cool features given here. So in compute and storage, if you come, you can again reconfigure your elastic pool settings, whatever storage you want to select and service tiers you want to select, you can select. Okay. Then there are also connection strings, which is a pretty cool feature. As you can see here, it is ADO.NET is given here, and if you're working on Java, then JDBC is also there, ODBC, PHP, Go, everything is here. Then there are replicas as well. Similarly, a lot of things are there. You can use them as per your need. Power BI, Power Apps, everything is given. So next thing we have to do is have to connect it to the management SQL server. So if you don't have a management SQL server, you can just download it from here. Just go to management SQL server. SQL Server Management Studio is there. So you can just click here and download it. But I already have downloaded it with myself. All I have to do is go to the studio. So yeah. So here it is. Just open it, and we can copy the server name from here. Copy to clipboard. So we have to add the client IP in Firewall, right? So we'll just add the client IP, and it is showing 158. So we will just give it from 0 to 255. So we will just save it from here. So yeah, then we can just go to the resource again, and we can see like database has been created as DB. You can see, so we can now directly go to database. You can see here as well, like you can see like it's showing like your deployment is complete. So database has been deployed, and now you can see like there are pretty cool features given on the left side of it. You can go to compute and storage. So here you can like again change your service tiers and purchasing models and everything if you want to change. So if you can go to connection strings as well. So it's a pretty cool feature. You can see like ADO.NET is already here, and if you are working on Java, so JDBC is also here, and then ODBC, PHP, Go, everything is there. Okay, so similarly, like pretty cool features given as per your need. You can use those features for security purpose or for, you can say, visualization purpose. Power BI and everything is given here. You can use all of them. So we will connect it with Management SQL Server Studio. So if you don't have it, you can just go to Google Management SQL Server. You can get SQL Server Management Studio. Come here, click here, and just a second. It's loaded. Yeah, it's loaded. So you can just come here and download it from here. Now what we have to do is, because I already have downloaded it with myself, so I will just open it. Just a second. So here server name is required, so we can just copy the server name. We have it here, server name. You can see all the information is given here, elastic pool, connection strings, and everything is given here. So right now I request server name. I have copied it. I will just paste it here. Here SQL Server authentication will only remain here. Okay. Login is Azure. Remember, we have given login and password. You have to remember these ID and password which I have created for SQL Server, if you remember, right? So don't forget them. So login is Azure SQL. Login is Azure DB admin password. So we will just connect it from here. So we have it here. Now you can go to new query, and you can write the query here itself. Table person where variable character Wi-Fi check person. Yes, done. And you can now insert the values into the table. So it will be like person's age we can give. Done. Then values that I can give any name, like give the name is given, and then I will give the age. So yeah, first name, last name, and age. Right. So it's been done. Value has been inserted. So after this, you can like select it. So select here, select from persons. Done. Okay. So yeah, so you can now execute the query. Line 8, eighth line. There's a mistake, right? In persons. Okay, just a second. If I execute now, yeah. So you can see it has been executed. You can say the table has been created, and with first name, last name, and age. Now you can even see that in tables. You can see. Just a second. Yeah. So DB of persons has been created. Okay. The table is created, and similarly you can do it for Azure Data Studio as well. You can download it Azure Data Studio. I already have it. So you can start a new connection from here. You have to give the server name. So you can go back to here. You can copy the server name from here, paste it here. You can select the SQL login. Then username and password you have to give. So the same Azure DB admin and the password which we have created for the SQL server. Remember, same thing. Okay. The database I have to select. It's loading, just a second. Yeah. So my database name was SQL DB, right? Yeah. So I will just name it SQL DB1 server group. If there is any, no. So I will just connect. So we can come to persons, which we have already created. It's been connected from within. So we can just go to persons. You can see, you'll be able to see the query for it. Go for edit data. So yeah, you can see the table here. It's been given. Okay, the Aman, Sahu, and 26. This is what our code was, right? So it's directly connected here. I hope you have understood this. So this was all about Azure SQL database. So yeah, now let's move forward. So next we are going to talk about the second major product of Azure SQL family, that is Azure SQL Managed Instance. First, let's understand what is the Azure SQL Managed Instance. So Azure SQL Managed Instance is the intelligent, scalable cloud database service that combines the broadest SQL Server database engine compatibility with all the benefits of a fully managed and evergreen platform as a service. Then SQL Managed Instance has like near 100% compatibility with the latest SQL Server. So database engine providing a native virtual network implementation and addresses common security concerns as well, and a business model favorable for existing SQL Server customers. SQL Managed Instance allowing existing SQL Server customers to lift and shift their on-premises applications to the cloud with minimal application and database changes. At the same time, SQL Managed Instance preserves all platform as a service capabilities, automatic patching and version updates, automated backups, high availability, etc. So all this drastically reduce management overhead and TCO as well. Now let's understand why the Azure SQL Managed Instance is required. So Azure SQL Managed Instance, for that we need to understand the difference between Azure SQL Database, which is platform as a service, and Azure SQL Managed Instance. So if you know about there's one more service, an Azure SQL family, that is the SQL Server on Azure Virtual Machine. So when we create a virtual machine instance and we install the SQL Server on it, so it has like a lot of features. There's a feature difference between the managed instance and Azure SQL database when we talk about, which is on-premise server. So what is the feature difference? Feature difference can be, I will give you one of the example. Like there is a SQL Server agent on when you install SQL Server on virtual machine. So there is this SQL Server agent which helps in executing your jobs. But the same feature is not there in Azure SQL database. So there are other features except SQL Server agent that are like link server and SQL Server auditing, SQL data synchronization, DB mail, which are supported by SQL managed instance but not by the Azure SQL database. So that's where SQL managed instance is required. So if someone is migrating data from Azure SQL Server, like from the virtual machine, to platform as a service Azure SQL database, remember this, like keep this in mind that Azure SQL database is a platform as a service, and whereas Microsoft SQL Server, which we are talking about, the on-premises server, that is infrastructure as a service. So if we are moving from infrastructure as a service to platform as a service, so first of all, what we need is we want all the features of SQL Server. Whatever was there on SQL Server, we want that on Azure SQL database. If a user wants to move all the data. And second thing is like from migrate, if you are like migrating to Azure, then there should be like less maintenance overhead. So with less maintenance overhead, what it means is if someone is moving from SQL Server to Azure SQL database, they don't want to again create a virtual machine and install SQL Server. They want the less maintenance overhead, which means like they don't want to go for extra steps. It should be minimized. There should be less amount of steps to get it executed. So that's where the Azure SQL managed instance comes into play. It has some cool features, like it has 100% compatibility with the latest SQL Server Enterprise Edition. So whenever you are using it, you will get the availability of the latest SQL Server, whatever the latest edition is. Other than that, it has a backup and high availability as well. So with virtual network, we can say like VNet implementation. What it means is it addresses like common security concerns and grants network administrations and full control over access and configuration using like firewalls and security groups. So which on the security basis, what it does is it keeps it isolated. Whatever you're making through managed instance, it will create a virtual network. In that, the SQL will be installed, and the apps that are in your private network can access your managed instance only. So, by a security point of view, it is very secure because it is isolated. And Azure SQL Database, which is a public service, can be like accessed in multiple manners. Whereas through managed instance, it is isolated. So that's where Azure SQL managed instance play a great role. That is in migration, especially. So the next thing is key features of Azure SQL Managed Instance. So if you see like Managed Instance for SQL database provide like several features that makes a deployment option stand out from single or elastic pool deployment. These features include like link servers that enable you to operate a distributed database. means it enables you to read data from remote sources and execute commands for those sources from your database instance. For example, you can use this feature to execute TSQL statements that include tables from an outside SQL server or database. This feature enables you to configure many API data sources as link servers, including Azure Cosmos DB, Microsoft Access, and Excel. Additionally, you can use the link servers to implement sharding without direct loading or the use of custom application code. Second thing is service brokers that provide native support of messaging and queuing. So this is a feature that provides like native support for asynchronous messaging and queuing. So you can use it to build distributed applications and enable communication between separate databases. So when you use Service Broker, you can easily distribute workloads across databases. For example, separating quick versus process-intensive tasks on front-end versus back-end servers. This feature manages the communication path for you, enabling you to focus on development and testing without sacrificing data consistency. Third is database mail. So there's a kind of feature that enables you to send email messages from your Azure SQL managed instance. So with this, you can send query results. Also, you can like notify users of completed processes and attach files from any other in-network resources. So now let's see the similarities between the Azure SQL database and Azure SQL managed instance. So if you look in the management, so like both SQL database and SQL managed instance preserves all platform as service capabilities that drastically reduce management overhead and total cost of ownership, that is TCO. And if you look into the backup, so both supports like automatic backup, full backups are like taken every 7 days, differential 12 hours, and like log backups every 5 to 10 minutes. So backup retention is like 7 days default and maximum 35 days. And third is availability. So Azure SQL database is like 99.99 to 99.995% availability is guaranteed for every database, whereas in same thing in Azure SQL managed instance. Here also like 99.99% availability is guaranteed for every database and can't be like managed by user. Then there is host accessibility. So there's like no direct control over underlying compute server. Both are like fully managed SQL Server database engine. Based on the latest stable enterprise edition of SQL Server, both are like deployed on standardized hardware and software that is owned, hosted, and like maintained by Microsoft. Lastly, there's one more similarity, that is license. So both have like built-in license model with pay as you go. Now let's look at the key differences like between the Azure SQL database and Azure SQL managed instance. If we talk about recovery model, so Azure SQL database has a recovery model from automated backups only, whereas in managed instance, it has like from automated backups and from full backups placed on Azure Blob Storage. Then second is active geo replication. So in this, the SQL database is like supported in all service tiers other than hyperscale. And then there is SQL managed instance. It is not supported. Alternative solution is like auto failover groups. Then the next one is auto scale. So SQL database is like only supported in serverless model, whereas in managed instance it's not supported. You need to choose the reserve compute and storage. Now the next one, which is automatic tuning. So which is actually supported in SQL database but not in SQL managed instance. And next is elastic jobs, which are like supported in SQL database but not supported in SQL managed instance. But in place of that, SQL agent can be used. Okay. So next is long-term backup retention, which is supported in SQL database and it keeps automatically taken backups up to like 10 years. And in managed instance, it's not supported yet, but like manual backups can temporarily work. Then there's hyperscale architecture, which is supported in SQL database but not in managed instance. Then there is SQL Server Profiler, which is not supported in SQL database but supported in managed instance. Then cross database transactions, which are not supported in SQL database but supported in managed instance. And lastly, the database mail, which is not supported in SQL database but supported in SQL managed instance. So with this, we come to the end of second major product, that is managed instance. This was all the theoretical concept of managed instance. Now let's try our hands on it by deploying it on Azure Portal as well as connecting through it. Let's directly go to the Azure Portal. So here we go to source groups. We created this one, right? This was our source group. So here we can like create a new one. So we'll create. From here we will create a virtual machine first. Virtual network, I mean to say. So virtual network we will create as we have been through the explanation. I hope you remember this explanation, right? When I was talking about why we need a managed instance. That's where I talked about virtual network as well. So here, create this network. So source group, Azure, same name I have to give. So I'll give it as so accept it and everything is done. Reviewing create it. So yeah, it's being created now. Deployment is in progress. It won't take much time. So deployment is successful. It's been done. Now we can again go back to our resource, that is Azure SQL resource. Here you can see I will refresh it again. You can just directly go to resource from here. So virtual network has been created. Just a second. So here it has been created, group.mi. And now the next thing is we are going to make the managed instance. So let's create the managed instance. Azure SQL managed instance. So let's create it. So resource group is selected. Managed instance name you can give. So I will just give. So virtual network I have named with the same. Okay, so I will just give it, instead of dot I have given just group mi, and we can configure it from here. Okay, first I will select the region, that is Central India. Then I will configure managed instance. So yeah, generation 5 I think general purpose is given. So I will give much lower than that. Just rate it for 64. So during everything is okay. Apply. So I will just create a password. So Azure manage instance admin right there. So then password be 16 characters. Remember that. Okay. So review and create. So the deployment is in progress. Yeah. So remember this. It takes like at least 2 to 3 hours to get deployed. So we ain't gonna wait for it. Keep that in mind that it takes 2 to 3 hours. So this was all about the deployment of Azure SQL Managed Instance. So let's move ahead to have a brief understanding of third major product in Azure SQL family, and that is SQL Server on Azure Virtual Machine. So SQL Server on Azure Virtual Machines enables you to use full versions of SQL Server in the cloud without paying to manage any on-premises hardware. SQL Server virtual machines also simplify licensing costs when you pay as you go. Azure Virtual Machines run in many different geographic regions around the world. They also offer a variety of machine sizes. The virtual machine image gallery allows you to create a SQL Server virtual machine with the right version, edition, and operating system. This makes virtual machines a good option for many different SQL Server workloads. So now the question arises when to use SQL Server on Azure Virtual Machine. So as you have read earlier, like SQL Server on Azure Virtual Machine is useful when you want to migrate your existing databases to Azure Cloud without doing much work. Secondly, another reason to select SQL Server on Azure Virtual Machine is when you want to use your existing SQL Server licenses and want to keep control of your database and virtual machine. The third factor can be the cost. So cost can be the major reason if you have high available systems with high traffic. So SQL Server on Azure Virtual Machine can save you significant compared to other options. Azure reservations can save up to 70% of your cost on SQL Server. So now let's look at the key features of using SQL Server on Azure Virtual Machine. The first is automated updates. So SQL Server on Azure Virtual Machines can use automated patching to schedule a maintenance window for installing important windows and like SQL Server updates automatically. Second thing is automated backups. So SQL Server on Azure Virtual Machines can take advantage of automated backup, which regularly creates backups of your database to blob storage. You can also manually use this technique. Azure also offers an enterprise class backup solution for SQL Server running in Azure Virtual Machines. A fully managed backup solution, it supports always on availability groups, long-term retention, point-in-time recovery, and central management, and also monitoring. So third feature is high availability. So if you require high availability, consider configuring SQL Server availability groups. This involves multiple instances of SQL Server on Azure virtual machines in a virtual network. You can configure your high availability solution manually, or you can use templates in the Azure portal for automatic configuration. The fourth key feature is performance. So Azure virtual machines offer different machine sizes to meet various workload demands. SQL Server Virtual Machines also provides automated storage configuration, which is optimized for your performance requirements. So now that you have a theoretical understanding of SQL Server on Azure Virtual Machine, let's see how it works practically. So you can directly go to Azure Portal, and then you can go to resource group, and you can like create a resource group. Say the new resource group is Azure Server, and you can select your region as well. So mine is Central India. After that, you can just review and create. So the resource is created. Then you can go to your resource and you can go to create. Just search for SQL Server 2019 for on Windows on Windows on Windows Server 2009. Okay. So we are going to select this one only. But in this, there are sub options where you can select for the free one. I am going to select free SQL Server license SQL 2019 developer on Windows Server 2019. Then there are different plans and like usage information to support everything is there. Let it be at default only and just create it. Now you have to create the virtual machine. You can give the name for it. So I will give it as SQL VM1. And the region I have to select. So I will select my region. That is Central India. Then let it be at default everything. PSQL no infrastructure required. Image is okay. I have to select the size. So there are different sizes you can select. So like you can select the sizes from here. And sizes are given. But I'm already going with a standard one, so that will be enough for me. So I will just select this one and I will give the username. So that will be Azure Admin Server, and then give your password. And don't forget these username and password. We will require this while connecting to the SSMS. So the password is, these passwords are meshed, public inbound ports. So select this, and RDP is selected already. So we will just go to the next one, that is disks. And in this we are going to select the standard SSD, which is better than HDD as it's faster. Then we go to networking. So our virtual network is this only, so everything will remain default. So all the options remain default in this. And then management, also the options will remain default, so is in advanced. Then you can just go to SQL Server settings directly. And here, so now in SQL Server settings, you can like see the SQL connectivity and port and everything. Then you can come to authentication and you can enable this. So that will remain the login and ID password which you have given now, because we are going to use this for connecting it with SSMS. So Azure Key Vault integration, everything is okay. This is okay. So you can just go to review and create finally, and you can just create it from here. So this deployment will gonna take like 20-25 minutes. So we ain't gonna wait here for that. You can download the deployment details from here. Like this you can download and you can go and see the deployment details. So what I did is I already created a virtual machine before only. Just for the demo purpose, I will show you. So I had a different resource for that. So when it get created, the VM1 I created. So this was SQL VM1, and these 9 records are being created. So you can just go to SQL VM1. So this virtual machine is actually stopped right now, so I will just start it. But when you create the virtual machine, it will automatically be in the on position, okay? Because this one I have stopped, so I have started it. It's getting started. So virtual machine, you can see like it's started. Now you can see the public IP address and everything like here itself. So we'll just give a refresh. So now just go back to the resource and you can see all the resources here. So here we have IP address and everything, and you can see the size as well, which is a standard DS1 V2 one virtual CPUs and 3.5 GB memory. So now we will connect through this IP through the database engine. Later on we will use this IP. So right now we can just go to, and connect through RDP, and this is okay. This is okay. You can just download the RDP file as well. So the RDP file is downloaded. You can just open it from here and connect and put the username and password which you have assigned for it. So I will assign Azure Server Admin and my password as well. Yes. So now I will just connect. Yes. So as you see, like this server is launched. So we can just go and launch the SSMS, means Microsoft SQL Server Management. So it takes a little time when you launch it for the first time, the SSMS. So now you can give the server name here, and authentication you can give Windows authentication, or you can give SQL Server authentication for connecting it to the SQL Server. So right now I'm giving Windows authentication. I will just connect. So now you see it got connected. This is the version, and these are the databases, the system databases, and you can also see for the security which we have chosen, which for logins, like you can see for SQL Server, like this is SQL VM1, and for login thing you can see it as Azure Server Admin. So we will just check the version. So take a new query. We will give it as select @ version, and you can just execute it. It is showing the version of Microsoft SQL Server 2017. So after this, you can come back to your resource. So now you can go to the resource group. So here you can see total 9 records are being created when you create the virtual machine. You can see like they are virtual network, virtual machine, SQL virtual machine, then public IP address, network security group, network interface, and 3 disks. So you can go to the virtual network, which is being connected through subnet, and you can see like there's a default subnet and the available IPs are 250. Now you can go back again to the resource. Now we can go to network security group, that is SQL VM NSG. In this you can see you can connect through RDP through port 3389, and for connecting through SQL you can use the port 1433 with your local system. Now let's come back. You can see you have the source group, Azure SQL resource which I have already made, and the Azure server resource which we have created. So let's see now. We have left this one, okay, for deployment. So this deployment is completed, as you can see. So let's come back, as I've already explained you all the process. And suppose if you don't want to continuously use your server, you can even stop your server. So what you can do is you can go to your resource and you can go to your virtual machine. So that just in the case you don't want your bill to be high and you want to put a limitation or you want to control your billing, so you can just stop the virtual machine whenever you are not using it. So you can just click on stop. As you can see, stop virtual machine is stopping. Processing is going on. We will also stop this one as well. So we can just go to the source code. So it's better because otherwise it will keep on billing and it may like cost a lot. So I will just stop this one as well. Go to VM1 and stop it. So let's check the last one. So this one we can see like this one is stopped already. Successfully stopped virtual machine. So you can see the virtual machine is stopped. That's the process. So I hope you have understood the process of SQL Server on Azure Virtual Machine. Now let's look at some of the use cases for Azure Virtual Machine. So the first one is developer or test environment. It's like an important use case for replicating or migrating data to SQL hosted on Azure, which is for developer and test environments. So before deploying to the production environment, it is pertinent that the data is tested against developer test environments. Azure SQL databases can like act as a target for just such environments. The live production environment can be replicated to the developer or test environment using a database copy. Second is business continuity. So one of the most important use cases for SQL on Azure is using it as a DR target to maintain business continuity. Azure SQL databases can provide an SLA of up to 99.99% by maintaining several copies of the data. This provides business continuity as it allows you to restore geo-redundant copies of the data or use active geo-redundant copies as failover points in case of outages at data centers or in regions. Besides Azure SQL database, you can also use availability groups to fulfill business continuity demands. Not only you can use availability groups in Azure SQL virtual machines, but also use Azure SQL virtual machine instances as a target for high availability and disaster recovery. Third is scaling out read-only workloads. So apart from providing BC or DR capabilities, active geo-replication can also be used to offload read-only workloads such as reporting jobs to secondary copies. You can also like extend on-premises SQL Server instances using readable always-on replicas. Fourth is backup and restore. So Azure SQL databases backed up automatically on a regular basis, and there are no storage costs for up to 200% of the maximum provision database storage. You can like restore backups to any point in time going back to the retention period, which is determined by the Azure SQL service tier in use. On-premise SQL Server databases and transaction logs can also be backed up directly to Azure using the backup to URL feature and stored in Azure storage. So Azure SQL databases can also be stored on local storage by exporting them to backpack files. Fifth is advanced analytics. So another important reason for hosting SQL in Azure is to make use of Azure's advanced analytics platform, such as Azure Storage Blob and Azure Data Lake Store. Common scenario with advanced analytics is when users reference data from various data sources. So you can use Azure Data Lake Store as the staging area, and you can like also perform transformation activities using Hive or Spark, and finally load the data into Azure Data Warehouse for BI and reporting. BI means business intelligence and reporting.
So why do we need Azure Data Factory? Well, first and foremost, we need to understand the fact that the amount of data that is being generated these days is huge. And this data comes from different sources. Now, when we move this particular data to cloud, there are quite a few things that needs to be taken care of. Now, this data, it can come in any form because we are talking about different sources. And these different sources would transfer or channelize this data in different ways. And it can be in different formats. So when you do decide to bring this data on cloud or at a particular storage place, you need to make sure that this data is well and truly managed. Now, what do I mean by this? Well, you need to transform this data. You need to delete unnecessary part or get rid of all the things that is not needed. Now, that is an after part or pre-processing part. But as far as moving this data is concerned, you need to make sure that you pick this data from different sources and bring it at one common place, then store it. And if required, you should be able to transform it into something more meaningful. Now, this is something that can be done by using traditional data warehouse as well, but then there are certain disadvantages. What happens is at times you are forced to go ahead and have custom applications that deal with all these processes individually. And this can be time consuming, and integrating all these sources can be a huge pain. Now, how do we solve this problem? Well, if there was a way to automate this process or create proper workflows, this burden would have been taken care of. Now, this is where Data Factory steps in. What it does is it kind of helps you automate this complete process. Instead of saying automate, I would say it helps you orchestrate this process into a more manageable or organizable manner. Now, that is something that is needed, and that is why we need something called as Data Factory, which lets you automate all these processes. What is Azure Data Factory? So if I just go ahead and talk about its definition, I would say it is nothing but a cloud-based integration service which lets you do quite a few operations like create data-driven workflows basically, and to go ahead and orchestrate all the sources that are there. But what exactly does it do? To name few common operations, what it does is it helps you create pipelines, which are nothing but, you can think of it as a logical pipeline which supports various processes that happen. It lets you ingest data from different sources and then process it. When we are talking about processing it, it also helps you go ahead and do analytics, which is very important these days because we know that the amount of data that is being generated, it can be helpful and it can help you take various good business decisions. And this is where analytics comes into picture. Now, what Data Factory does is it lets you transform this data and make it ready for something like Data Lake to use it. Now, Data Lake is something that lets you use various analytical tools or methods. Like you have something called as Azure SD Insight, maybe a Hadoop Spark, Azure Data Lake Analytics, and all these things. Now, as we move further, I would be talking about these terms to some extent, but till then you'll have to wait. For now, just understand one thing, that these are nothing but platforms or tools which basically let you go ahead and do various analytical operations. So that is what Data Factory lets you do. It lets you get in all the data, arrange it in a particular manner or order, and then supply it further for various processing or various other things that can be done with that data. So if you talk about particular steps, what does it do exactly? Well, first and foremost, what it does is it helps you collect and connect data. Now, when I say connect, I'm talking about connecting to various sources from which the data can come. Now, there are quite a few disparate sources from which the data can come. You can connect to all these resources by using your Data Factory. And then once you have this data, you can collect it and store it at a central place. Say, for example, your data warehouse. Then comes the process of transforming and enriching it. Now, when I say transforming it, I mean running various patterns on it, creating schemas and all those things. You can then actually go ahead and publish this data. Now, we all know that Microsoft Azure supports various other tools as well. We have one more popular data visualization tool called as Power BI, which is very good when you talk about data integration and various data visualization capabilities. What you can do is you can connect Power BI to your Microsoft Azure and publish this data, that is create various dashboards and all those things. Now, that can be very insightful when you talk about it from business intelligence perspective. So yes, you can go ahead and do that as well. And then you can actually go ahead and monitor your data. That means you can take a look at all the data that you have and you can actually go ahead and analyze it in real time as well. So these are the processes which we are talking about. That is connect and collect your data, transform and enrich it, publish it, and monitor it. Now that is what a Data Factory lets you do. Various concepts that surround this particular term. We have quite a few terms to discuss, like we have pipelines, data sets, activities, and linked services. Let us try to understand these one by one. First, we would be talking about pipeline. Now, pipeline is nothing but think of it as a proper pipeline. That is, it is something which acts as a carrier in which we have various processes taking place. Now, this individual process is nothing but an activity. If you take a look at this slide, you'd understand that activities represent processing step in a pipeline. That means your pipeline can have one or multiple activities. Now, when you talk about this activity, it can be anything. It can be a single process like querying a particular data set, or it can be something like moving data from one source to the other. Then you have something called as data sets. Now, data sets are nothing but sources of data. Say, for example, my data is stored at an N location, and that N location is nothing but my data set. So in simple words, it is nothing but a data structure that holds my data. Linked services. Now, this is nothing but a law. Say for example, I need to move my data from a particular database to a blob storage. There need to be something that connects these two things. That is a law or some information that lets a database understand that it has to move the data to a particular data source. So that is what a linked service is. It is nothing but an information that tells your data factory that is you need to connect to these particular sources. So these are some of the concepts that form a central part when you talk about a data factory. Difference between data lake and data warehouse. Now, why did I bring this topic up? Well, data warehouse is something that is a traditional approach towards storing data and it is still used widely. But then why do we need data lake and why am I comparing these two terms? Well, quite a few people confuse these two terms as in what is the difference between them exactly. Well, they're quite similar to each other, but there are slight differences which are important and I felt that we should have gone ahead and discussed those. That is why I put this slide here. So let's try to understand that as well. Well, this is a clear differentiation between these two things. That is, first of all, you need to understand that your data lake is nothing but something that is complementary to data warehouse. That means if you have your data at a data lake, that can be stored at data warehouse as well. But there are certain rules that need to be followed. Now, when you talk about your data warehouse, what happens is you can use again your data lake to bring in data. But the main difference is when you talk about a data lake, the data is detailed data or a raw data. That means it can be in any particular form. You just need to take the data and dump it into your data lake. That is not the case with your data warehouse. Here the data is filtered, summarized, refined. Now you might wonder that, okay, if everything is happening here at your data warehouse, isn't it better? In some situations, yes, definitely it is better. But as I've already mentioned so many times in this video, the amount of data that is generated these days is huge and it can come from any particular source. This might not be the best of options to deal with. Why? Well, your data lake has something called as schema on read and your data warehouse has a schema on write kind of an approach. What this does is, if I talk about it from a data warehouse perspective where you have schema on write, that means when you're writing your data to your data warehouse, it is written in a structured form or in a particular schema. So when I'm reading this data, I have to read it in that schema only. But when you talk about a data lake, here you just dump your data. It is not structured. So when you're using this data, you are free to go ahead and define your schema in a number of ways as it suits your needs. So this is where the benefit lies in. That is, your data does not follow a particular schema. You can just go ahead and pick a schema for it. So that is a plus point. Again, one more point. Your data warehouse basically it works in SQL. That is, it uses SQL to query or question your data. But when you talk about your data lake, no matter the data comes from different sources, it can be queried by using one single language, that is your USQL. And again, that actually helps you reduce various barriers because you're talking about different data sources, but still something that lets you access the data is one single programming language. So these were some of the concepts I felt that you all should know. That is what a data factory is and what a data lake is. Again, the reason I talked about data lake was it is an important part when you talk about data warehousing and data integration because all these topics would form a base when you talk about analytics and processing data. And that is why I wanted you all to know all these terminologies. Now, since we started our session talking about data factory, let us move back to data factory and try to visualize all the concepts that we talked about because I talked about something called as pipelines, activities, and all those things. So let me quickly switch to my Azure and we can actually go ahead and see how it works. Okay, so there you go. What I have done is I've gone ahead and I have logged into my so-called Microsoft Azure portal. For people who are completely new to this term, that is Microsoft Azure, what you should do is you should go ahead and take a look at other videos if possible. I've created quite a few videos in this series and those videos talk about various concepts as far as Microsoft Azure goes. There are certain basics as in how should you use it and what are the things that you need to do. One of the things that is there is creating a free account, which is very important. Now we are going to go ahead and use our free account or our subscribed account. What Microsoft Azure does is it lets you have a free account. You need to just register for it and quite a few resources would be made available to you and some credit is also given to you which you can use. That is, you would be charged for these resources, but since you are given certain credit, you can use that and that means the services are freely available to you. If you already have an account, then that is not a problem. We are just going to go ahead and take a look at the demo part. As far as this demo goes, what I'm going to do is I'm going to go ahead and create a database. For that, I need something called as SSMS. Let us go ahead and try to understand what that is first. But if you do not have that thing, you need to go ahead and install it. So how do you do that? Just go to Google basically and type SSMS. This is the first link that you get, and you open it. You have your SQL Server Management Studio. Now, this is something that we would be needing. You just come here and you click on it, and it would start the setup download. I guess it's getting downloaded twice. I don't need that. I've actually gone ahead and I've installed that thing on my system. I'm doing this for you people. What you need to do is you need to download this particular file. Now, as you can see, it is somewhere around 800 MBs. That is approximately equal to 1 GB. So you need to download that file. And once you do go ahead and download that file, you need to install it in your system. The installation can be a lengthy process. Now, when I say lengthy process, it can be time consuming. It is not difficult to do. All you need to do is open this file and double click on it. It would give you an option to install it and just say yes. Once you do that, it takes care of all the processes. And once you do go ahead and install that thing, now this is something that would help you have your own server, and that is on your local device basically. So this is something that we would be using in the later part. But what I would suggest is you come to this website and download this particular thing if you do not have it. And once you download it, I would suggest that you go ahead and install it as quickly as possible. Again, let me tell you, it might take some 10 to 15 minutes depending upon the processor you have and the internet speed that you have. So yeah, once you're done with this, then what we do is we again switch back to our Microsoft Azure account. Now what I'm going to do is I'm going to go ahead and create a database here. So how do we do that? Well, you go to your portal basically. And quickly log into your so-called account. My internet is fairly slow today, so yep, it might take some time. So this is how your Microsoft portal looks like. You have quite a few things to select and choose from. You can just go ahead and click on create a resource here, and it gives you quite a few options to select from. Or instead, what you can do is you can just come here and look for your so-called databases. And I select an SQL data warehouse. So it would ask for a database name, give it a proper name, say demo DB is what I would call it. And yes, the name is acceptable. My subscription is Azure 533. I would be needing to create a resource group. For people who do not know what a resource group is, it is nothing but think of it as a place where you put in all your resources basically. So it is a group of resources. Again, if you need to understand more about it, we do have a session on it, which you can take a look at it on YouTube. So I say create a new one. Say I call it demo RG. And let me just pick a blank database. I need to configure a server to it. So I would say create a new one. Let's name it say demo server, and I should give it some numbers. Probably yes, it is acceptable. And you need to create some login credentials when you do log into the server. So let those credentials be say admin demo maybe. There you go. And what password should I set? Let it be strong and let it have a number and a symbol basically. Location South India. That does not matter a lot. You can choose the location that is there in here. You have quite a few options. There you go. I would stick to what it is there and I would say select. Yes. So I have a demo server as well. Performance level. Now it depends as per your need, as in how fast do you want it to work. Now as far as my so-called demo is concerned, I do not need it to be very fast or something like that. Let me have it to this value. Now based on the location where you've created your so-called resource, the prices would be given to you. Now this is something that I created in South India. So the price to me is in INR, that is Indian rupees, and it is 223.88 per hour. All I would do is I'll just go ahead and apply. I would say pin to dashboard and I would say create. Now the deploying might take a little longer than normal because yes, as I've already mentioned that it depends on the internet speed, and even if your internet is faster, at times it might take a longer while for this thing to happen. So what I'll do is I'll just pause the video for a minute, and once the deployment is done, I'll get back to the demo part again. So yes guys, I've gone ahead and I've done the process. That is, we have our so-called demo DB already. It took a while. I actually went back and had a cup of coffee as well. It took that long. My internet is really slow today. So yeah, let's move further and now try to go ahead and do the other thing that we are supposed to do. As I've already mentioned, you need to go ahead and install SSMS. If you do go ahead and install it, this is how it would look like. Now, since we've already created a database, we can log into it. You can go ahead and give in your credentials here. That is, I would be putting in the credentials which I've mentioned. That is demo server 1100, and then the extension, that is database.windows.net. Yes, and the name here is admin demo. I can go to options here, connect to what database. We have something called as demo DB, and that is 321 TCP IP. I say connect. It wants me to sign into my so-called Azure account. I hate this each time it happens because I've already logged in. I should have stayed signed in, but I did not, and that is costing me now. Yeah, one more thing. At times you would be logging in from your client user or your client PC, and at times you might not be an administrator. So in that case, you need to change the firewall rule and make your system accessible here. And there you go, I've signed in. So we have our information here. That is, this is my server I used to log in. And if I click on databases, the schema is there. We have our database, that is DemoDB321. Now what we can do is we can actually go ahead and add a table to it. Now I'm not gonna go ahead and create a table, a completely new table. Instead, I'll just go ahead and maybe run a simple query which lets me have 2 columns. So what query should I put in? What table should I create? I'll just go ahead and pick up some query from Microsoft Azure website. Now this is something that lets you create a table with this name, and these are the so-called variables or column names that your so-called table will have. So I'm just going to copy this piece of code. If you want it, you can go to Microsoft Azure website and you can have this piece of code as well. I'll share the link, do not worry. So when I close this and I come here and I click on this, I say new query. And I simply go ahead and paste this piece of code. Now I'll just make some changes to the name just to get rid of ambiguity. Say 2, maybe 3. And I would be inserting 2 records in it. So this is the changes I make here. That is insert into this so-called table. And to do that, I would say execute. Okay, this should not take this long, but it is. Now, once it does happen, these are the 2 records that would be there. That is John Doe and Jane Doe. There you go. 1 row is affected is what it says. So we have actually gone ahead and logged into my SSMS, and we have connected to our SQL server, and we've created a table there. And as far as the table goes, it has these 2 records. So what I'm going to do now is I'm going to again switch back into my so-called Azure Data Factory, that is to my Azure account, and create an Azure Data Factory basically. So how do we do that? First thing you need to understand is, in order to have a resource group or have all these resources there on your system, you need to have a storage account. Now this account is nothing but more or less a compliance or a law basically. What that law does is it lets you have your storage entities on Microsoft Azure. So let us go ahead and create that account first. It is very easy. You come to this portal. Once you do that, you just scroll down and you see storage accounts here. And I say add. When I say add, this window should appear and you need to enter in details. So what details should I give in for my storage account? Let's call it say SA for demo. Now it is not accepting this name. Okay, it needs to be in lowercase. So I would say SA for demo. And there you go, it is taken. Resource manager is what I stick to. And I say V2. Location is South India. Now I've talked about your data getting replicated 3 times. That is 3 copies are maintained. And when I talk about the replication, these are the types of replications that you have. Locally redundant storage is which I'm selecting, which is the most affordable one. It is not very reliable, but since it is a small demo, I can use this. Performance should be standard. And if you see, by default, the blob storage is always hot. And when you talk about a resource group, let's go ahead and use the one that is already there. Our resource group was demo RG, if I'm not wrong. Yeah, let's select this. Pin it to dashboard and I say create. and my storage account would be created. This should happen quickly. There you go. The deployment again might take a longer while. So yeah, what we've done is we've gone ahead, we've actually created a database, we've connected to a server, put a table there, and now I've created a storage account. Since I have a storage account, I can go ahead and create again containers, and then I can use Data Factory to basically move data between various sources. As you can see, it has been deployed. Do I want to go there? Yes, I do. Now, when you come here, you see this so-called tab. Here you have something called as access keys. What you can do is you can actually come here and copy some of the data that is here. This is the name of your storage account, which you would be needing. Now, there are quite a few terminologies that you need to remember when you are using or going through this demo. Like I mentioned, you have created a database. You need to know its name or remember its name. You need to know the server name. What is your server admin credentials? Plus, what is the name of your storage account, which is this in this case. The key, I'm not sure whether we would be needing it or not, but if we do, I would still say that you copy this first key that is here, Control A, Control C, and I would just paste it. There you go. Now, when you move back to this page, you have this option here, blobs, where we are going to go ahead and create a container. You can click on it. As you can see, there's no container here. So you click on this plus sign and you have an option to create a container. So what do we call this particular container here? Let's call it, say, blob. Again, you need to use something small, that is demo new blob, maybe is what I'll name it. And I'll let the public access level be the way it is. And I would say, okay. And my blob is created here. Now, I won't be adding a destination folder or something here because when you do go ahead and move your data, a destination folder is created automatically. So let's not do that. Let it be the way it is. So I have a blob storage or a container with me. Now I need to go ahead and create a data factory here. So how do we do that? Come here, search for data factory directly. There you go. Now this is not where I want it to be. So I close it. I click on analytics. And here I have the option of data factory. I click on it. Yes. So I can create a new data factory. So what should I call this? Let's say demo df. Okay, it's still not there. So that is surprising. Okay, let me just try a few names and come back quickly. So this name is accepted now. So use an existing resource group. Which resource group did we have? It was demo RG if I'm not wrong. There you go. V2 is the latest version that we have. And do we need to bother about this thing? Let's say, okay, these are the areas that are there in the option. We select this, pin to dashboard, and I say create, and I have a data factory with me. So this might take a while. So let me again pause it and switch back to the time. No, I don't need to do that. It's created. Okay, so I have a data factory with me. Now I need to come here and click on this because I need to go ahead and move my data. So I come here. When I click on this thing, I would be given quite a few options to deal with. So I need to copy my data. So I click on this icon. There you go. I need to give a name to the task that is there. Let's call it, say, copy from DB to blob. And I go to next. I need to select an SQL server here. So I come here and I scroll down. Now the interface might vary from different portal accounts. This is what it looks like as far as my so-called system goes. SQL server, here it is. I select it and I say create a new connection. There you go. You'll have to scroll down right at the bottom. SQL server, server, server. Okay, did I miss it somewhere? Yeah, here it is. You select it, say continue, and you need to give a name to your new linked service. Now, what name should you give it to you? Say SQL server demo link maybe. And I also need to go ahead and create an integration environment. So I come here and I click on this thing and I say create new public network. I say next. So what name should I give it to it? Let's call it say demo integration maybe. And I say finish. Now, as you can see, what we've done here is I've gone ahead and I've given in details for my so-called source. That is the place from where I'm going to go ahead and use all the data. So I have this. So I need to go ahead and give in my server credentials again. So if I'm not wrong, the name was, I'm telling you, you need to write everything down because you would be using all these names. So a best practice would be to write everything down. So in my case, it was something like demo server 0011, if I'm not wrong. Sorry, 1100. The extension is .database .windows .net. There you go. The database name was demo DB 321. SQL authentication username was admin demo, if I'm not wrong. I scroll down and I enter the password, that is, and I say finish. So yeah, my source details are given in already. That is, this is my source data store and these are the informations, or this is the place from where I would be wanting to move in my data. So I go to next and then I enter the details about the destination now. But before that, what we do is I need to select a table. If you remember, we had run a small SQL query to give you the details. I do not remember the name. It was, what was the name of the table? Was it EMP3? Was it? Yeah. Let me just refresh it to see if the information is there or not. I scroll down and it is here. So I select it and it would load the preview saying that, okay, these are the records that are there. Now these were the records that we entered. So I say next. For my destination, I'll come here and I would select a blob storage now. There you go. Create new Azure blob storage and I say continue. Now I need to enter in details here as well. Let me just call it say Azure storage demo link. Let me just do this thing again quickly. Now we need to select a storage account name as well because we've gone ahead and created a storage account here, which was for the demo part. What was the storage account? I forgot the name of it. It was storage account for demo if I'm not wrong. And I've selected that. And then I say finish. I click on next. Now this is the service that I wanted to connect to. I say next. Now I have to enter the so-called details. For that, I would be actually needing the name of my blob, which I think I've forgotten. So let me just go ahead and get the details of that as well. It was something like this, that is demo blob. And the file name was emp3 if I'm not wrong. I say next. I say next. Next again. And I say next. And there you can see the data has been deployed. That is, I've actually connected my SQL server and I've gone ahead and I've moved the data to my so-called blob storage, which you can actually also do. Then you can go ahead and edit the pipeline if you want as you want, or you can just go ahead and monitor this data as well. Now it depends on your needs as in what do you want to do. You can go ahead and do quite a few things with it. That is, you can go ahead and move this data to your so-called Power BI and implement various other things on it as well. When we did go ahead and create our so-called blob storage, that is blob container, you can actually go ahead and keep that part or that so-called window open, because when you do go ahead and deploy this data, you can see all the details, that is what has just happened and how has it happened, all those things. So yes, what we've done is we've gone ahead and we've moved our data from a so-called database to our blob storage. Now, I actually accidentally went back and did not go through that step where we see the deployment, but do not worry, we can just go back to our dashboard and take a look at that thing as well. So how do we do that? I have this so-called storage account here. Now inside that storage account, we have our blobs where we moved our file. Now this was the blob where we moved the file, and then this was the file that we moved. So yeah, our deployment has succeeded. That is, we've moved our data from a so-called database to our so-called blob storage. And as far as this demo goes, that is what our aim was. I hope that I did throw a sufficient light on following concepts. That is our data factory and how do you go ahead and create a data factory and use it as a pipeline basically.
Before knowing what is Azure Databricks, we must know what Databricks actually is. Well, according to the definition, Databricks is a web based platform for working with Apache Spark that provides automated cluster management and IPython style notebooks. So basically, Databricks, developed by the creators of Apache Spark, is nothing but a web based platform which is also one stop product for all data requirements like storage and analysis. It was originally founded to provide an alternative to the MapReduce system and provide a just in time cloud based platform for big data processing clients. It can derive insights using Spark SQL, provide active connections to visualization tools such as Power BI, ClickView, and Tableau, and also build predictive models using Spark ML. Databricks also can create interactive displays, text, and code tangibly. So, in short, it is an alternative to a MapReduce system. Databricks is now integrated with Microsoft Azure, Google Cloud Platform, and Amazon, making it easy for the business to manage a colossal amount of data and carry out machine learning tasks. As we got to know that Databricks is integrated with all the three cloud-based platforms, today we'll discuss on one of those, that is Azure Databricks. So let us understand what is Azure Databricks. Azure Databricks Lakehouse is a platform that offers a uniform collection of tools for building, deploying, sharing, and supporting enterprise grade data solutions to a scale. It integrates with cloud storage and security in your cloud account and manages and deploy cloud infrastructure on your behalf. Azure Databricks supports Python, Scala, R, Java, and SQL, as well as data science frameworks and libraries including TensorFlow, PyTorch, and scikit-learn. Now that we have come to know what is Azure Databricks, let us understand why should we use Azure Databricks. Well, our customers use Azure Databricks to process, store, clean, share, analyze, model, and monetize their data sets with solutions from Power BI to machine learning. You can use Azure Databricks platform to build many different applications spanning data personas. Customers who fully embrace the Lakehouse take full advantage of the unified platform to build and deploy the data engineering workflows, machine learning models, and analytics dashboard that power innovations and insights across an organization. The Azure Databricks workspace provides user interfaces for many core data tasks, including tools which we'll be discussing one by one. So, first is Optimize Spark Engine. It is a simple data processing on auto scaling infrastructure powered by highly optimized Apache Spark for up to 50x performance gains. Next is Machine Learning Runtime. It is a one click access to pre configured machine learning environments for augmented machine learning with state of the art and popular frameworks such as PyTorch, TensorFlow, and scikit-learn. We also have MLflow that is used to track and share experiments, reproduce runs, and manage model collaboratively from a central repository. Well, here you can use your preferred language including Python, Scala, R, Spark SQL, and .NET, whether you use serverless or provisioned compute resources, so that you can quickly access and explore data find and share new insights, and build models collaboratively with the language and tools of your choice. In Azure Databricks, you have enterprise grade security, which is an effortless native security that protects your data where it lives and creates complaint, private, and isolated analytics workspace across thousands of users and database. Apart from that, it is also production ready. That means you can run and scale your most mission critical data workloads with confidence on a trusted data platform with ecosystem integration for CI/CD and monitoring. You also have collaborative notebooks through which you can quickly access and explore data, find and share new insights, and build models collaboratively with the languages and tools of your choice. And the most important thing, it has Delta Lake that brings data reliability and scalability to your existing data lake with an open source transactional storage layer designed for full data lifecycle. It has a native integration with Azure Services. That means you can complete your end to end analytics and machine learning solution with deep integration with Azure services such as Azure Data Factory, Azure Data Lake Storage, Azure Machine Learning, and Power BI. Last but not the least, it has an interactive workspace. That means you can enable seamless collaborations between data scientists, data engineers, and business analysts. So these were the key features that makes Azure Databricks unique. Till now, we have got an idea about the Databricks and Azure Databricks and why are we using Azure Databricks. Now let us deep dive in by understanding how does Azure Databricks actually work. As I said, Azure Databricks is structured to enable secure cross functional team collaboration while keeping a significant amount of backend services managed by Azure Databricks so you can stay focused on your data science and data analytics and data engineering tasks. It operates out of a control plane and a data plane. Although architectures can vary depending on the custom configuration, such as when you have deployed a Azure Databricks workspace to your own virtual network, which is also known as VNet injection. Now, let us consider this architecture. It is a common structure and a data flow of an Azure Databricks. Here, it consists of control plane and data plane. So, let us understand what is control plane. The control plane includes the backend services that Azure Databricks manage in its own Azure account. Notebook commands and many other workspace configurations are stored in the control plane and encrypted at the rest. If we talk about data plane, it is managed by your Azure account and it is where your data resides. This is also where data is processed. You can use Azure Databricks connectors so that your clusters can connect to external data sources outside your Azure account to ingest data or for storage. You can also ingest data for external streaming data sources such as event data, streaming data, IoT data, or many more. Well, your data is stored at rest in your Azure account in the data plane and in your own data sources, not the control plane. So you maintain control and ownership of your data. If we talk about the job results, then it resides in storage in your account itself. Interactive notebook results are stored in the combination of control plane, that is partial result for presentation in the UI, and your Azure storage. If you want interactive notebook results stored in only your cloud account storage, then you can ask Databricks representative to enable interactive notebook result in the customer account for your workspace. Note that some metadata about results such as chart columns, names continues to be stored in control plane itself. So this is the basic architecture of Azure Databricks. To know it more in simplified manner, let us have a quick hands-on on Azure Databricks. So here we'll be integrating Azure Databricks with the Azure Blob Storage, that is a service provided by Microsoft Azure. So as you can see, this is a small workflow of how we'll be working on the demo. So, as we know, Azure Blob Storage and Azure Databricks are both services provided by Microsoft Azure. Now, these are two separate services, but as long as you are using them in same resource group, you can integrate these two services. Well, now you must be wondering, why do we need to combine these? So, let's say that Microsoft Azure provides a multitude of services. It is often beneficial to combine multiple services together to approach your use case. So, if we combine multiple services, then we don't need to engage your local hardware in anything like, well, for example, currently I'm using a laptop. Maybe my laptop can be of lower configuration or it might not have enough space to process a huge amount of data. In that case, I would want the cloud service to handle all my use cases and my big data storage that I have. So in this workflow, as we said that we will integrate Azure Databricks and Azure Blob Storage. That means we're going to combine them. So here what you do basically is you interact with the coding notebook, which is nothing but the IPython or Jupyter notebook that your Azure Databricks will create. Then what you do is then you type some coding commands in your coding notebook, and then these commands are sent to the Databricks service. And then what happens is the Databricks service receives the commands from the coding notebook and it sends those commands to your Azure cluster. So whatever cluster you have created after creating your Databricks, so whatever commands that we are writing in the coding notebook is sent through Databricks to your clusters that you have created. Now, depending on the authentication provided to the cluster with regards to your blob storage account, the authentication commands are then sent to the blob storage account, saying that the data is fetched from the desired directory. Then it is brought back inside the cluster, and that data that has received by the cluster then is processed, and whatever output you get out of after the process is you can see it on your coding notebook. Now whatever output you receive from the coding notebook, you can also store that particular output that you have got from the coding notebook back to your blob storage account or space. So all of this is integrated easily and it is handled in a very simpler manner. Well, now that we have understood the architecture, let us now know how to implement it with a hands-on. For this, we need to quickly sign in to our Azure portal. So once we sign in, we land in our dashboard of the Microsoft Azure. As you can see here, the all the Azure services are mentioned here. And once you create your resource group, so it gets highlighted also. Now let us quickly open our Azure Databricks and let us create our Azure Databricks. So for this, once we come here, we need to just simply create. And here they ask for basic details like your resource group, then workspace name, region. So let us fill up one by one. So here, as we don't have any resource group, so we'll be creating a new resource group. As we are working on a demo, so let's name it as Azure Databricks demo, and let's create it. Now that we have created the resource group, now they ask for the workspace name. So we'll give it a unique name. You can keep it any. So let's name it as Azure Databricks hands-on. And then you can choose your region. So here you find different types of region where you can like work or create your Azure Databricks. So it is up to you whatever region you choose. For me, I'll be keeping West US as it is. After that, we come to the pricing tier. So here there are three types: standard, premium, and trial. So as we are working on the like we are just having a practical knowledge, we will be using the trial version and we'll just review and create. Now here you can just check on to your whatever details you had filled previously whether it is correct or no. So once it is validated, we can just create this Databricks. Now as you can see, they are initializing the deployment. So it may take a while to create a Databricks. Alright, so here you see the deployment is in progress.
So once your deployment is complete, you can go to your resource, and here you land up to your Databricks page. Now here what we need to do is launch our workspace. So it will move us to our main Azure portal. So it will sign us in the Azure Databricks. So this is the dashboard of the Databricks. Now here you have different options like notebook and data import, partner connect, transform data, and many other things. Here you can set up your workspace like create a cluster, import data, build a data pipeline as well. Now, one thing I should tell you that Databricks works on DBFS. Now, what do you mean by DBFS is? Well, DBFS is nothing but Databricks file system, which is a distributed file system mounted on Azure Databricks workspace and are available on the Azure Databricks cluster. So it allows you to interact with the object storage using directory and file semantics instead of cloud specific API commands. And it helps you out to mount cloud object storage location so that you can map your storage credentials to the path in the Azure Databricks workspace. It also simplifies the process of persisting files to object storage, allowing the virtual machines and attacked volume storage to be safely deleted on the cluster termination. Well, these are the things which you can implement it while you're working with the Azure Databricks. Now let's get back to our Databricks. Now that we have come to this page, so the first thing to be done over here is to create a cluster. Now we go to create a cluster. Now here we go to create compute. Now here, as you can see, we have the cluster name. So here we can edit the cluster name based on your requirement. So let us keep it as a Databricks cluster. And after this, we have the policy. So here policy is nothing but a cluster policy defines the limit on the attributes available during the cluster creation. So here we have different types of policies, that is unrestricted personal compute, power user compute, shared compute. So we will keep it unrestricted for time being. Now there are two types of cluster mode. One is multi-node and single node. So in multi-node, we can specify the minimum number of workers and the maximum number of workers. So here minimum numbers can be 2, or you can specify it upon, this is basically a standard limit for minimum and maximum, whereas you can change it accordingly based on your requirement. So now, as of now, as we are only practicing, so we will just disable this auto scaling and we can specify our number of workers over here. So we can keep only one worker as it is only for practicing. Whereas we can also change the timings for termination if the particular cluster is inactive. So you can specify that much of time to it. Apart from that, we have our access mode. That is nothing but there are three types of access mode, that is single user, shared user, and no isolation shared. So here we will keep it as it is, and here single user access is nothing but a subscription. After that we come to our performance. So here we need to specify our runtime version. So here in our case it is runtime 11.3 LTS Scala 2.12, and our work type can be standard, whereas there are other versions as well, but as of now we don't require much of it, so we'll be going with the standard version itself. And whereas we have already specified our workers, and termination time is also being mentioned. Now here towards your right, you can see the whole summary of your cluster, what have you been creating. So once you review it, you can just create this particular cluster. Now, as you can see, it is loading. It takes a while to create a cluster. Here in this section, you see the status of your cluster. So currently it is in a pending mode, like it has been creating. So we'll wait for a while. So now as you can see, our cluster has been created and it is in the running mode. Now, after this, what we need to do is go back to our main dashboard and we need to create a new notebook. So we'll create a new notebook over here, and here we have already specified the cluster. So we had created now, so it has automatically taken.
And here we need to specify our default language. So you can choose any of them. So here there are 4 types of languages which you can choose. Here I would be taking Scala for now. And we can give a simple name to this notebook. That is, it can be anything of your choice. So let us name it as Databricks notebook and let's create. So this will start very quickly. It doesn't take that much of time. Now here it is like you need to like run your command over here. So you just need to type down your command and just hit enter and it starts running. So now in this we will know how to upload a file through the Azure storage service, that is our Azure blob storage. So it's basically we need to first integrate the Azure blob storage. So let us know how. So before this, we need to go back to our Azure portal, and here we need to first create our storage account. So here, as you can see, we have our storage accounts, and here we'll create our blob storage. So let's create. So now here for creating storage account, you need to give your details over here. So as here we had already created the resource group previously while creating a Databricks, so we will be selecting the same. And after that, we will give a storage account name. So let us name it as Databricks storage account. And in region, we need to provide the specific region, whichever you like to choose. So as previous, I had chosen West US, so I'll be choosing that as well. And here now, when we come to the performance, so here we can choose any of those, any of the 2 options given below. So here we have standard and premium. So currently we'll be going with the standard version. And when we talk about redundancy, so here we have 2 types of redundancy. As you can see, locally redundant storage. Here it means the low cost option with the basic protection against server rack and drive failures, recommended for non-critical scenarios. Whereas geo-redundant storage is like for intermediate option with failover capabilities in secondary region, recommended for backup scenarios. So locally means it happens within the region, not across the whole world. So here we will be choosing the locally redundant storage. Now we have specified everything. So now let us review. So here before like creating, you need to check all your details. Once you review it, just create and your storage account is in initialization stage. So once it gets deployed, we will start working on that. So now our deployment is complete, so we can go to our resource. So here all of the permissions are automatically managed within the same resource group. So we don't have to worry about any permissions requirement. So now that we have created our storage account, now here we need to create our container. So we'll go to our containers and so here we can give it a name to our container. It can be anything. Name it as storage account 1 and let's just create. So as you can see, our container has been created. Now we will quickly go on to this container, and here we don't have anything in this container. So the container is empty. Now we need to upload some files in this particular container. So we'll just quickly go to upload, and here we will go to select file. So here what does it do? It will get connected to my Windows file. We can take any files over here. So as of now, I will just take a normal Excel, a CSV file, and we'll just simply upload it. Well, you can upload more than one files if you want to like upload it in the containers. You can also have a larger files, but it may cost according to the given size. Now we have a file in place and we also have created our notebooks. So now we have to integrate the blob storage with the Databricks. So for that, we need to run a code. Now here the code looks a bit complex. So here first we need to create a token.
so that we can get access to the files. So we'll just copy this whole code so that there's nothing to memorize. This can be provided to you while you are practicing. So now we'll just copy paste the whole command. So here now, as you can see, the container name. So here we need to specify the container name and the storage account that we have created. So we'll quickly go back to our Azure portal and we will fill up the details. So as they asked for the container name, so here we need to specify our container name and the storage account which we have created. So let's quickly go back to our Azure portal, and here as you can see, your container name is given. So we'll just quickly copy that. Okay, where did it go? Let's go back and we'll just copy this name and we'll paste it here. Now same thing to be done with our storage account. So we'll go back to our storage account and here we'll see this is our storage account name. So we'll just copy and we'll just paste it over here. Now for the SOS token, we need to go back to our containers, and here we will go to the shared access signature. So here we will be getting our SAS tokens. So SAS token can be generated for a limited amount, like for a given period of time. So you need to specify, like when you create your SAS token, so the time it has been started, it would be valid from the time it has been started till its time of expiry. So we'll just allow the services, containers, and the objects and let the time be as it is, as it is being specified. And now let's generate. So now here, as you can see, you can find your SAS token. Now we need to just simply copy this and go back to our Databricks and we'll paste it over here. So we have just added our SAS token. Let us just verify whether it has been correctly copied or no. So I feel everything looks perfect. Rest other things remains to be same. So here what happens, you keep on creating new variables. So here we have created a URL. So by appending the container and the storage account. So once we specify our URL and our configuration, then it comes the DB utils. So here we specify our source, mount point, and our maps to that particular token. So this is basically where the Databricks helps you get your sources from your different services. So here the Databricks plays the role where it provides you the data from where you want to extract from, and it shows it over here. And now you just hit shift plus enter. So now it is running the command. So here what does it do is we had discussed in our architecture. So it communicates first with the Databricks and then it communicates with our cluster and get all the sources and then shows its result on the cluster itself. So as you can see, your command has been run. Okay, so it shows some error over here. So let's quickly solve that error. All right. Now let's quickly run it again. So it may take a while. So here, as I said, it will first connect with the Databricks and then communicate with that, and then it will communicate with your cluster and get all the resources from there. So here, as you can see, they have specified your container name, storage name, and your token, which has been specified. Now, what we need to do is check whether our file has been extracted from our storage account or no. So here we'll specify first we'll specify our variable. So let's specify with spark.read, and now we're gonna give the format of the file. So as we had uploaded the CSV file, so we'll just specify it over here. CSV, and then we can give them some of the options that they should show. So let's give it an option, like we can ask them to show the header and their value should be true. Then we can also specify the inverse schema, so we'll just add on that as well. And for the efficient data requirement, we will just provide them with a mode that can be fail fast mode. And then we upload the, like mentioned, the file name. So here we paste this mount slash staging, that is our mount point, and we'll paste it over here. And then we will specify our file name, that is, let's go to our containers. Let's check what's the name. python1.csv. Let's copy the name and we'll paste it. So now let's just shift enter. So it shows some error. Let's see what is it. Okay. So here we had specified a wrong command. So let's just resolve it and let's run it again. All right. So let us see how it looks like. So now just do df dot show and let's specify some amount and just shift enter. So as you can see, so they have mentioned here the decimal and description, the percentage, your headers have been provided, and the number of rows that we required, they have specified that. So this is how we integrate the two services and we process data through Databricks. Now let us look on to some of the popular use cases that makes Azure Databricks in a huge demand. Well, Databricks isn't a catch-all solution for every business scenario. So there are the best use cases for Azure Databricks. First is database and mainframe modernization. Data storage, collection, and processing are incredibly important in modern businesses. Well, if you're looking to modernize your data lakes or looking into mainframe modernization applications, then Azure Databricks has all the integrations you need. Next is machine learning production pipeline. Here, using the underlying power of ML flow, Databricks is a good choice if you need to get machine learning applications into production. Getting data science out of the development and into production is a common problem, and Azure Databricks can help you streamline that workflow. If we talk about big data processing, then Azure Databricks is one of the most cost effective options for big data processing. In terms of performance versus cost, it offers higher efficiency. If your business needs the best performance for one demand data processing, then Databricks will likely be your best choice. Next is business intelligence integration. Integrating business intelligence tools means you can open your data lake to analysts and engineers more easily. There is no need for creation of new pipelines when analysts need access to new data. The data can be shared through SQL Analytics, Power BI, and Tableau. If this is a bottleneck for your business, then Databricks will help you enable your business intelligence team. Now, these were the four popular use cases by Azure Databricks. If your business fits in one of these use cases, then it might be the solution for you.
Azure Data Lake Storage. So, what is Azure Data Lake Storage? Azure Data Lake Storage is a repository that stores large amount of raw data in its natural format until it is needed for analytics application. So why is it named as Data Lake? Well, James Dixon, the Chief Technology Officer of Pentaho, is the person who has generally been credited with the coining of the term data lake. According to him, he described a data mart that is a subset of a data warehouse as akin to a bottle of water which is cleansed, packaged, and structured for easy consumption. While a data lake is more likely a body of water in its natural states. Data flows from the streams, that is the source of the system, to the lake. Users have access to lake to examine, take samples, or dive in. So, a data lake is a centralized repository designed to store, process, and secure large amount of structured, semi-structured, and unstructured data. It can store data in its native format and process any variety of it, ignoring the size limits. Next is how to create a data lake storage. For this, we'll have a practical demo to have a better understanding. So the first step to work on any Azure services is to first sign in. So first we need to sign in. Make sure you do have an Azure account so that you can have the access to different Azure services. So let's sign in. Stay signed in. So once you sign in, you enter to this dashboard. So you can see here, this is a dashboard of your account, and you can see different kinds of Azure services like storage accounts, monitors, virtual machine, resource group, SQL database, SQL managed instances. And also you can see your subscriptions and different types of resource group you have created and all other stuff. So let's quickly get started. First, we need to go to create a resource. So once you come here, you can see popular Azure services. So like virtual machine, Kubernetes services, Cosmos DB, and rest other. So for us, we need to go to storage account. Once you click here, so you enter to create a storage account. Here, we need to create a resource group. So first of all, what do you mean by resource group? A resource group is a container that holds related resources for an Azure solution. It can include all these resources for the solution or only those resources that you want to manage as a group. So let's create a new resource group. Let's name it as Demo Data Lake 1. Okay. And once you create a resource group, so you come to a storage account main. So a storage account contains all of your Azure storage data objects, including blobs, file shares, queues, tables, and disks. So let's name it as Marshmallow123. So once you have named your storage account, we go to the advanced section. Here we will directly move to data lake storage generation 2. So what do you mean by data lake storage generation 2? Data lake storage generation 2 is designed to deal with this variety and volume of data at exhibit scale while securely handling hundreds of gigabytes of through output. With this, you can use data lake storage generation 2 on the basis of both real-time and batch solution. So here we will enable the hierarchical namespace. Once we enable it, we'll click on review plus create. So it will take few minutes to validate all your details. Once validation is passed, you just click on create. So it's now getting ready to deploy. So here you can see your Marshmallow 123 is created and now it is getting ready for deployment. Here you can see deployment is in progress. Once it gets ready, so we will be working on it. Here you can see your deployment is complete. Now what you're gonna do is we'll move on to go to resources. Now here you can see your details, your resource group details, the whole storage account details basically. And even you can see the properties enabled with it. So here we have data lake storage, file service, queue service, table service, networking, security. So after this, we'll quickly go to containers and we'll create a new container for our storage account. So let's click on container and we give it a name to it. Make sure you give a name. It should be in lowercase because they don't accept the uppercase. So let's keep it
demo and create. So yeah, you can see your container has been created. Let's click on it. So here you can see there are no results as we haven't added any stuff. So let's upload. For this, you can either upload it from Azure Portal or else you can also go to Storage Explorer. So let's see how do we do on the Azure Portal. So once you come here, you can just click on select a file. Let's take any picture. Let's see, we'll upload a picture. So here you can see aws3.png. Let's upload it. So yeah, you can see AWS PNG has been uploaded in your container. Same as we can do on Storage Explorer too. For that, you need to download a Storage Explorer. In my case, I have already downloaded the Storage Explorer. So let's quickly go into it. So here also make sure you are signed in so that you can see all your containers and resource group which you have created. So here you can see my storage account, that is marshmallow123, which we have created recently. Under this, we'll go and find our container. Yeah, so here we go to block containers and we can see our demo. So here you can see the image file which we had uploaded through our Azure portal. Now we'll upload a file and a folder both. Let's see. So let's upload a file first. So you click on upload files, and then you select a file. Let's take any file. Let's take a picture again. So AWS 4. Let's take this an image. So now here you can see your image is transferring from your path to our demo. Yeah, so here your image file is uploaded. So as we said, we can upload any kind of data, maybe structured or unstructured. So let's check out by uploading a folder. So here you go with the same process and you select your folder. Let's take any folders. Let's see if we do have any folder. Okay, I'll just take any one of my folders and just click and upload. So your folder is also being uploaded over here. And once your folder is uploaded, now you can see the inside resources into it. So here there were different files, text, image, all of them are there. You can access it from here itself. And you can see other operations as well. If you want to download any of the file or a folder, you can do it. Or if you want to open it, let's open it any of the files. See, let's see if it is getting open or no. Okay, yes. So here you can see this file has been opened. Now, if you want to download this file, let's download sequence. So we'll download it and just put it in downloads. Let's see if it is downloaded or no. Apply to apply. So yeah, it tells your download is completed. Let's see if you find it or no. We go to our file and downloads, and here, see, now I had downloaded. This is the file which I had downloaded through our Storage Explorer. So this is how you manage your data through Azure Data Lake Storage. So apart from this, you can also give permissions to different users, like whichever file, if you want to give an access to a particular user, then you can also give permission to them that they can either read, write, and access the whole file or a folder. So for that, you just need to click on a file or a folder and right click, and you just see here manage access control lists. So once you come here, so you can see there are different owners, super user, owner, and all. So here I can add an owner, like for this file who can just get an access to it. So you can find out any name. If you find out any relatable person or a user, then you can give an access to that. Currently, I don't have anyone, so I won't be able to show you that. But yes, this is how you add
or give permission to different users. You can also do it with a folder, or else you can also do it with the whole container as well. If you want to share your containers with different people or different users, then you can easily share them. So here also you just go right click and just come to manage access control and just give them the access. Click on add and find out the person whom you want to give the access to, and just after that, once you give them the permission, you can see if you want to permit them for only read or only write, or if you want to give read and write, or all of the three. So you can just give them the permissions accordingly and click on OK, and then the particular user gets the access to all your files and folders. So this is how we create and work with Azure Data Lake Storage. Now let us see the comparison between Azure Blob Storage and the Data Lake Storage. So here are some of the comparisons between Azure Data Lake Storage and Azure Blob Storage. Azure Data Lake Storage is a technique of planning and control of the time, whereas Azure Blob Storage is an object store with a flat namespace. Azure Data Lake is an optimized storage for big data analytics workload, whereas Azure Blob Storage is basically a general purpose object store for a wide variety of storage scenarios, which also include big data analytics. In Azure Data Lake Storage, the APIs are over HTTPs only, whereas in Blob Storage, the REST API is over the HTTP as well as the HTTPS. In Azure Data Lake Storage, there is no limits on the account, but in Azure Blob Storage, there are specific limits for container sizes and the files in the blob. So these were the major points which differentiate Azure Blob Storage with Azure Data Lake Storage. At last, we come to the use cases. There are many use cases of Data Lake Storage, out of which we'll discuss about 4. So at first, business intelligence on Data Lake Storage. So Data Lake Storage dramatically improves the speed for ad hoc queries, dashboards, and remotes. You can run existing BI tools on lower cost data lakes without compromising performance or data quality. It also avoids costly delays, adding new data sources and the reports. At second, we see cloud data lake migration. Here, we can optionally deploy new applications to the cloud using data lake storage such as S3 or ADLS. You can also migrate from older on-prem data lake environments that are expensive and difficult to maintain while ensuring agility and flexibility. Next, data science on the data lake storage. Here, you can accelerate data science on data lake storage with simplified data exploration and feature engineering. Dramatically, it improves performance, making data scientists and engineers more efficient, resulting in high-quality analytical models. At last, data architecture modernization. So here you can avoid reliance on proprietary data warehouse infrastructure and the need to manage the cubes, abstract, and aggregation tables. You can run operational data warehouse queries on low-cost data lakes, offloading the data warehouse at your own pace.
Now I would like to brief you through the process of how machine learning works actually. And this is pretty much common for most of the algorithms that you're going to implement. First and foremost, you would be needing data. Now, I've already talked about the point that data is centric to machine learning. If you do not have data, you cannot make any predictions. And more the data, the better it is for you. So the first part is having data. And once you have the data, the next point you need to confirm or make sure is the data is appropriate for machine learning. And this is where pre-processing steps in. What pre-processing does is it helps you process the data that you have and prepare it for machine learning. I mean, your data might not always be clean. There might be some missing values, some repetitive values, which you do not want in your data when it is getting processed, right? So in this case, we filter out this data, we clean it, we fill in certain values, we predict certain values, and we put in those values there. And once this data is up and ready for working, then we pass it on further, and then we provide a particular machine learning algorithm to it. Now, this again is a trial and error kind of method where it seems simple at times because we've discussed all those machine learning algorithms, right? So to naked eye or to naked mind, basically, we might think in this direction where we would think that, okay, this is the kind of problem I'm dealing with, so this is the algorithm I might use. But that is not the case. At times, the data is misleading. We are not sure what kind of algorithm I want to use, what kind of data I want to pass, and how much data I want to pass. In that case, what we do is we first allot a particular algorithm, use it, implement it, then we test the values, then we try out some other algorithms as well, and then we come to a conclusion as in, okay, this is the best algorithm, and using which I've generated a model which is best to meet my needs. And while doing that, there are quite a few processes that happen, processes like training, testing, validating, where you pass in certain amount of data, you build the model, you train the model, and then again you pass or keep some data behind, which you later pass to test these models, as in, are they working properly or not? So this is an iterative process, and this might take in more than one iterations to actually go ahead and jot down or settle down onto a particular point. So once your algorithm is selected, once your machine learning model is built, you can actually go ahead and deploy this model into your environment or real-time working where it would be able to predict the real-time data or the data you provide your so-called algorithm, right? So this is how the whole process of machine learning works. Now, the processes which I talked about, pre-processing, then implementing various algorithms, training, testing your data. Now, this, again, they look simple, or when you listen to them, they seem pretty easy, as in training the data and all those things. But once you start implementing these things, it is fairly difficult. Ask any data scientist and that person would tell you that pre-processing is something that is very difficult to deal with. And mostly 60 to 70% of the work is done in these phases only. So what if we had something that could actually help us here? Wouldn't that be easy? I mean, if we could just speed up this process of pre-processing, algorithm selection, training and testing data, instead of doing these manually, can we do all these things automatically? The answer is yes. Now, this is where your Azure machine learning steps in. What Azure machine learning does is it helps you carry out the whole process. But as you can see, we have something called as ML Studio, and it focuses on your pre-processing, application of algorithms, and deployment processes. So bulk of the task which can be repetitive or which can require you to put in more efforts to implement manually, it actually helps you automate or speed up that process. So that is what ML Studio is basically. It is a studio or a service in a very popular cloud service provider, that is Microsoft Azure, which lets you implement various machine learning algorithms, and it carries out the bulk of tasks or the bulk processes which you would otherwise not want to do. Now, this is not something that actually is used to replace data scientists. You cannot do that. So no offense to any data scientist who is listening to this video or going through this video. It is more or less complementary to data scientists. You would be needing statistical knowledge, and hence we talked about machine learning a little, because even if you build models using Azure or any platform, you would be required to have proper statistical acumen or knowledge about data science, something that would help you understand the output of the models that you've built. So yes, some statistical knowledge would always help and you cannot replace that. But definitely if you are working on machine learning and you need to speed up this process or make it more efficient, then Microsoft Azure and ML Studio in particular is a very important resource for you to have. So what I'm going to do now is I'm going to switch into the demo part, and we would be building a model so that we can discuss some of this stuff that I've already talked about. And we also get to see how Microsoft Azure works in real time, right? So let me just switch to the Azure portal or console that we have at our disposal. So guys, what I've done is I've gone ahead and I've switched into my Microsoft Azure portal. For people who are completely new to Microsoft Azure, you can actually avail certain services that Microsoft Azure offers you for free for 1 month. Now, during this period, you can avail certain credit for US citizens or people who have an account in US region. They can actually avail up to $200 of usage where you can use certain services. Now, these services are chargeable. That is why the free credit that is made available to you. So, which I believe is more than enough for 1 month's practice. So if you're somebody who's new to these platforms, I would suggest that you go through or sign up for Microsoft Azure and you can avail those services. Now, since I am from India, we have Indian rupees as our currency. And for our usage, we are given somewhere around 13,300 INR or Indian rupees, which is a very big amount if you talk about using a service for a month's time. So it actually serves my purpose. I have been using it for a long time. That is this particular account. I've had a couple of accounts, but this one is something I created some 15 days back. And as you can see, I still have like 12,400 something, which I can use. And we would be not needing this much today. somewhere maybe 10-20 rupees to the max. So yes, you can go ahead and create this account. Once you do have this account, then you'd be having access to all the services that Microsoft Azure has to offer to you. You can go ahead and create all the resources you can have or utilize its compute services, storage services, database services, and all the services that it has to provide to you. But since we are talking about machine learning, we would be sticking to those applications as well. So in order to use your Azure machine learning, you need to create a workspace where you can actually go ahead and put in all your data. And once you create your workspace, you actually need to go ahead and sign into the Microsoft Azure ML Studio, which is an interface or IDE where you can actually go ahead and create all those models. So in order to go ahead and create a workspace, you just need to come here and type machine learning, and you might be having that thing in the suggestion. It was already typed, I believe, machine learning. And you have this place where it says machine learning studio workspace or service workspace. You can click on these. The studio workspace is something I've clicked on, and you need to put in some details, as in what is the name of your workspace, what subscription are you using, resource group. You can use the one if you already have one. If not, you can create one. Just give in some name. Now, resource group is something that holds in details about your resources that you're using, and then what kind of storage account you are using. You can create a storage account as well. It's not a big deal. It is nothing but think of it as a storage place where you can store in your data. That's it. So you do go ahead and put in these details, and then you say create. Before that, you have to put in what pricing tier are you using, and you'd be entering the region where you want your workspace to reside. Now, what cloud does is it stores your data in particular locations on the globe, right? So you can choose the location that is closer to you or closer to your business, depending upon your needs. For now, I'm gonna stick to the basic one that is here because we are just creating a simple demo. In fact, I'm not gonna go ahead and create a workspace because I already have my own workspace. But I would suggest that you put in these details and create one. Once this workspace is created, you can actually just open it, and at the bottom you would be seeing an option called as machine learning studio. Else what you can do is you can type in this URL and you would be redirected to this page where you have to sign in with your Microsoft Azure Portal account. And once you do that, you would be redirected to the ML Studio that I'm talking about. So the workspace would be created. Once the workspace is there, you log into your Azure ML Studio. And once you do that, this is what you'd be having at your disposal. Now, these are some of the experiments that I might have worked out or worked on in last week or so. Some of them are finished, some are still in drafts. So you can actually go ahead and create these workflows or these kind of workflows. Now you have so many options here. What are the projects that you create? Experiments, which we just saw, different web services that are made available to you. You can actually go ahead and create web services as well. You have your notebooks. Now, you might not always go ahead and start from the scratch, right? You might have your code written in maybe R or some other language like Python. So you want to import that code, you can do that as well. Or you can use the existing notebooks which Microsoft Azure has offered to you, where you have ready to use codes or ready to use models as well. And then we have data sets. Now, again, you can import your data sets that you have. There was one financial sample data set which I imported recently. You can actually go ahead and use sample data sets as well. Now you can see there are quite a few data sets that are made available here, which you can use and implement your own algorithms or implement the algorithms that Microsoft Azure has to offer to you, right? So you can do that as well. So it pretty much depends upon what do you want to do and what kind of processing do you want to do. As you can see, if you come here, you have some, this is somewhere you can see your trained models as well as in the work you've done or some models that you've implemented. So you can have that here. In this case, we are going to go ahead and implement one of the algorithms or algorithms that are implemented by Microsoft Azure. So if I come here to experiments and I go to samples, you can see that we have so many implementations. So we would be taking a look at one of these and then we would be implementing that on our own. Do not worry, we won't be copying it right away. So we have quite a few options here, as you can see. Okay, let's just go ahead and do one thing. Let's build our own model here. So for that, we need to go to experiments, or rather we can come down here and say new, and I say add a blank experiment. Let's just go ahead and try to build a recommender system or something like that. So to do that, let's call it say my recommender. There you go, and save it. Okay, there are no modules, so you cannot save it. So first, let's get started. Now, in order to create a recommender, for people who do not know what a recommender is, it is nothing but you pass in certain data and it might suggest, or the model might suggest you as in what you might like or what you might want to do. Say for example, when you shop on Amazon or any other website that is there, you normally have some suggestions, right? I mean, you may like this, you may like that. Same as with YouTube, you go through certain videos and it gives you suggestions as in you preferably might like these videos as well. So that is a recommender system. So let's go ahead and create one recommender system. Let's create one for movies. So let's just go ahead and practice or play with the data that we have. For that, we would be needing a data set first, right? Now, if you talk about ML Studio, it is very simple. You just drag and drop stuff, just like creating workflows. It is as simple as that. Now, in order to use a particular data set, we have these saved data sets here. Samples. Let's make a recommender systems for movies maybe. Yep. So movies. Do I have something in movie? Yeah, there you go. Movie ratings. So we would be using this data set. Now, once you put in this data set, it is available. You can just go ahead and take a look at it. So let's just visualize this data. And as you can see, the information is here. It has certain values like user ID, movie ID, ratings, and timestamp. Timestamp is something that people do not use frequently, but yeah, these are things that are important to us. We have factors like your ID, that is your movie ID, user ID, and rating. It's somewhere around up to 10. So I believe it has started from 0 or 1 maybe. So we have ratings from 1 to 10, which we would be using. So this is the data that we've just visualized, but at times this data is not as simple and as managed. It might have some missing values and you might be required to play with it or make some changes to it. You can actually go ahead and put in some factors here as well. Now here you have so many options that are made available to you, right? So you can actually go ahead and process your data a little, manipulate your data a little, like you can take a look at statistical analysis and all those things. But this being a clean data, we do not need to do that. So we're just going to stick to the recommender system part here. So we have the data set now. I need to select the columns that I want to use. So I'm going to project certain columns out of it. So for that, we have a module here called as project columns. Okay, I don't see it here. I believe they've changed the name. Select columns to, okay, so this is the one. They've changed the name. It's called as select columns in data set. So we drag it and place it here. And we hold on to the circle that is there on the previous module or the tab we had, and we pull it down so we can connect these two. Now they are connected. But since I've connected them, there's an error here. It says value required. Now I need to pass in some values as in what are the columns I need to focus on, right? So I would be clicking on this icon here or tab which says launch column selector, and it gives me options. So I'm going to put in certain rules. Now, what are the columns that I want? First, I would say that get in all columns and just exclude the ones that I don't want. So what are the columns that I do not want? Timestamp was something that won't be very handy. So I'm going to remove that. So I would be excluding that and I would be saying OK. Once you do that, the error is gone. So we have the data set, we've selected the columns. Now, next phase is I need to go ahead and pre-process the data, but data is already pre-processed. So I don't need to do that either. So in this case, I would be going ahead and splitting my data into two parts, my training data and my testing data. Training data is something that we would be passing on to the model and we would be training a model based on the data. And test data is something that we would be holding back. And then we would be using that testing data to test our models or to predict the outcome or to see whether the model is working fine or not. So to do that, we need to split our data. So come here. This process is easy. Just go ahead and type in the words that you need to do and it gives you modules to do that. So split data, I just pass in the data. So I've gone ahead and I've created or I've pulled this split data module or tab into my workflow. So yes, the data would be split and it would be split in this fraction 0.5, that is we would be using 0.5% data to test, that is half of the data to test and half of the data to train our models. So there you go. I won't be tinkering with these factors. Those are good enough for me. So let's just move further. Now there's an option here where you can zoom in or zoom out your model to fit in the screen. So the data is split now. Next job is to train your data. So train your recommender system. Do we have option to, yeah, train matchbox recommender. So we select this and pull it here. Now what we do is we pass in one of these branches here, first one, and the split data is passed on to this training module or tab. Now I'm not too good with the nomenclature, that is why this confusion. Let's call it tab. So yes, so I've pulled in this data into the tab. So this is something that would get trained here and I need to score it as well. So once I come here, I select this first and it shows me the details as in, okay, how many traits of the data that I have that I want to use to build this recommender system. Let's just say 10. Okay, 10 is fine. I don't see too many problems with it. Maybe let's do it 20. Number of recommendations, I want Okay, no, this can also stay to 5, no problem. Training batches, 4 is fine. So we just move further, and next what we do is we just go ahead and score the data that we have. So I say score and I pick in this thing. So again, to this I would be passing in my training data here, and I would also be passing in my split data, that is the testing data. There you go. So the data that has been trained, that would come here, and also the testing data would be here. So I have this score where I need to give in the details, as in what are the predictions that I'm looking for. Now I basically want prediction where I would be wanting related items, right? If I watch this movie, what kind of movie I need to watch, right? So this is what I would be entering here. So once I enter related items, it says what are the maximum number of related items to find from an item that you have. Let's say I want just one item. There you go. And so it would give me one related item to the movie. So if I pass in a particular movie to this recommender, it should suggest one movie that I might like watching. So that is what I'm talking about here. So one related movie, you can have more than one as well. So that is up to you. So we've done this. Now next is I build a model, or I've actually gone ahead and put in a tab for training and scoring. Next, I need to evaluate this data, right? So I say evaluate or test rather. So it says evaluate your recommender. You get in here, and this time you take in this value that is your score and you put it here in this column. We passed in one of these threads here. Next is we take in the split data and we enter it here. There you go. This is fine. I would be saving it here just to be safe. Once you save this data. Okay guys, so the connections that we pass in, these are important. In which port are you passing in what value? So this might hold. And this is more or less an experimental kind of a stuff where you might actually go ahead and put in some wrong connections and you might get in some errors. So you actually need to go ahead and troubleshoot some of those at times, not always. So we've actually gone ahead and we've almost built a model. Now we need one more table here, or one more data set, that is movie IMDb titles. Let's place it here. Okay, it has gone somewhere. Yeah, so I place it here. There you go. And whenever we have a new data set, we always visualize it to understand what it has. Okay, this should not take this long, but for some reason it is. So I have this data set where I have movie ID and movie name. So I would be using this data set for my recommender, where it has some IMDb titles, which is not the actual IMDb, that website which we have. It is a sample data set that is created. So we have this data set here. Now that we've seen the data, I'm gonna go ahead and use a command called as edit metadata, and I'm gonna place it here. And as usual, I'm gonna go ahead and put this thing in here. Now, if I come here, as you can see, there's this column here which says select certain columns which you want to use. So what are the columns that I want to pass to my metadata basically, or what is the metadata that I want to use? So I'm gonna go ahead and click on launch column selector. And in this case, with rules, I would start with no columns and I would say include. So what are the columns I need? First is I need item. So you have to hit the enter button. You won't be given a suggestion here. Okay, for some reason it is not taking in this value. Let me see what is wrong. Okay, we need to pass in first values to this so-called metadata. Before that, we won't be able to deal with items because we just took a look at this data set and it does not have item value. That is why we are not able to pass in that value. So let's pass in other values to it, the values that are more relevant to this data set. So we'd be coming here and we'd be selecting some other values. Now you can see that we have these values that are available. So let's just go ahead and select those. There you go. And I say okay. So the error is gone now. Now we have a metadata which is made available to us, and I have a model which is up and running here. Now I need to put in joins here. Now if you all know what joins do is, they basically help you select data from one table to the other. So we have two tables here, or two data sets. So I want to combine the data that these two tables have. Now I won't be getting into the details of joins and all those things, but we would be using them here for the general reference sake. So I have these two data sets here and I want to predict or compare the table with the table that is here. So what I'm going to do is I'm gonna build a model or create a join that lets me compare the movie names from one data set with the other, or give me recommendations from one of the two data sets, right? So for that, I would be needing a join here. So let's just come here and say join. Okay, before we get into this thing, there is one more important point. My edit metadata data type, it has to be string. There you go. Now I need to pass in values to this tab as well. So for that, I would be needing a score from here. So I would be taking this and I would be placing it here. There you go. And one from the metadata to this joint. Now, what are the values that I want to pass in here? Now it should be item, I believe. So as I've said, hit the enter button. There you go. And you say okay. And columns from R or the other table, what do you want from here? I would be saying maybe movie ID. There you go. I say okay. What kind of join do I want? I want left outer join. Now again, I won't be getting into the details of these joins. Don't keep the right key columns because that is the reason I'm using this join. There you go. I would be needing one more join here and I would be pulling it here because the first join would just give me the movie ID, but I just don't want the ID. I want the movie name as well, right? So I'd come here, I'd pull in this thing and I would pass it to this data set and edit metadata. There you go. Again, if I come here, it would ask me for values. I would say, give me related items if you have any. And here, I want the movie name. We would say save. If you missed out on one thing, we need to come here first and remove this left outer join and now save. We are bound to have some errors, guys, so stay tuned. Now this thing runs, it would run it tab by tab or module by module, and then everything would be executed. So this might take a couple of minutes. Once the module or the tab is executed, it shows a green tick on it. As you can see here, we have ticks here and here. This might take a longer because we've increased the number of iterations to 20 in the slide or in the tab when we were working on it. So the whole processing might take a little longer than normal. Okay, it says related item not found. Let's see why is that happening. Launch recommender selector. Yeah, this is the one that is the related item one. Probably there is no related item variable in the dataset that we generated. Now, as I've told you in the first model, I'll show you where. First, let me select this for now. And let me say, okay. Here in the score match box, I had passed in number of related items, right? It was 1. So by default, it was given a name called as related items 1. So that is something which we are passing in here or something that we would be displaying. So there you go. So what we've done is we've actually gone ahead and put in all the stuff that we wanted to. Let's just see whether it runs. And once it runs, I would be explaining this again to you people. So do not worry. First, let's run it. Now this time around, it should happen quicker because most of the stuff is done. We just have the error in the last tab or the last module. So the other parts should be done quicker, as you can see. And now the last one would be implemented and it is done already. So guys, our model is up and running. Let's just go ahead and check. So when I click on this icon and I say visualize, it should give me some values. See how relevant values these are. Let's just verify it. Now this being a model, it might not be that accurate, but let's hope it gives some values. It is not giving me the movie name and movie ID for the other section or the related item. Let's see why is that the case. But it says if you have seen this movie, you might like this movie, but we do not have that movie. So let us see where we have gone wrong first. So there is some error here or here. We have a movie ID here. So let's just come here and see. Okay, so we can just match ID to ID or map ID to ID. So let's remove this for now and say movie ID and then see whether we get the output. So I say save, not save as. I would say save and I would run this. So again, it should run quicker than the last time. There you go. Now let's just see what is the output that we get. So I say visualize. And there you go, guys. It's as simple as this. I mean, we put in or pulled in some values and we've edited certain values and we have the result here. Now this is an Indian movie called as Talash and it says that if you like this, you might like this. Oblivion, probably Jack Reacher. I haven't seen either of this. Iron Man, you might like Stand By Me. So I don't think this recommender is that accurate, but probably I'm sure that there would be some movies in it which are more relatable. So, and for people who are big movie fans, they probably would be able to relate a lot more to the movies that are here. So again, you can actually go ahead and select the number of related items that you want to select, and you might actually go ahead and tinker and tailor your algorithm a little more. For that, you have to play with the values that are there you have. in this algorithm, you can just come here and switch in these details, and probably the answer might vary depending upon the inputs that you pass to this algorithm. So this was my basic aim. I wanted you to get some hands-on on Azure Machine Learning Studio and nothing more than that. But as far as this model goes, or this particular session goes, we've actually gone ahead and taken in two data sets. We've actually gone ahead and built a model, trained it, tested it, and then we've used a join to actually go ahead and see what would be the possible movie that you might want to watch if you liked one of those movies. So again, as I've already mentioned, it might not be that accurate. You are free to go ahead and play a little more with it. You can pass in your own data sets as well.
Now coming to the other component, basically your virtual machine, So virtual machine is basically something people oftenly get, confused with that. So what is a virtual machine? So in this computer world, in this computing world, a virtual machine is just an emulation of your computer system. Your VMs are just based on a computer architecture, and basically, they provide functionality of a physical computer. So on your system, you can create as many virtual machines as you want. Okay, you don't have to basically worry about all this kind of things. So you just have to maybe in other words, you basically just need an ISO that you want to you know require in order to spin up a new virtual machine. For example, on your laptop, if you have enough hard drive, enough RAM, you can just create a new virtual machine. So you can basically have different softwares for this. You have basically have VirtualBox, you basically have ESXi. There are various softwares that you can basically use to build up the virtual machines. So like I can show you another example before I jump to that point. Same thing, the same concept basically applies on the cloud world, wherein what you do is you just use one instance, one account. For example, I'm going to log into Azure. I'm going to use my own account, and once I'm logged in with my account, I can create as many virtual machines as I want, and I have to pay as I go. Like I just have to pay for the virtual machines. I don't have to pay for entire infrastructure. So whatever I'm going to use, I'm going to pay for that. Now, first, one of the example of virtual machine, like in my local machine, I have enough space, so I build up this virtual machine, which is going to open up in a moment, using Oracle VM VirtualBox Manager. So this is a Kali virtual machine which I have built up. So if I'm going to launch it up, even though my system is of Windows, in my Windows operating system, it's going to open another operating system on this console, on the VM box console, which is Oracle VirtualBox console, a Kali Linux operating system. So likewise, it's going to right now these virtual machine. This is one virtual machine. I can have as many as I want till the time I have enough hardware space to utilize all the needs. So once I have created the virtual machine, I can just, depending on my hardware configuration, I can run as many virtual machines as I want. But all these virtual machines are going to be remain on my local machine. It's not going to be on a cloud. If I go somewhere else, I will not be able to access it. I need my computer or these, virtual machine files to access it. In the case of cloud, you can access it anywhere, wherever you are. Okay. So I hope you guys got a very fair understanding about each and everything that we have covered so far. So till now we talked about, what is basically is, cloud computing, what are different components of the cloud, what is basically, Azure, what are the different Azure features, what is a virtual machine. And now let's head towards the IoT. What exactly is IoT? Before we jump on Azure IoT, so we are basically breaking down the things in various parts, because I know that all the people come from a different background. So now before we directly jump to Azure IoT, we really have to understand what the cloud is. So we are basically taking the baby steps here. What the cloud is, what cloud computing is, what Azure is, what the different functionality of Azure you have, and then what virtual machine is, and then what is IoT. IoT means Internet of Things, which means that you're going to connect various devices just to have a kind of a resiliency and redundancy, and instead of having different devices, you're just going to focus on one device, and you're going to get the information from there. So you're going to connect various devices, various things over the internet without any human intervention. So like if we talk about one of the other example of IoT, which will give you more understanding, as you can see in this screenshot, What we have done is like we have basically connected wearable technology, smartphones, vehicles, your home lighting, your home appliances, your music, your personal computers, analytics, your flight services, online shopping. We have connected almost many functionality here just to have one solution. So instead of having multiple solutions, like a dedicated solution for online shopping, a different solution for wearable technology, different solution for your vehicles, different solution for home lighting, it's going to be a lot of solutions, which is going to be practically impossible for you to manage it. Plus you have to basically pay for all those kind of things separately. So IoT gives you an advantage wherein you combine multiple technologies just to make a single technology. Okay. Now I hope you guys got a very fair understanding and very thorough understanding about cloud computing, Azure, the components, IoT. Now let's head towards the major thing, which is IoT in Azure. Okay, so what exactly is IoT in Azure? Now you guys have a fair idea about IoT and Azure. So the very common analogy behind Azure is like it basically focus on the power consumption analogy, like you can see here. So it basically means that the pay as you go. So whatever the services, whatever the things that you're going to utilize right now, you are going to pay for that only. So it's not like that like I have written one of the example here. So it's basically similar to the power consumption. So whenever you're using the electricity, you basically pay only for the power units that you use, and you are not going to pay for anything else. So a similar concept lies here in the case of Azure only. You are just going to pay for the component itself, not about other things. So this is again the symbol of IoT in Azure, so where it's going to look like this. So I'm going to show you practically once I'm going to move towards that. So these are the different components in the IoT on Azure. As you can see here, what you have done is you have I have a use case. I want to combine a web app, a Power BI tool, a storage I need a Steam Analytics, IoT Hub. So with the help of IoT, which is one of the component in Azure, I can combine all those kind of features and I can use it directly. I don't have to worry about all other kind of things. Okay, so I hope you got a very clear understanding about IoT, wherein you combined the different technologies and just to build a one solution instead of having multiple solutions. If I have to conclude this as your IoT term. Now let's talk about the Azure IoT components. What are the different Azure IoT components that you can have? So the very first component that you can have is basically Azure IoT Central, which basically means that your all the different technologies that that you have combined basically are going to lie in just single technology. It's not like that my different technologies that I have combined, for that I need a different interface. I just need a single interface, and with that single interface, I can connect with all the different components. Like I want to build a web app, I can basically build a web application. I can simply build you know your the database application, and I want this web app to communicate with your database application. So you can make the dual level communication with both these applications instead of having a different interface with just one interface, which is going to be an Azure platform with single login account in which you are. You can just access all the different components that you have. Okay, other is Azure IoT solution escalators. So wherein so all these basically devices require some kind of interface. So these different devices, these different technologies can integrate with each other. So I'm saying that I have an application which is basically going to serve on the internet. Like I'm going to I want to make some shopping website wherein people are going to perform the shopping on directly on my website. So I have basically that shopping application. So this shopping application will require the database. This shopping application will require, let's say, a different network segment, all those kind of components. So it requires some form of interface between the different components. Like this shopping application has to integrate with a database which has to be on a different server for security measures, and I require another database which is going to store the hash of the passwords, because I want to be security centric as well, wherein if my database is compromised, let's say due to XYZ reason, so during that time I don't want that sensitive information of my customers should be hacked. So let's say I made this website in UK, and this has to be as per the GDPR guidelines, which is Global Data Protection Regulations. If my database is going to be compromised with the customers, I have to pay a hefty fine, to the government. At the same time, in addition to paying the hefty fine, it's going to spoil my name and fame, right? So we don't want to do that. So that's why I want all the different components to be on a different systems. At the same time, if I want to have all these components on different system, I want all these components to be, interactive with each other. So because your database is going to be on a different server, your web application is going to be on a different server, your passwords, which are going to be in a hash form, are going to be in a different server. So you have to have a kind of an interface where all these different components that you have basically can be interact with each other. So that's the benefit that you get with Azure IoT solution escalators, wherein it basically helps you in providing the interface. The next one basically is the Azure IoT Hub, wherein it means that you have just a central hub, a central repository from which you can just manage all the components. I'm going to show you, how it looks like on Azure platform, and you can just get the things, from there only. The other is basically Azure Time Series Insights. So it means basically that each and everything is basically logged with a timestamp. You can have your own logs. So basically, you don't have to rely on different people, different team members for logging everything. It's basically going to log each and everything for for your application. Even you can just configure your own monitoring tools as well. Let's say I want to completely depend on the Azure only. I don't want to build my in-house platform, so I want to build everything on the Azure itself. So each and everything which is going to be logged, all the requests which are coming in my environment, all the people who are trying to log in, each and every request is going to be logged. So based on that, those events, I can just set up the certain security mechanism wherein if a request is coming from that IP a couple of times, it's going to send an alert. So that's the meaning of Azure Time Series Insights. You can just be have a clear transparency of all different kind of events which are being happening. The other is Azure Sphere, which is basically one of the components of Azure Sphere, wherein you can just see all the components, you can manage it out. And the last one is Azure Maps. Like the Google Maps, basically, you can just see the information, you can just manage the information, and you can just, get the things from there itself. Clear? These are the different Azure IoT components. Now coming to one of the important part, which basically helps in building up Azure structure, is like virtual networks. So for the better security purpose, as well as for better isolation, we can use virtual networks, wherein we can just define our own network, and where we can put the applications into the different network zones. Basically, what I want is that I want my one application has to be in a different network, other application has to be in a different network. So it's not like that. That's some of the sometimes people think that how I can achieve on the Azure itself. Like if I'm building something in my in-house network, okay. So what we used to do is the critical components. For example, one of my critical application. Let's say in my let me make it more simple to you guys. Let's say in my organization I have 50 servers. Okay. Out of these 50 servers, I have 15 critical servers, which basically stores the information of the customer's credit card and everything. Out of these 50 servers, I just want to have only 2 servers on the internet. And that internet means interconnection of the network. So there can be certain computers as well, wherein the hacker can also be there, who can try to eavesdrop the communication. So he can try to put the malware on one of the machine. So if hacker is able to put malware in one of the system, he will be able to replicate those malwares in all the systems, right? So in order to minimize it, what we do in generally in the on-premises environment, we just put it in a different security zones. Like these 2 computers, I could put it on the internet via the proxies, or I can use DMZs for that, a different network basically, so that if something is compromised, it's going to compromise those 2 computers only, which are available via the internet. Rest 48 would be fine. So how you can achieve with this this thing with Azure, because the entire thing is on the cloud. So networks, people think that can be managed by you. That's wrong. Azure has a concept of virtual networks. Basically, what it means is, it means that the different the machines, the different infrastructure that you are creating, you can create a different V network for that. So here in this case, Azure Virtual Network, it means basically, a VNet. Basically, what you can do is you can just, isolate your different components, different computer, at a different network. So you don't have to basically rely on, one of the component, one of the network. You can just basically isolate, all these computers, all these, critical components into different, networks. So that's basically your virtual network. And in the Azure, basically, that is a sign of virtual network. On the Azure platform, if you're going to log into your account, you're going to get a sign like this of the virtual network. Okay, and this is again one of the real environment, that I can show you, which can help you in getting a fair understanding. Let's say these are the three virtual machines, in my virtual networks. I want these three virtual machine into a different, subnet. So what you can do is you can just put in a different subnet. This machine is going to be a different subnet. This machine is going to be a different subnet. This is going to be in a different subnet, which basically gives you an advantage. Instead of having machines in the same network, you can have machines in a different subnets, so that you can just protect yourself. And then if I have to summarize this entire architecture, the way basically how it works is, let me show you in the next slide. This is the entire architecture, the way it's going to look like to you, wherein you have basically NSG. NSG basically stands for network security groups. These NSGs are just like your firewalls only, which filter the traffic which is coming in and going out from your virtual machines. These settings can be easily done by the Azure itself. Then you can have a different subnets and different virtual machines into those subnets, and then you have at the core, at the top, you have basically the virtual network. Let me even show you, if you want to basically build, Azure IoT, how you can. So basically, like I mentioned, for starters, you need to have a Azure free account. So you can create a free account if you don't have any of the free account, basically. So you're going to log into your Azure account, and you're going to have a page like this, as you can see on my screen. This is going to be your home page. So you can just click on a dashboard here. If you get lost, by clicking on dashboard, you can just come here. You can just create a resource of you. As you can see in my screenshot here, this is basically the the entire the resource you can create it here. Once you have basically created the resource, remember everything in the Azure has to be live between a resource. You cannot have anything up in the air. You have to put the things in basically in a resource, so that all the whatever the kind of configuration you are doing, like I want to create a different network, I want to create a network security group, which is just like a firewall. You can just put everything in a dedicated resource group. So here you are going to create a resource. Once you create the resource, you're going to select here the Internet of Things, IoT, that we talked about, and you're going to have an IoT hub, the same thing that we have that we have learned a moment ago. So you can have a quick start tutorial wherein you can just watch the tutorial, and you can just get more information about it, all the information that you have already gathered with me right now. And then once you've created your basically IoT hub is basically ready to use. It's going to look something like this. So here this is basically the subscription, wherein you have to provide a subscription name, the resource group name, the region basically is basically you can use default one. So what it means basically is that if you are going to create a virtual machine in different region, you are, for example, I'm in let's say South Africa. I'm creating a virtual machine in a region which is let's say India. So it's going to create a virtual machine in that region, and I'm going to exit it over there. So sometimes it can have some kind of lag, but it does not create that much lag, so you are not going to create that much difficulty. So that's the region is. So if you're even using the default the region, that is also fine. It's not going to impact anything. It's going to create the virtual machine in that environment. And again, in the case of Azure, everything is basically into the cluster environment, where the things are in the cluster itself directly. And here we go. Here your IoT hub basically gets created.
What is Azure Service Bus? Azure Service Bus is a fully managed enterprise message broker which has three important entities, that is, message queues and publish and subscribe topics and namespaces. Before dwelling into these entities, let us learn what is Azure Service Bus and then why do we use it. So, as I said, Azure Service Bus is a multi tenant cloud messaging service that sends informations between applications and services. It provides platform as a service communication platform built to allow more robust multi-tenant software system to be built in the cloud. So when you need a cloud-based solution to broker messages between different applications to reduce your coupling in your system, you can use Azure Service Bus. Now let us understand, why do we use Azure Service Bus? As we know, Azure Service Bus is a messaging service on a cloud used to connect any applications, devices, and services running in the cloud to any other applications or services. As a result, it acts as a messaging backbone for applications available in the cloud or across any devices. Now let us understand some of the key scenarios that will help us to know why do we use Azure Service Bus. So first key scenario is, it can decouple applications that allow each component to perform its task independently. That means producer or consumer do not have to be online or readily available at the same time. The load is leveled in such a way that the traffic spikes don't overtax any services. This also improves reliability and scalability of applications and the services. Next is, receivers and subscribers can receive copy of messages depending on the filter rules set on the subscription. It means you can define rules on the subscription. A subscription rule has a filter to define a condition for the message to be copied into a subscription and an optional action that can modify the message metadata. So this can be useful if you don't want a subscription to receive all the messages to send to a topic, or if you want to mark up messages with extra metadata when they pass through the subscription. Next is, two or more operations can be grouped in scope for execution. So there is a feature in Azure Service Bus, that is transaction, that groups two or more operations together for execution in a scope. It makes sure that these operations either succeed or fail jointly and not partially. That is why the scope is often referred as atomic, which means the entire transaction always succeeds or fails as one unit of work and is nowhere left in a half complete state. With multiple concurrent consumer, you can process multiple messages concurrently to optimize throughput, to improve scalability and availability, and also balance the workload. This means you can allow for multiple competing consumers to read from queue at the same time, each safely obtaining exclusive ownership to the specific messages. Next is, auto forwarding can be used to scale out individual topic. So auto forwarding is a feature in Azure Service Bus that enables you to chain a queue or a subscription to another queue or a topic that is a part of the same namespace. When auto forwarding is enabled, Service Bus automatically removes that are placed in the source, that can be first queue or a subscription, and then puts them into the destination, that is into the second queue or a topic. You can also schedule a time to process the messages. That means you can submit messages to a queue or a topic for delayed processing. For example, to schedule a job to become available for processing by a system at a certain time. So, this capability realizes a reliable distributed time based scheduler. Scheduled messages do not materialize in the queue until the defined in queue time. Before that time, scheduled messages can be cancelled, which deletes the messages. You can also schedule messaging using any of our clients in two ways. Either use the regular send API but set schedule in queue time property onto message before sending. So scheduled messages do not materialize in the queue until the defined in queue time. Before that time, scheduled messages can be cancelled, which deletes the messages. Now that we have come to know why do we use Azure Service Bus, let us know some of its important entities. So first is namespace. So what do you mean by namespace? A service bus namespace is your own capacity slice of a large cluster made up of dozens of all active virtual machines. So basically, it is a container for all messaging components. So here, multiple queues and topics can be in a single namespace or namespaces. So as you can see in this diagram, this is a container which has queue and a topics and subscription. So it is a container for all messaging components, which can include multiple queues and topics. So you can have multiple topics and queues in a single namespace or namespaces, which can later serve as an application container. So you can think of a service bus namespace as a server with its own capacity of large cluster of all active VMs. This makes the service bus as an available and reliable service to scale without us needing to manage the service. Next is topics and subscriptions. So topics and subscription are the message oriented middleware that is responsible for holding and delivering messages to the subscriber. So basically, it provides one to many form of communication in a publish and subscribe pattern. It is useful for scaling a large number of recipients. Each published message is made available to subscription registered to that particular topic. So, when a publisher sends a message to a topic, one or more subscribers receive a copy of the message, depending on the filter rules set on these subscriptions. So, as I said in previous key scenarios, that subscription can use the filters. So, here they use the additional filters to restrict the message that they want to receive. So, the consumers don't receive messages directly from the topic. Instead, consumers receive messages from the subscriptions of the topic. So, when a subscription is created, you can supply a filter expression that operates on the properties of the messages. The properties can be both the system properties, for example, label, and the custom application properties like store name. So, as we look onto this diagram, we do have subscriptions along with the topics to process the messages. So, the sender sends the messages to a topic in the same way that they send the messages to the queue, but it varies in a slight factors where the topics can have multiple independent subscriptions. So, as you can see, there are multiple independent subscriptions which are colored in red, green, and yellow. So, subscriptions are durable by default but can be configured to expire and then can be automatically deleted as well. So here we can define rules on a subscription. And then a subscription rule has a filter to define a condition for the message to be copied into the subscription and an optional action that can modify the messages to the metadata. This means you can, by applying filter, we can decide which messages should be sent to which receiver. So as you can see here, we have applied filters. So for an example, the messages highlighted in red are to be sent to the receiver, which is highlighted in red. Whereas the green one goes to the green and the yellow one goes to the receiver, which is colored in yellow. So this is a simultaneous process. Here, as it is a one to many relation, so we can send these messages to the n number of receivers which are subscribed to the subscription. Now, if we talk about queues, as we know, queues offer first in and first out message delivery to one or more competing consumers. That is, receivers typically receive and process messages in the order in which they are added into the queue. And only one message consumer receives and process each messages. So as you can see in this diagram, this is a queue, and the sender, when it sends the messages, it goes into the queue in a synchronous way, like in sequence, one by one, first in, first out. So here, the system can have multiple senders. So as you can see, a sender has sent the messages and it has been organized in the queue. Now only one person can consume the messages at a time. So here, if you see, the person one consumes the first messages, and then the second person can consume the second messages as it is synchronous process. And lastly, the third consumer can consume the message. So this is how we send and receive messages through the queue. So a key benefit of using queues is to achieve temporal decoupling of application components. In other words, we can say that means the producer, that is a sender, and a consumer, which is a receiver, don't have to send and receive messages at the same time. That's because messages are stored durably in the queue. Furthermore, the producers don't have to wait for the reply from the consumer to continue to process or send messages. Now that we have come to know about these entities, let us compare the two most important entities, that is queues and topics. So we'll be comparing them based on some of the important constraints. So first constraint is consumer options. Here in queue, multiple server receivers can be added to the queue, but each message will be sent to one of them. As I said, it is one-to-one relationship. So one single consumer can receive a message at a time. Whereas in topics, the messages can be received by numerous recipients as it offers one to many relation. And each message copy can be delivered to any number of subscribers linked with that particular topic. Next is message filtering. In queues, because the messages are only received by one person, queues do not require any filters. But in topics, a collection of attributes can be attached to each message broadcast across a particular topic. When a custom subscription filter is applied, then these properties are utilized. Next is consumer scalability. In queues, if you need to scale a queue, you are still limited to having the one consumer. Whereas in topics, does not need to be recreated. When new subscription is formed, all new messages submitted to the particular topic are also received by the new subscriber. So once a new subscription is created, this can be more scalable than queues as more than one consumer can receive messages. And once a new subscription is created, all new messages that are sent to that particular queue will be received by the new subscriptions also. Let's look on to few more constraints. Next is message auto forwarding. So in queues, messages can be automatically routed to a queue or a topic. However, a topic subscription cannot be a destination. Whereas in topics, messages can be sent automatically from a topic to a queue or any other topic. Additionally, messages from topic subscription can be sent to a queue or a topic. Message removal. In queues, the first receiver who finishes reading the message also removes it from the queue, preventing further readers from processing it. Whereas in topics, the message is removed only after every receiver has processed the particular message. So, when the message is read by all the subscribers, the message is then removed from the topic too. Last is use cases. So, we choose service bus queue when there is a need to pass the message in the one to one system. Whereas we choose topics when there is a need to send messages to multiple systems. So these were the key differences between queues and topics. Now let's understand the concept with a couple of hands-on so that we understand how do we send and receive messages through Azure Service Bus. So our first hands-on is sending and receiving messages by queue. So here I'll be using the Python program to send messages to and receive messages from Azure Service Bus queues. For this, we must have Azure subscriptions. I hope most of us might be having the Azure subscriptions. If not, you can sign up for free and get the subscription through Azure Portal so that you can get access to many services. So let's quickly move on to our Azure Portal. So here we will be first signing in. So let's quickly sign in. After signing in, we'll directly drop down to our dashboard. So here, as you can see, there are many different services. So let's quickly create our service bus. So once you log into your Azure service, our first step is to create our service bus. So here, as you can see, we have the service bus option. So just directly click over here. Now, as you can see here, we have no namespaces yet. So as we had discussed that what are namespaces, so here they are nothing but containers. So we need to create a container over here. So let's quickly create a namespace. So before using any services, we must have a resource group. So if you already have a resource group, then you can use it, or you can create a new resource group. So let's quickly create a new resource group. So let's name it as Service Bus Demo 1. Okay, so this is our resource group. Now what do we need to do is to give our namespace name. So
let's name it as well. Let's name it Service Bus Demo 1. Okay, it shows it already exists. Let's add a few more details. Okay, now as you can see, it has been checklisted, and now you can choose your locations as per your requirement. So I'll just choose West US, and now it comes to our pricing tier. So here, as you can see, there are available pricing tiers. So as you can see here, it is premium, standard, basic. So in basic, we might not get all the requirements or all the features which we might require while using our services. So we'll go ahead with the standards, as premium requires some of the amounts. We need to pay some amount so that we can get an access to all those features. So here we'll be choosing standard. Once you create your namespace and choose your location and your pricing tier, we'll just move on ahead. So here we'll be keeping everything in default, and let's review and create. So as you can see here, it is validating all the details, and once it is validated, then we can create the service bus. So our validation is succeeded. Now we'll just quickly create it. As you can see here, it has been initialized. It will take a minute or two, like it won't take that much long, but yeah, it will get started to deploy. So yeah, here our service bus has been created, and now it is showing deployment is in progress. So this might take some time. So as I said, here I'll be using the Python programming. So every one of us know it is quite easy to use. So whereas you can use any other programming languages or other packages like NuGet package, or to like work on with the Azure Service Bus. So here first we'll be seeing how do we send messages into the queue, and then we'll see how do we receive messages from the queue. Now what do we need to do is go to our resource. Once you land here, you can see the overview of your service bus. So you can see in under which resource group it is being located, and what is the status, location, and your subscriptions and your pricing tier, everything. Now our next step is to create a queue. So as you can see, we have no queues over here. So you can come to these entities and you can just select queue, and from here we can create a new queue. So let's just create a new queue. So here also we need to give a name to the queue. So let's name it as Service Bus Demo 1 queue. Sounds good. And here, as you can see, your maximum queue size is 1 GB. So it has been given as a default. Whereas you can change your maximum queue size based on your requirements, and you also have the maximum delivery count. So here the maximum delivery count is your number of, like, how many times you can send the messages or you can process the messages. So here, as you can see, you have a value range from 1 to 2000. So here the default value will keep it as 10, and rest is your message time being live, so it has been kept for 14 days. So let's keep it as it is. We'll keep everything as default, and let's quickly create. So here you can see your service bus demo queue has been created. So if we'll just click into it, you can just see the overview of the queue. So here you can get to know how many messages have been sent, or either it has been scheduled or not. So now that we have created a service bus, we have also created the queue. Now our next step is to create a program so that we can send messages into the queue. So first let us create a folder so that we can store all our programming files into it. So as you can see, I have created a folder as Azure Service Bus. So here what do? I'll store all my Python programming code files so that it is easy for me to locate. So now what do we do is open a notepad. Alright. Now here we'll be writing a code to send the messages into the queue. So as I said, we'll be using the Python language to work on with the Azure services. We'll be like writing the code in Python. So for that, make sure you have the higher version of Python installed in your system, so that you can even install the packages when we need to import it. So let's quickly open our command and let's see what is our Python version. So as you can see here, we'll just check our Python version. So as you can see, this is the latest version of our Python. So make sure you have the latest version of Python so that it is easy for you to work on with the codes, and as well as your process goes very smoothly. As we have our Python installed in our system, now it is time to install the packages for Azure Service Bus. Here we'll install the Azure Service Bus client library for Python so that we can create a connections which will help us to send the messages and receive the messages. So let's quickly install our package first. Pip install Azure Service Bus. Alright, so I've written a wrong code. So we'll just correct it and we'll hit enter. So this is the command for installing the packages. So here it shows that my packages are already existing. So previously I had already installed my packages. So it is available, as you can see here, the version of the package is already available. Now what do we need to do is start. So now what do we need to do is write a Python program so that we can send the message. So first thing is to create an import statement. So this means you are importing the Azure Service Bus package. So from Azure Service Bus import. So here we'll be importing the client as well as the service bus message. Now that we have imported our Azure Service Bus, so now here we'll be mentioning our connection strings and our queue name. So str is equal to, here we'll be mentioning our connection string. So what is a connection string over here? So as we go to our Azure portal and we'll go to our service bus. So here, once you create a queue, we need to authenticate that particular sender so that they can send the messages into the queue. So here we'll be mentioning the namespace connection string so that the sender, whatever message he wants to send into the queue, it can go through these connection string. So we'll click on to this root manage shared access. So as you can see here, you can either manage, send and listen. You have all the three process to it. So we'll just copy the primary connection string. You can use the secondary connection string only if your primary connection string doesn't work. So we'll copy this primary connection string and we'll paste it in our code. Alright, so once that is done, now we need to mention our queue name. So our queue name was Service Bus Demo 1 queue. Alright, it has come into caps lock. We need to change the case. Service Bus Demo 1 queue. Alright, so this was a queue name which we had created. Now the next step is we need to add the method. So we need to create a message so that we can send the message into the queue. So here we'll be adding a method to send a single message. So here the sender is an object that acts as a client for the queue that you have created. So let's quickly create a method. So def send single message. So here we'll be mentioning the object that is a sender. Alright, I hope this is clear now. So now as you can see over here, we imported our we have imported our package into the code, and then we create a connection string and we mentioned the connection string over here and the name of the queue which we have created. Now what do we need to do is to create a method. So here we'll be sending a single message. Now we need to create a service bus message. So how do we create that? Is message is equal to service bus message. So as it is a single message, so we'll be mentioning here as single message. Now this message has to be sent to our queue. For that, we'll use our object, that is sender dot send message. Now we'll mention the message that we have created, and there we'll print it as sent a single message. So this was for this was a method to send a single message. Like this, we can also send a list of messages or a batch of messages where we can give the value of how many times the message has to go. So let's quickly add those methods too. So def send a list of messages. We'll mention our object, that is sender, and then we'll have the same code over here. So we'll just copy paste and we'll change the values. Here as we are sending the messages in list, so we'll write it as message in list, and we'll mention the range till how many range it has to go. So for range 5. Okay, I need to add this square bracket. All right. Now we'll change a statement, that is sent a list of 5 messages. All right. So now that we have created the list of messages, now let's create a batch of messages. For that, now let's first define our method, that is send batch of messages, and we'll mention our sender. And now we need to create the batch of message. For that, we'll write batch messages is equal to sender dot create message batch. So this is the method that we are creating over here. Now we need to provide a range that how many messages can be sent. So as I had mentioned before in the list of messages, here we'll be mentioning in a range of, let's take 10, and then now we need to add messages into the batch. For that, we'll batch message dot add message. Now we'll mention our service bus message. Now in this, we'll write messages inside a service bus message. Now we'll write a following code: except value error break. Now that we have created our batch message, we have added the messages into the batch. Now we need to send this batch message into the queue. For that, we will write sender dot send message batch message, and then we'll write a statement, that is sent a batch of 10 messages. Now that we have added the methods, now we need to create a service bus client and then a queue sender object to send these messages. So let's quickly create that. So first we'll be creating a service bus client using the connection string. So for that, we'll type service bus client is equal to service bus client from connection string. And now we'll mention the connection string which we had mentioned above. So connection str is equal to and logging enable is equal to true. So we are giving them the access. Now with this service client, we're gonna get the queue sender object to send the message to the queue. So let's write that with service bus client sender is equal to service bus client dot get queue sender. And now here we'll mention the queue name which we had created. So queue name is equal to queue name. After this, now we need to send the three types of messages, that is single, list, and the batch. So for that, we need to write with sender send single. So here we'll be mentioning the methods which we had created. So here let's quickly create all of them. We'll just copy this and we'll paste it and we'll change the method name. And lastly, we'll just mention it done sending messages. Alright, so this was a code for sending the messages into the queue. Now let's quickly save it. So we'll save it in our Azure Service Bus folder itself. So let's name it as send queue message, or we can just write it as queue send message and dot py as it is a Python program, and we'll save it. All right. So this is our whole code, that is to send the messages into our queue. So let's quickly move to our command prompt. So let's see in our folder whether it has been there created or no. So here, as you can see, it is a Python program has been created. Now what do we need to do is go back to our command prompt, and now let's run our program. So as you can see, the program has been run successfully. Your output has come: send the single message, the list of 5 messages, send a batch of 10 messages. So now let's quickly move to our Azure portal and check whether the messages has been sent or no. So we'll go to our service bus and we'll go to our queues. Alright, so as you can see, previously we had no active messages, that was 0 messages. Now we have 16 active messages. Now as this means your messages has been sent into the queue. Now if you want to see these messages, like what messages are being sent over here, so we'll go to our service bus explorer. So here we can do all the 3 processes, that is see or peek the messages, receive the messages, and send the messages. So currently we are in peek mode, so we'll go peek from start. And now as you can see here, there are almost 16 messages over here. Now you can select any one message and see it is a single message. Now let's move on to our different topic. So this one is message in list. Let's try our different? Okay, so here it is shown. Whatever we had written into our code, it is being shown over here. So this was our message inside a service bus message batch. So we can see here it is shown. And you can also count the number of the range what we had given over here. So for a batch, we had given up to range 10. So let's count 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. Let's see. Okay, so we have 10 messages like that, and we have 5 messages of list. So this is how you can see your messages from the queue. Now we got to know how to send messages into the queue. Now it's time to receive the messages from the queue. So for that, we'll go back to our notepad. Now we'll just open a new file, and here we'll write a code for receiving a message. So on our previous program, we had created a code in which we had added methods for sending the messages into the queue. Now what do we need to do is to receive all these messages from the same queue. For that, we'll just copy the upper code, that is our from the Azure package, the connection string and the queues, and we'll just paste it over here. And then we'll also mention our service bus client, that is which we had used to, like where we had created a service bus client so that we can send these messages. Now after this, what do is we write a code for receiving these messages. So let's quickly write the code. We'll mention our queue name, and we'll define a maximum wait time for it. So let's define maximum wait time is equal to 5. And now with receiver, we'll receive the message. So for message in receiver, print received, and we'll mention the message. Now receiver dot complete message, and we'll mention the object. So here we mention this command is to like complete the message so that the message is removed from the queue. So once the receiver receives the messages, so there won't be messages available inside the queue. So this is the whole code. Now let's save it. We'll mention it as queue receive message.py, and let's move on to our command prompt, and let's clear everything, and now let's run the program. So as you can see, all your messages are being received from the queue. Alright, so here you can get the notification received message in list, received single message. So all these messages are received by the receiver. Now let's quickly go back to our Azure portal and quickly check whether the messages are still there or no. So we'll go back to our queue and let's check. Alright, now as you can see here, we don't have any messages now. This is because the receiver has received all the messages from the queue. So this is how we send and receive messages through queue. Now let's quickly move on to our next part of the hands-on, in which we'll see how to push and pull messages by topics and subscriptions. So in this also we'll be using the Python program to send messages to a service bus topic and then receive messages from a subscription to that particular topic. So it is quite simple scenario of sending a batch of messages or a single message or a list of message to the topics, and then we'll receive those messages from the subscription that we have assigned under that particular topic. So for that, first let us create a new topic. So let's quickly go to our portal. So we'll follow the same step. We'll go to the Azure Service Bus. So anytime when like while creating a queue or a topic, first thing is to create a namespace, and then we can add on the multiple queues and topics under it. So let's quickly create a new namespace. Now we'll follow the same step. We'll give a resource group name. So service bus demo. And now we'll give a name to our namespace. So service bus demo. All right. So let's change this name. Okay. So as I said, you can choose any locations as per your requirement. And then we'll come to our pricing tiers. So we'll select standard, and then we'll quickly create. Okay, so our validation is succeeded. Now let's create it. Alright, so our deployment is complete. So we'll quickly go to our resource, and now we'll go to our topics. So previously we had selected queues. Now we'll select topic, and now we need to add a new topic. So let's quickly create one. So how did, like in previous hands-on, how we had created the queue, so in the same way we'll be creating our topic. So let's give a name to it, service bus topic. And as we know, maximum topic size will be 1 GB, and the messaging time to live is till 14 days. So let's keep it as default. Let's quickly create. Okay, now we need to create our subscriptions as well. So we'll go under this topic and we'll create our subscriptions. So we'll quickly go to our subscription section and we'll create a new subscription. Now we'll click on subscription, and here we'll mention the name, service bus sub, and the maximum delivery count. So as I said, the default maximum delivery count is 10, whereas you can change your delivery counts if you have a value of ranging from 1 to 2000, so you can take up to that. So rest other things would be kept default, and let's quickly create. All right, so our topics are created and our subscription has also been created. Now let's quickly open our notepad. All right, so here we'll be writing our Python code so that we can send messages into the topic. So as usual, first we'll write the import package code. So our import package code is from Azure Service Bus, import service bus client, comma, service bus message. All right. Okay. Now we need to add our following constants, that is our connection string, topic name, and our subscription name. So let's quickly write that. Connection string is equal to. So first let's write the code, then we'll add on all our values to it. Topic name, subscription name is equal to. Alright, so first we'll copy our connection string. That how do we go? We'll go to our Azure Service Bus demo, and we'll come here to shared access policy, and from here we'll copy our primary connection string. Now let's paste it. After that, our topic name. So our topic name was service bus topic, and our subscription name was service bus sub. Alright, now that we have given our constants, now let's quickly add our methods. So like before, how we had sent a single message, then a list of message, and then a batch of message. So let's quickly add the methods now. So def send single message. Now we'll create a service bus message. So message is equal to service bus message, and here you can specify your message. So let's write hello, and then we'll send. Now to send this message to the topic, so we'll specify sender dot send message, that is our message what we are, that is hello. So we'll be sending that messages to our topics. Now we'll print we'll just check our indentations. Alright, now that we have added our single message method, now let's add a list of messages. So def send list of messages sender. Now we need to create a list of messages. So how do we create? Is message is equal to square bracket service bus message hello, how are you doing? So you can type down any message of your choice. It's just for an example. And then we'll specify a range. So for in range, so here we'll specify, let's say 6, and then we need to send this message to our topic. So sender dot send messages. Now we'll create the same for our batch of messages. So let's quickly create that. So what did we do now? We have created a batch message, and now in this we'll add messages into the batch. So now we'll just complete this method. So here we'll add a break so that the service batch object reaches a maximum size, and then you can create a new service bus batch object to send more data. Break. Alright. Now we send the message to our topic. The sender dot send messages dot batch messages print. Now we'll specify send a batch of 10 messages. Alright. Now that we have added the methods, now it's time to create a service bus client and then a topic sender object to send these messages. So let's go down, and first thing we'll create a service bus client. Service bus client is equal to service bus client dot from connection string. So here we'll specify the constant that we had specified up, as you can see here. So we just need to call it over here. So connection string is equal to connection name. Now after this we'll get a topic sender object to send the messages to the object. So as we had specified here the sender object, so we'll create one over here. So sender is equal to service bus spacebar client dot get topic sender, and now we'll specify the topic name. Alright, now next thing we need to send all the messages, that is single list of messages and batch first. So for that with sender. Now we're going to call all the methods over here. Send single message, sender, send a list of messages, and then our batch message. All right. Lastly, we'll just print done sending messages. Now we're gonna save this. So service will go to our previous folder, that was Azure Service Bus. So service bus topics, and now we're going .py. Now we'll save it. So this is the whole code where we used to send the messages into the topic. Now let's quickly move on to our command prompt. Now let's run our Python code. So as you can see, our messages have been sent successfully. Now let's quickly move on to our Azure portal and let's go to topics. Let's check whether the messages have gone or no. Alright, now we'll just enter our subscriptions, and here as you can see we have 32 messages. Alright, now if we just go to our Service Bus Explorer, we are able to see the messages what has been sent into the queue. So let's go to peek from start. Now you can see here single message, messages in list. So these were the previous messages. Now you can see over here, hello, how are you doing? This shows that the messages have been successfully sent into the topic. Now we'll see how do we receive these messages from the topic. Now let's go to our notepad. Now let's quickly open our new notepad. So we'll go by control new, and now let's write the code for receiving the messages. So we will just copy the previous few codes. So we'll just open this. So here we need to import our packages first and the connection string. So we'll just copy and paste it. And now what do we need to do is to take this service bus client and we'll paste this. And now we need to write the code for receiving messages. So it's very simple code. Here we need to get the subscription receiver object for the subscription. So as we discussed that the receivers will receive their messages from through the subscription. So we need to create a receiver object and then we'll complete the messages so that the message is removed from there. So it means like once the receiver receives the messages, the topics and subscription will get emptied. So there won't be any messages left. So let's quickly write a code. So with service bus client, now here we'll mention our topic name. So let's quickly mention is equal to, and here also we'll also describe our subscription name as the receiver will receive from the subscriptions. So let's quickly mention that. And we'll specify the maximum wait time. Let's give it 5. So it means that this code continuously receives the new messages until it doesn't receive any new messages for 5 seconds. All right. So now let's complete the messages. So with receiver for message in receiver, and now we'll specify print received, and now we'll add the message str message. receiver dot complete message. So this is the whole code for receiving the message. So let's quickly save this. Alright, so let's mention it. Service bus subscription dot py. So this is the whole code that we'll write to receive the messages. Now let's quickly run our code. Alright, so here you can see that we have received the messages. So all our messages have been received by the subscriber. Okay, now let's quickly move on to our Azure portal, and now let's refresh this. So here you can see now no messages are left in the subscription because all the subscribers have received the messages. So this is how we send and receive messages through topics and subscriptions. So in queues, the sender used to send the messages into the queue, and from there the receivers used to receive the messages one by one. Whereas in topics, the sender sends the messages into the topic, but unless and until we subscribe, we are not able to access any of the messages. So once we create a subscription and we have number of subscribers, then we can receive all the messages from the topics.
Let us see what are the top companies using this cloud service providers. First, talking about AWS, its services are used by top companies like Netflix, Coca-Cola, McDonald's, Unilever, ESPN, and Adobe. Next, coming to Azure, it is used by many Fortune 500 companies. And some of the companies which use Microsoft Azure clouds are Samsung, HP, BMW, FedEx, and Pixar Animated Studio. Moving on to GCP, the top companies who use their services are PayPal, Twitter, 20th Century Fox, P&G, and King Digital Entertainment. Now that we have seen what are the top companies which use these cloud service providers, let us compare them based on the compute services. Compute services are one of the core services when it comes to cloud computing. Compute services helps to create instances of virtual machines in minute and also scale up instances instantly if needed. So in today's session, we're going to compare these three cloud service providers based on the compute service and storage service. The primary compute service for AWS is Amazon EC2. The primary compute service for Azure is Azure Virtual Machine. And for GCP is Google Compute Engine. Now all the three services are equally powerful but unique in their own way. Each one has its own advantages and disadvantages. Like Amazon EC2 has 99.5% of the annual uptime and can be tailored with variety of options according to users' requirements. On the other hand, Azure Virtual Machines provides enhanced security and hybrid cloud capabilities. But when you compare the cost, Azure instances tend to get costlier as the compute size increases. Next, talking about Google Compute Engine, they're comparatively cheaper, they come with a persistent disk storage and provide consistent performance. Next, talking about the storage services, AWS offers a variety of storage options like S3 for object storage, EBS for block storage, EFS for file storage, and a few other storage services. Next, talking about Azure Cloud Storage, this also includes object, file, disk, queue, and table storage. They also have specialized services for data-rich applications and many data backup services. Now talking about GCP Cloud Storage, they have a fewer storage as compared to the other two, but they are more targeted. For object storage, GCP offers cloud storage. It offers persistent disk for block storage to be used with virtual machine and file storage for storing the files. For backing up your data, AWS provides a service called as AWS Glacier and Azure provides a service called as Azure Backup, but Google does not yet have any backup services. Next, let us compare these three cloud service providers according to their pricing. Now, all the three cloud service providers offer a pay-as-you-go structure, which means you only pay for the services you use. Now, pricing would vary for different services. Like for compute services, one cloud service provider could be cheaper, but it could be costlier for database services, and so on. So just to give you a general overview of the pricing, among the three cloud service providers, GCP offers a slightly cheaper pricing model and has a flexible cost control, which allows you to try the different services and features. AWS charges you on an hourly basis,
whereas Azure charges you on a per minute basis and GCP provides per second billing for its resources. When it comes to a short-term subscription plan, Google Cloud and Azure gives you a lot more flexibility. But in certain services, Azure tends to be costlier when the architecture starts scaling up.
Today, nearly 80% of all business solutions and services have moved to the cloud. Most of the projects are happening by utilizing cloud platforms, which include software as a service, infrastructure as a service, and platform as a service. With projects being hosted on the cloud architecture, it makes perfect sense to utilize DevOps solutions to continuously deliver value for enterprises. Building upon that, we have the Microsoft AZ400 exam, or the Microsoft Certified DevOps Engineer Expert. But what is the AZ400 exam? As described by Microsoft, AZ400 certification training is an intermediate level course from Microsoft for professionals who want to gain knowledge of designing and implementing DevOps processes and practices for an enterprise. This 5-day AZ400 training course is ideal for professionals who combine people, processes, and technologies to deliver value to the organization. Some of the skills that are outlined by this curriculum include developing an instrumentation strategy, which carries a weightage of about 5 to 10%, developing an SRE strategy, which again carries a weightage of 5 to 10%. Then you have development of a security and compliance plan, which carries the weightage of 10 to 15%, as well as managing source control, which has the same weightage. Apart from that, you also learn how to facilitate communication and collaboration between your teammates, stakeholders, and vendors, and define and implement continuous integration or CI, which has the majority of the weightage, which is about 20 to 25%. And finally, you learn how to define and implement a continuous delivery and release management strategy, which again carries a weightage of 10 to 15%. Now, this is the entire skill set. But before you get ready to take on the world with your newly certified skill set, a candidate for this exam must be familiar with both Azure administration and development and must be an expert in at least one of these areas. There is only one prerequisite for taking this exam, and that is, as a candidate, you must have cleared either the AZ-104 or the AZ-203 exam. Furthermore, there are other prerequisites that you should keep in mind before appearing for the AZ-400 exam. Now, even though these are not mandatory prerequisites, these are the ones which can improve your chances of qualifying the exam, such as proficiency in agile practices, the ability for designing and implementing DevOps practices for version control, configuration management, build compliance, release, and testing, all of this by leveraging Azure technologies. Now that you know how you can qualify to give this exam, let's go ahead and look at who is this exam most beneficial for, or who can take up AZ400. First of all, this course is designed for professionals who are aspiring to clear the Microsoft Certified DevOps Engineer Expert exam, right? So individuals looking to establish their credibility and value in the market as experienced DevOps practitioners, agile practitioners, and cloud computing professionals. Apart from that, this course is also meant for system administrators, software developers, project managers, and technical leads, and practically anybody that wishes or aspires to lead a DevOps team. So now that you understand who can take up this exam, the main question arises, why should you take this exam? What are the benefits of taking the AZ400 examination? Now, the DevOps market is expected to grow from $3.42 billion in 2018 and 19 to $10.3 billion by 2023 at a compound annual growth rate of nearly 25%, which means this industry is going to grow more than threefold in the next few years alone. Out of which Azure holds 19% of the total global cloud infrastructure market, which automatically qualifies you for a majority of the MNCs in the industry today. Not just that, this also has proven to give you a huge boost in your salary as a mid-level Azure DevOps engineer earns on an average of $145,000 per year, whereas a senior level Azure DevOps engineer can make up to $185,000 per year. Apart from that, the Azure infrastructure is very ideal for DevOps, which is why a lot of companies are quickly moving to DevOps, which makes you a front runner in the race for all of these companies. Now, talking of companies, here are a few aggressively hiring for Azure certified DevOps professionals, including but not limited to Amazon, Ernst & Young, Dell, Accenture, Microsoft, Google, and VMware. Now that you know what all is there in store for you, I'm sure you're curious to know what does the curriculum outline look like. So here it is. First of all, you shall be introduced to Azure DevOps and understand the important aspects of Azure as well as DevOps. Along with this, you also learn the role of a DevOps professional in an organization. Then you learn about implementing continuous integration, followed by building containers with Azure DevOps, where you learn to create and deploy a multi-container application for your DevOps pipeline. Followed by that, you learn how to design a dependency management strategy as well as managing artifact versioning. Next up, you learn how to set up a release management workflow where you learn how to configure a CI/CD pipeline using YAML and manage your secrets using the Azure Vault. Followed by which you implement deployment models and services where you configure infrastructure as a service and platform as a service on Azure. Followed by which you learn how to implement and optimize a continuous feedback mechanism. Next is the meaty part where you learn a bunch of different Azure tools for infrastructure configuration as well as a few third-party tools. And finally, you learn how to implement compliance and security, where you learn how to manage and check code quality with Sonar Cloud on Azure DevOps. You also learn how to integrate Azure Key Vault with Azure DevOps to access secrets in the Azure pipeline. And that was all about the course outline of the AZ400 curriculum. This certification exam not just enhances your skills as well as demonstrates it to your employers, thus making you gain that edge in the industry. The time is right to upskill. And DevOps and cloud are two of the biggest domains in the industry to take advantage of the career opportunities that come your way.
What is Microsoft Azure certification? Azure certification is a level of Microsoft cloud expertise that an individual obtains after passing the certification exam. Azure certification validates an individual cloud expertise and skills. Now, talking about some of the benefits of Azure certification. The first one is you stay ahead of the crowd. An Azure certification will validate your cloud skills in a selected domain. You will earn the credibility and your present or future employer will know for sure that you've worked on Azure and you have the skills as you mentioned in your resume. The next benefit is higher salary package. BusinessWire has estimated that Azure core certification have raised their wages by 20 to 40%. Payscale.com also announced that based on the position and job description, those credited by Microsoft Azure could get a salary of $128,000 annually. The next benefit is it offers a flexible career. A Microsoft Azure certification enables you to pursue a wide range of career options. You can become a cloud architect, a developer, or a system admin, and many more. In addition to this, the certification enables you to work with various industries at different locations. The fourth benefit is it acts as a proof of commitment. An Azure certification proves that you're able to commit. To get a certification, you have to sign up for a course, study, and then pass the exam. This simply implies that you can commit your time and resources towards achieving a goal, and that you're dedicated to improving your career objectives in the long term. So these were some of the benefits of Azure certification. Now let us move on to the main topic for today and understand what exactly is Azure Fundamental Certification. Azure Fundamental Certification, or AZ900, is intended for candidates who are just beginning to work with cloud-based solutions and services or who are new to Microsoft Azure. This certification is a basic certification. It is intended for individuals who just want an entry-level job in Azure and do not want to get in-depth into Microsoft Azure. And according to Glassdoor, the average salary for a Microsoft Azure Fundamental Certified candidate is about $110,000 per annum. This certification can also be the stepping stone for other certification in Microsoft Azure. With this certification, you can prove knowledge of cloud concepts, Azure Services, Azure workloads, security and privacy in Azure, as well as Azure Pricing and support. To write the certification exam, you should be familiar with the general technology concepts, including concepts of networking, storage, compute, application support, and application development. So this was just a brief introduction to Azure Fundamental Certification. Now let us talk about the skills measured while writing the certification exam. Firstly, you should be able to describe the cloud concepts and also know about core Azure services. Next, you should be able to describe core solutions and management tools on Azure. Then you should be able to describe the general security and the network security features in Microsoft Azure. Moving on, you should also be able to describe the identity, governance, privacy, and compliance features in Azure. And then finally, you should be able to describe the Azure cost management and service legal agreements. So in the certification examination, your skills on all these topics are measured. So in order to pass the examination, you need to have knowledge about all these topics. Now let us move on to the next topic and talk about the certification exam guide. So first, talking about the exam format and question types, Microsoft continuously introduces innovative testing technologies and question types. Your exam might contain questions like multiple choices, repeated answer choices, short answers, mock review, drag and drops, and so on. Next, the examination duration is 45 minutes, but the seat duration is 65 minutes in total. Next, the cost for this examination in the United States is $99 and in India it is around 3,600 rupees. Now talking about the languages in which you can write the certification exam, you can write this in either English or Chinese, Korean, Japanese, Spanish, German, and 6 other languages. This is the only certification exam in Azure which you can write in so many languages. Now let us take a look at the topics from which the questions will be asked in the certification examination. The first topic is from cloud concepts, where 20 to 25% of the questions are asked in the examination. Next, you need to describe core Azure services, and from this topic, somewhere around 15 to 20% of the questions are asked. Next, you need to describe core solution and management tools on Azure. And from this section, 10 to 15% of the questions are asked. Moving on, you should describe general security and the network security features, from which 10 to 15% of the questions are asked. Next, you should be able to describe the identity, governance, privacy, and the compliance features, from which 20 to 25% of the questions are asked. And finally, you should be able to describe Azure cost management and service level agreements, from which 10 to 15% of the questions are asked. All this is mentioned in the certification exam guide. To go to the certification exam guide, just go to your Microsoft certification page that you can find the Azure Fundamental Certification. And when you click on that, they will have an option to download the exam guide. So this was about the Azure Fundamental Certification exam guide. Now let us move on to a final topic for today and see how you can prepare for the certification. The first thing you should do for preparing for the exam is to see what is asked during the exam. So to understand that, study the certification exam guide thoroughly. Now every Microsoft certification exam page has the skill measured in its exam guide. The list is usually very accurate and helps you focus and study the right content. The page also has some training and courses to prepare you for the certification. Also understand the different question types which will help you prepare for the certification. The next step is to understand some of the basic concepts like what is cloud computing and the various services and deployment models in cloud computing. Learn the architecture and a few important service domains such as compute, storage, databases, networking, and security. You need to basically learn all the topics mentioned in the exam guide. After you learn all these topics, the best way to pass the Microsoft Azure exam is through real hands-on experience with the technology. By Microsoft gives you some free hands-on learning modules. You can practice there, and there is also Azure free trial account. The Azure free trial account will provide you with 12 months of free Azure services. Not all the services, but some of the prominent services will be free for you to use. You can hands-on practice what you have learned in the previous steps using the free trial account. The next step which will help you prepare for the certification is by reading the Microsoft documents. Read the Microsoft Azure documentation so you will understand the topics better which will come in the examination. As I mentioned before, read the skills measured on the exam page, look up to the specified Microsoft document page and read them thoroughly and try out in the tutorials. Also, read some books from Microsoft Press. Now, these are some of the tips which will help you prepare for the Azure Fundamental Certification examination.
Why should you actually go ahead and become a data engineer? So alright guys, so you must have heard about data scientists or a data analyst, right? Now the core of their job is to basically work on data. Now data engineer are people who basically avail this data, which has to be worked on to data scientists or a data analyst, right? So if you think about any company which basically has to have a data scientist or a data analyst will need a data engineer in the team, right? Now talking about that, or if you talk about the data engineer profile, now according to a tech job report by 2028, the number of jobs involving data will rise by 12% according to the Bureau of Labor Statistics, and more than 5,46,200 new roles related to big data will result from this. Now, you must have heard that being a data scientist is probably the next go-to of the 21st century. But understand this, guys, without data engineering, there is no data science. That is why the numbers speaks for themselves. Hence, the data engineering job is basically one of the fastest growing jobs. Now, even in 2023, there is going to be a huge jump in the number of jobs opening. The reason being a lot of things, a lot of businesses have basically gone online in the past years because of the pandemic. Now, there are several reasons why organization may choose to hire an Azure data engineer or why an individual may choose to pursue a career as an Azure data engineer. So the first reason being its high demand. So what I meant by that is as an organization increasingly rely on data to drive business decision, there is a high demand for professionals who are skilled in designing and implementing data management solution. Now, according to Microsoft, the demand for an Azure data engineer has increased by over 100% in the past years. So the second reason being its strong earning potential. Now, an Azure data engineer are in high demands, right? So which often translate into what? Into a strong earning potential. Now, according to the Glassdoor, the median salary of an Azure data engineer in the United States is anywhere around $120,000 to $133,000 per annum. And the third reason being career growth opportunities. Now, as you all know, the role of an Azure data engineer provide opportunities for career growth as individual can advance to positions such as data architect or a data scientist, right? Now, the fourth reason is Azure is a leading cloud platform. Now, what I mean by that is Azure is a leading cloud platform with a growing number of organizations using it to store and manage data. Now, as an Azure data engineer, you will have the opportunity to work with the latest technologies and gain valuable experience that is in high demand in the job market. Now, the fifth and the last reason being its flexibility. Now, as an Azure data engineer, you can work in a variety of industry, giving them the opportunity to choose a career path that aligns with their interests and goals. This is where you come and work in a variety of roles, including full-time or as a freelancing position. Now, as you can say, overall, becoming an Azure data engineer can provide individual with a rewarding career path that offers a strong earning potential, career growth opportunity, and the chance to work with the latest technology in a flexible and dynamic environment. Now that you have understand that why data engineering can be the next big thing in the coming job world, now let's go ahead and understand who is a data engineer exactly and what does he do. Alright, so guys, a data engineer are basically not only responsible for giving the data to the data scientist or to the data analyst. Now, they basically have a generalist role where they have to do most of the jobs that probably a data scientist or a data analyst also has to do. So the first job that they have to basically understand is they will get the requirement from the data scientist that this is the kind of data they need, and now they have to figure on the internet how they can find that data. Now, once they found the data, they will have to create a process, right? Now, on how the data can be brought to their own platform and make it basically ready for the data scientist to use, right? So you can say that they have a job of managing and organizing the data that basically will be looked upon by the data scientist and basically help him to find out the trends and other things which can help a company to improve its current business and opportunities. Okay. Now, secondly, talking or pinpointing the exact role that are data, it is basically divided into three types of data engineers, right? Now, there are people who are generally called as a data engineer. Now, when we say that, there are people who basically not only does the data engineer work, but also have their roles and responsibility coincide with the data scientist and a data analyst also, which he also does, right? For example, people who are a data engineer, they will also have to do the job of a data scientist. Now, they will also do the job of a data analyst, and they are usually people who are at a very high or senior profiles, and they basically have to wear multiple hats, right? So, say for example, let's say once again, let's say you introduce a new data team in a company. Now, that data team is still in a very nascent stage, right? So, probably the person who has to set up the team initially will have to do all the work. Now, which is required to basically show the stakeholder that this team can actually work, right? And once it becomes successful, then he basically hires more people who can do more specific tasks, which are basically tasks that has been doing previously. Okay, so that's what a generalist data engineer does. Then you have people who are basically pipeline centric data engineer. Now that is people who basically have the job of setting up how to bring with the data, which is basically online or scraping of data from the web, then converting or transforming it into a useful manner or in a useful state, and then giving it to a data scientist so that he can consume the data. So this pipeline, which is created from the web to the point where a data scientist can use it, is basically called a pipeline for data. So guy who basically looks after this pipeline, or the data engineer who basically look only after this pipeline, is called the pipeline centric data engineer. Then the third kind of data engineer is database centric data engineer. Now in some companies they basically say we have all the data in a database. Now you check this data and then you figure out what can be used by a data scientist to make their job better, or through which these guys can actually go ahead and able to do their job. So in those cases you need to have the skills or expertise in that database which the company is using. And hence for him the job becomes a database entry, out of which he will have to create a pipeline, right? So these are the three kinds of a data engineer which are out there. And if we basically take a look out of it and define the jobs or responsibility of a data engineer, he is basically responsible for creating architectures which are related to data pipelines. He is the guy who will be aligning the architecture with the business requirement. He will be the guy who will be responsible for data acquisition. He will be the guy who will be developing processes through which he will be creating the data pipeline. Now he will also be making use of a lot of programming languages and tools to accomplish this. And he will also be the guy who will basically be responsible to further enhance the data, reliability, efficiency, and quality. So guys, these are the roles of a data engineer. And after this, I think you guys now have an idea about what a data engineer will do in his day-to-day life. Now let's move on and talk about what are the salaries, and followed by we shall also see the career opportunities which are there in becoming a data engineer. So let's go ahead and also understand the average salary of a data engineer. So in the US, the average salary of a data engineer is $133,000. But remember guys, this is basically an average salary, which basically means that there are people who are above this salary, or can even be a person who is below this salary. Okay. But later in this session, I'm also going to talk about some of the job description which can tell you the kind of salary that you can earn once you start applying for a data engineer profile. In India, the salary is around 6.5 lakhs per annum or 7 lakh per annum, and the same goes for an Indian jobs as well, that the salary can be higher than this average package or it can be lower than the package as well. Now that you have seen the basic or an average scale of a Azure data engineer, let's go ahead and see the job description of an Azure data engineer. Alright guys, so thinking again about what a data engineer does. An Azure data engineer is responsible for designing, implementing, and maintaining data management and data processing system on the Microsoft Azure cloud platform. Now they work with large and complex data sets and are responsible for ensuring that data is stored, processed, and secured efficiently and effectively. Now when you basically define a job role like that, you have many jobs description which are floating in the market, right? Now how can you identify which job description you have to apply to? Now let's go ahead and understand that. So talking about the job description which basically exists in the market guys, you will see a job description which is an entry level job description. And then on the next slide, I will show a job description which is a mid or a senior level job description. Alright. So heading back to the entry level. So if you see the first job description, which is an Azure data engineer, the salary is anywhere around 6 lakh per annum to 14 lakhs per annum. And these are the skills that you require. Now, as I mentioned before, these are the expected skills required for an Azure data engineer. Now, what are the skills which are expected? Now, you are expected to know NoSQL or a Cosmos database skill. Now, they are expected to know data lake, data factory, data warehouse, and strong experience in building pipelines in Azure Data or an Azure Data Lake. Then you should be able to analyze and understand complex data. You should be able to understand business requirement and actively provides input from data perspective. Now, at the same time, if you look at these skill sets, These skill sets are all the skills at which you will basically know after you study for or clear the Azure Data Engineer certification. So once you're done with the certification, once you are done with the skill sets, which is just there in the certification, you can easily go ahead and apply for a job that lies in the salary range, which is for an Azure Data Engineer. Now, talking about a mid-senior level data engineer profile, the list is quite long, as you can see. Now you can see that over here, apart from all these skill sets, a lot of other things are also mentioned here as well. For example, you should have some 4 or 5+ years of experience in implementing or designing solution using Azure Big Data technologies. Then you should have an experience with an hands-on in Azure Data Factory, Azure DevOps, Azure Data Lake Storage, etc. Now you should have a knowledge of big data pipeline, then design and build modern data pipelines and maintain the data warehouse schematics, layouts, architecture, and relational or non-relational database for data access and advanced analytics. Now you should also know Java, jQuery, SQL or Scala or any preferred programming language, right? So over here, what we recommend to our learners is you should go ahead and learn Python, because although they have mentioned only these programming language, but companies are very much flexible. Now, if the target profile has any programming experience, but a strong one in any of the programming languages, right? Next thing that they expect you to know is advanced skill using one or most common language, for example, like Python, Batch, etc. So this Python will basically serve as a dual purpose, that is all a scripting language and a programming language as well. The next thing that they expect you to know is the ETL process using big data technologies such as Spark, Kafka, Hadoop, and others. Now, the next thing that they expect you to know is the ETL process using big data technologies such as Spark, Kafka, Hadoops, and others. And then you need to understand the data visualization experience using Python. Python here is a plus, guys, so you need to understand this. And then you actually need to learn Tableau or a Power BI. Any one of the tools or technology is a plus point. So you either have to have a skill on Tableau or a Power BI. So this again is an important skill to have, and this again coincide with what a data analyst does, right? Because he is also responsible for data visualization to some extent. Then you have a solid understanding and experience implementing cloud data platform in Microsoft Azure DevOps. So if you're a guy who wants to start off, you can start off with the fresher profile, and after having experience in the fresher profile and learn all the skill sets like big data, Azure, these are the skill sets that if you gain, you can actually apply to the senior or mid-level in particular. Okay, so guys, these are the few job descriptions which are related to the data engineer profile. Now that we are clear with why, who, and what are the career opportunities and salary of an Azure data engineer, we shall see the path towards becoming an Azure data engineer. So first of all, you will have to talk about the different Azure storage which are out there. Now you'll have to learn about these like the blob storage, table storage, file storage, and the queue storage. Now you will have to learn about the relational database options as well, which are there in the market, such as the SQL database, SQL DB warehouse, analysis services. Now you will also have to learn about NoSQL. You will have to learn about big data services in Azure like data lake analytics, data lake storage. Now you also have to learn about the data factories, Azure Functions, Stream Analytics, IoT hubs, event hubs, etc. Now apart from that, you will also need to learn Redis Cache and Azure Search. So these are the services that are basically required for you to understand in order to clear the certification and go ahead and become an Azure data engineer. Now these are also coincide with the job description that we had a look earlier, right? Now all the services which are mentioned there is basically a part of what you have learned in order to crack the certification. Now apart from this, we also recommend going through the open source services of Hadoop such as Spark, Hive, and the Hadoop itself, right? Now let us go step by step to reach our goal in becoming an Azure data engineer. So in order to become an Azure data engineer, you will also need to have a strong foundation in data engineering and cloud computing. Here are some steps you can take to develop the skills and knowledge needed for a career as an Azure data engineer. So the first one is learn the basics of data engineering. Now, in order to become an Azure data engineer, you should first develop a strong foundation in data engineering concepts such as data modeling, data pipelines, data processing, and data storage. Now, you can learn these concepts through online courses or books or by working on practical projects. Now the second is learning a programming language. Now as an Azure data engineer, you will need to proficient in at least one programming languages, as I've already mentioned earlier. Now Python is a very popular choice for data engineering, but you can also consider learning languages such as Java, C Sharp, or Scala. Now the next step is you need to learn an SQL. Now as a data engineer, you will be working with a large amount of data. You've already known that since the name itself, as an Azure data engineer. So you will need to be proficient in SQL to extract and transform data. Now the next thing you need to learn is Azure data storage options. Now as you know, Azure offers a range of data storage options such as Azure Blob Storage, Azure Data Lake Storage, Azure Cosmos DB, Azure SQL Database, and Azure Synapse Analytics, formerly SQL Database Warehouse. Now you should familiarize yourself with the features and capabilities of these storage options. Now the next thing you need to learn is Azure Data Processing Technologies. Now Azure provides several technologies for processing data such as Azure Stream Analytics, Azure Databricks, Azure Data Factory, and Azure HD Insights. You should learn how to use these technologies to build data pipelines for ingestion, transforming, and processing data. So the next thing you need to learn is Azure Data Management and Security. So you as an Azure data engineer should learn about the Azure tools for managing and securing data such as Azure Data Catalog, Azure Data Lake Security, and Azure Private Link. So what is the next step? The next step is get certified. As you know, getting certified is very crucial and it's very important in today's generation because all the organization, as I mentioned earlier, if I just have to go back in my slide, I will show you the job description where they have actually mentioned that you need to actually pass the certification. All right. This is the certification you required. That is a DP200 and a DP201. But as for now, you don't need DP200 or DP201. You only have to give one exam, which I'll be further talking about it. That is a DP203. Right, guys? So moving ahead again. So you need to earn an Azure Data Engineer Associate certification by passing the DP203 exam. Right? Now, what is the next thing you need to do is you need to gain practical experience. Now, the best way to learn Azure data engineering is by working on practical projects. Now, we all know this, right? Now, you can find data engineering projects on online platforms such as Kaggle, or you can work on projects in your own organization, or you can enroll with Edureka and they provide you tons and tons of live projects which are developed by the instructor who have already worked as a data engineer in their organization. Now, the next thing you need to learn is continue learning. Now, as a data engineer, you will need to keep your skills and knowledge up to date as technologies and best practices evolve, right? Now, making sure to stay current by learning about new Azure data engineering features and participating in professionals development activities. All right, guys? So now let us understand the things that you need to know about this certification that I've just talked about, that is your DP203. So guys, if you're applying for an Azure Data Engineer Associate, there used to be two exams that you have to give, which I've just mentioned now on the screen in the previous slide, right? One is implementing an Azure Data Solution, and the next exam is design an Azure Data Solution. Now, after clearing both these exams, it will give you the Azure Data Engineering Associate certification. And these two exams basically have the code, like I've mentioned, DP200 and DP201, right? But now this exam have been retired on 23rd February 2021. Now you guys just have to give one exam to clear the data engineer certification, and this exam is DP203. Now what they have done is they have clubbed both these exams and they have now included its syllabus in just one exam. They're asking questions from it, right? So earlier what you have to do is you have to pay for two exams, then prepare for two exams and give them, and then only you will get the certification. But now, just by passing one exam, you can clear out the data engineer certification, right? Now, as part of the new exams, now the skill sets have been updated, as you can see on the screen. So basically, these are the distribution of topics and they'll be covered in this exam. Now, first of all, you will be asked most of the questions on design and implement data storage. Now, this is going to have 40 to 45% of weightage, okay? Now I'm going to tell you what are the topics that comes under the design and implement data storage. So make sure you write it down, okay guys? So the first is design a data storage structure. Then the second is design a partitioning strategy. Then the next question is design the serving layer. Then you have the implement physical data storage structures, then implement logical data structure, and lastly implement the serving layer. Now after this, you will have design and develop data processing. Now this is of 25 to 30% weightage. Now there are 4 points coming under this design and develop data processing. Now the first is you need to learn about the ingest and transform data. Second is design and develop a batch processing solution. The third is design and develop a stream processing solution. And lastly, we have the manage batches and pipelines. All right. So coming to the third is design and implement data security, which is of 10 to 15%. So there are two main topics here, that is design security for data policies and standards, and the second is implement data security. Now talking about the last is you have the monitor and optimize data storage and data processing, which is again of 10 to 15%. Now even here also we have two main topics that you need to be covered, that is the monitor data storage and data processing, and the second is optimize and troubleshoot data storage and data processing. Now if you are with me till at this point, you shall have understood what are all the things that you have to learn in order to clear the exams and become an Azure data engineer, right? Since we have already discussed what are the path and what are the skills to learn to prepare ourselves, so like I said earlier, you now just have to give this DP203 exam to get the Microsoft Certification Associate Data Engineering certification. Okay, so just one exam and now you will get the certification for it.
So now when you talk about cloud computing, a lot of different people have different definitions of cloud computing. So now cloud computing is something which is not very new technology, I would say. I mean, the terminology is new, but the technology is not. The first product I would say which was talking about cloud was my Hotmail, which was designed and developed by Sabir Bhatia. So I'm sure a lot of people listening to this webinar would be aware of that particular name. So what he did was he designed a mail server. So in that particular mail server, I used to go ahead and access my mails, right? So that mail server was in the cloud, and then I was connecting to that mail server remotely to access my mails. So that makes it a cloud product, right? So now when you talk about cloud computing these days, the definition has changed. But as far as the working is concerned, it remains pretty much the same. So now when you talk about this, we talk about that we use and pay, right? So pay per use is the kind of model what we talk about. So we basically use and then pay only for that amount of, I would not say data, but I would say services which we use. So there's an explanation down there in the slide. It talks about, it is the use of servers on the internet to store, manage, and process data. The difference is instead of using your own servers, you're using somebody else's server to do the task and pay them for the amount of time for which you use them, right? So this is what the idea is. So pay per use is the model which we focus on when we talk about cloud computing these days, right? So this is what cloud is. This is what a basic definition of cloud is. If you search the internet, you will have more than, I guess, 100 plus definitions on cloud. Now, as far as definitions on cloud are concerned, it's up to you which one you would like to adapt and which one you would like to go with. But then it works with a single model, which is pay per use. So when you use, you pay. If you don't use, you don't pay. And end of day, you're using somebody else's resources. No, you're not using your own resources, and you're only paying for their resources, what you use. Okay. Now talking about different types of services, which we talk about as far as my cloud is concerned. So there are three major things what we talk about, which is IaaS, PaaS, and SaaS. And there are other things like somebody has talked about DAAS, database as a service. Then you talk about SaaS. So that is for my mails. But then majorly we categorize these into three types. One is IaaS, PaaS, and SaaS. So IaaS talks about infrastructure as a service, and you get the hardware in that from the cloud provider as a service. So say for example, you want to go ahead and deploy a machine, deploy a server. So basically when you talk about that particular scenario, you are basically putting a server in IaaS, which is my infrastructure as a service. So you get complete control on a virtual machine, which is there in the cloud hosted by Microsoft, Google, or AWS. And then you can just go ahead and put in your resources onto that particular machine. So this is how it works, right? Simple enough. Then you talk about PaaS, platform as a service. So in this, you don't get access to your machine, or in other words, you can say you don't get access to the underlying layer, but you get complete access to the resources or the services, right? So it's more like my platform on which you publish your applications or you put your application. There are a few examples. So I talk about my web apps, my mobile apps, which are in Azure. Then you talk about the last type of service offered in cloud. So this is my SaaS. So when you talk about SaaS, you get software as a service in Azure. So you don't need to worry about infrastructure. You don't need to worry about platform. So you basically are getting the end product, which may be running on the infrastructure, which may be running on the platform. So for example, when you launch a VM on Azure, if you talk about OS, you're not buying the OS. And if you talk about PAS, you're not buying the service. So you're just basically paying for the software which is running on either IaaS or either PAS. So this is what we get as far as my types of cloud is concerned. Now let's just jump on to another question. Now, what are the different cloud deployment models? So explanation talks about three models which we have. One is my public cloud, one is my private cloud, and one is my hybrid cloud. So let's just take this with examples. So I am a general user, I'm a home user. I want to go ahead and put a website. So I decide that my website will be hosted on my cloud, right? So I want to go ahead and deploy a VM on the cloud, and I want to put my website over there. So I go to Microsoft website, Azure website, I sign up there, and then maybe you can say provision a machine. Once I provision a machine, I put IaaS on top of it. Once I put IaaS on top of it, I will just go ahead and move my resources. When I say move my resources, move my application on the cloud. So what I'm trying to say is a general basic end user who is sitting at home can log into the cloud, get a machine, and then use a machine, right? So this is what my public cloud is. So it's available for the public, right? Then you talk about the private cloud. Now, as far as private cloud is concerned, it's owned by the enterprise, okay? And only enterprise people will have access to it. So organizations like Accenture, or maybe Wipro, or maybe Capgemini, Cognizant, so all these people own a private cloud, right? So the idea is that the resources are owned by them, and hence their people are the ones who will go ahead and access that. But then at times, what happens is they give access to their private cloud for their customers also. Now you might have a question that why do I build a private cloud? Because end of the day, I'm spending a lot of money on infrastructure, I'm spending a lot of money on air conditioning, electricity, and I'm spending a lot of money on licensing also. So why can't I just go ahead and work on public cloud? Why do I need to go ahead and implement a private cloud? Now, basically, when you talk about a private cloud is built for automation. So that is one of the most important things. And the second important part when we talk about is that when you talk about private cloud, it gives me more control over the resources. Whereas when you talk about public cloud, I do not have control over the resources because everything is owned by the vendor, right? Now talking about hybrid cloud, so I'll give you an example for this also. I go to Amazon, and Amazon is my public cloud provider. And I tell them that I need a private cloud. So would it be possible for you to host a private cloud for me? So Amazon says yes. And they dedicate a list of resources for me, only for my organization. So now when you talk about Amazon, Amazon is hosting a public cloud, but then they also are capable enough of hosting a private cloud for my organization. So that makes it a hybrid cloud. So this is what hybrid cloud means. So these are three different ways of how I categorize these cloud models. Now, few other questions. Now, the question says, I have some private servers on my premises. Also, I have distributed some of my workloads on the public cloud. What is the architecture called? When you talk about this kind of scenario, so we talk about my virtual private network. So these are my options, basically, virtual private network. Then we talk about private cloud. Then we talk about my virtual private cloud, and then you have hybrid cloud, okay? Again, so just read the question carefully, and then probably I'll just jump on to the next slide and we will talk about the answer and the explanation. So again, I would say I have some private servers on my premises. Also, I have distributed some of my workloads on the public cloud. What is this architecture called? Okay. So now it says hybrid cloud. So when you talk about this type of architecture would be on a hybrid cloud. Why? Because we use both public cloud and the on-premise server, which is on the private cloud. Now let's just jump on to the next question. So we have a few general Azure questions. Now, these are Azure specific. The questions which we did talk about previously were just general cloud questions, right? So if you are giving an interview for maybe Azure, maybe AWS, or maybe Google, so those 4 questions are something which I would say, go with any of the scenarios, any of the interview which you would do. Okay. Now these are specific general Azure questions. So when I say specific general Azure questions, so we talk about only Azure in here. Okay. So the first question talks about what is Microsoft Azure and why is it used? Okay. So as I initially said, that Azure is my public cloud from Microsoft. So let's just see how it works. So we have a definition on the next slide. Okay. So as discussed above, the companies which provide cloud services are called cloud providers. And of course, I did explain you this in the previous slide. I mean, the first slide which we talked about. So I explained you about Google. So that is a cloud provider. I explained you about AWS. That is a cloud provider. And then I talked about Azure, which is a cloud provider. So now Azure is from Microsoft. And the idea behind this is it's more like my public cloud. So you can go to Azure, you can log on to Azure, create a machine, and then start working on that. So this is one of the cloud providers. So Microsoft is one of the cloud providers, one of the major cloud providers these days. Right? So this is what my Azure is. Now talking about which services in Azure is used to manage resources in Azure. So we have few options. I have my application Insight. I have my ARM, which is my Azure Resource Manager. Then you have my Azure Portal. Then you have my Log Analytics. Okay. So as far as this is concerned, so we talk about my ARM. So this is a service which is basically on the newer portal, right? So now when you talk about these services, which is on the newer portal, so it is used to manage the infrastructure which involves a number of Azure services. It's basically my fabric. So I'm not sure how many people are aware of what is an Azure fabric, but then the idea behind this is that when you talk about my Azure Fabric now runs on something called ARM. Previously, in version 1 of Azure, it was using the service management model. So now this is a new thing, right? So when you talk about managing the resources in Azure, so we basically talk about my resource manager model and then how services run on it, how they work, and how they interact with each other. There are a lot of things which you need to work on and which you need to learn as far as my ARM is. But for the time being, you just need to remember that we talk about my Azure Resource Manager. So this is something which runs everything and takes care of a lot of different things as far as my Azure is concerned. So when ARM came, a lot of different things started coming in. So tag was one of them. Resource groups was another one. So if you are familiar with resource group, great. If you're familiar with tags, great. If you're not, just go to Google and search for it and you'll find your answers. Okay. Then we have few questions. Which of the following web applications can be deployed with Azure? Okay. So we can, of course, put ASP.NET applications in Azure. Now you might have a question, where exactly I can use these applications or where exactly I can deploy the applications. So to answer that, you can deploy it either in IaaS or you can deploy it either in PaaS, right? So you can, of course, deploy ASP.NET, you can deploy PHP, you can deploy WCF. So the answer is all of the above. But then it's very important for you to understand that if there is an application which is on Java, so that may have few problems when you deploy it on Azure, right? Because, of course, Azure is majorly designed for Microsoft services, okay? Now, when you talk about these Microsoft services, Java is not a Microsoft product. So it's more like, it's not that friendly when you compare it with other services which we are running in the cloud, okay? Specific to Microsoft Cloud, of course, I would say. Okay, jumping on to the next one. Then few other questions. So these are my fill in the blanks. A dash role is a virtual machine instance running Microsoft IaaS web services that can accept and respond to HTTP or HTTP request. Okay, so we have 4 options in here. One is my web, one is my server, one is my worker, and one is my client. Okay, now when you talk about this, the answer to that is web role is something which is basically hosted on a virtual machine and is running on Microsoft IaaS web server, and that is capable of accepting HTTP and HTTPS request. So basically on the web role, what you do is you can upload your website and your website runs on top of it. And then of course, you know that my website works on HTTP and HTTPS. So hence my web role is the one which is capable enough of running that particular maybe application or software or web services. Okay. The other question what we talk about is what is the use of roles in Microsoft Azure? So when you talk about what is the use of roles, we talk about 3 roles. One is my web role, one is my worker role, and one is my VM role. Okay. So now when you talk about my web role basically is for hosting and deploying my websites. Okay. The worker role is the one which basically helps the web role to execute the background processes. The example I can give you is my web jobs. I'm not sure how many people are aware of web jobs, but if you want, you can again search on the internet. So my web role is residing on worker role. Worker role is the one which supports my web role, and the worker role is the one which actually resides on my VM role. Okay. So this is the one which talks to the underlying layer. It's more like a framework. It acts as a framework. So that means on the operating system, I have my worker role. On top of it, I have my web role. So my web role is the one which will host my services. I would not say services, but the applications rather. Okay. So jumping on to the next one. Now the question says, is it possible to create virtual machines using ARM in a virtual network that was created using classic deployment? And of course, I don't think so it's possible. So let's just see. This is not supported, as I said, because ARM is something different, and previously the classic portal was using a different model of deployment. So it used my classic model of deployment, which was basically for service management. And if you're aware of the 2 portals, you'll see there's a huge difference in how classic portal was and how the new portal is. So there's a huge difference in terms of that also. So it's not possible. Jumping on to the next question, what are virtual machine skill sets? So scaling up, scaling down. So if you're not aware, if I have more number of requests coming in, my virtual machines have the capacity and capability to scale up and scale down based upon schedule and performance. Okay. So in other words, what I can say is if my CPU is spiking to 100%, or not 100%, I would cap it to 90. So if my CPU is spiking to 90 and my requests are still coming in for accessing that portal, the web portal, maybe you can say, which is running on this particular machine. So my scale set is intelligent enough to scale one more instance and then load balance the traffic between the 2 instances which are now deployed running the same set of application. Okay. So this is what my scale set does. It automatically auto scales, I would say, rather the workloads, right, based upon the performance and the schedule. Now how this schedule thing works. So say for example, if starting from morning 9 to evening 9, you have more number of visitors on the website, so you can scale more number of instances for your website. And after 9 p.m. at night, you can minimize the number of instances, right? So this is how my scale set works. Okay, jumping on to next question. Are data disk supported within scale set? So now first of all, when you talk about this, yes, of course, my data disk are supported in scale set. Okay. So when you talk about this, a scale set can be defined as attached data disk configuration that applies to all VMs in the set. So there are a few types of data disk examples which I've given over there. So one is of course my Azure files, which is my SMB shared disk. And then you have my OS drives, then you have my temp drives, then you have my Azure Data Services, like the blobs are there and tables are there and cubes are there. And then you have my external data services, such as remote databases. So all of these are supported. All of the disks are supported, which you see over there. Talking about availability set. So do scale sets work with Azure availability set? Now, first of all, you need to understand what is an availability set. Availability set is basically grouping of servers so that I can load balance the information among those servers. So that is done for high availability. And there is something called fault domain and update domain as far as high availability is concerned. So fault domain says that if I have 2 VMs in same availability set, both the VMs will share the common power source and common network. Okay. As far as update domain is concerned, so update domain talks about that if I have, say for example, 10 VMs and I would keep the value of update domain to 2, so I will have sets of 2 to each, right? So I'll have a group of 2 to each, right? And at a given point in time, if Microsoft needs to perform a planned maintenance, only one update domain will go down at a given point. So this is what my update domain means. So now, does it support my availability set? The scale set supports my availability set. Yes, the scale set supports my availability set. And you can just go ahead and fetch some information about the availability set if you're not very much well versed with availability sets as far as my Azure is concerned. Okay, and there is a small description also over there. So I'll just read that for you. Yes, a scale set is an implicit availability set with 5 fault domains and 5 update domains. Okay, scale sets of more than 100 VMs span multiple placement groups, which are equivalent to multiple availability sets. Okay, so this is what it means. And then I would just skip the other part because I've given you enough explanation for this. And I would definitely recommend that you read the availability set. Okay, now the question is, what is a break fix issue? Break fix issue is a technical problem, which is like your environment is running and then all of a sudden a problem comes, right? That is a break, and then fixing that particular problem is my fix, right? So technical problems are called break fix issues. It is the industry term which refers to work involved in supporting a technology when it fails in the normal course of function, which requires intervention by a support organization to restore the service. Okay, so this is what break fix is. Now, it's not specific to Azure actually. It's just a common term what we use as far as my services are concerned. So even if I talk about on-premise networks, so we still talk about break fix issues, right? So I'm not sure how many people have got a chance to call Microsoft and open a support case in case you have issues with any of the things in your environment. So those issues are basically my break fix issues. Jumping on to next question, why is Azure Active Directory used? Okay. Now, when you talk about Azure Active Directory is used for identity and access management, first of all. And it's a PaaS-based service. Azure Active Directory is a PaaS-based service. Now, it is used to grant access to employees to specific products and services in your network. So there are a lot of examples, Salesforce.com, Twitter, right? I can give you a few more examples, Office 365, Intune, which are two different products from Microsoft. So they work with Azure Active Directory, right? Now, Azure AD has some inbuilt support for applications in the gallery, which can be added directly. Okay, so there is a gallery, and then you can just go ahead and add support for Azure Active Directory to any application which is available in the gallery. Okay, talking about a few other questions regarding Azure AD. What happens when you exhaust the maximum failed attempts for authenticating yourself via Azure AD? Okay, so we have a more sophisticated strategy to account lockout, which is based on IP of the request and the password entered. Okay. So now when you talk about on-prem, we talk about account lockouts. So if you enter incorrect passwords more than 3 times, so your account is logged out and it will be unlocked after maybe 15 minutes or half an hour or 1 hour based upon how your administrator has configured it. Now the same thing happens in Azure AD, but then it happens based upon the IP address. Okay, so it will go ahead and track the IP address of the request and the password entered, and the duration of the lockout also increases based upon the likelihood that is in the attack. Okay, so this is how it works when we talk about maximum failed attempts for authenticating yourself. Okay, jumping on to the next question. Where can I find a list of applications that are pre-integrated with Azure AD and their capabilities? So when you talk about this, my Azure AD has around 2600 pre-integrated applications, and all pre-integrated applications support single sign-on. Single sign-on lets your organization credentials to access your apps. Some of the applications also support automated provisioning and deprovisioning. So there's a gallery, you can just go to the gallery and then you can get a list of applications which are available for using my Azure AD. But of course, that is not the complete list of applications which are available, which you can use as far as this is concerned. There are a huge number of applications which are supported by Azure AD. Okay. Of course, single sign-on is one of the components of Azure AD. So probably in case you're not aware of single sign-on, you can just go ahead and do some research on that. Now, talking about the next question, how can I use applications with Azure AD that I'm using on-prem? Of course, you can do that. Now, my Azure AD gives you an easy and secure way to connect to the web app that you choose. You can access these applications in a way you can access your SaaS-based applications in Azure AD. So you don't need to have a VPN installed. Okay, you can just go ahead and install a component, and then you are ready to go. You can use the applications which are there on-prem. A few examples I can give you is you can use your SharePoint. You can use your web apps for which the servers are installed on your premises, and you would like to use Azure AD for authentication. So you can do that for sure. Now the question, important question, very important question. what is the Azure Fabric, Service Fabric? So when you talk about that, my Azure Service Fabric is a distributed system platform that makes it easy to package, deploy, and manage scalable and reliable microservices. Okay, so this is the guy which actually controls your network, your storage, and your compute. Okay, which are basically the most critical components of my cloud. So if my fabric will not be running in the backend, so nobody will be assigning IP addresses, nobody will be assigning resources, and nobody will be assigning the storage. Okay, so this is the guy which actually runs everything, I would say, in the cloud infrastructure, right? Okay, let's go further. Service Fabric also addresses the significant challenges in developing and managing cloud applications. Developers and administrators can avoid complex infrastructure problems and focus on implementing mission-critical, demanding workloads that are scalable, reliable, and manageable. Now, my Service Fabric represents the next-generation middleware platform for building and managing these enterprise-class Tier 1 cloud-based applications. Okay, now what is VNet? VNet is basically nothing but my virtual network. So VNet is a representation of your own network in the cloud. It logically isolates your instances launched in the cloud from rest of the resources which you have in the cloud. So this is my whole network based on which my configuration of machines depend. I mean, the subnets, the address space depends on, right? Talking about few other things, what are the differences between subscription administrator and directory administrator? So when you talk about the subscription administrator is the one which is responsible for the complete subscription. Now, by default, only one subscription administrator role is assigned in Azure. A subscription administrator can either be a Microsoft account or either can be your work account. And that guy has control over the complete Azure portal and the services which run on that. Okay. If you want, you can just go ahead and sign up more accounts, which are basically subscription administrator, and these people are my co-admins. Now, as far as the Azure AD is concerned, so the account which we set up over there for identity and access management, so we talk about my Azure AD administrator, the directory administrator. So let's just read this. Azure AD has a different set of admin roles to manage the directory and identity related features. These admins will have access to various features in Azure Portal or the Azure Classic Portal, and the admin roles determine what they can do, like create or edit users, assign administrative roles to others, and so on. So this is what my Azure AD administrator does. Are there any scale limits for customers using Managed Disk? Managed Disk eliminates the limit associated with storage accounts. Now, first of all, you need to understand what is a Managed Disk, right? When you create a machine now, these days, you will have an option over there that you want to use Managed Disk or Unmanaged Disk, right? So when you select Managed Disk, Microsoft manages, I would not say Microsoft, but then the Azure Fabric manages all your disk, right? So a disk which is assigned to VM will be managed by Azure. Okay, so this is what my Managed Disk is. Now, using my Managed Disk, I basically eliminate the limit associated with my storage account. However, the number of Managed Disk per subscription is limited to 2000 by default. Okay, so you can have 2000 Managed Disk in Azure subscription. Now, talking about what is the difference between service bus queues and storage queues. Now, the Azure storage queue is simple and the developer experience is quite good. It uses the local Azure storage emulator and debugging is made quite easy. The tool for Azure storage queue allows you to easily peek at the top 32 messages, and if the messages are in XML or JSON, you'll be able to visualize their content directly with the Visual Studio. Furthermore, these queues can be purged of their content, which is especially useful during the development process, the QA efforts basically. And as far as my service bus is concerned, so the Azure service bus queues are evolved and surrounded by many useful mechanisms that make it enterprise worthy. They are built into service bus and are able to forward messages to other queues and topics. And they have built-in header message queue and messages that are timed to live, that has control. Hence, messages don't automatically disappear after 7 days. So if you talk about this, probably you'll have to go ahead and read about what is a service bus queue and my storage queues. So I talk about my storage queues, which are a part of my storage itself. If you're not aware of storage, storage has 4 types of storage. One is my blob, one is my files, one is my queues, and one is my tables, right? So you need to have more information of what my storage queues is. Okay, now talking about what is Azure Redis Cache. So Redis is an open source in-memory data structure store used as a database. And then you talk about cache and a message broker. So when you talk about my Azure Redis cache, that is based on the popular open source Redis cache. It gives you access to secure dedicated Redis cache managed by Microsoft and accessible from any application within Azure. It supports data structures such as strings, hashes, lists, sets, sorted sets with a big range of queries, bitmaps, hyperlogs, and indexes with radius queries. Okay. Another question we talk about is why does not Microsoft Redis Cache have an MSDN class library reference like some of the other Azure services? Now, of course, when you talk about this is an open source, one very important thing. Now, my Microsoft Redis Cache is based on the popular open source Redis Cache and can be accessible by a wide range of Redis clients. And that is the reason we cannot just go ahead and put it into MSDN. Okay. So simple enough, just remember that. Because each client is different, there is not one centralized class reference on MSDN. So we cannot just restrict it, maybe you can say, right? So this is the reason we do not have any MSDN class library for my Redis cache. What is my Redis databases? So Redis database are just a logical separation of data within some Redis instances. The cache memory is shared between all the databases, and actual memory consumption depends on the key values stored in the database. For example, a C6 cache has 53 GB of memory, and you can choose to put all 53 GB into one database, or you can split it into a multiple set of databases. Then you have another question, why was my client disconnected from the cache? Okay. Now when you talk about this, the following are some common reasons for cache disconnect. Now my client side causes the client application was redeployed. The client application performed a scaling operation. In the case of cloud services or web apps, this may be due to auto scaling. The networking layer of the client side changed. Then you have transient errors occurred in the client or in the network node because of the client and the server. The bandwidth threshold limits were reached. CPU bound operations took more long to complete, and then you have my server side issues also, few of the server side issues also. On the stand cache offering, the Azure Redis Cache service initiates a failover from the primary node to the secondary node. Now Azure was patching the instances where the cache was deployed, and this can be the Redis server updates or general VM maintenance. Then you have what is Azure Search. So simple enough, Azure Search is a cloud search as a service solution that delegates server and infrastructure management to Microsoft, leaving you with a ready-to-use service that can populate with your data and then use to add search to your web or the mobile application. So it works with REST API or .NET SDKs, of course. Few other questions. My web app still uses an old Docker container image, and I have updated the image on Docker Hub, which is basically the new portal what we talk about. So we are basically talking about container services. Do you support continuous integration deployment of custom containers? Now, first of all, for private registries, you can refresh the container by stopping and starting the web app, or you can change or add a dummy application setting to a force and refresh of your container. So this is what you can do. Now, talking about few other things. What are the expected values for startup file section? And I configure the runtime stack. Now for JS nodes, you specify PM2 configuration file or your script file. For .NET Core, specify your compiled DLL name. For Ruby, you can specify the Ruby script that you want to initialize with your app. Okay. How your Azure Marketplace subscription is priced. So we have these models. One is monthly fee, so pay as you go kind of thing, usage based. Then you have free software. So Microsoft gives you a free subscription. So free subscription is valid for a period of 1 month, and you get approximately $200 in that. So you can use that. Then you have the free. So this is for the customers who are not charged marketplace fee for use of the offerings, the Microsoft offerings. And you have BYOL, bring your own license. Okay. So these are the subscription models. Basically how these are priced, you can say. So jumping on to the next one. What is the difference between price, software price, total price in the cost structure for virtual machine offerings in virtual machine? So let's just see. Price refers to the cost of Azure virtual machine to run the software. Software price refers to the publisher software running on the virtual machine. Total price refers to the combined cost of these two. Simple enough? I don't think so. You need to get more details of this because it's very simple. Price of VM, software price, total price. Total price is equal to price of VM plus software price. Now, the other question talks about what are stateful and stateless microservices for Service Fabric. So Service Fabric enables you to build applications that consist of microservices. So stateless microservices such as protocol gateway and web proxy do not maintain mutual state outside a request and its response from the service. Now my Azure Cloud Service Worker role is an example of a stateless service, and my stateful microservices such as user accounts, databases, devices, shopping carts, and queues maintain a mutual authoritative state beyond the request and its response. So this is how it works. Now, what is an application partition? Okay. Now, when you talk about the application partition are a part of Active Directory system, and having said so, they are directory partitions which are replicated to domain controllers. So usually domain controllers that are included in process of directory partition hold a replica of the directory partition. Now, maybe you can read some more information. My domain controller has 4 types of partition. One is configuration, one is schema, one is my domain partition, and then you have my application partition. So all the information related to the application goes in the application partition. So it actually again has nothing to do with the cloud, but then it's always good to know, because if you're designing and developing an application on the cloud, you can just go ahead and put that information in the application partition on the Active Directory server. But then it's very important for you to understand that we should have an Active Directory server up and running fine in the cloud.
So the first question is, what is DevOps? Of course, this is one of the first Microsoft Azure DevOps interview question that you will be asked. So the answer to this is, DevOps is a set of cultural ideas, practices, and technologies that improves an organization's capacity to provide applications and services at high velocity by changing and enhancing products at a quicker rate than traditional software development and infrastructure management methods. In simple terms, DevOps essentially speeds up the process of delivery of application and software services. Coming with our second question, why use DevOps? So this is a common Azure DevOps interview question. So how do we answer it? DevOps is significant because it is a software development and operation methodology that allows for faster product creation and simpler maintenance of existing installations. When problem arises, the DevOps team is able to listen to the user and provide the necessary features and repairs. It also facilitates the delivery of smaller features to clients in a quick and efficient manner and allows seamless software delivery. So this was the answer to why use DevOps. Let's quickly move on to our next question. How does DevOps work? So DevOps is about breaking down barriers between previously compartmentalized departments such as development and operations. These development and operations teams collaborate across the whole software application lifecycle from development and testing to deployment and operations under the DevOps paradigms. Going ahead, what is Azure DevOps? So as I said before, Azure DevOps is a Microsoft application as a service platform that offers an end-to-end DevOps toolchain for building and distribution software. It also interfaces with the majority of the market's main products and is an excellent choice for coordinating a DevOps toolchain. This process includes testing automation, continuous integration, as well as continuous delivery. People with both development and the operation skill work together and implement various tools for CI/CD and monitoring for quick response to customers' requirements and fixing issues and bugs. Moving ahead, what are the benefits of DevOps? So there are 5 benefits of DevOps, which we'll understand one by one. So first is speed. DevOps practices let you move at a velocity you need to innovate faster, adapt to changing marketing better, and become more efficient at driving business results. Second benefit is rapid delivery. So when you increase the pace of the releases, you can improve your product faster and build competitive advantage. Third is reliability. In this, DevOps practices like continuous integration and continuous delivery can ensure the quality of application updates and infrastructure changes so you can reliably deliver at more rapid pace while maintaining an optimum experience for end users. At number 4, improved collaboration. Under DevOps model, developers and operation teams collaborate closely, share responsibilities, and combine their workflows. This reduces inefficiency and saves time as well. And finally, number 5, we have security. So you can adopt a DevOps model without sacrificing security by using automated integrated security testing tools. So these were the 5 benefits of DevOps which makes it more demanding. Let's move on to number 6. So the number 6 question is name a few DevOps tools. So the answer to this is some of the popular DevOps tools are Git, Selenium, Jenkins, Puppet, Chef, Ansible, Negios, Docker. So you can answer any of the 4 DevOps tools which are easy to remember. Moving ahead with the next question. What are the popular DevOps tools for continuous integration and continuous deployment? So, Azure pipelines support macOS, Windows, and Linux. So, some of the popular DevOps tools for continuous integration and continuous deployment are Jenkins and TeamCity. These two are the DevOps tools which provide you both continuous integration and continuous deployment. Quickly moving ahead with the next question. Question number 8, that is, what are Azure boards? So, Azure Board is a user interface that allows you to keep a track of tasks, defects, and features in your software project. It enables you to monitor all your ideas to each development stage in order to keep your team on track with all the essential code modification related to your work procedure. Azure boards include features like boards, sprints, work items, dashboards, backlogs, queries, etc. Going ahead, what is Azure Repos? This is a basic Azure DevOps interview question, but it can be difficult to answer. So, the answer to this is Azure Repos is a collection of version control tools for managing your code. Using version control as soon as feasible, whether your software project is huge or little, is a smart idea. Version control systems are a piece of software that allow you to keep a track of changes to your code over time. Azure Repos offers centralized version control system as well as the distributed version control system, that is Git. At number 10, what are containers? Containers are software packages that include all the components required to execute in any environment. Containers virtualize the operating system in this fashion, allowing them to operate anywhere from private data center to a public cloud or even a developer's own laptop. Containers also provide the means to package software code, its configuration, dependencies, and packages into a single unit or object. Multiple containers can run on the same machine or share OS with containers for running fast, reliable, and consistent deployment anywhere. Moving ahead, what containers does Azure DevOps support? So Azure DevOps support the following containers such as Docker, Azure Kubernetes Service, ASP.NET with containers, Azure Service Fabric application with Docker support. So these are the containers which are supported by Azure DevOps. Moving ahead, what are Azure pipelines? Azure Pipeline is a cloud service that allows us to automatically create and test our code projects. The Azure Pipeline includes several features such as continuous integration and continuous delivery that allow us to test and build our code on regular and consistent basis and ship to any destination. It automatically develops and tests the code projects. It is a service on the Azure cloud that offers well with most project types and languages. Going ahead, at number 13, what is the use of Selenium in DevOps? Selenium is widely used browser automation technology, and testing teams heavily rely on it in DevOps pipeline. It is an open source solution that saves money for testing teams and functional testers that are in charge of UI testing. It specializes in the form of regression and functional testing. At number 14, what are Azure test plans? This is another one of the popular interview questions asked in Azure DevOps. So the answer to this is Azure Test Plans is a service provided by Azure DevOps that offers a browser-based test management solution for exploratory, scheduled manual, and user acceptance testing. In addition, Azure Test Plans includes a browser extension for exploratory testing and getting feedbacks for the stakeholders. Additionally, it also focuses on automated testing. It combines the contribution from developers, managers, testers, product owners, and user experience advocates and enhance the quality of the project. Moving ahead, what are the some important features of Meme Cache? So Meme Cache offers a wide variety of features. Some of them are like it is an open source, it's a UDP or TCP server client program. It works as a standalone service. The cached nodes are very ignorant, so they don't have other nodes involved. They are also under the license of Berkeley Software Distribution and it reduces the database load. So these were some of the important features of Meme Caching. Quickly moving ahead, at number 16, what is a dogpile effect and how can you prevent it? So a dogpile effect refers to an effect that occurs when a cache expires and websites are attacked by several requests sent by the client at the same time. It indicates the expiry of cache followed by the website being simultaneously hit by numerous respects. In simple terms, it indicates the expiry of cache followed by the website being simultaneously hit by numerous requests. This impact can be avoided by employing semaphore log. When a log expires in this system, the first process gains the lag and begins creating the fresh value. At number 17, what is continuous testing? What is the use of test automation in DevOps? As we know, DevOps is all about people, culture, and automation. In this, continuous testing is the process of running automated tests as a part of the software delivery pipeline to get feedback on the business risks associated with a software release candidate as soon as feasible. DevOps use test automation to use the test cases to find the flaws and save time. Unlike manual testing, automation test cases accelerate testing, allowing you to get products to market faster. Moving ahead, number 18, what is a forking workflow? So before we get to know what is forking workflow, let us know what is forking. So forking is a git clone process that is performed on server copy of the project's repository. The forking method supports open source projects and isolates changes from the main repository until they are ready to be integrated. What is forking workflow? Forking workflow is a git clone process that is performed on a server copy of a project's repository. This method supports an open source project and isolates changes from the main repository until they are ready to be integrated. Moving ahead, what are some of the useful plugins in Jenkins? So it has a very simple answer. So there are many useful Jenkins plugins, out of which would be describing few. So among them are Amazon EC2, Maven 2 Project, HTML Publisher, Join, Copy Artifact, Green Balls, and many more. So these are few useful Jenkins plugins, and it will be very easy for you to remember it. Quickly moving ahead with number 20, can we move or copy Jenkins from one server to another? So the answer to this is yes, it is possible. Jenkins can be removed from one server to another just by cloning the job directory from the previous server to the new or the current one, and later you can rename it. This enables moving an installation by copying the corresponding job directory. So these were the top 20 Azure DevOps interview questions. So let's look on to some scenario-based Azure DevOps interview questions. So the first one is, we have 50 commits in develop branch, out of which only 5 commits need to be pushed in the release branch, which will eventually deployed in the production. Okay, so the question is, we have around 50 commits in the develop branch, which is mostly used for development activities. So in that we have multiple commits, and the release branch is used to release your changes into your proper environments like your stage production. So here, out of 50, only 5 commits need to be posted into the release branch. So the best way to achieve it is through Git cherry picking. Git cherry picking is the act of picking a commit from a branch, applying it to another. Git cherry pick can be useful for undoing changes. For example, say a commit is accidentally made to the wrong branch. So what you can do, you can switch to the correct branch and cherry pick the commit to where it should belong. More simply, it would be like a box of cherry in which you have to pick 5 best cherries out of it. So you start picking the best cherries, and if you want to run this cherry picking, you need to use the Git console. So using the git line command, you can initiate the cherry picking. So let's move on to our second scenario. So in the second scenario, a developer has created an ASP.NET Core application, and now he wishes to automate the entire build and release process through Azure DevOps. Guide the developer with the entire end-to-end process and deploy the application on Azure Web App using IAC methodology. Okay, so guys, as you can see that we have multiple questions, and in this entire scenario which we are talking about, the first question is that there is a developer which is very much new to DevOps, and he has reached out of the reaches of DevOps engineer, and now he asks how to automate the entire build and release process. And in the another scenario, we need to deploy this on the Azure web app using the IAC methodology. So the first step is to be taken by the developer to build the application locally. After that, we create a Azure repos and push the source code in the remote repository along with the IAC configuration file. And lastly, we create a build pipeline, classic or YAML based, in which we can build the solution using MS Build or VS Build, run the code analysis through SonarQube, Veracode, etc., run code coverage, copy ARM or Terraform configuration files, also publish the artifacts either on FillerShare or Azure Pipeline drop location. So this was the answer to the scenario. Moving ahead with the next scenario, here the developer named Ram has few commits changes in his local branch, and now he has to empty the current work directory to accommodate emergency change. So how can Ram handle such scenario without losing his uncommit changes? So to achieve this, we use git stash. What is git stash? Git stash is a command that takes your uncommitted changes, that is both staged and upstaged, and save them away for later use, and then reverts them from your working copy. So there are commands like git stash, which stashes the uncommit changes, and next is git stash list. So you can list all the stashed changes. Then there are other commands like git stash pop to reapply the most recent stat changes.